Welcome to Full Stack AI DevOps Masterclass with Microservices. And before I begin, I want you all to drop your attendance in the comment section of this particular video. This will help me gauge the kind of response that this kind of content brings in. And also, if you find this particular video to be valuable, which you can you can discover the value from the timestamps that I have added in the description. Okay, so if you find this video valuable, be sure to hit like, subscribe, and let me know in the comments that you found this content to be valuable. It just makes me happy. So what is this content all about? And by the way, before I begin talking about this video, a lot of viewers are not subscribing. Okay, so I don't know. I get a lot of views from like people who are not subscribed. Okay, this is what YouTube analytics tells me. And I don't know why people are not subscribing. Maybe because I thought my content is not valuable. But then I realized there are a lot more of you who are also returning viewers. Okay, so if you're returning to the channel, it means you all are finding the content valuable. Okay, but not subscribing. I don't know why. Okay, so hit that subscribe button, turn on the bell notification icons, and let's talk about this video. So this particular course, like the name says, it's a full stack AI DevOps masterclass. Now, why full stack? Because here we work with full stack applications and AI, as in there are some AI strategies like AI assisted DevOps. I have some strategies inside the course that helps you accelerate your DevOps workflow. Okay, so hence the word AI. And yes, it's a DevOps masterclass, and anyone can take this particular masterclass, whether you are a DevOps engineer or a developer who is willing to understand DevOps. Okay. And yes, we also cover microservices over here. So full stack, as in we deal with full stack applications and microservices. So there are full stack microservices that we deal with. Okay. And yes, this is what the course covers entirely. So we start with the DevOps mindset. Okay, so see, this course is for beginners. Like I said, even beginners can take, experienced professionals can take. I have timestamps clearly mentioned in the description section, so if you feel like skipping a part, you can do that. But this course starts with the ultra basics. So if you are a beginner who don't know what DevOps is, who has not heard terms like Docker, Kubernetes, what is Kubernetes in cloud, what is IAC? Okay, that's infrastructure as code. I'll talk about that. GCP, AWS, Azure, what is all of this? Okay, so if that's the case, then this course is for you. We start with literal basics. Okay, we start with like what is a DevOps mindset, what DevOps is. So we literally start from there and we graduate to understand all these concepts. And not only we learn these concepts theoretically, so I have minimized a lot of theory in this particular course. It's hands-on practical. You get access to a production grade application that you learn how to containerize or deploy on Kubernetes on cloud, all of that you learn over here. Okay, so it's fully hands-on. It's like a workshop that you are doing or you are enrolling in. Okay, so that's how the course is designed. And we start with Docker, we containerize the application. So first we start with DevOps and understand the nitty-gritties of DevOps, then Docker, then we learn Kubernetes, and then we learn how you can make your application run on Kubernetes in cloud. So first, this Kubernetes part is understanding Kubernetes and running it locally and deploying applications as well locally. And then we take our applications to cloud, and then we learn what is infrastructure as code using Terraform. Okay, so this is gaining a lot of popularity these days. And it's important that you as a developer or a DevOps engineer understand this. Also, this is very rare. Okay, GCP, Azure, and AWS covered all in one course. This is very rare. Okay, I could not find a good course that covers all these three cloud platforms. These are major cloud platforms. Okay, that is being used by enterprises, startups, everyone. Okay, so if you know these three, you win, right? And I believe it's important you should have knowledge of all three cloud platforms. Okay, you should be expert. You can be expert in one or two, but have knowledge of all three. Because see, today you're working in company A or project A. You might be shifted to project B, and that client might be wanting some other cloud provider, right? You might switch jobs and that company is using, let's say, some other cloud provider. So it's best to know like all the platforms, but be expert in one or two. That's what I recommend. Okay, so this is how the course flows. I am not going to take a lot of time here, okay, because I believe my content speaks for itself. Okay, so this is a very comprehensive course. Do watch till the very end. I hope you all have marked your attendance, and let me know in comments what sort of videos I should bring more on this channel, and where are you from, or what are your goals, why you're watching this video, and where are you watching this from. Like I said, the city, state, you mentioned that, the country. Okay, so I would be happy to see your message, and of course I'll be replying to everyone, whoever I can. Okay, I get a lot of comments, I try to reply as much as I can, and I'll give my best shot there, right? So yes, if you have not subscribed last time, okay, please hit that subscribe button and like the video and share it with your friends, whoever needs this. Okay, sharing is also important. Sharing is caring. This is a free tutorial that we are sharing here. Okay, if you find this valuable, do share it with your friends. Hey there, so it's time. I thought I should share some useful resources that can enhance your learning experience. So first is this GitHub repository. Okay, there are 2-3 resources that I want to share. First is the GitHub repository, and this is the official GitHub repository of this particular course. And what you can do is you can clone this repository onto your machine, and as you start taking the course, you will realize you have all the files that are needed, that can help you save time and make sure you follow the course in the right way. Okay, so all the files are provided over here, and also if you scroll down here, you have the learning roadmap and access to our roadmap, which can help you become a full stack developer. Okay, so you can refer to this roadmap as well. Also here, if you check the branches, there are 2 branches you will see. One is the main branch. So we start with main branch, and if you find if you want to access something, or if you want to see what I wrote in a particular lecture, you have another branch, which is the working branch, and this working branch has all the source code written by me in the lectures. Okay, so while recording the videos, whatever source code I've written is on this particular branch, and this main branch is the starting point of the course. So you actually need access to main branch, but if you're stuck and want to compare my source code that I've written, you don't need to type everything out. You can switch to working branch and just see what I've done. All right, so now is the time that we begin talking about what DevOps exactly is. So we are going to understand what DevOps is and the problem it solves, and we'll also break some misconception about DevOps. So I'm going to paste something over here, add something over here. Okay, so what is DevOps? First of all, DevOps is a way of building and operating software where development and operations work together. Okay, and what does development mean? Yes, it's the development team. What does operations mean? It's the operations of the software or the application that you're building. What comes under operations and all, we're going to discuss that shortly. And if you're not aware of what operations means, don't worry. Okay, we'll cover that shortly. But for now, DevOps is a way of building and operating software where development and operations work together. And this happens usually with shared responsibility to ship features faster and safer and more reliably. Okay, and there is also automation that is being involved. So shared responsibility and automation that is being involved over here. Now, one thing I would want to mention over here, that DevOps is not a tool, but it's a culture, a practice, and you can call it a workflow as well. Okay, so there are different tools out in the market like Docker, Kubernetes, CI/CD, you have Spring Boot. So it's not a tool. Okay, it's a culture, practice, and a workflow. Okay, so putting together DevOps actually is a culture which brings shared ownership. It is a set of practices. So basically implementing CI/CD tools, infrastructure as code, monitoring tools, and having a workflow in place wherein you plan, build, deploy, test, operate, and improve. Okay, so that is what DevOps is. Now let us go a little bit further, and let us also try to understand why DevOps first of all came into picture. Okay, so what I'm going to do is I'm going to add something over here. Okay, and I'm going to cover the before part of the DevOps. Okay, so before DevOps, what was the thing that used to happen and why DevOps came into picture? Okay, so before DevOps, there were 2 distinct teams. Okay, one is the developer team and the other one is the operations team. Okay, now what is the responsibility of developer teams? So developer team writes codes, add features, will push changes, and it will say that it works on my machine, right? So this, don't mind this statement, but this is generally what every developer will say. So if there is something that is not working, okay, you're always going to say that it works on my machine. And even I as a developer have said that n number of times. I don't even remember how many times I've said, but this is usually the case, right? So he's going to write code, add features, he's going to push the changes, and he's going to write code on his machine. Features will also be added on his machine, and he's going to push the changes to a remote GitHub repository or a software for version control, whichever your team is using. And if there are any issues, okay, developers usually have this tendency. So that is what I have added over here. Now, what is operations team? Okay, so before DevOps, there was a separate operations team that used to come in, and the job of the operations team would be to run servers, okay, handle deployments, and they will even fix outages midnight, okay, and they will even say that your code is unstable. So anything breaks in production, they are always going to say that, hey, your code is unstable, and developers will generally say that, hey, my code is stable, it's working on my machine. Now this brings us to the problems part. Okay, now there are a few problems that come in with this approach. Okay, so earlier when DevOps was not there, we had two operations team, and then this lead to few problems. Now, what are the problems? So let's talk about problems. Problems, as you can see here, the first problem is slow releases. Okay. Now, slow releases meaning whenever there is a new feature or anything added, it used to take a bit of time, a good amount of time to reach the production, for that features to reach the production, because ops would require a bit of time for deploying that new feature, and developers, and because of this, okay, because of this problem over here of slow releases, developers could not release features that frequently that they would want to. Okay, and this is one problem. Then you had blame game that comes into picture. So, if something fails in production, DevOps or the operations team is going to say that, hey, your code is unstable, but the developer team is going to say that, hey, my code is not unstable, it is working on my machine. See over here. So usually this will be like a blame game that used to happen in teams, wherein one team is blaming another and other one is blaming back the same team. Okay, and hence here there was no shared context, no accountability for the production. Okay, so this is another problem. Then you had manual deployments. Okay, so operations team will do manual deployments. They will manually copy the files to the servers. They will restart the servers, and this entire process will be manual. So for example, there could be some issues, like if I have to give an example, let's say a missing .env file will cause a outage on production, and this would be because ops deployed wrong configs manually. Okay, so they were not aware of the right configs, okay, and .env file got missed. .env file is an environment file that holds the environment required, or environment variables that is required for the software to run. And because of this, there will be like issues in the production, and hence its manual deployment is equal to high risk. That is what I have written over here. Right now, the next problem over here is no feedback to the developers. Now, what does this mean? So developers essentially could not see the error rates, metrics, latencies, and all of this. So they are shipping the features. Okay, they are just on the build mode. Okay, they are shipping the features, but what is actually happening? What is the performance of their features? All that sort of visibility was not there for the development team. And the last problem we had is inconsistent environment. So inconsistent environment meaning the dev machine on which the developer would build the software would not match staging or production. Okay, so for example, developer is making use of Python 3.10. Okay, he's using a particular version of Python, but the prod has 3.8. Right, so it's not going to match, right? So it's working on local machine of developer, and production has some other version. Right, so developer's machine is not simulating the production's machine, right? So that's a problem over here, and because of this inconsistent environment, there used to be problems. Okay, now because of this problems, DevOps came into the picture. Okay, now what DevOps did is DevOps said that, hey, let me make the entire flow over here automated and predictable. Okay, so here I have a few things added. Okay, I'll just take them in the frame. So DevOps made the entire flow automated, predictable, and monitored. Okay. So DevOps said, I'll add some fixes over here. Okay. And what fixes it added is it will say that instead of manual work, okay, right now what used to happen is, I just mentioned what used to happen is, operations team will do manual deployments. They will handle servers manually. They will create servers manually. They will restart manually. Everything was manual. So DevOps said that, hey, let's bring in automation and let's not rely on manual effort put by humans out there. Okay. So that was a number one thing. So just to give you some context as to how this is done, this is done by writing pipelines, where pipelines is going to do the job of building, testing, and even deploying the code. Okay. So that's one thing that DevOps brought in. Shared ownership. Okay. Now talking about the first point itself. Okay. I want to give you an example. So let's say a retail company is there and it wishes to deploy backend services, let's say 5 times in a day. Okay. There are some quick releases that are happening. So it does not have to rely on manual effort of an operations engineer, right? Since it's automated, it can deploy 5, 10, 50, 100 times also. Right? That can be done because it's just automation in place. Shared ownership. Now, with shared ownership, what happened is backend engineer is also involved a little bit in development. Okay, sorry, not development, deployment. Okay, so backend engineer is involved in deployment. So what happens is shared ownership, the culture of shared ownership came into place, wherein developers started thinking about deployability, reliability of the application, errors, performance, all these sort of thought processes started coming to the developers. So operations is going to automate the infra so that developers can ship safely. That sort of culture started coming into place. Okay. Then there was this another thing that came in wherein containers came into picture. Okay, so you must have heard, if you have been building softwares, you must have heard of this term called containers. Okay, wherein you can create application containers, and these are small runtimes that get created on your machine, and it can run anywhere. Okay, and they have everything the application needs to run on itself. Right. So these came into picture. And because of containers, since container is carrying, so how it used to work is, I'll just give you an example over here. Okay, so how it'll work is, here you have this one container. This is the container. Now this container will have the dependency. Okay, dependency that the application requires. It is going to have the code for the application. It is going to have everything, basically everything app requires to run. So this is the container. So container will be created like this, which has everything in itself that application requires to run. It does not have an operating system, because installing an operating system within container will make it heavy. It's very light, and it just has those things that is needed for the application to run. So it's like a machine in itself, right? Now this eliminates, right? Okay, so this eliminated this thing wherein developers used to say that, hey, it works on my machine, because everything is now being containerized, right? You're creating containers and you are shipping the code along with its dependencies, right? So this eliminated a lot of issues over here. Then IAC ensured that infra is reproducible and stable. Now, what does this mean? So IAC means infrastructure as code. What does this mean? It's a practice wherein you can define infrastructure in the form of code. Right. So for example, I'll just give you a quick example. If I need 2 virtual servers, 2 EC2 instances, I need one private network to run my application. So earlier what used to happen is you will go and manually create that using the dashboard on your cloud provider, whether it's AWS, Azure, or Google, GCP. With infrastructure as code, you can define all of this in the form of code. Okay. And you have to just run it. So it will automatically get created because that is what you have defined. Okay. Now this ensured, so infrastructure has come in the form of a code, right? You can define infrastructure in the form of a code. Now this ensured that infra can be reproduced again and again, and it's stable. If there are any sort of updates or changes you want to make, you have to make in the code, and you have to apply the changes, and the infrastructure in the cloud will get updated. So this was a major thing which helped developers to reproduce the infrastructure. For example, I created an infrastructure today with the help of code, And tomorrow, if I want to destroy and restart everything, I can do that easily. Okay, so earlier with UI, what used to happen is developers used to forget clicking or creating few things. So that got eliminated with this, right? Then monitoring closes the feedback loop. What happened is with the culture of DevOps, monitoring came into picture. Like developers got involved into monitoring earlier. Only infra guys were involved into that. So this gave developers a picture or sort of a feedback as to what is happening with their application. Okay, so yeah, this is how DevOps has helped shape the entire ecosystem of building and publishing the apps or any sort of software that you build today. Okay, so just reiterating on what we discussed, I know it's a little bit heavy, but I've tried to crunch it as easy as possible into as easy language as possible. Okay, so we started with what is DevOps. So what is DevOps? DevOps is not a tool, but it's a culture, practice, and a workflow. Okay, and it's a way of building and operating software where development and operations both work together. Okay, now what is development and operations? So here we spoke about development and operations, wherein before DevOps, okay, developers were responsible for writing the code and operations were responsible for deploying the code, managing the servers, doing deployments and all of that. So developers will write code and forget it. Operations will take that code to production. Now there will be problems like slow releases, a blame game, manual deployments. There's no feedback to the developers, inconsistent environments because developers' machine is having something else, and remote production or staging or dev environment are having something else. Now here comes the culture of DevOps, wherein the entire flow of taking your code from the developer's machine to that of production is automated, predictable, and monitored. And how it's done? So it's done with these 5 points that I discussed over here, where automation comes into place. There is shared ownership, and because of this, this works on my machine thing is eliminated. You have infrastructure of code come in, and then there is also monitoring that will close the feedback loop for the developers. So I hope this has been useful, and I hope this has given you some good insight here. So now it's time that we begin talking about Docker, and I'm not just going to discuss Docker, but actually I'm going to explain this amazing concept with the help of a scenario so that it gets cemented with you. All right. So let's talk about Docker, and the scenario we are going to take is of two developers, okay, who are working in team. One developer name is Sarah, as you can see on the screen. Sarah or Sarah, whatever you want to call it. And another developer that I have is of a John. Now they both are teammates. They are working on the same code base. And generally in development environment, when people are working on the same code base, usually they have a shared environment where they have all the code stored over here, right? And what happens is generally these developers commit, pull, push from this shared environment. Now, this shared environment can be anything. Like it can be a version control system like GitHub, Bitbucket, okay, whatever you want to call it. So usually what will happen is these developers will commit, push, pull, and whatever they are doing on the local machine, they'll make sure that it's updated onto the shared environment. And from the shared environment, they'll make sure that they have everything onto their local. Okay, so this is how thing is going to work. Now, let's say while working, okay, of course, the application that they're working on is going to have some sort of dependencies. Now, when I say dependencies, it's like if you're building a Python application, you're going to have some dependencies with the specific versions. If you're building a Java-based application, you will have dependencies with specific versions, right? So these dependencies have versions. And let's say one of these developers, like for example, John in this case, he happens to update a library. So he updates the version number of a library. Now what will happen? What will happen is he pushes this particular code to the shared environment, and Sarah pulls this code onto a local machine, and suddenly everything breaks on Sarah's machine. So why does it break? Okay, why does it break? Because one developer has updated the library and it has caused the issue to the another developer due to the version conflicts or the compatibility problems on her system. And this leads to inconsistency and issues in the development environment, and it also makes the developers or it also makes difficult to produce these issues, because it's because of the environmental conflicts, right? So the point that I'm bringing over here is same piece of code is working on one developer's machine, but it's not working on the other developer's machine. Okay. Now, to solve the problem, what could be the solution to this problem? Now, of course, the solution to this problem is Docker. So to solve this problem, Sarah's team decides to use Docker, and what they decided is they will containerize the application using Docker, create a Docker image that will include everything like its application code, dependencies, required environment, and everything that the application needs to run. So earlier they had a shared environment wherein they just had the code, right? Now what they will have is they are going to have a container sort of thing, a container which is going to have the application code. It is going to have the dependencies, and also it is going to have the required environment configuration. Okay, so all the dependencies, right? So everything is packaged into a container and it is stored on the shared environment. Now, how will it work in the scenario? So let's say Sarah has, the container with the code. Now, this is not just a container. It has everything that the application needs to run. So it has dependencies, the environment configs and everything. Okay. And this code, this container, in fact, is basically then pushed to the shared environment. And John also has this shared environment. Now, the thing over here is if there are any updates on the John side, so he will update it over here, and basically it's updated into the container. And then everybody has those same changes. So if it's working on John's machine now, there's no way that it won't work on Sarah's machine. So I hope this is making sense as to how we are able to solve the problem over here that existed amongst developers who are working in a team. And this is very common. If you are an experienced developer, you even might have encountered this kind of scenarios, right? So now it's time that we define Docker. So what is Docker? So Docker is an open source platform that allows you to automate the deployment, scaling, management of applications using this technology of containerization. Now, containerization is a lightweight virtualization technology that enables you to package an application and its dependencies into a standard unit called a container, like we just saw in our case. So everything that the application needed was packed up into a container, and then it was shared amongst the developers. Now with Docker, you can create containers that encapsulate everything. Now, and everything meaning it can include your application code. It can include the runtime environment that the application needs. It can include all the libraries that your application needs to function. And it can even have the system tools. So all of this can be packaged into a Docker container. And these containers are very portable and they can be deployed on any system that supports Docker. Okay, and this ensures consistency, and it also eliminates this phrase that this works on my machine and I don't know why it's not working on yours, right? So this is a very common phrase amongst developers you would hear if you happen to work in teams. Okay, now once we discussed Docker, I also wanted to shed some light on this amazing concept that exists, which is the concept of virtual machines, because generally learners have a confusion when they are learning Docker that, hey, this seems similar to virtual machines. How are they different? Okay, so I'll just clear this air out over here. So in virtual machines, now what are virtual machines? Virtual machine is like separate computer inside your computer. So to define virtual machine, you can think of a virtual machine as a separate computer inside your computer. And you create a virtual machine which is a software emulation of a physical computer system, and it allows you to run multiple operating systems and applications on a single physical machine, as if you have multiple computers within that machine. Okay, and each virtual machine will behave like a separate computer, as you can see on my screen. And virtual machines are created and managed by virtualization software. So there are virtualization softwares that exist, and they will allow you to create virtual machines. Okay, so see, imagine you have one powerful computer and you want to use it to run different operating systems, different applications that may not be compatible with each other. Okay, so instead of buying separate physical computers and using them to host operating system and running those applications, what you would do is you will have one powerful computer, and within that, using the virtualization software, you will create multiple virtual machines that will run their own operating system, and it will also run the application that you wish to run. So it's like you are creating a computer within a computer. Okay, so like I said, each virtual machine behaves like a separate computer. So it is going to have its own virtual hardware. It is going to have its own CPU. It's going to have its own memory, storage, network interfaces, everything on its own. Okay, and you can install and run different operating system like Windows, Linux, or macOS on each virtual machine, and they operate independently. They isolate the resources and software from the host system. Okay, so it's not like you're buying separate physical computers. You just have one computer, and on that you have bifurcation, and you have different virtual machines that you have created that will make use of resources of the host hardware. Okay, so for example, if you have 18 GB of RAM, for example, or 16 GB of RAM, let's say, for example. Okay, and you created two virtual machines, so you can allocate 5 GB to both the virtual machines, something like that. Right? So basically they have their own set. So one virtual machine is going to have 5 gig of RAM it's going to use, and you can also assign a hard disk, let's say 100 GB of hard disk you can assign to that virtual machine. So that virtual machine is only going to operate within that limit. Okay, so and that's enabled by virtualization software, and there are different virtualization software like VMware, VirtualBox, or Hyper-V. Okay, you can just search for these names, and these software will provide you with the necessary infrastructure to create, run, and manage all the virtual machines onto your system. Okay, so it is going to allow you to allocate resources to each virtual machine. Like I said, which virtual machine should have how much of resource, how much of RAM should it use. All of that will be provided by this virtualization software, and it can even allow with some additional functionality like taking backup, snapshots of the virtual machines, and startup shutdown is a standard functionality that you will have to control. Okay, and the advantage of having virtual machine, like you must be wondering that, hey, why do I need to create virtual machines? So the advantage they provide is to have a flexible and a scalable way to utilize hardware resources. All right, now you have single machine, like I said, that's very powerful. Okay, you want to run 3 operating systems, and you want to have three machines essentially, or 3 computers running. So instead of buying separate hardware, okay, you can basically do that in the same machine itself, and you can allocate hardware resources. Okay, and yes, all the instances of the virtual machines will be isolated from each other. They are not going to conflict. And why are they not going to conflict? Because that is how virtualization software manages them. Okay, so that is how virtual machines function. Now, let's talk more about virtual machines and how they differ from Docker. Okay, so here you can see this is how virtual machines will look like. So you have machine over here, then you have the host operating system. Okay, so this is the machine here. Then you have the host operating system. You have something called as hypervisor. Now, hypervisor is a thing that helps you run and manage virtual machines. Okay, so these 3 things you will have on your host system. Okay, then what you would do is whenever you create a virtual machine, so you are going to have guest operating system. Okay, you're going to have libraries and binaries that is needed for the application to run. So this is the application that you want to run, application A, let's say, and you want to run it in a virtual machine. So you will create a virtual machine with an operating system, library, and binaries that the application needs, and the application itself. And this entire package is called a virtual machine. Okay, now one thing I'll tell you, you might have Windows, Mac OS on your host machine. Host machine meaning your own machine. Okay, then on that machine you are creating a virtual machine, right? So virtual machine can have any sort of operating system. Like for example, if your host OS has Mac OS, you can have Windows installed on the host or the virtual machine. Right, so this virtual machine will have Windows installed, and your application will run on Windows. And then you can have one more virtual machine for application B. This is a separate virtual machine. This is also going to have its own copy of guest operating system, like I said, libraries and binaries for the application to run, which is application B, and application B itself, the source code and the running instance of application B. So all of this becomes second virtual machine. So you can have Windows over here on the first virtual machine. Second virtual machine, you can install, let's say, Ubuntu Linux. Okay, then you can have third virtual machine wherein you are running a second instance of the same application B. So here you are running application A, you have application B, and then on the third instance of the virtual machine, you are again running application B. And this also has its own copy of guest OS. Like I said earlier, libraries and binaries that are needed by the application B to function. Now, all these three guest OS can be same or different. It's your choice, right? Because they all are isolated from each other. So for example, application A can have this first virtual machine can have Windows operating system. Application B, or the second virtual machine, or the virtual machine on which application B is running, can have Mac OS or Ubuntu, let's say. And the third virtual machine can have another version, or another Linux, or let's say a normal Linux, basically, or Red Hat Linux, or something like that. Okay. So it depends on what sort of operating system. See, choosing your operating system is your choice. Okay. When you create a virtual machine using the virtualization software, you are going to have an option to select the operating system, right? Which is the operating system you wish to have on this virtual machine. So all of that you can set up and you can create virtual machines like this. Now these are all running in isolation. Okay, these are all running in isolation. Now there is another there is another way which is using Docker. Now over here, what you saw is these are three machines running on your machine, right? This is like a three computers running on your machine. And your machine also has a host OS, right? So there are 1, 2, 3, 4 operating systems running right now on your system, right? Now, if you talk about Docker, Docker has your machine, it has your host operating system, then it has something called as Docker engine, which is used to manage and communicate with Docker images and Docker container, right? Now, Docker by concept uses something called as containers, which are lightweight isolated compartments that contain only necessary thing to run your application. Okay, let me explain this better because this is important. So here in virtual machines, you saw you have entire copy of guest OS. So this virtual machine has entire copy of guest OS. This has another copy of guest OS, another copy of guest OS. Okay, so let's say you install Windows in this first virtual machine. Now your application does not need the entire copy of Windows to run, right? Let's say your application just needs three things, okay, three components, okay, not the entire copy of Windows. But with virtual machines or with virtualization, you still have to install the entire copy of Windows because that is how it works, right? But when it comes to Docker, you don't install operating system, but instead you just have what is only needed by the application to run. Okay, so it's like a container being created. Okay, it's like a separate machine wherein the application is running, but it's not having the entire operating system. It just has things that your application needs to function. Okay, so for example, if I wish to run app A in an isolated manner in a container, so what I'm going to do is I'm going to create a Docker container, and it's just going to have the necessary libraries and binaries that the application needs to run. Only those things. Okay. And with this, it becomes very lightweight compared to the virtual machines, because virtual machines, you are running three operating systems here. Okay. But if you create three similar Docker container, it's going to be lighter than running three virtual machines. I hope this is making sense. And I hope I'm able to make a point as to why it's lighter. Because here you are running the entire operating system, right? You might run Windows over here, you might run Ubuntu over here, you might run Red Hat over here, some other operating system over here, right? So the entire operating system is running on your machine, and your machine also has an operating system, right? You have installed Mac OS or Windows on your machine, right? So it's using your system resources. So it's heavy. Okay, does your application need all the components of the operating system? It might not. Right? It might not need. It might be a simple application. So that is where Docker comes in, and Docker says, like, I'm going to create containers that only need things that are needed by the application. Okay, and this makes Docker pretty much lightweight. The Docker containers become pretty much lightweight and easy to run and manage. So here you have application A, which has libraries and binaries, application B, which has libraries and binaries that it needs, and you have another instance of application B, which has libraries and binaries that it needs to function. Okay, I hope this is making complete sense. This is very important from understanding the difference, from the perspective of understanding the difference between virtualization and containerization. Okay, and this is where a lot of people get confused. And I've tried to explain this in the simplest possible manner. Okay, I hope this makes sense. Now, let's talk about a few differences between virtual machines and Docker containers. Okay, so if you talk about the differences over here, the size of virtual machines are relatively large and resource intensive, right? And Docker containers, on the other hand, are lightweight. Okay, so this is one major distinction, because virtual machines run their entire copy of operating system, and a lot of components that you are running on might not be necessary. But with Docker containers, you only have things that are needed, and hence it becomes lightweight and resource efficient for you. So you can run a lot of containers together, even on a system with lesser capacity, right? Startup time. Now, when it comes to startup time, of course, virtual machines will be heavy because they are running full operating system. So they'll need more time to start. But when it comes to Docker containers, they will be instant, because startup time will be lesser because operating system boot is not required. Okay. Resource utilization. Now, when it comes to resource utilization, okay, connecting all the dots that we have discussed so far, virtual machines is of course going to use up much more resources. But with Docker containers, you will have fewer system resources that are being used because it's lightweight. Isolation. Okay, so strong isolation is provided between virtual machines. Okay, when it comes to virtual machines, but in Docker containers, containers are isolated, but it shares the host operating system kernel. So if you are running Docker containers on your system, okay, it is going to make use of your operating system kernel, whichever is running on your machine. Okay, because it does not have its own OS, right? So that's completely okay. It does not come across as a disadvantage. Portability. Now, virtual machines are portable, okay, but they need OS compatibility. But when it comes to Docker containers, they are highly portable and independent of the host operating system. So this is one major thing that comes across. Now, talking about scalability. So virtual machine scaling require provisioning of new virtual machines. Okay, so you have 3 virtual machines already running. You want to scale, you will need to provision 5 virtual machines, for example, 5 more. Okay, if you want to scale to 5 more instances. Okay, but with Docker container, it is easier to scale by creating more containers. You don't have to provision the entire operating system and all, because they are lightweight, right? Ecosystem. Now, virtual machine specific tools and if you talk about the ecosystem over here, virtual machines will work with the virtual machine specific tools and management framework, and Docker will work with the Docker ecosystem and the tooling that they have, right? Development workflow. So virtual machines, of course, will be slower to set up, and provisioning process will be slower. Docker containers are faster, and dependency management is also better. Deployment efficiency. For deploying virtual machines, you will need more overhead due to larger VM size. But Docker container, it's efficient with smaller container size. Okay, so I hope this had made complete sense as to what are Docker containers, what is Docker, the problem it solves, how it works, how it differs from virtual machines. I hope this has come across really, really well. Okay, and lastly, I would want to sum up, like, why should you use virtual machines? Why should you use Docker over virtual machines? Why should you do that? Because Docker is efficient. Okay, Docker containers are lightweight. They use few resources. There is portability with Docker. Okay, Docker containers are highly portable. You can port them across machines as long as the other machine supports the Docker ecosystem. Okay, speed. Docker containers start much more faster. They stop much more faster. And isolation. They provide a great isolation as well. Okay, like VM. Okay, so they don't interfere with each other, the Docker container. So I hope this sums up, and I hope you have understood the importance of Docker and how they add value to a developer's life and their workflow. So now it's time that we begin talking about some of the terminologies and concepts that we often refer to in the world of Docker and containerization. And it's important that you understand these terminologies well before moving forward. Okay, so first thing that we would want to discuss is Docker images. Now, what are Docker images? So Docker images, you can think of them like templates that define what a container should have and its dependencies. It's like a blueprint that exists over there. And containers are basically the runtime environments that are created from Docker image. So you can think of container as a running instance of your application that is derived from the image. Okay, so basically you have image that exists there, which defines how the container would run and what all dependencies it would have. That is what the image is. And then from images, containers are created, and the container is nothing but a running instance of an image. Okay, we'll understand this further. Don't worry if it's not clear yet. Don't worry, we'll understand this further. And then you have something called as a Dockerfile. Now, what is Dockerfile? So Dockerfile is like a instructions file. It's a file that contains the instructions to build Docker image, right? So we are talking about images, and that image should have all the dependencies and necessary things that is required for a container to run, right? That is what an image should have. But who provides that definition, right? It has to be defined somewhere. So that definition is provided by this file called Dockerfile. Right? So Dockerfile defines the instructions that are needed to build a Docker image. Okay. Once the image is built, images are nothing but like a template that helps spin off container. And then containers are nothing but runtime environments that are created from images. So you can call container as the running instance of the image. Okay. Now, to summarize this in the form of a diagram, this can help you understand better. So here on the left hand side, you can see Dockerfile. It has the image definition. Then you have the Docker image, right? So basically, image definition will have the definition of the image as to what all the image should have, what all dependency the application should have, how to run the application, because you might be running different kind of application. You might be running Python, JavaScript, you might be running Spring Boot. Every application has different needs, and there are different ways in which the application run. For example, running a Node.js application, Spring Boot application, and Python application, they all might vary. Right? You cannot run a Spring Boot application the same way you might run a Python application. So that would vary. So all of these instructions will go into the image definition, which is Dockerfile. Then using this Dockerfile, a Docker image is created. Right? And Docker image, like I said, it's like a blueprint for your application or the container. And it's a lightweight read-only thing that your container will use to run. Right? And then what is a container? So container is just a running instance of the image that exists, right? And basically it will have your application running as well. Now, from a Docker image, it's possible to have multiple containers running. So if you have a Docker image created, it's not like you can just run one container from that Docker image. You can run multiple instances of your application in separate containers. So you can have multiple containers up and running. Now, another terminology that you will hear is image layer. So what is an image layer? So every image is made up of multiple layers that is stacked on top of each other. So you can see this in this diagram over here. You have this Docker image, and this Docker image consists of multiple layers. Now, why are layers used when it comes to Docker images? So the reason is rebuilds are faster, okay, and a layer can be cached. Okay, that is one reason. It improves the performance, and if there are multiple Docker images that are making use of similar layers, then that reduces the storage space because it is going to reuse a particular layer across multiple images. Okay, so basically that is the reason. Basically, from efficiency point, the performance standpoint, and even storage standpoint, images have layers. I hope this is making sense. And then you will hear the concept of Docker Registry as well. Now, what is Docker Registry? A Docker Registry is just a storage service for Docker images. So it's just a place where images are stored remotely. Okay. So understand this, okay? You have your source code residing on your local machine, okay? If you're using version control system, you would want to push it to a remote cloud like GitHub or Bitbucket, right? And you may be using a particular version control software, and you do this so that you have your source code available on a remote cloud that can be accessed by other people, your team, and it also serves as a backup for you just in case your local machine or local system fails, right? Similar way, for Docker, you have your Docker image on your local machine over here, right? Now you might want to share this or make this image available across the globe, across the internet, amongst your teams. So how are you going to do that? Or you might want to even move it or delete it from your local machine and have it stored in the remote cloud just in case your system fails. So in that case, you will make use of a Docker registry, which is a remote cloud, which exists in remote cloud, where you can push your Docker image. So this thing of moving your image from local machine to a Docker registry is called push. So you push your Docker image, and your Docker image will reside in a Docker registry. Okay, and Docker registry can be accessed by anyone in the world, and they can access your Docker image and use it. And of course, there are concepts like public and private repositories. You can have public images or private images. Okay, if you don't want the image to be publicly available, you can of course do that over there. Okay, but that exists. Then there is a concept of Docker tag. Now, what is Docker tag? So whenever you create a image, okay, you can assign it a tag, and tag is simply a label or a name that is assigned to the image version. Okay, so for example, you are working on an application, and let us say that application is your development version. So you can have app name : dev over there. So that tells that this is a development version. So similarly, you can see some tags over here. So this is my app is the image name, and prod means it's a production version. My app is the image name. Version 2 means it's version 2, v2. My app is the image name, and latest meaning this is the latest image available. Okay, so these are some examples of the tags that can exist for an image, right? So this is about tag. So there is one more concept that I would want to touch upon, which is Docker Engine. And Docker Engine is a runtime that is doing the job of managing the container. So this is one of the concepts that you will often hear when it comes to Docker and containerization. I hope this has been useful, and I hope whatever we discuss is clear. So now it's time that we begin talking about Docker registries, and it's an important concept. I will talk about what Docker registries are and what are the different registries that exist. So Docker registry, first of all, it does the job of storing your container images. Okay, now one question or one thing you might ask me is, hey, I can store it on my local machine too, right? I created a Docker image. I can store it on my local machine. Why do I need something called as Docker registry? Okay, so let me explain this to you with the help of the analogy of your code. You wrote some code, okay? You have version control system like Git on your local machine. You are tracking the versions of your software, right? Now, despite you having your code on your local machine using version control system locally, you might want to push it onto a remote service like GitHub or Bitbucket, right? Why do you do that? Because having source code just on your local machine is risky. Tomorrow, if something happens to your local machine, you're not able to access it, you lose your source code. And also, having your source code hosted on a remote platform enables you to do team collaboration, so that tomorrow, if your team grows, you have different people working, and they all can access the source code, and it's basically a team driven building that you are doing, right? Same goes with images. You have images created on your local machine, okay? You want to store it remotely on a cloud so that anyone can pull the image, use it. So in that case, you will make use of something called as Docker registry, right? So this is where Docker registry comes into play. Now you can think of Docker registry, like I said, just like a storehouse for your Docker images. And just like you push and pull and pull your source code, you can push and pull your images as well to and from the registry. All right. Now let us come over to the browser and let us take a look at some of the Docker registries that exist. All right. So sorry for the light mode over here. I could not figure out the dark mode on this website, but just bear it with me. This is docker.com. So we'll talk about different services that offer Docker registries and the differences between them as well, which one to choose when you're beginning and all of that stuff. Okay. So just hang in there. This is docker.com, the official website of Docker. Now, if you come over here, if you go to product, you'll see something called as Docker Hub over here. So Docker Desktop is the software which enables you to use Docker on your local machine. But if you want to store your Docker images remotely, you can make use of the official registry over here, which is Docker Hub. Now, if I click on this, okay, if I click on this, you'll see this Docker Hub up here. And here you can see this is the entire Docker Hub. Now you can see some stats over here. So Docker Hub, basically, before we move any further, I'll mention like Docker Hub is the default registry for Docker. So if you're pushing and pulling images and if you don't mention the registry, by default, it's considered as Docker Hub. Okay. And there are so many images over here, and these are like monthly unique IP addresses that access the site. Okay, so there are a lot of official images as well, okay, which we'll talk about, but you can just go through this website. Now this website keeps on changing. They might alter the design and all. So depending on when you're watching this video, you might see something else over here. All right, but that's absolutely okay. Don't worry about it. So Docker Hub, and this is what the interface looks like. And here you have an option to choose a plan. You can get started over here. Choose a plan meaning, yes, they have paid plans as well with additional features. But if you're starting out, generally free version is enough for learning. Okay, so you don't need a paid version unless and until you need some specific features. I have been using free version itself for so long, and free version just suffices. Okay, so if you're building projects, doing a lot of things, you just stick to the free version and just sign up over here. So if you click on get started, you will be taken to this particular page wherein you can sign up over here. Okay, so this is Docker Hub. Now I'll tell you something. Docker, the pro of using Docker Hub is basically it's easiest to use. Millions of official images you will find over here. It's great for beginners, and all the public images are free over here. Okay, so that is something that you can. And generally, when developers start their journey, when they start learning about Docker and all, the first thing they use over here is Docker and Docker Hub. Okay, so they start actually with Docker Hub and not with the other registries that exist. Okay, so this is your starting point over here. And yes, talking about the official images over here. So you won't see any images over here without signing up. It's asking you to create an account, but I would recommend you come over here to hub.docker.com. Okay, Docker Hub. So this is hub.docker.com, which is the official Docker registry. Come over here, and here is where you can browse all the images. Okay, so this product actually you saw over here, Docker Hub, this product. This is hosted on this domain, hub.docker.com. So just come over here. It has a fantastic dark mode, as you can see. You know, it's built for developers, right? So here you can toggle the dark mode, light mode. Okay, I love dark mode. So you can see dark mode, and here you can browse all the images. So for example, here you can see generative AI based images, like AI models over here, MCP servers. Okay, you have different categories over here, and you can see a lot of official images. Now, what do official images mean? Official images meaning images that have been put out by someone who is officially behind it. For example, this is the official image of TensorFlow, and it's being put out by TensorFlow itself. Official image of PyTorch, LangChain, official image of Python. You can see over here. So you can actually pull this image and you can run Python source code without installing Python onto your system. You know, it's that powerful. So you can see a lot of images over here, MySQL, Postgres. You can just browse through and you can click over this, and these are all official images, right? So you can just play around with this. If you click, you will see the detailed page over here. Okay, with some commands as to how you can get the image onto your local machine and all. Just the overview of the image size, last updated, everything around this image. Okay, you can see tags and all as well over here. Okay, so this is Docker Hub. Hub.docker.com is where you can access it. And if you want some additional details, you can go to the official website and check the additional details. Now over here, you can create a free account. Okay, you don't need a paid account, like I said. If you're starting out, free account is recommended. You don't need paid for anything as of today. All right. So that's something about Docker registry. And yes, it's best for learning, putting out open source material out there. This is the best site over here. If you're building some open source software and you want to expose the images or publish the images publicly, this is the best site. Okay. There are lots of open source projects hosted over here, by the way. Okay. So this is Docker Hub, which is officially from Docker itself. This is the official registry and the default one too. So now just come to Amazon over here, which is aws.amazon.com. Click on products. and just go over here and say browse all products. So there are tons of products that AWS has, and here you should search for ECR. Okay, so if you search for ECR, it stands for Amazon Elastic Container Registry. ECR, Amazon ECR. Okay, so this is the registry. So if you click on this, this is the registry by Amazon that allows you to easily store, share, and deploy your container software anywhere. Okay, and like the name says, it is basically AWS behind it over here. Okay, and this is also being used by a lot of organizations, to be specific. So if your organization is making use of AWS for a lot of things, like for example, it's using EC2 instances, they have Kubernetes on AWS, so they will prefer Amazon ECR to store and manage images. Okay, and yes, it's a product coming in from Amazon, so it's best. It's basically best for working inside the Amazon ecosystem. Okay. So this is one option you have, and then you also have a product from Google Cloud. And if you come over here to cloud.google.com, go to products and click on containers, and here you will see this artifact registry. So the registry by Google is called as artifact registry. You can click over here and you can just go through the artifact registry. Okay, so you can basically publish your images over here with Google's artifact registry. Okay. With Azure, if you come, so Azure also has their own container registry. If you go to products over here, and let me look for here, you can see under container, you have, you should have Azure Container Registry. This is the one. So click on this, Azure Container Registry, and it's basically, you can see a registry of Docker and Open Container Initiative. Okay, so you can basically have your containers hosted over here. So if your company is preferring Google, you can make use of Google Container Registry, Google Artifact Registry basically. And if you're making use of Azure for hosting your applications and all, then companies generally prefer making use of Azure Container Registry and staying in the Azure ecosystem, because integrations and all is easier over here. But if you're not in Amazon ecosystem, not in Google ecosystem, not in Azure ecosystem, then companies or people, individual developers prefer Docker Hub, because that's the easiest and the default one available there. Okay. Now also I would want to talk about this concept of public and private repositories, or public and private registries, not repositories. Okay. Repositories is in source code. Okay. So what is public registry? Like the name says, like it's the registry is public. Anyone can access, pull image. Anyone can see what all images are there. Anyone can check the image. Okay, and use it. And private registries is only restricted. It's restricted to you or to your team. So if you're doing a development team, and if you want that registry to be accessible to your team so that anyone in the team can push images, so that's something you can do. So if you're basically building a software in a company, you have a team, so you will make use of private registry because you don't want your development work and everything to be exposed to the outer world. So you will make sure that the access is restricted to the team itself. Okay, but if you're building something open source, you want it to be public, so you can make use of public registries. So there's a difference between public and private registries. I hope this has made sense, and you got a good hands-on overview of different registries that exist in the world. So now it's time that we begin talking about the architecture of Docker. So let's discuss Docker architecture, and I'll try to make it as simple as possible so that even beginners amongst you can follow it easily and understand what are the different components and how are they working together for you to deliver amazing experience. Okay, so first thing, we start talking about the host operating system that you can see over here. Now, what is host operating system? Host operating system is the operating system where Docker is running. So if you're running Docker on your machine, your system becomes the host operating system or the host machine. And this is where the CPU, which is the compute power, is allocated to Docker. The memory is allocated to Docker, networking resources are allocated to Docker, and also a little bit of file system is allocated to Docker to store and manage images and containers. Okay, so host OS is simply the machine or the system where Docker is running. Then next comes a few components. Okay, don't get overwhelmed by these components. I'll explain everything bit by bit. Okay, so Docker daemon. What is Docker daemon? Docker daemon is a component. Docker API is also a component, and Docker CLI is also a component. So what is Docker daemon? Docker daemon is like a heart of Docker. Okay, it's actually the heart of Docker, and this is who does all the work of managing images, containers, starting the containers, stopping the containers, building the images, pulling and pushing from the registry is all done by Docker daemon. Okay, who does it? So what is the heart of Docker? It's Docker daemon who does the job of managing, maintaining containers, images, pushing, pulling from the registry. All the work is done by Docker daemon. Now, what is Docker API in that case? So Docker API allows you to interact or send requests to Docker daemon. Okay, so Docker daemon is exposed via Docker API internally. Can you access API externally? No, it's internally. Okay, and then you have Docker CLI, which is a client that allows you to interact with Docker. Okay, so CLI meaning command line interface. So if you're running commands related to Docker, so if you use Docker down the line, you will be running Docker related commands. Those commands are basically given to CLI, or those are intercepted by CLI, and then it goes to API, Docker API, and then it is communicated to Docker daemon, and then the action performs or action happens based on whatever command you have run. Okay, and all these components are together called as Docker engine. What are they called? They are called as Docker engine. And so Docker engine is one term that you will hear very, very often during installation, during using Docker. You'll hear this term very often, Docker engine. So Docker engine has three main components. One is Docker daemon, which is the heart of Docker. It actually does all the job of managing, maintaining Docker images and Docker containers, as you can see over here. Then you have Docker API, which allows you to interact with Docker daemon. So it acts as a messenger between Docker CLI and Docker daemon. Okay, it's a way in which you can communicate with Docker daemon. And then you have Docker CLI, which is nothing but the command line interface, Docker command line interface, which allows you to interact with Docker using commands. And generally, you will be running Docker commands on your terminal, and those commands are intercepted by CLI, then given to API, and then Docker daemon does the job. And this entire Docker engine is running where? On your host operating system. Okay. And your host operating system, like I said, is doing the job of allocating resources, CPU, memory, networking resources, and even file system for storing everything. So this is how Docker functions. And then remotely, you will have Docker Registry, where you will host images and you will pull the images locally onto your system. And Docker daemon will actually do the job of pulling the images from the registry, and it will store the images locally. And then if you want to run containers out of it, or if you want to run images, it is going to run Docker containers for you. Okay, so this is the entire architecture simplified for you. Okay, and now when we talk about Docker, you generally have your machine, host OS, and you have Docker engine, right? So you have your machine, which is your machine hardware. You have host OS and then Docker engine. So this is applicable if you're running Docker on your system. Okay, if you're running Docker remotely on any cloud provider, then you will have a virtual machine over there, like a machine, host OS, and Docker engine. And over there, within Docker, like Docker engine, over the top will have libraries and binaries, and your application basically packed into a container, and you can have multiple containers running over there. Okay, so this is the entire architecture of Docker. I hope this has been useful, and I hope you all have been able to follow it with ease. So now it's time that we begin talking about installing and setting up Docker onto your system. We are going to set this up onto our system because we want to have the ability of running and managing containers onto our system as well, right? And for that, we will have to come to docker.com, and here you will see this option of downloading Docker Desktop. So you can download directly from here, but you can do it from here. I'm not going to show you this way because this is of course straightforward, but I'll take you to the documentation where you will find additional information and step-by-step guides on how you can proceed with the installation. Okay. So I'm going to touch on Docker Docs. Okay. So here you can click on developers and click on documentation. Open this over here. Yes, of course, you have download links everywhere. So it's not just on the website where you can see the download links, but you have download links everywhere. Okay, you can see. So come over here, click on Get Started. And then over here under Introduction, you will have this option of Docker Desktop. Okay. Now, one thing I'll mention over here, Docker Desktop is the easiest way to get started with Docker onto your machine. So if you're learning Docker, there is a software or an application called Docker Desktop that you have to install, and you have to make sure that it's running whenever you are working with Docker. Okay. So Docker Desktop, you have to come over here. Okay. You click on Get Docker Desktop, scroll down. And now over here, you can see you have Docker Desktop for Mac, Docker Desktop for Windows, and Docker Desktop for Linux. So let us discuss steps for each one. But I'll tell you something, the steps does not vary a lot. Only there are few things that I want to discuss for each operating system, and I'll make sure you're up to speed. So first, for Mac, you have the Apple Silicon chip version, you have the Intel version, and then you have the install instructions. Now, if you are making use of Apple Silicon chips in your Mac machine, you have to download this, and this goes without saying. You can download this for Intel-based Mac machines. Install instructions. So install instructions are very straightforward. Okay, I'll just take you through the installation steps, but you have to make sure that you have the supported version of Mac OS and at least 4 GB of RAM. Okay, so just make sure you have that, and then you will basically, once you download, you get this Docker DMG file that you can open, double click, and you can drag it to the applications folder, and the installation is done. Okay, it's very straightforward. Okay, so just do that, and I'll come back over here. Okay, so coming to Windows, we'll click on Install Instructions. Now, if you go to Install Instructions, you will see there are quite a few versions of Windows, the Windows version. Okay, so you will see x86-64. And then you have x86-64 ARM. So if you have ARM based PC, then you need to download this one. But how do you check if your PC is ARM based or x64, x86_64 based? Okay, so for that, I'll tell you. So you have to hit your start button, the Microsoft start button, search for settings, just go to settings over here like this. And once you come over here, you can go to system. Okay, so here you have system, and then you scroll down over here, and you will find about over here. Okay, and if you scroll down further, you will see the device information at the bottom somewhere. Okay, over here, device specifications, and here you can see that I am on x64 based processor. Okay, so if you have x64 based PC, you have to get the AMD version. Okay, AMD 64. Otherwise, if you have ARM over here mentioned, then you have to get the ARM one. Okay, so this is the x64 one. So this is the one for me. So I'm going to download this. Just download this. If you see ARM over there, you have to click on ARM. Okay, so just do that. And if you're on Linux, so I'll go back, and here on Linux, if you go to install instructions, okay, depending on the platform, there are different install instructions like Ubuntu, Debian, Fedora, and Arch. So basically, if you're on Debian or if you're on Ubuntu, okay, click over here, and you need to basically install this, and then you need to run this command. Okay, that's it. The installation will be done. So this is for Linux, but let us now install the software over here. Now, since I'm on a Windows machine, okay, I double clicked on the .exe file that got downloaded onto my system. Okay, so I had downloaded the installer, which is x64 based installer, which is the one for my machine. I installed that. I downloaded that, and I double clicked on the exe file. Now I see something like this, installing Docker. So these are the default options. Use WL2 instead of Hyper-V recommended. So I've checked that. Add a desktop shortcut. This is optional. I don't want to add a desktop shortcut. If you want, you can add. And I'll just say OK over here. And you can see it's processing everything and it's finishing the installation. So we'll wait until this finishes. And you can see a progress bar at the bottom. Okay. So we'll wait for a while until this progress bar finishes. So now over here, I see the progress bar was complete. It took a while, a few minutes, and the installation has been succeeded. Okay. Now I'll say close and I'll open Docker Desktop from my applications list. Now, if you are from, if you are on Mac, okay, it will be just drag and drop for you in the applications folder. If you are on Linux, okay, you have to run the command line like I showed you over here, install instructions. You have to just run the command basically based on the operating system or based on the Linux version you are on. Okay, and then basically you can launch the Docker desktop on Linux. Okay, it's pretty straightforward, not that difficult. And now I have launched Docker desktop for the first time, and you can see this pop-up over here. Okay, this is a pop-up that is asking me to accept the subscription service agreement. I'll just say accept. You can read more if you wish to, or if you're curious. So these are the same steps. Now after installing Docker, the first experience is same for all Windows, Linux and Mac. Okay, so just say accept, and then you will see something like this. Okay, so it's asking me to create an account on Docker. Okay, now you can create an account on Docker. I highly recommend that. You can enter your, so click on personal and you can enter your email address. If you have a work email address, you can select work and enter that. Okay, but if you have personal, you can use personal, and you can create an account. I highly recommend that. But if you happen to skip it, if you don't want to do it right now, you can also do it later. Okay, so you will have an option over here to sign in, which will ask you to create an account. All right. Now here, this is the first interaction with Docker. Okay, so what I will do is I will quickly create an account by hitting sign in, and I'll make sure that I have a registered account in my Docker desktop app. This is important. I'll tell you why. Because if you want to push images from your local machine to a remote registry like Docker Hub, then in that case you would need an account, because it's going to register everything, the images, against your username, right? So you need an account. So just say sign in and create an account. It's free anyways. It does not cost you anything. Now, once you're done with the installation, you have to make sure that Docker desktop is running over here. It's open. Okay, and just open any sort of inbuilt terminal on your operating system, whether you are on Windows, Mac or Linux. Just open any sort of terminal. So here I'm on Windows, so I've opened PowerShell. Now we are going to run a few commands and verify our installation. Okay, so first command I'm going to run is docker -2 times and version. Okay, so the moment I press enter, all right, okay, I made a spelling mistake. It's version. Okay, so that is why it did not work, but you can see the version number is being printed. Okay, and you can see the build number also being printed. I'll just clear everything out and I'll just run this again on a fresh screen. Okay, so you can see Docker version, and this is a version of the Docker installed onto my system. This should ideally work on your system, and this verifies that Docker is working properly. Also, you need to, if you need to check the Docker engine info, so you can say Docker, and you can say info over here, and it will just give you the information around Docker engine and everything. Okay, so you can see there is a lot of information that has been pushed out. Okay, so it's long. Okay, but you can check it just for the sake of it. You can see client version and everything over here. Okay, so this is about Docker information. You also need to check Docker Compose and then version. So Docker Compose is just another tool which you can use to manage multiple containers and run Docker Compose files. Okay, don't worry if you don't know these keywords, but just run Docker Compose version and you should see Docker Compose version being printed over there. Okay, so yeah, these commands verify the installation, and with just one tool, Docker desktop, you have all three working on your local machine, whether it's Windows, Mac or Linux, and that verifies that we have Docker up and running properly onto our system. Now, one thing I would like to highlight over here, whenever you are running Docker based commands or working with images or containers, you have to make sure that Docker desktop is up and running. Okay, so you have to make sure that Docker desktop is up and running. If it's shut down, then these commands won't work. I hope this helps. All right, so now's the time that we get some experience with Docker, and we create and run our first container, and we also get some image locally onto our system. All right, so what I'm going to do is I'm going to explore some pre-built images that have been hosted already on Docker Hub. And for that, I'm going to come to this website, which is hub.docker.com that you see over here. And here I am going to search for hello-world. Okay. Now, like any programming language, you start with hello world, right? Hello world comes first. And whenever you're learning something, you make a program that displays hello world. So same is the case that we are going to follow with Docker. And here you can see this image hello_1 hello_world, sorry. And here you can see this batch. If you hover on this, you will see that this is a Docker official image. So just click on this, and if you go over to this is an official image. You can see the number of pulls that you have had over here, which is 1 billion plus, and this has been starred over 200 or 2,500 times. Okay, and here if you scroll down, you'll see all the information about this repository. Okay, and what you need to do is here you can see over here, this is the command. So here you can see example output. And you can see Docker run hello_world. So if you run this command, you will see this as the output, this complete output over here, right? And what I'm going to do is I'm going to copy this command, Docker run hello_world. I'm going to head over to our terminal over here. And on the terminal, you make sure, before heading over to the terminal, you make sure that Docker desktop is up and running, because without Docker desktop, you won't be able to run any kind of Docker command. So just make sure Docker desktop is up and running. Then I'm on Windows, so I have opened native terminal, which is, this is Windows native terminal, which is PowerShell. If you're on Mac Linux, just open any terminal that you have installed by OS on your system. So just open that and make sure Docker is running, like I said. Okay, now before running this command, I've pasted this command, but before running this command, if you come over here to containers, you won't see any containers. So you can see on this Docker desktop application, you have an option to see containers, images, you can see volumes and Kubernetes and everything, right? So I'm not seeing any sort of containers, neither I'm seeing any sort of images. So I'm going to say Docker run hello world. And the moment I say enter, you will see it says unable to find this image locally. So it is pulling this image from the library. Pull has been complete, okay, and it downloaded the new image. So this part over here that you could see is done to basically pull the image onto your local machine. Okay, so see this. You're trying to run an image. Okay, you're trying to run an image, and what happens is Docker starts looking for this image locally onto your system. If it's not able to find, then what it's going to do is it is going to look on Docker Hub for this image. Now, why Docker Hub? Because that's the default registry that is configured with Docker, right? So it's trying to look for hello world latest. Now, latest is the latest tag. By default, it's looking for the latest tag if you have not specified any tag over here. And you can see it's pulling this tag, it's pulling this image. The pull was complete. Pull meaning it is downloading that image onto your system. You see this hashed number over here. Then the status is downloaded new image for hello world latest. And then this is the output from the image. You can see over here, right? So you can see hello from Docker. This message shows that your installation appears to be working correctly, right? So Docker image is working correctly, and hello world message was also printed. And you can see over here, to generate this message, Docker took the following steps. The Docker client contacted the Docker daemon. Right, so we have Docker client installed. We have Docker client that contacted Docker daemon. Now, Docker daemon is a part of Docker desktop, right? And Docker daemon did the job of pulling the hello world image from Docker Hub. Okay, and this is AMD64, and the Docker daemon created a new container. So once the image was pulled, from that image a new container was created, which runs the executable that produces the output that you are currently reading. Okay, so Docker daemon created a new container from the image. Who got the image locally onto a system? Docker daemon. Who created a new container from the image? Docker daemon. And then Docker daemon streamed that output to the Docker client, which sent it to your terminal. I hope this is making sense, right? So to try something more ambitious, you can run an Ubuntu container with this command, right? So you can run an Ubuntu container with this command. It is also suggesting you, and you can share the images, automated workflows, and all on this website, which is the Docker registry, hub.docker.com. Okay, so I hope this is making sense. This is a fantastic image to get started with Docker and see what's happening, right? And it also gives you an explanation. So it's for beginners. And if you go to Docker desktop over here, so I accidentally clicked on settings. If you go to Docker desktop, under images, you're going to see this image, which is hello world over here. You can see the tag of this image available on a local machine is latest. This is the image ID. So every image has an image ID, and beside these, you will see the copy button. Okay, this image was created 4 months ago. Size is 20.34 KB, and this is an option for you to run containers from this image. So if you click this, a container will be created. Okay. And here you can see green dot. Now green dot means that this image is currently in use. In use meaning there is a container that is created with the help of this image. Okay. And here you have an option to delete the image. So if you have any sort of images that you wish to clean up your system, because images might consume, there will be heavy images that you will work on, and images might consume a lot of space onto your system, right? So you might want to clear up, and you can do that using this delete button. And then if you come to containers tab over here, you can see this container tab over here, and this container is now stopped. So if you see over here, it's exited. This dot says exited, right? And this is a container ID. This was the image that this container was using, and CPU percentage, there's no CPU percentage because this container is stopped, and you have an option to start this container again, right? If you click on this, you can see logs and all of this particular container, right? So yeah, this is how things worked. Now, one thing I would like to mention over here, you executed this command docker run hello world, right? So if you run, if you make use of docker run command, and if you specify an image name, if that image does not exist locally, what you saw over here is it pulled the image from Docker registry. But if the image existed locally, what will happen is, so if I come over here and if I run this command again, docker run hello world, then you will see it is not pulling the image again, and it is just directly running or creating a container from that image. Okay. So if the image does not exist, there is one additional step wherein the image is downloaded onto your local machine. But if the image exists, like in this case over here, okay, the image was not downloaded because the image already existed onto our system, right? So I hope this is making sense. And here now you will see there are two containers created from one image because you ran the command docker run 2 times. So 2 containers were created over here. Okay. So what is image? Image, like we know, image is a blueprint, okay, which provides the definitions for containers. And what are containers? Containers is a running instance of the image, right? And basically it has everything. It has its own set of dependencies and everything that is needed for your application to run and function. Okay. So yeah, this is what it is. And I hope this has given you a good overview and good first experience of Docker. So now is the time that we explore and try to make use of some images that expose something via the browser for us to access. Okay. And this will be interesting because this will allow us to work and play around with some more concepts around running images. Okay. So what I'm going to do is I'm going to again head over to this website, which is the Docker registry, and let us explore the image of Nginx. Now, Nginx. So you can see this is spelling not E, it's Nginx, Nginx it's called. Okay, so you can see this Nginx over here. If you're not aware of Nginx, what Nginx is, so it is an open source web server, right? And it exposes a page that you can access through the browser. So there is a objective of why we are playing around with this image, because without a lot of effort, we will have a Docker image running on our application that will expose something that we should be able to access, right? So you can see over here, this is Nginx. It's an open source reverse proxy server for HTTP, HTTPS, and all these protocols. Okay, it does a lot of work over here. So this is what we are going to run. So what I'm going to do is here, you can see the image name. This is Nginx, right? So I'll come over here, right? And I'll make sure that Docker desktop is up and running. And here, if you see here, we just have one image. So I'll come over here. I'll say clear right now, and I'll say Docker run, and I'll say Nginx like this. Oops. Sorry, so there's a typo over here. Docker run Nginx. Now, let me press enter and let us see what happens. Okay, so you can see it is unable to find this image locally. So it's pulling all the images remotely, and you can see the image pulling is happening in layers over here. You can see, and the image was downloaded, and you can see the image is running over here. Okay, you can see started worker, and there are a lot of logs that are coming in, right? So this is working fine. And here, if you scroll through, so this is all the logs. Now, let's say I wish to access the web server. So there is a page that is by default exposed by this web server, which is port 8080. Now, if I try to expose this web server post, so if I say localhost 8080, this won't work. This won't work. Why is this not working? Okay, because it's exposing the web page inside the containers port 8080. Okay, and I'm trying to access it from my local machine's port 8080. So it won't work. So in this case, there is a concept of port mapping that comes into play. Okay, so I'll shut this container. So you can see this this window is basically completely occupied over here, and this is different from running hello world containers, right? So in order to be able to execute, in order for me to be able to execute any sort of commands over here, I should stop this container by pressing Control C. So Control C on Windows and Control C or Command C on Mac. Okay, so this will exit the container. This will stop the container. Now I'll run a new command. Okay, I'll add some parameters. So I'll say over here docker run, and I'll say -p, and I'll say 8080 colon 8080, something like this. Okay, and I'll press enter. Now let us try accessing this. Okay, so let me refresh this, and you can see now you're seeing this welcome page. So welcome to Nginx. If you see this page, the Nginx web server is successfully installed, right? Have we installed it onto our local machine? Not really. So where are we running Nginx server? We are running it as a Docker container. And are we able to access it from a local machine? Absolutely yes, we are able to access it from a local machine. How does that happen? So this happens because of port mapping. So here if you see the command that we ran, okay, docker run -p 8080 colon 80 Nginx. Okay, so I'll explain what this thing means, because this is something new, and this enabled us to access the welcome page that is running on port 8080. Okay, so let me explain this. So see, whenever you are running a Docker container, okay, it's running like this. So this time we had Nginx running inside a Docker container. Okay, now what happens is whenever you are running Nginx inside a Docker container or anywhere on your local machine as well, you have access to a welcome page which is running on port 8080 inside. So this time, since Nginx was running inside a Docker container, this port 8080 was accessible or was exposed within the Docker container. Now this entirely is running on our local machine, right? So this is our computer. Now since this 8080 port is inside the Docker container, it's not accessible from our host machine, right? So if you have a let's say browser running over here, so let's say this is our browser. This is our browser, and if you try to access this port from here, you won't be able to access. Why you won't be able to access? Because this port is not mapped or not accessible from your host machine. What is your host machine? Host machine is your machine where you are running the Docker container in this case, right? So that is the host machine. So this won't be, since this port is not mapped, this is not accessible. And that is why in the first try, when we tried accessing it, we were getting an error, right? So what we did is we ran this with -p option. Now what is -p option? So with -p, you can map the port on your local host machine to a port within a Docker container. So we said, so this is syntax -p, and you can mention host port, and then you can specify a column, and you can say container port over here, like so. Okay, so you said 8080 over here. So the port on your machine, which is 8080, got mapped to 8080 inside the container. Okay, so whenever now the request is coming in from your host machine to port 8080, it is automatically forwarded to port 8080 within the container because of this option that you have mentioned. Okay, I hope this is making sense. This is the concept of port mapping, people. Okay, and you can map ports of your host machine to any port within the container with the help of this option. The only thing that you have to do is you have to mention this flag -p. This is called as flag or an option. Okay, whatever you want to call it. So you can make use of this flag -p, and you can mention the host port first that you want to map and the container port to which you want this to get mapped. Okay, and whenever any request goes to the host port, it will be automatically forwarded to the port within the container, and you will see the actual output or as if you're running this request within the container. So in a similar way, here in our case, if you see, we had the welcome page within the container on port 8080. So what we said is, we said -p, so port on my host machine, which is 8080, which is on my Windows machine, map it to the port inside the container. And that is how I'm able to access this by just typing in localhost 8080. I hope this is absolutely making sense to you all. And this option of port mapping is very commonly used, and if you're making use of Docker a lot, you will be using this option a lot. Okay, I hope this is making sense and this is giving you clarity. So imagine you have an application like Node.js application. It's running within the container on port 3000 and you want to access it from your local machine. So you will have to do port mapping this way, right? If you're running a Spring Boot application, it's running on port 8080 within the container. You'll have to do port mapping this way if you want to access it, or if you want your application to be accessible from your machine, right? So this will be very important, people. Okay. Now another thing you will notice over here is if you're running Hello World container. Okay, Hello World container is not designed to run continuously. It stops after a while, right? It stops after showing you the output, right? But this particular container is running continuously and it is not stopped unless and until you explicitly stop it, okay? So if you see over here, if you go to Docker, you will see that if you go to container, okay, in containers, you will see, if you expand this a bit, you will see this particular container, which is of Nginx, is running continuously. It's running, see over here. So this is one previous container of Nginx, which we stopped. Okay. Then we have Hello World container, which gets stopped automatically, right? So if I open a new instance of PowerShell over here, if I clear this out and if I say Docker run Hello World, you can see it ran and it stopped automatically. Okay. You can see it ran and it stopped now automatically. Did I stop it explicitly? No, it stopped automatically. So what I mean over here is some containers are designed to stop automatically and some containers are designed to run as long as you stop them, right? So Nginx web server, because this is a web server, so you can see it will keep on running until and unless you stop it explicitly, and you will keep seeing all the logs, right? You can see, you will keep seeing all the logs over here. And you can see here we accessed 8080. So you can see it's showing you that output over here that someone accessed. Now, if I access it once again, if I refresh this once again, and if I come over here, you will see more logs over here. You can see, right? So it's occupying one terminal over here. Now, let's say if I don't want it to occupy this terminal and run it in a background, there is another option wherein I can run this container in a detached mode. Okay, so let me stop this. I've stopped this using Control C. So that will exit it. Okay. Now this is a command that I ran over here, Docker run -p, and this is for port mapping. Now I can pass in another option, which is -d. Now what is -d for? -d is to run this container in detached mode. So if you press enter now, you can see you are able to make use of this particular terminal over here. And it's no longer occupying this terminal with the logs. Right. So in the earlier case, when you are not running it in the detached mode, what was happening is this terminal was fully occupied. And if you shut this terminal, the container will also stop. That was the case because it was strongly tied to this terminal, right? It was displaying all the logs. And if you shut the terminal, the Docker container is also going to stop. But that is not the case now because we are running it in background in detached mode. And this is known as detached mode, -d, right? So this is an option that you have to mention. And here you will see the output as the container ID. And this is the container ID. You can see db8f. So you can see db8fe, and that is what you're seeing over here, db8fe, right? So this is a container you are running, and if you click on this, you will see all the logs over here, right? You have to click on this. So you will see all the logs inside. Okay, and it's running since 54 seconds, you can see, right? So this is another option, which is -d, that allows you to run the container in the background. Now, there is one more option that I would want to show you, which is using which you can name the container. So here now, the names that are being generated, you can see they're all random. Right? Have you given these names? No, they're generated randomly. So what you can do is you can mention a name of the container. So here you can say after -d, I'll pass in one more flag, which is name over here. Okay. And I'll mention my Nginx, something like this, and I'll press enter. Okay, failed to set up the container. Okay, my nginx. Okay, this is because it's not able to do because this container is already running. So you have this container already running and its port is mapped to my host port 8080. Okay, so it is not able to map port 8080 again to this container because my host port 8080 is already engaged. So I'll have to stop this. Okay, but you can see this container is already created, but it did not start because the binding failed. Okay, so let me run this again. Okay, it won't run again because the container with this name already exists. So I'll say my nginx and I'll mention new over here and I'll press enter. Now you'll see my nginx new is created over here, right? So container name has to be unique. If you try to create one more container with the same name, you will get an error. So you can see my nginx new is created and you can see over here the port mapping as well. You can see the port mapping over here. The port is mapped. So the first container that we ran of nginx, we did not have any sort of port mapping. We ran that for demonstration that we are not able to access 8080. So you can see there is no port mapped over here. But here now you can see port is mapped and you have a link over here also to click. So if you click on this, it will take you to localhost 8080. Okay. You have an option to stop, you can stop it from here as well, these containers, or run it from here. You have a command to stop the container as well. So you can say docker stop and you can mention the container name. Nginx, something like that, and this will just give you the container name and you'll see the container is stopped. Okay, my nginx new is the name, like so. Okay, so this will stop again. Can you see, right? So this is these are some commands that help you get up to speed with Docker. What did we learn? Okay, first thing is you learned how you can run containers, how you can run images, how you can make containers from images. You understood what is the difference between running container in foreground as well as background. We also covered how you can stop the containers. We covered an important concept of port mapping, which enabled us to map a port from our host machine to that of containers. And with the help of port mapping, it enabled us to access a page or any sort of thing that is being exposed by our application that is running inside the container via our host machine. Okay, and we also learned how you can make use of detached mode, how you can name the containers, all these options we covered. And we also learned one more thing: you can have multiple containers running at once from the same image. So for example, I can run, nginx instance, nginx image is only one. There's only one nginx image on our system, but you can create 10 nginx containers that are running at the same time and they are mapped to different ports. You can do that. So 10 instances of nginx running at any one given point in time. You can do that. All right. If you want to see, let me show that to you as well. So what I will do is I'll run this container. Okay. So there is this container already with this name. So I'll just delete these containers, these two containers. Okay. And I'll clear this. Okay. So we'll first run this container. Okay, so this is first container. What I will do is I'll create another container and I'll map this to 8081 on my local machine. And instead of nginx new, I'll just say my nginx. Okay, this is one. And then over here, I'll map this to 8082 and I'll say nginx 8082, like so. Okay, and I'll say enter. So you can see 3 containers are now running from the same image and they all are accessible on different web pages. So 8080. There is one accessible at 8081, you can see. There is another one accessible at 8082. And if you go to 8083, there won't be anything that is accessible because we don't have anything mapped over there. Right? So it just won't work. Right? So this is how you can have, this is a relationship actually between containers and images as well. You can have multiple containers being created and executed at once from a single image. Okay, I hope this has been useful and I hope you all have been able to follow along. So now is a challenge time, and the benefit of this challenge is it is going to allow you to reinforce all the concepts that you have learned so far and get you going hands-on with everything that we have learned. Okay, so here on Docker Hub, what I will encourage you is to search for EmbarkX over here, EmbarkX. If you search for EmbarkX, you will see over here, all these images come in, right? EmbarkX/Hello Spring. So you can click on this EmbarkX/Hello Spring. Okay. And the moment you click on this, you will see this image is by EmbarkX. Now, this is my username and we have hosted few Docker images over here for you all to play around with. All right. And you can see these images over here. So don't look at this other images, just these images that you see. So here, EmbarkX / hello node, hello Python, and hello Spring. Okay. You can look at all three, any one. You can even pick any one. And like the name says, this first image, hello node, is the image basically which says hello, and it's built using Node.js. This other image that we see over here is also an image or is also an application that says hello, and it's built using Python. And this hello Spring, like the name says, it says hello again, and it's built using Spring Boot. Okay, so these are different applications, and the goal is to try out everything that you have learned, all the commands so far with all these images. Okay, so if you click on hello Spring, for example, you will see a lot of details over here. Okay, how you can get the image onto your local machine and how you can run it. Okay, so you can play around with this and try it out. Different images will run on different ports, like Python application will run on port 3000 in the container, but you can map it, of course, to any port on your local machine. Okay, so you can try out few commands, and then I'll so pause this video and then play this video to see how I play around with these images. So I hope you all got a chance to pause the video, and welcome back. I hope you tried port mapping, detached mode, and all the concepts that we have seen so far. Now what I will do is I'll click on this hello Spring image. Okay, and here you are going to see these commands as well, and this is the name of the repository. So what I'm going to do is I'm going to come over to my terminal, and here I'm going to say clear. Okay, and let me see if there is anything already running on port 8080. Okay, so there are a few containers that are running on port 8080. Okay, so I'll just stop all of them. You can select all and stop. So I've stopped everything on my system. Now what we will do is, see here you can see Docker pull command. Now what is Docker pull? Okay, so till now what we have seen is you can run an image. So you can say Docker run, and you can say -p, and you can mention 8080. You can map the port to that of within the container, and here you can mention the EmbarkX / hello -spring, like so. Okay, so this is the name of the repository, and you can run it in detached mode as well, like -d. Okay, so if you say enter, what this is going to do is this is going to pull the image onto your local machine, and then it is going to run if the image is not found on your machine. So pulling will happen first. Pulling means downloading the image onto your system. Okay, but let us say if I want to pull the image first and then run it. Okay, so I can also run a pull command first. So I'm just copying this. Okay, and I can say Docker pull, and I can say EmbarkX / hello Spring. So I want to download this image onto my system but not run it. So I'll just say Docker pull, and it will just pull this image using this default tag, which is latest. And you can see this image is brought onto my local machine. And if you go over here, it's the pull is not yet complete, but it's downloading, and it will take a while depending on the image size and all. So we'll wait for a while until this process completes. Okay, but you can see it's extracting in layers and it's downloaded. Okay, and you can see the image appear over here. Now there is no container that is making use of this image, so you will see here unused over here. This is not green dot. This is a black and white dot. Okay. So yeah, this is the process of pulling. So pulling means just getting the image onto your system. It's like downloading image onto your system. You can even directly say Docker run and mention the image name. And if the image is not mentioned onto your system, it will anyways download it first and then run it. Okay. So if you run this command over here, Docker run, something like this, you can see it's now running over here, and you can see now the image is in use. And now you can come over here in containers tab, and you can see Sleepy Lovelace is the name of the image. Nice name, by the way. And you can see we are exposing port 8080. So now if you come over here and if you refresh this, earlier we were running Nginx on our, we were mapping Nginx port 8080 from the Nginx container on our local machine. So if you refresh this, now it's mapped to the Spring project. Okay, so I'm not seeing, I'm not able to access this. Why is this so? All right, I understood the issue over here. So the application is running on port 8080. So if you see the page also over here, it is running on 8080, but we have mapped it to port 80 only. So this needs to change. So I'll just do Docker stop over here. Okay, so you can even do Docker stop using the container ID. So I can just mention this entire container ID over here and the container will stop. Okay, now I can run this command again with a better, with the right port in fact. Okay, so I'll say 80 and here I'll mention 80 like so. Okay, now if you come over here and if you try to access it, it is going to work. You can see the API is working fine. Okay, so you can see it's working absolutely okay and the application is up and running, right? So you can try this with any of the applications that are hosted. Like I mentioned, there are 3 applications: Node, this is for Python, and this is for Spring. Okay, so if you see for Spring over here, okay, I've tried this option -d -p, and you can even try -name over here. Okay, I'll just show you running one more image over here. So if you go to hello Python, so this is the Python image, and you can simply say run this. Okay, something like this. So here what you're doing is you are running this on your local machine, and you are mapping the port 3000 to that of 3000. Okay, on within the container. So if you run this, okay, it is going to first pull the image from Docker Hub, and it will take a while, okay, depending on the image size and your internet connection, but we'll wait for a while. And if you try to access localhost :3000, it should work. You can see it's working, right? So output is the container ID. It is giving the container ID over here. So you can see the container ID, right? This is the container ID that you're getting. Okay, you're getting no env set, and you're getting the message over here as hello from simple app. Okay, and here you're getting the similar message, hello from simple app Spring Boot, container ID, and there is no env set. All right, so I hope this is helpful. So now is the time that we begin talking about the biggest superpower of Docker. So Docker solves the problem of it works on my machine. Now, what does it mean when I say it works on my machine? See, generally when you're working in teams or when you're working for large companies, you're always going to work in teams, right? And in teams, a lot of people will be committing and pushing code. So they'll be writing, committing, pushing code to a remote repository that exists. All right, and different people are going to have different set of dependencies and different software versions installed on their machine, and you cannot control that, right? So what used to happen early on is one person wrote the code, so person A. Okay, let's say one person wrote the code, and that person is going to have the dependency of a particular version. Let's say he has the dependency of version 1.0 installed onto his system. Okay, then if this same code is being executed on someone else's machine, it might throw an error because that person might have another version of the same dependency installed, which is version 2.0, right? So the dependency is same, everything is same, the operating system is same, just that the version mismatch happens, right? And this is the case everywhere, So what Docker does is Docker solves the problem by adding containers. Now within containers, you have a lot of other things, like you have things like dependencies. So if I have to mention what all it has dependencies, okay, code, all the everything, okay, libraries, everything. It has packed, like whatever the application needs, it is packed into this particular container. Okay, it is packed into this particular container, and as a result, you don't need to install all these softwares because the application is running in a container, and it has everything that it needs to work. All right, and because of this, a major superpower comes in with Docker, which is of platform independence. So any kind of application, whether it's written in any sort of programming language, Python, Node.js, Spring Boot, Go, you can run it on your system just with Docker. So let me give you an example. So here, if you come to our official repository, EmbarkX, you're going to see 3 applications hosted over here. So you can type in the URL directly. Okay, so you can see the URL listed over here. Okay, this is the URL, hub.com /u/EmbarkX, or you can search for EmbarkX on the search bar over here. Right, you will come on this repository, and here you are going to see 3 images. These 3 images are the images of the same functionality. So they expose a Hello World API, but they are written in different programming language, like Hello Node, So this hello node is written in Node.js, hello Python is written in Python, and hello Spring is written in Spring Boot, right? So what I'm going to do is I'm going to run all three images onto my system without installing their corresponding software. So I'm not going to have Node.js installed onto my software, but I'm going to be able to run this Node.js image onto my system. I'm not going to have Python, but still this Python image will run. I'm not going to have Spring Boot or Java installed, but still this is going to run without Java on my system. So if you come over here, okay, if you say clear, okay, let us try first with Node, then with Python, and then with Spring. Okay, so we'll go to Node and you'll see this command over here, docker run -p. So the application within the container runs on port 3000 and we are exposing it to 3000 port on our local machine. Okay, so I'm going to copy this and I'm going to run this. Okay, so it's not going to find this image, but it is going to pull this image and it is going to run it locally by exposing this port. Oops, I forgot one flag, which is of detached mode. I forgot that. So it is going to occupy this terminal. You can see it's occupying. Okay, this port is already allocated. So this port is already being used and you can see it's being used. So I'll just select all and I'll just say stop all the containers. So it's going to stop everything. And now let me run this in detached mode. Okay. So I'll run this in detached mode and now you'll see the container is running. Okay, so you can see a new container created over here. And now if you go to 3000 over here, you will see hello over here. And this is the container ID that you're seeing, right? You can see container ID. Okay. Now I'm going to run the same command for Python as well. So if you go to the Python repo, you can see it's exposing port 3000 again. So I'll just copy this. Okay. And we have port 3000 already utilized on our machine for that of Node. So what I will do is I'll just add this flag -d and here I'll change this to 4000. Okay, so on my local machine, it is being mapped to port 4000, but within the container, the port is 3000 only. So I'll come over here and now if I duplicate this and if I say 4000 here, like so, you'll see this is the Python app, which is using the framework called Flask, which enables us to write REST APIs. So I've created this and you can see the container is this, and this is the container ID that you saw over here as well. We can also do this for our Spring Boot or the Docker image that makes use of Spring Boot. So I'll copy this, come over here, add a detached mode, right? And then just run it. So you can see it's running here. And if you come here, 8080, so earlier there was nothing running over here, but now you can see Spring Boot application. So 3 applications with same functionality. Okay. So right now it's same functionality. You might have 3 applications with different functionality. Okay. And they're running on my system without the need of the software. Okay. So I don't need Java to run this Docker image that is running a Spring Boot application, right? I don't need Java onto my system. I just need Docker, because within the container, it is going to have everything, like from Java to everything that it's need, right? Here, this application is making use of Node.js. Now, I might not have Node.js installed onto my system, but still this application is going to run because it's written in Node.js and it's running within the container with all the dependencies installed and available within the container for it to function normally, right? So I don't need to have all the dependencies onto my system. And same goes for this Python app as well. I might not have Python installed onto my system. I might not have the right version of Python installed that this app needs, but still it is going to function in the same way without Flask installed. So this is making use of Flask. So all of this is available within the container and it's running as a container in an isolated manner, right? So 3 applications with different programming languages run perfectly fine onto your system. And this is the major superpower. Without any dependencies installed, you did not do anything. You just ran the image and it's working fine. So yes, Docker enables your application to be platform independent, meaning you can run this application on any machine that does not need the setup to run the application. You just need Docker installed. Okay. And this is an amazing magic. This is a real superpower. You write your code anywhere and run it everywhere. Same output, no setup issues. And this solves the problem of it works on my machine forever. Okay. So generally during like before Docker, people or development team will always say to the infra guys that, hey, it works on my machine. I don't know why it's not working on production server. It's working on my machine. So the application is working fine, and poor production guys will do the job of figuring out, okay, why is it not working over there? What is the dependency mismatch and all of that? Okay. That problem is solved with Docker. And this indeed is a superpower. So now is the time that we begin talking about the life cycle of Docker containers. Now it's not like you create a Docker container and it just starts running. Okay, there are a few life cycle stages that you should be aware of. So these are the life cycle stages. You have create, start, stop, restart, and then remove. Okay. So create means this is the stage wherein the container gets created with a container ID dedicated to it, right? So this is just a creation. The container has not started running, but yes, it is configured to start running. Okay. Then the next stage is when the container starts running. It actually starts running, and whatever is there inside the container is exposed based on how you are running the container. Stop is the stage wherein the container that was in the start stage is being stopped, which means the container exists, but it's not yet running. It's stopped now, right? So that is the stop stage. And then you have restart container. So if you wish to do a restart, the ID remains the same, but the container is restarted. Okay. And then you have remove, wherein the container is deleted from the system. Okay. So stop is when the container is stopped, it's no longer running, and removal is the container is deleted or removed. So in stop stage, the container is not deleted, okay, but it's stopped. The container ID is still allocated or still assigned to that container, and it can start running if it moves to the start stage. So this is the complete life cycle of Docker containers. And what I'm going to do is I'm actually going to go hands-on and show these life cycle to you. So what I'm going to do is I'm going to clear everything out. Okay, and now you can see over here all the containers running over here. There are 3 containers running, right? I'll also show you few commands that will help you see what containers, what images exist on your system. Okay, so you can make use, of course, of Docker UI or Docker desktop to see which containers are running and which are stopped. But there is a command called Docker PS, which tells you which Docker containers are running right now. So if you run Docker PS, you're going to see over here 3 containers that are running, right? So you don't need to switch to the UI, or if you're running or if you're working on a system which does not have a UI, like you have connected to a remote server using SSH. So you can make use of these commands, right? So you're seeing these are the 3 containers that are running. Now you can stop these 3 containers, right? So I can say Docker stop. Okay, and I can make use of this container ID. So you can see this is stopped. You can again say Docker stop, and you can pass in the container ID over here. Okay, and you can stop it, and then you can say Docker stop, and you can pass in this last container ID. Okay, and it is going to stop it. Okay, now if you run Docker PS over here, you're going to see there are no containers running, and this particular command gives you container ID, image, the command. Okay, command as in the command that is running inside the Docker container to run the app. Okay, so since this was a Python app, you can see Python main py. Okay, this was hello spring, so there was some command that was running. This was a Node.js app, so there was some command running over here. Okay, status meaning what is the status, and status is up. You can see all the containers were in up stage, ports, and then the container names. Now what I'm going to do is I'm going to clear this out, okay, and let us play around with the life cycle. Okay, so what I'm going to do is I'm going to say Docker create. Okay, I'm going to make use of this command. I'm going to say name, and this is going to have app1 as the name. Okay, and I'm going to say -p 3000, and okay, 1 second. So this is 2000 accidentally typed in. So this will be 3000 : 3000, and you can pick any image. So one image I'll pick in is for Python maybe, and you can take this. So you have to make sure that within the container also it's running on 3000. Okay, if you're mentioning 3000 over here, because this is the container side, right? So I'll just paste this image and I'll say enter. Now over here you can see you got container ID over here, right? This is the container ID. Now, the container is created. The container ID is assigned to it, but it is not running. So if you scroll down over here, you can see this container is not yet running. Okay, it exists, it is created, container ID is assigned to it, but it's not running. And this is a stage wherein you can see create stage. We are on create stage right now, right? So this is the first stage of the life cycle. Now, one question you might have is, why create a container? Why not directly run it, right? We can directly run it using docker run command. Why create a container first? What is the use case over here we are talking about? Okay, so see, if you want to run it, you can of course run it, and first the container is created, and then it will go to the start stage in the life cycle, right? If you directly make use of docker run, so first container is created in the background, and then it runs, right? So this stage anyways happens in the background. It's just that you are not seeing it. But there will be scenarios wherein you might want to create or configure a container before running it for advanced workflows or advanced CI/CD workflows that your team might have written. So there might be a situation wherein you might want to create a container, then do something in it, and then start it. So in that use case, if you have that sort of a use case, then you might want to create a container first, do something, and make sure that the container is created, IDs assigned, you do something, and then you start it, right? So in that case, you might run this command manually, docker create -name app1. App1 is the container name, and I've mapped it to this port. Okay, now this is docker create. Now, if you have created a container and if you want to start it, how would you do it? So you can say docker start app1, something like this, and you can see it's running. Now, one question you might have is, what is docker start? Why docker start command? There was docker run command, right, which we used to run the containers. Why are we using docker start over here? What is this new command, and what is the difference between run and start over here? So let me clear out over here. So docker run command creates a new container from the image and starts it. What does docker run command do? It creates a new container from the image and starts it. But docker start will only restart or start a previous container that has been created or stopped. Okay, so if you want to start an already existing container, you have to make use of docker start. And now if you say docker ps, you're going to see this container is up and running, right? And you can see it over here as well. Oops. So here also you can see app1 is running, right? So this is docker start. Okay. Now we have seen the create stage. We have seen the start stage. Okay. You can even make use of run. Okay. So run command basically is the combination of create and start. So these two commands combine to form a run command. So you can say docker run, and you can mention like all these same things. Okay. So it is going to first create the container, and then it is going to start. All right, I hope this is making sense. And then you have docker stop. So you can say docker stop, and you can say app1 like so, and it is going to stop the container. Now if you do docker ps, you won't have any running container instances out there. Okay, so we have seen create, start, stop. There is an option to restart the container as well. So you can say, so let me start the container, docker start app1. You can say docker restart app1. Okay. And what this will do is this will restart. So it will stop this container and then it will restart it. Okay. So I think the restart was quick, so we didn't get to see. Okay. So you can see it's restarting over here. Okay. It's quickly restarting. So we are not getting a chance to see that it's restarting, but it's restarting the application. Okay. So it restart the same container. And why would you restart the container? So you might want to do restart for several reasons. Okay. But a thing to remember over here is the container ID remains the same, and storage and all, if your container is using, all that remains the same. Okay, so container is not destroyed. If you want to remove the container, so you can see over here restart, and after restart you have remove. If you wish to remove the container, so you can say docker rm, and you can say app1 over here, something like this. Okay, cannot remove the container is running, so you will have to stop the container first. Okay, stop app1. And then you will have to remove app1 like so. Okay. So now if you see, the container itself is deleted. So here the app1 container won't be there. It's deleted right now. Right. So this was the entire life cycle of Docker containers. Okay. And we took a look at it along with an example. Okay. Yeah, I don't think we have anything left to cover from the lifecycle standpoint. You just need to remember these lifecycle stages: create, start, stop, restart, and remove. I hope this has been useful. So let's start talking about image tag and versioning. Okay. So what is a tag? So tag is basically a name or a label assigned to an image version. And when you're working with softwares, and if you're making use of Docker, you would be aware that every software has different versions. Like you might have a dev version, prod version, you might have a latest version. Okay. So version, how would you identify a version? So you would basically name them. So you would have a dev version. So if an image is labeled as dev, it means that it's a dev version. You might have v1, v2 version. You might have the latest version. So I have some labels mentioned over here. So this is the image, my app, and then you have the tag, and tag with image name is displayed or mentioned with the help of a colon. So my app is the image name colon latest. So it means that we are referring to the image, my app, with latest tag over here. Okay, that is what a Docker tag is. Now let me show this to you as to how Docker tag is represented on Docker Hub. So here I am on Docker Hub, and if you open any of this image like hello node, hello Python, or hello Spring, let me open hello node. So you're going to see over here, these are the tags. So this is the overview of the repository, and if you click on tags, you will see different tags available and are associated with this particular image. So you can see this is the tag called stable. Okay, then you have tag, this is version 1.0. Then you have tag latest. Okay, so there are 3 tags that are available, and you can actually pull and make use of any of these tags. So if you wish to get this tag or like this image with this tag onto your machine, you can do that. If you want to get version 1.0, you can run this command, and if you want this, so you can run this command. They all 3 are different, but it's the same image. Okay, now if you don't specify a tag, okay, one thing you need to understand, if you don't specify the tag, it defaults to the latest version. Okay, it defaults to the latest tag. All right, and with that, let me head over to command line, and I'll just clear everything out. I have had few commands already running up over there. Okay, now what I'm going to do is let us pull an image. Okay, so what I will do is I'll go to images over here, and let me delete these image. Okay, or let me delete everything. So I'll just delete Spring over here. Okay, hello Spring. Let me delete this. Okay, some container is using it, so I'm not able to delete it. Okay, so if you go over here, okay, I'll just delete all these containers. Okay, so we can delete all this. Okay, and then I'll come over here and I'll just delete hello Spring. Okay, so this image is deleted. Now, of course, what you saw over here is I was not able to delete an image if a container is already created using that image. So you cannot do that. One thing for you to know. Okay, now if you come over here, okay, hello Spring is what I've deleted, and if I go back and if I open hello Spring over here, you will see there are different tags over here. Right, so I can get the 1.0, okay, version 1.0, and I can like run this. So I'm pulling the image with this tag, and you can see how the image tag is mentioned over here. It is separated by colon. So there is a colon between the tag and the image name, as you can see over here. It is downloading the entire image like this. Okay, you can see. And if you come over here, so once this process is complete, now this process might take a while depending on your system speed and the internet speed, but it has downloaded this. Okay, it just took some time, and you can see over here EmbarkX hello Spring, and the tag is this one. And before that, whatever images I have used are all latest because I never specified the tag. Right, I never specified the tag, so everything is latest. So this confirms that if you don't mention the tag, okay, what is going to be fetched is going to be latest, because latest is the default one. Okay, now latest might not mean the newer version, it just means that so latest is not, so by the name latest it might seem that latest means the new version, right? But actually it's not the new version, it's the image that was most recently tagged as latest. Okay, latest is the name of the tag. Okay, so never rely on latest in production. Never rely on latest in production. In production, you should make use of proper versions. All right. I hope this is making sense. And you can pull multiple images. Okay. So I have this one over here, which is version 1.0. I'll get the stable one also. So I'll come over here and I'll get the stable one. Okay. And while running the image, you will see, so you can see stable and this one, both are here now, right? So stable is also here, and while running, you can also mention the name of the tag. Okay, so that is something also you can do. Okay, so I'll just edit this one. Okay, and instead of 3000, I'll just mention 8080, and here also I'll mention 8080, like so. Okay, and here instead of hello node, I'll mention hello spring, and the tag is v1.0.0, like so. And if you press enter, you will see this container is up and running, and now you can go to containers and you will see this container. It is making use of this particular image. Okay, so if I expand this, you can see it is making use of this tag over here, right? The tag is also mentioned, right? So this is working, and this is how you can make use of tags. Okay, so just to reiterate everything that we have discussed so far. Okay, a Docker tag is a version label attached to an image. Docker run uses latest tag if no tag is specified. Latest is the default, and latest is not safe for production. So generally, if you're looking at a production, if you're working on production grade scenarios, then don't make use of latest. It might not be safe for production because latest does not mean the best version out there, right? And using semantic versions is important over here to make sure that there is consistency. Like for example, 1.0.0, this is a semantic version. Okay, and always pull and run specific tags for predictable deployment outcomes. Okay, so have a habit of making sure that you use tag always when you're making use of Docker commands or images. I hope this has been useful. So now is the time that we take a look at how you can view logs and debug inside containers. Okay, because viewing logs and all is a part of the process, and there will be scenarios wherein you might want to do that. So let us come over here. I'm going to say Docker PS. Now, when you run this, it is going to give you a list of all the containers that are running right now along with the container ID. Now, you can make use of this container ID and do a lot of things with it. Now, what is a container ID? First of all, okay. So container ID is basically a SHA-256 hash, basically that is assigned to a container as its unique identifier. Now, here you can see a few characters. I believe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are 12 to 14 characters that are being displayed over here as container ID on the terminal. But if you go over here, here you will see a fewer, okay, but actually container ID is pretty much longer. Okay, so here also you can see not the entire container ID, but it's a shorter version. Okay, do we have the complete container ID somewhere over here? It's not there. Okay, but what I can do is I can run a new container and I can show it to you. Okay, so what I will do is I'll run something like this, and instead of hello spring, or instead of mapping it to port 8080, I'll map it to port 8081. So we'll have two containers with the same image or using the same image. Okay, I'll run this and you can see this container ID is pretty long, right? So this is a full container ID. And if you run Docker PS now, you will see a shorter version of the same container ID that you saw over here. All right. Now, should we use short container ID or should we use the complete container ID? So let me show that to you. So when you make use of commands to watch logs inside your container, you will have to make use of container ID. Okay, so I'll just open a new terminal session. Okay, so I'll say clear over here. I'll say Docker logs. This is the command. And now over here, you can make use of the container ID. So I'll just take this entire container ID and I'll just paste it over here. Now you can see the entire logs over here. You can see what's happening inside the container. Right? So you can see the application is started over here, right? Now what I can do is I can even use the shortened container ID. So I can copy this and I can come over here. I can say Docker logs and I'll run this. So I'll get the same output, right? So whether you are using the complete container ID or if you're using a shortened version, it's still the same. Docker allows you to do this, and this is done or this is allowed from a convenience standpoint, because we are humans, and remembering or typing in such long container IDs is not always possible. So you might want to use short form. So you can even use first 3 letters of the containers to get the work done. Okay, so here the first 3 letter is E55. So I can say docker logs E55, something like this, and you can see I still get the logs. Okay, but you have to make sure E55 is unique, right? There should not be like 2-3 containers that are starting from E55, otherwise it will be a problem. Okay, so that's the context. Okay, so that is the context of container IDs. Okay, and I'm talking about container IDs over here and give you a gist of it, because to view logs you will need container ID, because it should know which container you wish to view the log for. You can even mention the container name. Okay, that also can be done. So over here, this container, what is the name of this container? It's trusting ls. So I'll just copy this. You can even make use of this. So I'll just say clear. I can say docker logs, and I'll just paste this. So you can see the entire logs. So either you use the container name or container ID. A lot of developers you will see making use of container ID. So, and you might see them making use of 3 letters or like 7 letters of container ID, or 10 letters or 14 letters. So you should not get confused. Even you should know like Docker allows this, and that is why I'm giving you like different examples. Okay. Now here you are seeing the logs. Okay, it printed the logs and it has forgotten it. Okay, so let me see over here. So here you saw this logs and it's forgotten it. Now let me access the website. So what I will do is I'll come over here on 8080 and I'll just refresh this. Okay, so did the logs update? Not really. Okay, but if I try this again, okay, there is no log actually that has been generated. Okay, so let me try another container if it's generating the log. Okay, so I'll say docker logs and here I'll paste this. Okay, so completed initialization and this is running on port 3000, I believe. So let me run this. Okay, so what I did is I tried running hello node, hello spring, but if you try to access them in browser, it is not updating the log. So what I'm going to do is I'm going to clear this out, okay, and I'm going to make use of a publicly available image again, which is Nginx, because if you access its endpoint, it updates the log in the container, and that is one of the use cases that I want to show you. So what I'm going to do is I'm going to run this command over here. And instead of hello node over here, I'm going to mention Nginx over here, and I'll have a port 80 mentioned over here, and this should be mapped to 8085, let's say, for example, because 8080 is already engaged. 8081 on my machine is also already engaged, and I'm running it on detached mode. Okay, I can also name this container as I'll say name is Nginx logs try. Or Nginx logs is what I'll tell. Okay, and I'll just run this. So this container is up and running. Okay, now let us try viewing logs for this container. So I'm going to say, okay, or I'll come over here and I'll say clear. Okay, I'll say docker logs and I'll paste this container ID. The moment you paste this container ID, you will see these are the logs that are being generated in the container. Now let me try to access this. So this is running on 8085, like so. Okay, you tried accessing the endpoint. Now a new set of log is generated because you try to access this endpoint, but you are not seeing the log update over here because it showed the log and it's not following the logs live. So logs are being generated in the container, but they won't display over here. Okay, because it just printed the logs that were generated at that point in time when you ran this command. So they are not updated live. But if you run this command again, you will see the newly appeared logs over here in the end, right? So you have to basically keep running this again and again to see how the logs are updating. Okay, so if I try to access it again, there will be one more access over here. You can see there's one more log over here, right? Now, instead of running this log command again and again, what you can do is you can basically follow the logs live. So you can say, you can mention container ID and you can make use of -f flag. So what this will do is this will follow the logs live. Now, if you try to access this, okay, so let me access this over here. So I've opened this in split view so that you can see the logs being updated live over here. Now if I try to run this, okay, if I try to open this, okay, you should see the logs appear live. Okay, let me refresh. You can see logs being appeared live. You can see I'm refreshing and it's being appeared live, right? So the logs are being updated over here in live manner. Okay, if you want, you can leave this. Okay, the container won't stop. The container is running because the container is running in detached mode. And this command docker logs -f, the -f flag allows you to follow the logs in real time. Okay, that is the benefit of having -f and not having -f. Okay, so this is about logs. Okay, I hope this is making sense, and I hope this has been useful. Okay, now I'll show you how we can execute or how we can get inside the container. Okay, now there will be scenarios, of course, wherein you might want to get inside the container. Why? Okay, for whatever reason, yeah, like you might want to execute some commands inside the container. You want to install a particular software inside the container. Okay, so you might want to do that. Okay, now I'll get back to its original size over here. Okay, so yeah, this is the original size of the terminal. Okay, you might want to do that. So how can you do that with the help of commands? So what you can do is you can say docker exec, and you can say it meaning interactive shell or interactive terminal. Okay, you have to mention the container name or ID, and then you can mention bash or sh. So if you want to log in through bash, you can mention that. If you want to log in through sh, you can even mention that. Okay, so here's the container ID, and I've logged in using sh. So you can see this over here. Okay, and you can like run like commands over here. You can see ls. So these are all Linux based commands. You can see entry point.sh and all of these. Okay, so dev and everything over here. So this is F526, right? So this is F526. So which container is this? This is basically Nginx container. Okay, so I can exit this. Okay, if I want to exit, I can just say exit, and I'll be back to my host over here. Okay, so let us try this with some other terminal as well. Okay, so docker ps over here. You can see tons of containers running. Okay, so which one should we try it with? So this is the one, this is a Node.js one. Okay, so what I can do is I'll get the container ID for this, and not this. Okay, so this is the Node.js one. I'll copy this. I'll say docker exec, and I'll mention like this. Okay, I'm inside the container. I'll say ls over here. So you can see Dockerfile app.js. So this is my application file. Node modules is there because this is a Node application. You have package lock.json and package.json. If you want to see the contents inside package.json, what you can do is you can say cat and package.json. So this will give you the entire content between inside this particular file, right? These are all Linux based commands, right? If you want to see what is app.js, so you can say cat app.js, and you will see the entire application code over here. So it's making use of Express.js, and it's running on port 3000. You can see, and this is the response that you're getting in the endpoint, right? So that's the entire source code within the container, right? And it's running inside the container because we have logged in over there. Okay, I'll exit it. Let's take a look at Spring Boot application. So here we have hello Spring. I'll just copy this container ID, and I'll run the same command, execute it, and I'll just log in using sh. Okay, now here if you say ls, you will see app.jar. Why app.jar? Because in Java you will have application packaged into a jar file, and that jar file will run. Okay, so our application that we are looking for is a jar file, and it's running inside the container. Okay, I hope it is making sense. Okay, you can even try this out with Python based container. Okay, so I can say docker ps. Okay, sorry, docker ps is Python container running. Is the Python app running? No, not really. So what I will do is I'll just start the Python app over here. Okay, so I'll just take a look. Okay, instead of hello Spring, I'll say hello Python, and I'll just change the port. So for Python, the port was, let me see the port. Okay, so the internal port within the container was 3000. Okay, so instead of that, instead of 8080, I'll have 3000 mentioned over here. 3000. Okay, like so. And here I'll have 3005, because if something is running on 3000 on my machine, I don't want it to conflict. So I'll say 3005 just for the safety. I'll run this. Okay, unable to find this image. So what it's first going to do, it is going to download it, and then it's going to run the container. So container is up and running. Okay, you can take first 3 letters at least, and then you can go inside. Okay, like so. Okay, and then you can say ls over here, and the moment you say ls, you will see Dockerfile main.py. So main.py is the main Python file, and then you have requirement.txt. So if you're a Python developer, you will know that, for managing Python environments, you basically need requirements.txt for dependencies and all. So you can say cat requirements.txt. Requirements.txt, and you can see there is Flask as a part of the requirement, and you can see cat main.py as well. So you can see it's making use of Flask, and it is returning this as the endpoint. So this is the code of our application, right? So what we are doing is we are getting inside the container, and we are able to run any sort of commands. Now you can run any sort of command. You can, if you want to install something inside the container, these are running containers, right? And these are like running machines. So you can run anything if you wish to, right? And for example, if you check over here, Python 3 version. Okay. So you can see Python 3.10.19. This is the version of Python inside the container, right? If you exit this and if you SSH into, or if you log into this particular one, okay, this is going to have, this was the Java application container. So here you will have Java version. So if you can say Java -version inside the container, and you will see it's running on Java version 21. So Java version 21 is installed inside the container. That is what you are seeing over here, right? Now you will say, hey, why these logs and everything, like getting inside the container, all of this matter? It matters, okay? Logs, running logs of an application tells you everything. It tells you why a particular container crashed. So if the container crashes, okay, you don't know what to do, right? What would you do? You don't know why it crashed. So you will first take a look at logs as to what happened there. So you will know, you will get answers to questions like why a particular container has crashed. If the application is not responding inside the container, why is it not responding? Check the logs, right? If the port binding is not working properly, why it did not bind? Check the logs. If the server didn't start properly, why it did not start? What error did we get? Check the logs, okay? Errors, stack traces, warnings, all of this you can find on logs only, right? So the logs command that we did over here sometime back that I showed you, okay, oops, I'm not getting the logs command. 1 second. So here in the history, I would have logs command. Okay, here, logs. So these logs command, docker logs and the container ID or container name, and -f flag if you want to follow it live. This helps you view logs. And if you want to get inside container, you have to make use of docker exec. So docker exec lets you diagnose wrong environment variables, right? Why wrong environment variables? Because you are setting environment variables. You might set environment variables for your application, right? Where should they be set? They should be set inside the container. So you can debug that by getting inside the container like this. And you can see what environment variable, what a particular environment variable is holding, right? You might have missing configuration files, missing dependencies, permission issues, wrong working directory, app output not visible in logs. So for that, you can log in inside the container and you can take charge and you can see why there are missing configuration files. Is a particular file missing? For example, your application might not be running and saying like this file not found. So log into the container and see whether that file actually exists, right? If there is missing dependencies, so check whether that dependency is actually missing from the container. You can check that, right? For example, I checked Java and Python version, right? So if there is a version conflict, if you check, okay, and then you will know, okay, the container is having this version. So probably the image definition needs to change, right? So all these sort of issues, if there is permission issue within the container, you can do all of that using docker exec, right? So getting inside, we covered two concepts, getting inside the container, and without getting inside the container, you can check the logs of the container or the application. Okay. So both these things are important. Logs, like I said, helps you understand everything about the application, what happened, why it crashed, why something is not working well. And exec, like docker exec, and it's interactive session that we did, okay, IT, and then we mentioned terminal name and we went inside the container. This helps you debug issues like wrong environment variables or missing config file, missing dependencies, permission issues, wrong working directory, all of this, okay. So it's really helpful and it's a very helpful skill for you as a developer. Okay. Now I would want to show you few bonus commands over here. Okay. So if you want to see last n lines of a particular container, like you don't want to see all the logs, you want to, let's say I want to see last 10 logs of a particular container. So what I can do is I can say docker logs, okay, and I can say last hyphen tail like so, and I can say 10 over here, okay. So you will see only last X lines of a particular container. Now here the lines might look that they are more than 10 because one line is overflowing into 2 over here because I have zoomed in. But if you zoom out over here, you will see these are actually 10 lines, right? So I'm zoomed in so that you all can see better. And that is why it might seem the line is overflowing into multiple lines, right? A single line is overflowing into multiple lines so that you all can see properly. But if you are zoomed out, you will notice that these are only last 10 logs that you are seeing from the container. Okay, if you want to see the timestamp as well, so you can add -t as well. So one second. So here I'll get rid of this and you can see -t over here. And you will get the timestamp as well along with the logs. Okay, and you can view the logs without timestamp as well. Okay, like so you can say you can get rid of this. Okay, and you can see, right? And you can even have make use of since over here, since in last 1 minute. Okay, and last 1 minute there's been no log, right? Last 1 minute there's been no log. Last let's see, last 3 minutes, no logs. Okay, last 5 minutes or last 6 minutes, no logs, is it? Last 60 minutes. Okay, there are all the logs. Okay, so probably last 10 minutes will give you a decent output. Okay, not last 10. So probably this is an old container. Okay, last 20 minutes. Yeah, this is an old container like that was running, that is running since 20 minutes. So you're getting logs in last 20 minutes over here. So you can add since flag also. This is since. Okay, I hope this has been useful and I hope you all have been follow along. Now, whether you are a developer, a DevOps engineer, SRE engineer, whoever you are, these skills like of checking the logs, executing commands inside the container, these are really essential. Like it does not matter whoever you are, whether you are a developer or DevOps engineer, these are really crucial for anyone. If you're a developer, you should be able to debug issues on your own, right? If you're a DevOps engineer, you should be able to debug production issues, of course, right? So these skills are really important. Don't take them lightly and practice as I'm showing you things. Welcome, and now it's time that we take a look at some of the important Docker commands that you should be aware of. All right, and I do have categorized this into image like commands when working with images, commands when working with containers, and so on. Okay, we'll talk about image-based commands first. Okay, so here what I can do is I can say the first command that I will talk about is docker pull. Now, of course, you must be aware that docker pull is used to pull image from a remote registry. And if you're not mentioning the registry over here, then the default registry is Docker Hub. And you can mention over here nginx :latest. So I can mention the tag as well. And the moment you mention enter or you specify enter, you will see the image is being pulled and you get this ID and you can see image is up to date and so on. Right? So you can pull the image with a particular tag using this. Now, if you want to see the list of images on your machine, you can say docker images like so. Okay, oops, images like so. And you will get the list of all the images that is present on your machine along with the disk usage that it is doing. So the image name with the tag, the ID, disk usage, and the content size inside the image. Okay. That is what you're seeing. Now, if you want to remove any image by chance, you can say docker rmi and you can mention the image ID or the image name. So let's say I wish to remove this nginx. So I can just mention this over here and I can say enter. Okay. You won't be able to remove images if the image is being used by a particular container. Okay. But there is another command that can allow you to do so. So you can mention -f over here, which means force remove the image. So this will remove the image even if it's in use. So you need to use it carefully. I won't be using it, but that's a command that exists. But if you try to remove it, it will remove if it's not being used only. Okay, so this is one command that you should be aware of. So these are the commands that are here for images. Now I'll clear all of this. Okay, let's talk about container commands or commands that you can make use of with container. So you can say docker create a container. And when I say create a container, it will just create a container, not run it. Okay, so you can mention the container name. So you can say nginx, manual. Okay, I'm manually mentioning the name over here. I'm just saying manual just for its sake. And you can mention the image as well. So it's nginx over here, like so. You can mention, oops, so what happened over here? Oops, the image name is incorrect. Okay, and I'll just print enter. Okay, what happened? Okay, the name is 2 times hyphen. Okay, so now it's created. Okay, so this is a command over here, and you will see the container is created. Now, if you want to see the list of all the containers, you can say docker ps over here. Okay, and you would see the container that you just created over here. Okay, this is, so where is nginx manual? Okay, it's not running. So Docker PS is giving you the list of all the containers that are actually running, and we have just created the container. So this container is not running yet. Okay, if you want to see it amongst this list, then you need to run the container. So you can say docker start and nginx manual, like so, and you'll see this container is now running, and you can run docker ps, and here you will see nginx manual somewhere. Okay, so nginx logs, and you can see nginx manual here 45 seconds ago, right? So this container is created and it's running completely fine. Okay, you can even directly, like, you can combine these two steps. So for example, we created the container first and then we started the container, but instead of doing that, you can simply say docker run, and you can simply mention nginx, and you can just say enter. So this will directly run the container. It will create the container, it will run it in one command itself. And here we have not run it in detached mode. Okay, so if you wish to have it in detached mode, okay, you can have -d over here. -d meaning detached mode, and your console or this terminal won't be occupied with the logs. Okay, so if it's occupied by the logs, see, if you run it this way, and if it's taken over by the logs of the container, then you cannot run any other command over here. And if you try to press Ctrl C, it will stop the logs, but it will also stop the container. You can see it stopped the container actually. So your terminal becomes gets tied to the container that is running, right? And that is why you face this issue. So it's best to run it in detached mode unless and until you have some specific requirements of viewing the logs continuously. But to view the logs continuously, also there are commands that you can run later on. Okay, so I hope this is making sense. You can even run the container in an interactive mode. So you can say docker run -it. So what this will do is this will run the container in the interactive terminal mode, and you can use this if you're testing something. So nginx, something like this, and you can see. You can even remove a container by its container ID or container name. So you can say docker ps, and you can say docker rm. Okay, and you can mention the container. So I can remove this one over here. Okay, I can paste it like so. Okay, cannot remove the container. So you need to stop the container and remove it. But if you want to remove it without stopping it, so you can force remove with -f flag. And if you press this, press enter, it will remove it irrespective of whether the container is running or stopped. Okay, so that's force removal. Okay, so this is about the container container commands. Okay, I'll also show you inspecting and debugging containers. So you can say docker ps. Okay, you can view logs of a particular container. Okay, you can say docker logs, and you can mention the container ID. Now when using container ID, you can make use of any number of characters, like 3 characters or like more, depending on your choice. Docker allows you to do that because it's human friendly. You can view the logs, and you can even mention like tail 10. So this will only show you last 10 logs, right? So I'm seeing only 10 logs over here, right? So all these things can be done. You can even log into the container. Okay, you can say docker exec it, interactive terminal, which is it, and then container name or ID, and then you can say sh. Oops. So this is exec. I did a spelling mistake, right? And now you can run any sort of commands over here, right? You can exit like this, right? You can do all of this here. Okay. Now I'll show you, like, there are tons of containers and images out there on our system, right? We might want to clean up. We might want to do a cleanup. How would you do the cleanup? Okay. So first of all, you can say Docker container prune. So here you can say Docker container prune. So what this will do is this will remove all the stopped containers. So whatever containers have been stopped, it will remove it. So here I have the Docker UI. Okay, so here you will see a lot of stopped containers. You can see a lot of stopped containers without this green dot over here. Green dot meaning they are running, right? So a lot of stopped containers and they are consuming memory and storage. What I can say is Docker container prune, and you can see over here, warning, this will remove all stopped containers. Do you want to proceed? Yes. So I'll say Y and enter. And you can see this has deleted all the containers and this is the total space that is saved on my system. And you can see only running containers now exist. Okay. You can even get rid of all the images that are not being used by the containers. So here you can see there is one image that is not being used by any container. So what you can do is you can say Docker image prune. So this will ask you for the confirmation. You say yes. Now there might be a scenario wherein you want to remove all unused images, containers, networks, and all of that. So there is Docker system prune -a. So this will remove everything. -a will remove unused images too. And this will ask you for a confirmation. I'll say yes. And if you say yes, this will get rid of everything, you know. So you can see it got rid of quite a few things over here. All stopped containers, networks, images without at least one container associated to them. So it removed hello world as well, right? It removed a lot of stuff, right? So this is done. And then you have a command that will remove all the containers. Okay, so I can say Docker rm, and here I can make use of $, and within the bracket here I can say Docker ps-aq. Okay, so Docker ps-aq gives you the name of the running container. So let me show that to you. Okay, so I won't run this command, but I'll say Docker ps-aq. So if you run this, you'll get the container IDs of all the containers that are running. Okay, and these IDs are then passed into this command Docker rm. Right, so we are actually combining two commands over here. So this is giving us the ID of all the running containers, and then we are removing all the running containers. Okay, so if you run this, it will remove. Okay, so it's giving us an error. It cannot remove. So you can add a -f flag. Okay, because the containers are running and they are not stopped. So it's telling us that, hey, please stop the container, and then we can remove it. But I'm not doing that because my goal was to show you the command and not actually remove it. But that's fine. You get the cracks. Okay, you can add a -f flag and get it deleted if you wish to. Okay, there is one more command. Okay, I'll tell you. So Docker images -q. So this will give you all the image IDs. Okay, so if you say Docker images here, it will give you all the image IDs. See, you can see you got all these image IDs using this command. Right, so there is, if you want to remove all the images, you can say Docker rmi, and then over here you can mention $, like so, and here you can say Docker images -q, like so. So you can see it was trying to remove all the images, but it could not delete because the image is in use. So you can make use of -f flag again over here, but I'm not going to do that. Okay, so yeah, these are some of the commands that exist. Now there are some commands that can give you system information, like Docker -version, something like this. Okay, you can also get the version using Docker version, like so. Okay, it will give you complete version of complete information of Docker over here. Okay, so with version flag and without the version flag, it is giving you a lot of information. Okay, or if you just say Docker info, it is going to give you a lot of information as well. You can see tons of information, right? So yeah, depending on the requirements, so Docker info is giving you system level information. Okay, so depending on the requirements, you can basically leverage these commands. All right, I hope these have been useful, and I hope this has helped you. Now if you want to do a big cleanup of your system, so you can say Docker prune, Docker prune system prune -a. So this will remove all the stopped containers, networks that are not used, images without associated containers, and all the build cache. So there's nothing for me to clear because all those things are already deleted, but you can run this to save a bit on space. I hope this is useful. Now, just in case if you want to learn more, I do have the list of commands that we discussed as well over here. So these are all image related commands that we spoke about and executed. Okay, force remove, build an image, tag an existing image, all of this. Then you have a container cycle related commands. Okay, this is very helpful over here. Okay, and you have container cycle related commands continued over here. You can restart, remove, delete, and run the container like this. A lot of things you can do. Then you have inspecting and tagging containers. These are all commands that allow you to do that. Okay, you can basically execute these commands onto your system and get it done. Okay, these are debugging related, not tagging related. I said tagging accidentally. Okay, then you have cleanup and removing everything. So these are different commands that allow you to clean up and remove everything. Few commands are combination of two over here. Okay, we've discussed this. And then you have system information related commands. All right. So these, keep this list handy. This will help you a lot. So now it's time that we begin talking about Dockerfile and understand what Dockerfile is. And we'll also take a look at a sample Dockerfile and understand different instructions in it. All right. Now understand this. Okay. What is a Dockerfile? So Dockerfile is the file that defines how a Docker image is created and what all the Docker image has. Okay. Now you might have an application and you might want to containerize it. So it would need a set of dependencies. There will be certain libraries it would work with. So all of those things, the right versions and everything, you define it in a Docker file, and then Docker picks that up and it creates the image for you using that file. Now, every Docker image that we talk about consists of multiple layers, right? So these are layers that are stacked on one top of each other, right? On top of each other. So Docker image consists of multiple layers, and how are these layers formed, or how is it decided that what should be in a particular layer? So every layer is one instruction. So Dockerfile has a set of instructions, okay? Like some Dockerfile might have 5, 10, depending on how complex your application or how complex image you are building, you might have certain set of instructions. And one instruction forms one layer in the Docker image. Okay. And this concept of layers exists because layers get cached. So if you are changing something, the image is rebuilt. Right, and if there is no change in that particular layer, so that same layer is used and it enhances the speed of image building. So layers are basically cached, making builds faster. And if any early layer changes, so for example in this stack, if any early layer changes, for example layer 2 changes, so everything after it must be rebuilt. That is how the system works. If early layers stays the same, and if there is any changes in layer 5 over here, for example, then the 1 to 4 are reused and only 5 and 6 are rebuilt. So this enhances and increases the speed of creating Docker images. Okay, and this concept of caching and layering is essential for performance. Now what we are going to do is we are going to take a look at sample Docker file, and we are going to understand some instructions in it. Okay, and this is going to give you a gist of how a Docker file is defined, what all instructions it have. And before we talk about instructions, I will mention Docker file does not have any extension. You just mention Docker file, D capital, and everything after it without space in small Docker file. You mention that there is no extension, and that is how the file is defined. Okay, but what does the file have? So this is a very simple, very simple Docker file for a Spring Boot application. Similar files can be created for Python, Node.js, Go, Lang, any sort of application. So we'll be taking a look at Docker files for multiple languages as well, but we need to start somewhere. So this is one example that I'm showing you. Okay, and let us discuss about this file. So the first line, okay, we'll talk about line by line. Okay, we'll discuss line by line. So first line says from Eclipse Temurin 21 JDK. Okay, so what this means is, see, whenever you are running your application in a container, right, you would need a runtime environment, right? So this is that runtime environment that my application needs. So right now my application is Java, since we are talking about Java. So what I'm doing is I am getting this base image or with 21 JDK, like JDK version 21. So that is what my image is starting with. So this image already has a Java 21 installed in it. So I'm getting this image, okay, and I'll be working on this because my application needs Java 21 to run, okay. There will be pre-built images for Java version 24, 25, Java 17, Java 8. So whichever version you want, you can make use of the base image for the same, okay. These base images are available on a Docker Hub and they are available publicly free of charge, okay. So this is the first thing wherein we are setting the runtime for the container. Then the next thing is work dir command. So first command was from, and then we have work dir. Now what does work dir mean? So this means create a folder called app inside the container and we will be working inside it. Okay. So all the commands that will follow after this one, work dir, will execute inside /app folder. So it's basically setting up a working directory inside the container where the rest of the instructions will be executed. Okay. So once we set the work dir, the next command or the next instruction we have is copy command. So this is going to copy the jar file. Okay. So this Docker file will exist in my project, right? That I want to containerize. So what it will do is it will take a look at target folder and within that it will pick up the jar file. Okay. So this is the source and this is the target. So it will pick up from here and then it will paste it inside the container as app.jar. Okay, so whatever is the jar name, it will copy it and paste it inside the container as app.jar. And where does this app.jar now reside? Inside the container and within /app directory. Okay, so it's copying the jar file from my computer to the container, and jar file is now right now living on target folder on my local machine, because that is how, if you're making use of Maven, it will be making use of target folder over here. Okay, and we are renaming it as well into app.jar over here. Right now, once this is done, what we are doing is, once this is copied, we are exposing port 8080. So we are saying expose port 8080, which means that this application listens to port 8080 inside the container. It does not actually publish the port. Okay, it just documents the intended port. Okay, and that is what we are doing over here in this particular step. And the next step we have is the command cmd. So this is the default startup command. When the container is started, see, when the container is started, it has the jar file, right? When the container is started from this image, it is going to have the jar file. But how to run that jar file? So that command you need to provide. So once the container starts, okay, this command, whatever is provided using this cmd instruction, will automatically execute on the container start. So cmd java-jar, and you are mentioning app.jar. That is how you are mentioning. Okay. And this is what you have mentioned. And once the container starts, this is going to run and your application will be up and running. Okay. So to summarize, this Docker file simply says that make use of Java 21. Okay. Set the working directory as this one. Take the jar file on my local machine, copy it to working directory, expose port 8080, and then run this command to start my application. That is what it's doing over here, right? Now, this file will basically containerize the current application and it will give you the output. Okay. Now with this, what we will do is we'll take a look at some essential Dockerfile instructions. You have already seen one Dockerfile example. We went line by line. Let us take a look at another thing of Dockerfile, wherein we'll talk about some popular instructions that are used a lot. Okay, so first is from. Okay, so from, what is from? So from is basically the starting point for your container, and it sets the base image for our container. So here are some examples of how from can be used. So you can see from node 20. So if you want to make use of Node.js version 20, you can set this from node 20. If you are willing to run a Node.js application within the container. If you're willing to run a Python application within the container, you can say Python 3.10, whatever version you want. If you're making use of Java, you can use this OpenJDK 17 JDK, right? This is for Java 17. So depending on your preference, you can set this, right? The next essential instruction is copy. So this is used a lot. Okay, so see, from command, from instruction that you see, this is always the first line of Dockerfile. Generally, if you take a look at Dockerfile, from is going to be the first line of Dockerfile, which sets the runtime environment for Node.js, Python, Java, whichever application you have. Copy is going to bring your application into the image. right? So there can be different versions of this command. You can say copy dot and dot. So what this is going to copy. There's one version of copy. Copy, you can say copy package.json to the container. This is another version. Copy app.py to the container. Okay, or copy target / app.jar to app.jar. So this is something you are doing for Java. Okay, so first command is basically copying everything, right? So copy is basically essential to bring your app code into the image. So these are two instructions. Then we have more. We have run. So what run does is run is going to basically execute commands during the image build. So this could be like if you want to install some dependencies, you might want to, so this is like you are running the npm install. So you are installing Node.js based dependency. Here you are installing requirements.txt Python based dependency. Here you are basically doing a Maven clean package. You are repackaging the jar, right? So run basically happens during the build. Okay, and this is one of the commands that is used frequently. Then you have cmd. So when cmd tells what to run when the container starts. Okay, it defines the default commands that runs when your container starts. So these are some variations of cmd. So this way you can start a Node.js application. This way you can start a Python application. This way you can start a Java application. These are 3 different variations. Okay, and this can be you can use it for running any command. Okay, but generally you would run it to start an application. All right. So these are few essential Dockerfile instructions. I'll also give you a gist of what Dockerfile will look like for a Spring Boot application, for a Python application, or for a Node.js application. So here you can see this is for the Java application. Here you are setting up the base version as Java 21 JDK. Work directory is set. You're copying the jar file. You're exposing port 8080, and then you are running this command. Here you are setting this for Python application. So you are setting the base image as Python 3.10 slim version. Work directory is /app. You're copying the requirements.txt first. Then you are installing the dependency within the image, right? You want the dependencies to be installed. Then you're copying whatever is there in the current directory to the container. So all the source code goes there. Okay, provided your Docker file is in your source code directory. Okay, and then you expose 3000 and then you run Python main.py. If you don't want to copy everything, you can just copy main.py as well. Okay, but then you can run this. Then you have this for Node.js application. So you say from Node.js 18, you set the working directory. Okay, you copy like everything that starts with package star.json to the root directory, to the root of the container over here within app. Then you say run npm install and you pass this production flag. Okay, you copy all the other source code that exists in the directory, you expose port 3000, and then you have this cmd app.js. So these are 3 definitions which make use of the instructions that we discussed, and these are for different kinds of apps like Spring Boot app or Node.js app or Python app. I hope this gives you a good clarity, and I hope this has given you, this has helped you, right? Because Dockerfile is something that you will see a lot, and it's important that you get used to seeing this kind of code and understand what every instructions mean, because that will help you a lot. Just wanted to add this small video and mention that down the line, we would be making use a little bit of Visual Studio Code. Now, why Visual Studio Code? Because it's easy to use, it's easy to install. And of course, if you have any sort of language specific IDEs, you can feel free to use them as well. But I'm recommending Visual Studio Code because it's free, easy to use. And if you're a developer, then it's very likely that you must have heard or used Visual Studio Code at some point in time in your life, right? So this is Visual Studio Code over here. For those who don't know, if you go over here, it is open source, and here you can go to the website and you can get it for your operating system. The installation part of Visual Studio Code is pretty simple. You just see this download button. You can download from here. I'm on Windows, so I'm seeing this Windows button highlighted. If you're on Mac or Linux, you're going to see the appropriate button highlighted for your operating system. You have it for other platforms as well. You can see over here the availability. So get it and install it onto your system. This is what it's going to look like. And down the line, we are going to work on Docker files, right? So we will be containerizing the application, creating Docker files, containerizing microservices. So you're going to learn all of that. And Visual Studio Code just fits in everywhere. But if you prefer making use of IntelliJ or PyCharm or any sort of IDE that is specific to the work you do, or if you have any other preference, feel free to use that. But my recommendation would be Visual Studio Code, wherein you can even add extensions. So for example, here I have one of the repositories open over here. Okay. Here you have an option of adding extension. So if you're working on Docker, you can basically add a Docker related extension, and it adds a little bit of Docker related features. So this is the official, you can see 48.6 million downloads it has, and a very good star rating. So I use this often, but I've uninstalled it for a while so that I can demonstrate this in the course. So I've uninstalled this plugin. I have this plugin usually, and I use Docker a lot. So this gives you the extension pack for Visual Studio Code, like Docker extension pack, and you can make use of Docker files and manage all the Docker related code easily over here. Okay, so that's the leverage with Visual Studio Code. With IntelliJ and other IDEs also, I'm sure there will be plugins or extensions that you can make use of. Okay, but yeah, I wanted to just add this short lecture wherein I just give you a gist of how you can make use of Visual Studio Code. Now, Visual Studio Code I'm explaining over here because we are going to containerize applications. We are going to learn how to containerize applications in different programming languages like Node.js, Python. We are also going to take a look at Spring Boot, right? So, of course, if you're keen to learn all of them, of course, you can learn your language only, like Node.js only. I'm a Node.js developer. You will be like, I'm a Node.js developer. I want to just see how I can containerize Node.js. So that's fine. You can just skip to those lectures that cover Node.js because I have labeling done clearly. If you Python is also covered. So I'll have a simple Python REST API which I'll show you how you can containerize and a microservice as well. So it will give you some additional knowledge, and even Spring Boot, of course. So here Spring Boot is not mentioned, but Spring Boot, of course. But what I mean to say over here is Visual Studio Code. If you're installing Visual Studio Code, it works with all the programming languages, right? You can code in Python, you can put code in JavaScript, which is Node.js, you can code in Spring Boot. It supports everything, and it has good extension for Docker as well, and it's free to use. So that is why I'm recommending Visual Studio Code. And I feel as a developer, you should not get stick to one IDE. You should always have that corner in behind you which says, okay, I'm fine. Let's try out this IDE or let's try out that IDE, which is absolutely okay. Tomorrow, if you want to experiment with some other IDE, so you should be free to do that, and you should have that mindset as well. Okay, so yeah, like I said, we'll be learning how to containerize different kinds of like applications written in different programming languages. So we'll containerize a simple simple app written in all three languages like Node.js, Python. We'll cover Spring Boot as well. And down the line, we'll also learn how you can containerize a microservice, right? And microservice written in 3-4 languages like Node.js, Python, Spring Boot, Java. Okay, so yeah, ready to start? All right, so now is the time that we begin exploring the GitHub repository for this particular course. So you will find the link to the repository in the description of this video or in the resources section. So I believe you should check out the resources section, or if you don't want to check out, this is what the repository link will be. If I update this repository, then you will see it in the resources. The updated link should be there. Okay. And also, this is the official repository. It's a public repository. You don't need any sort of access to access this. And here you can see you have one folder over here as of now. Okay, so I'm working on this, and as you progress through the course, you will see many more folders, if needed, will be added over here, and you can check out that as well. Okay, so what I will do is I will just clone the current stage of the repository onto my local machine. Okay. And right now I'll get only one folder because right now as I'm cloning this, the repository has only one folder. But down the line, you might see more folders. So feel free to check out everything. Okay, but we will only be talking about this Docker folder right now because it has the source code that we need to proceed with further. All right. So what I'm going to do is I'm going to come over here. I'm going to copy the repository URL, and I'll come over here. And here you can switch over to a folder on your local machine. So create a folder on your local machine which serves as a workspace for this particular course, and whatever work you are doing for this course resides in that folder. That will help you keep you organized, right? And then via the terminal, so right now where I am, so I am in this directory. So feel free to navigate to this directory over here. Okay, so what I will do is I'll just copy this link and I'll say cd and I'll paste this. Okay, so now if you see, I'm in this directory, and if you do ls, there is nothing here. Okay, I'll just clear this out. And then I'll once again copy this URL, and here I'll say git clone and I'll paste this URL. Okay, so this entire repository is being cloned on my local machine, and if I say enter, okay, so you will see entire thing being cloned. All right, and you'll see it over here, and I'll just navigate to Docker and okay, so cd, and if you see, okay, DevOps Masterclass, and then if you see, you have Docker over here. Okay, so this is created, and now within Docker you will see a couple of applications over here. Okay, you have this application 1, which is a simple hello. It's a simple application which just says hello, and then you have app2 tax calculator, which is app2, and this is a microservice based project. So here, if you go to Spring, so this microservice is written in 3 languages over here. So you have the language for Spring, which is Spring Boot. There are 2 microservices. Python also has 2 microservices, and Node.js also has 2 microservices. Okay, but if you come back over here, app 1 is what we are going to talk about. So here, this is a Spring Boot folder which has hello Spring over here, and then you have Python folder which has these 2 files over here, and then you have Node.js folder which has these 2 files. Okay, now this is what the repository has as of now. Okay, and app 1 hello, this folder is what is going to be the focus for few lectures down the line. All right, and we will talk about Dockerizing or containerizing the project. So this is actually the project source code for a hello world application. So it just displays hello world, and the code is already written. Okay, what you can do is you can open this entire folder in Visual Studio Code so that you can get a sense of it. So I'll just open Visual Studio Code here. So I have a Visual Studio Code open over here. All right, and I've not opened the project yet, but what I'm going to do is I'm going to click on this open folder. If you don't see open folder, you can get it from file and open folder over here. Okay, but just say open folder and just navigate to the folder where we just cloned the source code. So I've just navigated to this folder, and I'll just select DevOps Masterclass and I'll say select folder. Now this is going to open everything for me. Okay, so I'll just close everything, and here you are going to, this gives a better view of the entire project. Okay, so you have this Docker folder right now. Now of course, like I mentioned earlier on, okay, right now I'm seeing this Docker folder. Or down the line you might see, so when you see this repository after I'm finished recording this entire course, you will see many more folders over here, right? So just click on this Docker, you go to app 1, okay, and here you have this Node, Python and Spring Boot. Okay, so these are this application is what we are going to focus on, app 1 hello, and this has a hello world application written in 3 different languages. So this has Node.js code, okay, it has Python code and a Spring Boot code, like a Spring Boot project. Okay, it has all 3, and this is what we are going to talk. And here we have app 2, which is tax calculator, and this is a microservice based project wherein you have 2 services written in 3 different programming language. The services are same, the functionality is same, but they are written in 3 different programming language like Node, Python and Spring. All right, and we'll be talking about how you can containerize this down the line, and how you can create Docker image out of it. For all 3 programming languages. This is going to help everyone, okay, even if you're coming from a different dev background, or even if you're Java dev today, and if you happen to work on Python tomorrow or Node.js tomorrow, so this knowledge is going to help you. I hope you are able to follow along so far. So now is the time that we will begin containerize our Python application. So in the repository that you have opened, just head over to the app 1 hello, and you will see this Python folder. Now within this Python folder, you will see this main.py application. Okay, so this is the Python file. It's a very simple application which just gives this as an output in the JSON form. Okay, so it says this is a message. Okay, and this message is coming in from Python Flask based app. We are making use of Flask. This is the env variable, and then you have container over here, like, so the host name basically, right? And this triggers the app to run. This is sort of main method that is making sure the app runs on localhost and is exposed on port 3000. And then here at the top, you will see we are initializing this, and then we are initializing env and host name. So here we are getting the host name, which means the container name wherein the application is running. And we are getting this env variable that is being set, right? And this method, basically, this is a method which is hello method, which is responsible for returning the data in the JSON format, which is displayed at this particular endpoint, and it is being mapped to a GET request. So it's a very simple source code. Hardly, I would say, like not even 20 lines of source code, okay? Including all the new line character, okay? And it's pretty simple. Like here we did do the initialization for Flask and all. We initialize the app, then here we get couple of variables, which is the env variable and the host name, right? And this is the method that is mapped to a GET request on the root URL. And then we are simply returning the JSON message over here, whatever we want to message in the JSON form. So message key and the message, env key and the env, container key and the host name. And then we have the main method over here, right? So it's pretty simple. This is the Python application. Then we have requirements.txt. Now requirements.txt will have the list of all the dependencies that your application needs to function. So right now this application just needs Flask. All right. Now what we are going to do is we are going to containerize this application, which means this one, and this is the second, which is requirement.txt file. Right. And if you're coming from a Python background, you will know that requirement.txt is used to have all the dependencies listed. And if you create virtual environments and all, it becomes easy to install all the dependencies at once. So you have the list ready, right? Now what we are going to do is we are going to create a Docker file. So here in the Python directory, I'm going to add a new file, and I'm going to call this as a Docker file, something like this. Okay. And the moment you create a Docker file, if you are making use of Visual Studio Code, you will see this suggestion, of course. And you will see this suggestion in other IDEs as well. For example, IntelliJ gives this suggestion on creating a Docker file, whether you want to add this Docker plugin, right? So generally, a lot of IDEs do this, and I'm getting this recommended container tools extension from Microsoft for Docker language. Now I can say install, and this is an extension that helps us work with Docker related code easily. So you can see Dockerfile is highlighted this way, right? You can build the image by right clicking on it. It has a lot of things that you can do. You can see all the images and everything. So it makes your life easy. You can see everything in this GIF, what you can do, all the containers that are running. All right. So it's great, I would say. And that is being installed over here. And if you come here now, so you will see this Dockerfile has this icon now, right? So Dockerfile has this icon, and now here, you can start. So here you can see it's giving me an option to generate the code or select a language, right? So I'm simply going to type in the code over here. Okay. So the first thing I'm going to do is I'm going to specify from, and I'm going to have the base image. Okay. Now what is the base image name? So I'm going to make use of an image that has Python in it. So 3.10 and slim version. Okay. So this is one of the images that I'm using. Okay. Now, if you wish to see more about this image, what am I using? So you can go to Docker Hub over here and search for this image here. Okay. So this is the image that I'm making use of over here. Okay. So this is the official image coming in from Python. Okay. You can play around and explore whichever image you wish to use. All right. But yeah, this is the image that I'm using. So it'll have Python pre-installed. Okay, I'll specify work dir, which will be /app. Okay, so within the container, this will be the working directory. Then I'm going to say copy, and I'm going to have I'm going to copy requirements.txt to the current directory. So to the current directory within the container, which means like the current directory in the container we have set to /app. So I'll just set this to dot. Okay, so requirements.txt in the current directory where I'm writing this Docker file will get copied to the current directory which we have set within the container, which is /app within the container, right? I'm going to say run, and I'm going to say pip install. I'm going to say no cache and dir -r, and I'm going to say requirements .txt. Okay, so what are we doing over here? We are running this command wherein we are saying pip install no cache directory. No cache directory just ensures that none of the caches are considered. -r and then requirements .txt. So this is done. And then what I'm going to have is I'm going to say copy, and I'm going to copy everything else, okay, from the current directory to that of current directory in the Docker container. And after doing this, I'm going to say expose port 3000, and then I'm going to end this with a command. Okay, so I want to run this application, so I'm going to say Python and then main.py, something like this. Okay, so this is done, and this is what our Docker file looks like. Now here, if you see this dot over here, the white dot, it means the file is not saved. So just say Control S and the file will get saved over here. All right. Now this is done, and we have our Docker file set. Now we were getting some suggestions over here when as I was typing in the code, like CMD was coming in the suggestion, expose was coming in, there is syntax highlighting. So all of this is because of the extension that basically we have installed over here. Right now, once this is done, what I will do is I will head over to my terminal. Okay, you can make use of terminal, or you can make use of terminal inbuilt within Visual Studio Code. But I'll just use an external terminal because I have been using it that way since a while. Right, so I'll just say pwd and I'll just relocate to folder called Docker and app1 hello and then Python. So I'll just navigate to where my Docker file is. So my Docker file is over here. I'll just do ls. You can see main.py, Dockerfile, you can see everything over here, right? Now what I will do is I'll say docker build and I will say -t. And then what you will have to do is you will have to mention the image name over here and you will have to mention the dot. Okay. So dot meaning basically it has a Docker file in the current directory. So it will build the image from the current directory. But here you need to specify the image name. Now what image name should we specify? So I'm going to say over here hello. Okay, hello, and then Python. Now one more thing you have to do is, this is the image name. Of course, this image will be built locally, but if you want to push this image onto a Docker registry like Docker Hub, you will have to prepend this with your username, right? And for that, you will need an account on Docker Hub. So it's a free account, and if you have it, it's good. But I already have a free account on Docker Hub, and my personal username for this particular course that I've created is decode007. Okay, so this is mine, temporary username for demonstration purpose, and I'll be pushing it to this particular account over here. So this is a account that is created by me. You can create your own account by going to hub.docker.com. Just make a note of the username and just come over here. Okay, and just paste that over here and just put /. Now, why are we doing this? Why are we prepending it with the username? Because that is how Docker Hub organizes or have the image pushed to Docker Hub. So if you want to push it to Docker Hub, you have to include the username, because only then it will know where the image or which account the image is supposed to be pushed. Okay, and before doing that, you also have to make sure that you log in. Okay, so I'm not sure if I'm logged in, but I'll just press enter. Okay, let us see what happens. So the image is being built. Okay, so for building the image, you don't need to be logged in, okay, because you're just building it locally, right? And you will see all the steps basically over here. Okay, I'm sorry about that. I said you have to log in before doing this step, but that's not the case. I missed one thing. You have to build the image. The image will be built. So you're just building the image. You're not pushing it yet. The image has been built locally. So you can take a look at all the steps over here as to what is happening now. Now this output that you're seeing has a lot of learnings in it. Okay, so I'm going to spend some time on this. This is going to give you a lot of understanding about how Docker images are created and how Docker works in a nutshell. Okay, so see, this first command that we gave, we mentioned you build. Okay, then we said -t over here, and we mentioned the name of the image that we wish to have. Okay, because this is the image where this is the command where we are building the image, and we mentioned dot over here. Why did we mention dot? We mentioned because we wanted to tell Docker that you need to make use of current folder as the build context, right? So since we are running this particular command in a particular folder, and that particular folder that particular folder has a Docker file in it. Okay, this is a Docker file. So it will make use of the current folder as the build context, and it will take a look at the code, the Docker file, and all the source code, and then it will build the image from whatever is there in this particular folder. So it is using this particular folder as this build context. That is what we have mentioned. This is the image name, and this is the command docker build -t. Okay, this is done. So it started the image building process. Now, if you take a look at the image building process, you will realize that whatever you had mentioned in the file has been taken into consideration. File meaning Docker file. Okay, so you can see over here, first it loaded the build definition from the Docker file. So it picked up the Docker file. Okay, then transferred the Docker file, then it loaded the metadata for this particular base image. It pulled this base image. Okay, it got Docker ignore and all of that. And then it started from step 1 of 5. Now, why 1 of 5? Because here, if you see, you have like all the instructions, right? So it is going step by step, right? And what it did is, here you can see it resolved Python. This is the base image. It extracted everything. Then it set this work directory over here. Then this is the third layer wherein it got the requirements.txt. Then it got this installation run. Then it copied everything. Okay, and then finally it exported everything to the image. Okay, and it got the image created over here. Okay, so this is the image that has been created, and if you type in Docker images over here, okay, you should see the image. So you can see this image here, right? You can see the image. Decode hello Python and latest. Now here, one thing you will assume, or one thing you will notice, that here the tag that has appeared is the latest tag. Why it has appeared as a latest tag? Because we did not specify any sort of tag. Right? When we ran the command, did you specify any tag? So tag can be specified after this over here with the help of a colon. So I'll just give you an example. So here you can mention the tag like this, like v1, something like this. We did not mention the tag. So by default, the tag that was assumed to be of latest over here. Okay. And we mentioned this. So the image that is being created is being tagged with this name, right? -t meaning we are tagging it, right? Now, in order to, once we are done with this, image is created, right? If you go to the interface over here, like Docker desktop, you will see this image is being created, right? You can click on the image and you can see all the layers, everything, what happened. You can see layers over here. So these are all the layers, right? So you can see there are like few things over here. Python version was added as the 5th layer. Then you can see this cmd work directory was set. So a lot of commands you will see are coming in from Docker file that we defined. Requirements.txt, you copied this, exposed this, cmd python main.py. All of this basically is what you are seeing from the Docker file, right? Now, in order to run this, what we will have to do is we'll have to make use of the docker run command. So I'm going to say docker run -d because I'm running it in detached mode. I'll name my container. I'll say py-app and I'll do a port mapping. So I'll map this to 3000 port on my local machine inside the container, because inside the container it is running on port 3000. So inside the container, port 3000 should be mapped to port 3000 on my local machine. And then I'll say decode 007 / hello -python, something like this. Okay. Now, the moment you say this, you can say enter over here and you can see the application is up and running, right? And you'll see, if you go over here, you will see this green dot appear, which means there is a container that is making use of this application or this image, and you can see this application running. And you can check this application by heading over to localhost :3000, right? And you can zoom in a bit. Okay. So this is the output that you get. Okay. There is no env set because there was no environment variable set. Container ID is this, and this is the message from the application. This is the exact container ID that we have got over here, right? So this is what we have got, right? So this application is up and running. Now, what we can do is we can even get this application or this image pushed to the Docker registry. Okay, and for that, you'll have to say Docker login first. So you will have to log in on the terminal using your Docker Hub username. So just say Docker login and you will be prompted for username and password in the browser. So just finish that authentication and return. It will take you back to the terminal and it will authenticate the session on the terminal, because you cannot just randomly push to any account. You have to authenticate yourself on the command line, and that tells Docker that you are the owner of that particular account. So I'll just say Docker login and I'll just get myself authenticated. So you can see over here, I already had logged in with Docker on the terminal in past. So it is saying authenticating with the existing credentials, and it authenticated myself. You can see over here, right? And you can see it says Docker I info. So yeah, here it's printing the username. So I'm indeed authenticated with the right account. I have multiple Docker Hub accounts, for demonstration purposes. But yeah, this is done. Now what I can do is I can say Docker. I can say push over here, something like this. Okay, and I can mention decode. Decode 007 slash py hyphen app, like so. Okay, the moment you say this, using the default tag latest, and this tag does not exist. Is that so? Okay, let me see. Decode 007 hello Python. Okay, I'm sorry, I mentioned the image name as incorrect. I mentioned the image name as incorrect. This is the image name, decode 007 hello Python. py-app is the name of the container, right? So don't get confused. py-app is the name of the container, and this is the name of the image. Okay, so just come over here, and you can say over here hello Python, hello Python, something like this, and just say enter, like so. And you can see it's actually pushing the image to the remote repository, and we'll wait for a while. It will take a bit, it will take some time because it will make use of the internet, and it says it's pushed. So we'll go to my Docker Hub account, and here you can see last push was 5 months ago. Let me refresh this. Do we see a new app coming in? So you can see this is a new application that has been pushed here. Can you see this? Hello Python. And if you click on this, this is the image that we have pushed. And one of the tags that exist is latest. Why latest? Because we have not specified any tag when building the image. So latest is the default one, right? If you click on this, you're going to see the image details, everything that you were seeing on the Docker desktop app, and its size, everything is visible over here. And it's also running on our local machine, right? And this can be pulled and run on any machine which has Docker. I hope this has been useful, and I hope you have a good gist of, how you can work with Docker, and how you can, create and build and push your own images for your Python application. Now, one thing I'll tell you, you cannot, one question normally people have, can you push if my application or my image name is not pre-tagged or not tagged with this username? So right now it is username / image name. Right, that is the syntax we have followed. So can I push my image? So the answer is no. Okay, it will be denied. Okay, also you have to make sure that you are logged into the terminal to push the image to the remote repository. Okay, and also you won't be able to push if you do not have access to the repository. Okay, so if you are working in teams, you have to make sure that you have access to the repositories. I hope this has been useful and you all have been able to follow along. All right, so now it's time that we begin talking about Node.js application. So what we are going to do is you will have this DevOps Masterclass source code over here. Like you must have cloned it onto your local machine. Just go under Docker and just go under app 1 node and just open node. So under node, you will see like 2 files. This is the source code for a simple Node.js based application which exposes a REST endpoint, and that says hello world. Okay, so I'll just take you through. If you open package.json, you will know like this is the dependencies file. So just in case if you're not well versed with Node.js, I'll just give you a gist that this is the file that keeps tracks of all the dependencies and app information. So here the dependency that I'm using is Express.js over here that you can see, and here you can see this is a version of Express.js that I'm using. Okay, there is a latest version available, so probably this can be upgraded to the latest version, but I believe I'll stick to this one because this is the stable one. Okay, if you want, you can change the version numbers, but the goal is to learn how you can containerize a Docker image for a Node.js application. So how we can containerize a Node.js application. So this is the package.json. Okay, we are making use of Express.js. This is a web framework which can help us create REST API. So what I've done is here we have this app.js. Okay, it's a simple file. I'll keep this to the point. Okay, so here at the top you are seeing some constants. Here you have this get endpoint being defined over here. You can see this get endpoint being defined, request response, and here this is just returning a JSON based response which has three things: message key, env key, and container key. So this message is just displaying the message. Env is just displaying the environment variable, and if this is not set, the environment variable value, then we just have this message no env set. Okay, this is the port that is being set. So the port is not being used here, but it's being used later. And here we are displaying the container name. So this container name is coming over here like so. Okay. And these are some initializations for Express.js. So we are initializing Express.js. We are initializing few variables over here like port, env, and hostname. And then we have this REST endpoint coming in over here. And then we are basically running the app over here on this particular port, right? And this is how it's running. So it's very simple, like hardly around 15 lines of code. Okay, a very simple REST API, and it's just exposing one endpoint. Okay, now once this is done, what we need to do is we need to containerize this application. All right, so what I will do is I'll come over here and I will create a new file. Now I just have two files over here within this particular folder. So I'll just create a new file, and this file will be the Docker file. Now make sure you have exact this casing over here, Dockerfile, where D is capital and everything else is small. No extension. I'll just press enter. Now the moment I press enter, you will see this icon come in over here, right? That so Visual Studio Code identifies that this is a Docker file. Now this is because I have an extension installed over here already. Okay, and this extension is for Docker. So if you search for Docker over here in the extension section, you will see that okay, I don't see. Okay, so it's giving me an option to install, but I had installed this. So 1 second, let me see this. Probably there is some problem. Let me refresh. Or I'll clear this out and let me see what all is installed. Okay, container tool is installed over here. Container tool. So not Docker, but container tools is installed. And this is basically helping me work with Docker files. Okay, so this is installed. And if you don't have it installed, you will be prompted to install this. So be sure to install this, or you can install it, or you can even do without it. Okay, it's not like it's not going to work, but it just helps, and if you're making use of any other IDE like IntelliJ or any other IDE of your choice, almost every IDE has plugin for Docker these days. So feel free to install them. Right now, what we are going to do is we are going to define a Docker file, and this Docker file is going to have the recipe for image creation. Okay, so first thing is I'm going to have a base image mentioned over here. You can see this suggestion base image. So we need to mention the base image. For this, we'll come over here to Docker Hub, and you can search for Node. Now I'll get the base image for Node.js over here. Okay, so you can see there are tons of images. So if you scroll down, okay, this is the official image of Node.js on Docker Hub. Okay, so you can search for Node, come on this page, and you can see tons of versions over here. Now you might see a different version altogether depending on when you're watching this video. Okay, but I'm showing you how you can pick the right version. So what you can do is after coming over here, you can pick any of the latest Slim version. So here you can see somewhere you will see version 25 Slim. So can you see this 25 Slim, this one? You can make use of this, or you can make use of 24 Slim. So here you should have 24 Slim as well. You can see this 24 Slim. Okay, let me select this. Let me see if I can select this one, 24 Slim, right? So I'll click on this. I'll make use of this 24 Slim. Okay, it opened the GitHub page. I don't want to go to GitHub page, of course. So I'll just mention 24-Slim, right? So node:24-Slim. So I'll come over here and I'll say node:24-Slim, something like this. Okay. So this is something I'll add. Okay, so it is going to take this. Now why Slim? Because Slim basically is, it's basically a slimmer version, right? The size is slimmer. Okay, and it works best for simple Node.js based application, and 24 is anyways the LTS version, so I'll prefer that. Okay, rather than going for the latest version, which might have some issues. Okay, so I've not tried Node.js latest version, so that is why I'm going for this one. So this is the first thing. Okay, you can feel free to change the latest versions depending on when you're watching this video. There will be latest versions available, so you can feel free to update this. But this is done. Okay, we have the base image set. Now what I'm going to do is I'm going to set the work dir, and here I'm going to set the work dir to /app folder. So this will be set, right? And you can see how I'm getting auto suggestions for the Docker instructions that I'm adding. And this is all because of the extension that I have added. So you can see copy, and you can see I'm getting a suggestion. Copy. So now here you'll write source and destination. So what you want to copy from the source and destination. So I'll say I need to copy package over here, package. package star.json. So any sort of package JSON file, okay, which starts with package will be copied to destination. And what is the destination? Destination is the container. Okay, so it will copy that, and after copy we will make use of run over here, and we'll say npm install, and I'll say production. Okay, so this will only install the dependencies, and it will skip the div dependencies because of the production flag enabled. Okay, so we are basically installing all the dependencies. Now, where is this dependency installed from? It is installed from package.json, right? And package.json is already copied. So you have to copy the package.json first. And even before copying, you have to set the work directory first. Okay, so work directory is going to set the working directory, right? And if this folder does not exist within the container, like Docker is going to create it, it will copy this, and then it will run this command inside the container, right? And then we need to add one more command. We'll say copy, and I'll say dot. So everything in the current directory to the container's current directory, right? So rest of the files apart from package.json is also copied into the container. So that is what we are mentioning over here now. And then I'll say expose port 3000, because our app is going to run on 3000. As you can see from the source code over here, port is 3000, right? And then I'm going to have a command executed. So this is a default command that will be executed when the container starts. So I'm going to say node, and to run Node.js applications, we need to add space and then app.js. So this is usually passed in JSON array, the CMD. So whatever command you want to pass in will be passed in JSON array, and this is how it's passed. Okay, so node space app.js. So node will be one parameter and app.js will be other parameter. And then I'll save this Dockerfile. Now, once this is done, okay, what we will do is we'll come over here, and you have to make sure that you have an account on Docker Hub. Okay, so I do have an account on Docker Hub. It's a free account. I'll encourage you to sign up over here. And you can see my username is dcode007. So this is a dummy account that I've created for demonstration purposes. Okay, so what I'm going to do is I'm going to make use of this account. So I'm going to come over here, right? And let us make use of this. So I'm going to build the image, right? So first of all, I have to make sure like I'm in the right directory. Okay, am I in the right directory? Absolutely not. So maybe I need to say pwd. Okay, ls. Okay, pwd. Now I'm in Docker, so I'm going to say app1 hello and then node over here. Okay, now I'm in the right directory, clear. So I have to be in the node folder, and then I'm going to say docker build -t, and I have to mention my username / image name, and then I have to mention dot. Dot stands for the current directory. So what this command is going to do is we are telling Docker to build a Docker image and tag it with this name. Okay, and use the current directory as the build context. I repeat, we are telling Docker to build a Docker image using this command, docker build, and tag it -t with this name, and we are using current directory as the build context. Okay. Now in name, why have I added / over here in between, and why the name is like this? Okay, I'll tell you that as well, because we want to push this to Docker Hub, right? So the syntax is here, you should have your username, which is dcode007. This is my Docker Hub username, and here I should have the name of the image. So I'll say hello node over here. So decode 007 / hello node. Why? Because this is a convention. If you don't specify your username / image name, so if username is not added to the tag or the image name, then while pushing, it will not accept on Docker registry or Docker hub. Okay, so this is mandatory. You need to name your or tag your image this way, and you need to mention the current folder as the build context. Okay, it has all the source code and the Docker file. Now we'll say enter. Now, the moment you say enter, there will be a lot of processing that will happen. It is going to pull the base image. It is going to, you can see node 24 slim. It is pulling this base image. It is loading everything, doing a lot of stuff. And all the steps that you have mentioned in the Docker file, it is following that step and it has built the image. Okay, let us go through all the steps over here. So here you can see first it loaded the build definition from Dockerfile. Okay. Then it transferred the Docker file somewhere, and then it loaded the metadata for node. This is a base image, node 24 slim, right? Then it loaded docker ignore. Now there's no docker ignore file that we have created, but similar to get ignore, we have docker ignore. So if you want to ignore certain files to be considered by Docker, you can create a docker ignore file. Okay. Then it started with first step. Now first step meaning here, there are like steps 1, 2, 3, 4, and 5. This is the step that will be executed when the container runs. So these are the 5 steps. Okay. So first thing is it will pull the image, right? It has extracted the image. Then it set the working directory. Then it copied the package.json, and then it did npm install, and then it copied this rest of the source code. So until here is basically 5 steps. 1, 2, 3. 1, 2, 3, 4, 5, right? And these 2 steps are left over here, right? So this is done, and then it exported to image, exported all the layers. So all these steps became layers over here. You can see. Then it exported all the layers and exported config everything, and now it has unpacked this into an image. You can see, and if you say Docker images, you are going to see this image being created over here, right? And you can see the size of the image and everything, and you can even see it over here. You can see hello node latest. If you click on this, you will see the layers over here, right? And some of the instructions that we have written in Dockerfile have turned into layer. For example, this is a layer. You can see this is a layer. This is an instruction from Dockerfile. This is a layer. This is a layer, this is a layer, this is a layer. So what will happen is if you're changing any instruction, only that layer and layers after that will be rebuilt. Okay, so the image building process will be faster. That's the benefit of the layering technology. So this is done. Now what we need to do is we need to run the image. Okay, so I'm going to say Docker run -d for detached mode, and -name. I'll mention the name as hello node over here. And I'm going to map this port to 3000 on my local machine to that of 3000 within the container, because within the container application is running over here. And I'll say decode 007 / hello node. So this is my image name. Okay, I'll say enter, and you can see the container is running, and you can access the application as well now. So you can come over here, you can say localhost / 3000 like so, and you will see message, env, and container. Okay, this is coming in from simple app, and this is the same container that we just ran. You can see, right? So the container is running. Now, how do we get this image from our local machine to that of Docker Hub? So for doing that, the process is fairly simple. Okay, we are going to say docker push and decode 007 / hello -node like so. Okay, the moment you do this, you can see this is pushing to the repository, and you can see this is pushed, and you can see it is taking a while, but this will be pushed. And once this is complete, okay, so it's pushed, and you can see, okay, this is done. So you got the latest digest SHA 256, and this is done. Now, if you come over here, okay, if you come to your Docker Hub account, if you refresh this, you're going to see hello node appear, and it's pushed less than a minute ago, right? And you can click on this and you can see a lot of information like what tags exist. Now, the default tag that exists over here is latest tag because we did not mention any tag. Okay. So one thing I'll tell you, if you want to add your own tag, you can mention it like while tagging the image, while building the image, you can mention it over here with the help of colon, but we did not mention that. So it by default considered it as latest because that is the default one. If you click on this, okay, here you will see the image layers, right? Something like this. So this is done, right? And the image is also pushed. Now, if you want, you can even check the logs and everything for the image. Okay, so you have the image name, container name and everything. So you can check the log, follow the logs and all of that. All right. I hope you have a complete picture of how you can containerize and build images of your Node.js application. And I hope this has been super useful. So now is the time that we are going to take a look at how you can containerize a Spring Boot application. Okay, I do have Visual Studio Code also installed. I'm of course going to also make use of IntelliJ because a lot of you prefer IntelliJ. I know a lot of Java devs, but I also have Visual Studio Code also installed where I have checked out the code. And here under app hello 1, I have Spring Boot code as well. Okay. But let me open this project in IntelliJ as well. So I'm going to say open over here and navigate to the project directory. So I've navigated to the project directory and I'll open the Spring Boot folder. So under app1 hello, I'll go to Spring Boot. Hello Spring is my project and I'll select pom.xml. Okay. And I'll open this as a project and I'll say trust project over here. Okay. These are just some security features from IntelliJ. Okay. So it's open here as well in IntelliJ. And okay, build scripts found. So load the Maven project. So it is suggesting that this is a Maven project. Do you want me to load it as a Maven project? So I'll say yes. Okay. So it's now being recognized as a Maven project over here, as you can see. All right. And yeah, this is it. This you can also do in Visual Studio Code. Okay. But usually Java devs prefer using IntelliJ. So I'm just giving you all the IntelliJ experience. But whatever I'm doing over here, showcasing over here can be done in Visual Studio Code as well. Okay. Now, first thing over here is I'm going to add a Docker file. Now, what is a Docker file? Docker file is a file that is going to help us define our image, right? It's going to have the recipe for image creation. So I'll say right click, new, and here I'll say, you can see I have this option for Docker file. Okay. Or you can simply create a new file over here. Okay. Sorry. So you can create a new file. And you can call it Docker file if you don't see the option for creating a Docker file directly, right? And this is done. So Docker file is created. Now for me, it's coming with this Docker icon, right? This whale icon, Docker. But if you're not seeing this, what you can do is I would recommend you should install an extension or a plugin. So you should go to settings over here. And under settings, you will have this plugins option. So here I have this Docker plugin installed. So you can search for Docker. Switch to marketplace and search for Docker over here and you will see this Docker plugin. So this enables you to work with Docker in a very easy way and basically it reduces a lot of effort, you know. So things like you'll see like create a new Docker file and all those options, okay, whenever you are working in the project. All right. So this is done and the same thing you can do in Visual Studio Code also. Here also you can create a new file. Okay, and Visual Studio Code also has an option to add Docker related setup. So the plugin is called, the one I have installed over here is Container. Okay, what is it called? Container Tools, right? So Container Tools help you. So here you can see Docker icon appear against the file name, right? And if I type in, I'll get auto suggest as well. Okay, but I'll make use of IntelliJ. Okay, just because everybody prefers IntelliJ. But Visual Studio Code is also fine. Whatever I'm doing over here can be done in Visual Studio Code too, right? So come over here and here I'm going to write some instructions. Now, first thing is I'm going to have the base image pulled. So I'm going to say from, okay, Eclipse. You can see the suggestions, Temurin, okay, and I'm going to say Eclipse Temurin is the name of the base image and I'm going to say 21-JDK, like so, okay. Now, if you want to know what is the Eclipse Temurin, so you can see I got some suggestions. You can even select Alpine over here. This is another version, but I'm just selecting 21 JDK. If you want to see what Eclipse Temurin is, so just come over to Docker Hub and search for Eclipse Temurin. Okay, so you can see over here official images of OpenJDK binaries. So you want a base image which has JDK. Okay, and if you scroll down, you'll see like Eclipse Temurin 21. There are tons of tags. You can like play around with this and just explore the tags, whatever tags they have. All right. So I'm making use of one of the tags. Okay, over here. And then I'm going to set the working directory. So I'm going to say work directory should be set as app within the container. So within the container /app directory will be created if it does not exist, and it will be set as a working directory. So whatever we are doing afterwards with respect to the container will be done in this directory. All right. So this is my way of organizing things. Now what I'm going to say is I'm going to say copy, and I'm going to copy the jar file. Okay. So I'm going to say target /star.jar. So whichever jar file we have over here in the target folder, just copy it as app.jar to the container. Right. So this is the source and this is the destination. Right. So source and the destination. This is done. And then I'm going to say expose port 8080. Okay. And then I'm going to run a command over here, and command will be in the form of arrays over here with the CMD instruction. I'm going to say Java, comma, the option is -jar, and then comma, and the option is app.jar, because that is the name of the jar file. Okay, so that's the thing over here. All right, now this is the file. Okay, simply we are getting the base image, setting the working directory, copying the jar file, exposing the port, and running the command to start the jar file within the container. Okay. Now, one thing I'll mention, we don't have this target folder yet. So if you see over here, we don't have target folder, right? Do we? We don't. So if you create an image with this, it's going to fail. So we need to have target folder. Now, what is a target folder? Target folder, when it comes to Spring Boot projects or Java projects, is a folder for the build output. So that is a folder where jar files and everything is created. So what I'm going to do is I'm going to open the terminal. Okay, you can even do this in Visual Studio Code. So in Visual Studio Code, you have an option to basically open a terminal here, right? So you can open the terminal here too, right? So I'm going to open the terminal here, and I'm going to make sure I'm in the Spring Boot directory. So I'm in the project directory, right? If you do ls, you can see all these files. I'll clear. Now here I am going to build the entire project. So you can build the project using the command line. Or what you can do is you can run the project from here, run the entire file from here. So you can just go to the main code over here and you can run it. Okay, we'll do that. Okay, so instead of running, I'll just run the command. Okay, so if you're on Mac or Linux, you have to run it this way. You have to say mvnw clean package and -d skip tests, something like this. Okay, this is the command that you need to run. Now this is for Mac. Okay, what are we doing? We are making use of Maven wrapper over here. So we are building the entire project using Maven, and we are making use of Maven wrapper. Now with Spring Boot project, you get Maven wrapper over here, right? So we are using that. But if you are on Windows, okay, if you are on Windows, you need to run something like this, mvnw.cmd. Okay, something like this. Let me run this. Let me see if this runs. Okay, some problem over here. What's the problem? It gave me this error. So let me try this again. So I'll come over here, and dot and / is what I'll try. Okay, I did some research and I got to know like this would work. Okay, so it worked. You can see mbn cmd. Okay. So yeah, if you are on Windows, so I'll just reiterate. Okay, let me clear this out. Okay, let me clear this out. Clear. If you are on Windows, so it has to be / over here and mvnw. Okay, something like this. This is how it will run on Mac. Okay, but if you're on Windows, it has to be like this. Okay, /. So this is how it works on Windows. And once you run this, you would have seen. So if I run this again, you will see. Okay, the entire project is built. Okay, if you don't want to run the command, what you can do is you can come over here and run this main file. Okay, that will also produce the target folder. So you can see target folder is here now. And within target folder, you will get a jar file. Right. So if you run this, it should produce a target folder, or you can rebuild the project. Okay, rebuild the project. So that can produce, or I would recommend running it via command. Okay, that is the best thing you can do, right? So once you have the target folder, you will have jar file inside. Okay, and this jar file is what now will be copied into the Docker image. So this is sorted, right? This image creation won't fail. Also, let me take you through the entire source code over here as well. Okay, so here you can see you have this project here within main. So first of all, if you go to pom.xml, it's a very simple project over here. Okay, it's making use of Java 21. Very simple web project over here, right? And here, if you go to hello controller, okay, so this is a controller, very simple controller. It is giving access, it is returning this thing over here. It's returning message, env, and the host name, right? And we are getting the host name from here, and env we are getting from here, environment variables. And this is being mapped as get mapping and rest controller. All right, so this is a very simple controller which is just returning this data over here. Very simple, no nothing else over here. It's very simple to the point, right? So this is done. Now what we will do is we'll make use of a PowerShell. So I'll switch over to PowerShell because that is what I've been using. And I'll make sure like I'm in the right directory. Okay, so I'm in Docker. I'll say app1 hello, and then I'll switch to Spring Boot like so. Okay, so I'm in Spring Boot directory and I'll switch over to hello Spring like so. Okay, so now I'm in the right directory here. So this is done. What I need to do now is I need to build the image, and before building the image, what I need is I need an account on Docker Hub. So here, this is what I need. Okay, so I have an account already created on Docker Hub. So you can see decode007 is my username. Now, why do we need this? Because later on, because now when we create the image, we need to tag the image with the username so that later on we can push it to our Docker Hub account, right? So I'll come over here. Okay, here on terminal, and you have everything in this directory. So you have Dockerfile and all the source code as well. Okay, so I'll clear out everything and I'll just take this forward. Okay, and here I'm going to say I'm going to run this command docker build. So this is a command to build a Docker image. I'm going to say -t because I want to tag it, and the syntax is here you will mention the username and the tag name followed by a slash. You can even mention the, this is the image name. Okay, I'm tagging it with the image name. So this is the username. This part is the image name. And after colon, I have to mention the tag. So tag is the version basically. And then I'll have a dot. Dot meaning the current directory. So this parameter basically tells a Docker build command as to which directory should be used for the build context. Build context meaning which directory has the source code, the Docker build file, and everything that is needed for Docker to build the image. So it's the current directory because we have navigated to that directory, right? If we have not, then we have to mention the path, right? Now we need to fill these placeholders. So here I'll have my username decode007. Here I'll have the image name, which is hello, and I'll say Spring like so. And I won't mention the tag right now. You can mention the tag if you wish to, but if you don't mention the tag, the default one is latest. Okay, you should know this by now, right? And I'll press this. I'll press enter over here. Okay, now you'll see the build process has begun. Okay, and it will take a bit, depending on your internet connection speed and everything, but the image will be created. So you can see. Okay, so let us start from the top. We have Docker build command. We are saying tag this by username / the image name and use current directory as the build context. Now it took total 6.2 seconds and it started with a lot of things. So it first loaded the Docker file. It started working on this Eclipse Temurin image. It pulled that, it loaded Docker ignore. Now Docker ignore is a file like gitignore. In GitHub you have gitignore which allows you to ignore certain files from the repository or from the version control. So Docker ignore in the similar way, there is a file that you can define to ignore some files that you don't want to be considered by Docker. So if you have any sensitive files, you can make use of Docker ignore, right? This can help you reduce image size. Then it started with first step. So you can see there are a few steps, first step, second step, and third step. And these steps are decided from the instructions that we have given in the Docker file, right? So this is the first step. This is the second step. And then this is the third step. these two steps are not considered right now because they will come into play when the container is started, right? So here if you come, first step is it will pull the Eclipse Temurin image, right? Second step is it will set the working directory. Third step is it will copy the jar file into the image, okay? And then it will export the image, export the layers, and it will save the image locally onto your system using this name. You can see, right? It's naming this and it is unpacking over here. So this entire process finishes and you have everything along with the time the process or the step took, okay? And you have the image ready. Now keep in mind whatever instructions you are defining that are that form one layer. So one instruction is one layer, okay? And you can see that clearly over here, right? So this is done. You have the image and now you can run this command docker images over here. You should be able to see this image over here, which is created. See, along with the size and all the details, okay? And then we can run the image as well, okay? You can see the image here also in the UI, like you can see this docker. So this is the images tab and you can see the image. If you click on this, you can see the layers as well. There are 20 layers, right? And you can see these commands over here, few layers in the end. You can see this is coming in from our Docker file. So if you make any sort of changes in the instructions later on, let's say you add a couple of instructions or you modify the command to start the application, you add certain flags. So only those layers, only that layer will be modified and all the layers afterwards will be modified. Okay, that will be done. So this is done. All right. And now over here, what I will do is I'll run the application. So I'll say docker run. Okay. And basically to run the application, I'll have to make use of port mapping and all. So I'll say -t and -name. First of all, I'll name the container. I'll say hello and I'll say Spring and I'll mention the port mapping. I'll say -p and I'll map it to 8080 port on my local machine and I'll map it to the container and I'll mention decode 007. Sorry, so the name of the image is okay, decode 007, that's the correct username, and /hello world, something like this. Okay, so this is something we need to mention. I think this is it. Let me run this. Okay, unable to find the image. One second. I'm sorry. So it's not hello world. I mentioned the incorrect name. It's hello spring. I'm sorry about that. Decode 007 hello spring. Okay, so now you can see the container is started. And now if you go to localhost :8080, you're going to see the output from the Spring application. You can see Spring Boot, and this is the container 2AE555. So you will see 2AE555 over here, like so, right? So container is running, and you can like check the logs also, Docker logs, and then 2AE555, like so. You can see the entire logs over here. Okay, is the actual container that you have created from the image. Okay, now the next thing after creating an image is you want to push this image to Docker Hub. How would you do that? So you can say docker push and you can mention decode 007 /hello spring, like so. Okay, and press enter. So you can see it's pushing the image to the remote repository. You can see this is the remote repository. Okay, now before pushing, you also will have to log in. Okay, I forgot to mention one step. If you will also have to log in over here. Okay, so you will have to say docker login. Okay, and I'm already authenticated, so it's not asking me for any sort of credentials. But generally, if you're not logged in, so before pushing, it will ask you for authentication, and you will have to log in. And it will open in the browser. You will have to authenticate, enter your username, password, and then you will be redirected to the terminal. Okay, and only then you can push this. Okay, only then you can push this. So remember that and keep that in mind, because it's your account. How can you push it from your terminal? Right. So you need to give access to the terminal to your account, right? And you can do it with this command docker login. Okay. So you need to do this, and once you're done, basically you should be able to push this. I'm already authenticated, so it worked with me. Okay, because I work on Docker a lot, so I'm already authenticated. right? So this worked and it's pushed the image. Now you can come over here and you can see pushing also happened in layers. You can see, right? If you come over here to your Docker Hub and if you refresh, you're going to see Hello Spring appear over here. 1 minute ago, it was pushed. If you click on this, you're going to see the latest tag over here. Did we mention the tag? Not really. So how did latest come over here? Simple. If you don't mention the tag, by default, it's considered as latest. Now, if you want a specific tag, you need to tag your image explicitly by mentioning it when creating the image. So when you were creating the image, you can mention it over here, colon, and v1, something like that. Okay, so it will be considered, right? So this is done. And if you click on this latest, you're going to see all the layers that you could see on Docker desktop as well, right? And anyone in the world, is a public image, right? So anyone in the world can pull this and use it. You can see, you should see somewhere. So this is a public view. This is public repository, right? Okay. So public is not mentioned anywhere, but this is a public repository, I'm pretty sure. Okay, let me go to repositories. Okay, so you can see visibility is public, right? So you need to be sure of whatever you are pushing, right? So yeah, this is how you can create Docker images for a Spring Boot application. This is how you can containerize it. And this is how you can make sure that it's pushed to the remote Docker registry. Now, one question beginners often ask me is, do you need to mention the image name in this way? Like your username / the image name. Why can't I just use image name? So the answer to this is a convention and this is compulsory, mandatory, wherein you need to have Docker Hub username appended before the image in this format if you wish to push the image to the remote Docker Hub registry. If you don't mention your username, it's going to fail, right? So you need to mention that. So I hope this clears out and I hope this has been useful. So I also wanted to mention that this particular course is a part of full-fledged course that is available here on Udemy, and you can get the discounts coupon for this particular course here on our website, the link for which you will find in the description below. Don't go directly and buy the course, but you should claim the discount coupon for being a viewer of our channel. So you will find a discount coupon below. You'll find the link and just head over to this website, and if you click on enroll now, you will get the latest coupon applied, the link with the latest coupon applied. So just click over here and this link will take you to Udemy with the best coupon available at that particular point in time. Now, talking about the course, this course is right now the bestseller in its category, and as I'm recording the video, it has just launched, okay? And it is part of Udemy for Business subscription as well. So Udemy courses, like you can get it for very low price. We believe in affordable education, and yes, this course is around roughly 40 hours. Okay, I'm adding more and more content every now and then. So people who are enrolled into this particular course, thank you very much for the trust. And you all know how I'm updating the content, right? So there is new releases happening every now and then. So this length increases with latest industry trends and technologies, whatever is happening in the world. I keep on updating the courses, and right now you can see this course stands strong with roughly 40 hours. It's total 40 hours right now in length. It's massive. It deserves a lot of, or it demands a lot of commitment from you, but it delivers the skill. And this is something that you can get from the ratings and the bestseller tag that it has. Now, remember, being a bestseller in this niche on a platform like Udemy is not a joke. Okay, there are so many courses that are competing for this spot, but good content always finds the way. Okay, so just head over to this website, and this website is EmbarkX.com. Also, I'll talk a little bit more about this course. So here you can see this is the course. So by the way, from the title, you will see Full Stack AI DevOps Masterclass. So why are we calling this course as Full Stack course? Because in this particular course, we learn how to deploy full stack applications, right? We learn how to do DevOps on full stack application. Full stack meaning front end as well as back end. We don't build the application, but we learn how to perform DevOps, right? Then AI. I've not added AI as a marketing tactic over here, okay? Because every other course you see, they add AI in the headline, but that's not the case here. You learn AI-driven DevOps as well, AI-assisted DevOps as well. You learn how to make use of DevOps to you learn how to make use of AI to improve on your DevOps workflow. So that is also covered. So that is why AI comes over here. DevOps, of course, because it's a DevOps course. Real projects, because we give you access to some real projects. So we give access to monolith application and also microservices. I'll talk about that. Microservice access is also given. You get a ready-made application, a full stack application built in microservices architecture, and you can do like everything, like deployment, containerization, Kubernetes deployment, deploying it to cloud. So all of that you learn, how you can manage configurations. All of that is covered. And yes, this is the first course, I would say, that covers all the three major technologies, major cloud platforms, I would say. AWS, Azure, and GCP. These three in combination in a single course are rare. Okay, at least I have not seen. And at an unbelievable price. So we had to keep this on Udemy, okay, because we believe in affordable education, and trust me, the price at which you get this course for, this course delivers far more than that. Okay, I can promise this to you. Okay, so you can go and check the reviews as well, and you can check the curriculum. But what all we cover over here? So we understood the title, why we have this kind of title over here. Okay, we have microservices as well over here. Okay, so first this course starts with DevOps mindset. Then we head over to Docker. So we containerize the application. And when we talk about containerization, we just don't containerize monolith application. We containerize microservices, and then we learn how to go full stack. Okay. Then we learn about Kubernetes. Okay. And we learn how to make use of Kubernetes and deploy our application to Kubernetes. So monolith, microservice, and full stack again. Okay. And also I'll tell you, okay, looking at these keywords, I know a lot of beginners will get overwhelmed, but don't worry. If you've never heard of Docker, for example, if you've never heard of DevOps, you don't know what DevOps is, then this course is still for you. So I forgot to mention one thing. This course is for absolute beginners. Okay. In fact, it is targeted towards developers and also DevOps engineers who are breaking into this field. So I literally start. So look at the first lecture that you see over here. Okay. You learn first what is DevOps. What is DevOps? That is where we start. Okay. And then we start with Docker. Okay. So if you have never heard of these terms, don't worry about them. Okay. You just enroll and just start taking lectures in a daily manner, and you will learn all these terminologies. So I was talking about Kubernetes. If you've never heard of Kubernetes, we have that covered inside the course. After the course completes, you will not only learn what is Kubernetes, but you will also know how you can deploy, manage applications on Kubernetes. What are pods? You will understand. If you're a developer, what major challenge is today? Developers can't interact with DevOps engineers. They can interact, but they don't understand the terminologies that they are using. So this course equips you with that. Okay, you learn the terminologies, you understand the terminologies, and you can communicate with DevOps engineers with ease. Okay. So that's something there. So first we set up Kubernetes locally, and then we take Kubernetes to the cloud. Okay, so you learn how to deploy applications in cloud on Kubernetes infrastructure. And we cover all three cloud providers over here, like GCP, AWS, and Azure. Okay. And yes, we also cover infrastructure as code. So IAC means infrastructure as code. So this is covered using Terraform. So see, infrastructure provisioning is a part. Okay. And, these days infrastructure can be provisioned with the help of code. And how it is provisioned, that is something really, really important that you need to understand. So all of that is covered in a hands-on manner. See, I deliver courses that are hands-on. Okay, I believe in learning hands-on. I don't believe in theoretical and, mucked up learning. I don't believe in that. And that is what my courses also reflect. Okay, so if you take a look at all the learners, okay, or if you take some sort of feedback from all the learners who have graduated from my courses, you will know that courses delivered by us, EmbarkX, okay, these courses are hands-on. We talk about real things. We build real things. So that's what we deliver on. And yes, Udemy as a platform is awesome. Okay, we have the courses hosted there, and you can come over here on EmbarkX.com. You'll find all these links in the description below, by the way. Okay, so we have this Spring Boot roadmap. Spring Boot course over here, which is the flagship course available on Udemy. Okay, and then we have a microservices course. Okay, this is also a flagship course hosted on Udemy. These are all bestsellers, and they're bestseller for a reason. Okay, and so that's there. And if you if you wish to know the roadmap, okay, or if you're not sure as a beginner or in which order you should take our courses in, so you can go to EmbarkX.com, okay, and you can say /roadmap over here. So you will get access to this roadmap and it will give you a complete understanding, okay, you should enroll if. So it will give you complete understanding of which course you should take when. Okay, so it starts with this full stack professional e-commerce masterclass. It's a full stack course that teaches you how to build professional e-commerce grade applications using Spring Boot. We cover React, JavaScript, everything inside the course. Everything is covered. You just need to know Java, object-oriented programming, basic knowledge of Java. You just come inside the course and we take you through, right? Spring Boot Microservices is the next, okay, which I just spoke about, and then full stack DevOps for software engineers. So this is the course. So yeah, I hope you all will leverage the coupon code, the lowest price coupon code that I'm sharing on the website. The link for the same is in the description below. Feel free to take a look at the discount and then decide. A lot of people have already enrolled and the feedback has been tremendous. Okay, this can help you take your career to the next level. Okay, all the best. All right, so now it's time that we begin talking about Kubernetes and understand why something like this exists today. And the goal is, by the end of this video, you are going to have a complete picture and understanding of Kubernetes and why everybody is using it. So first, let's talk about Docker. So we are already aware of the problem that Docker solved, right? So Docker solved this problem of developers saying, hey, it works on my machine, right? So whenever you're sharing your application with someone, an executable or a source code, okay, the thing is it's not going to work on their machine because it's not going to match your environment. So Docker came in and it solved the problem by packaging the application along with its dependencies into something called as containers. And with Docker, you could build images, run containers, expose ports, and make use of Docker Compose as well, right? But Docker alone is going to break in the production. Docker alone is not enough in production. Of course, Docker is needed. We need to containerize our application, but we need more to make sure that our application functions smoothly in production. And to introduce that problem, what problem it is that Docker is not able to solve, let me give you a scenario. So let's say you have a application, okay, imagine this scenario, okay, this is like a real scenario. You're going to have multiple services. So here I have Node.js service, Spring Boot service, Python service, and even the front-end service, okay. These are the services that are running in the production. Now, what happens if, now there are some questions, what happens if a container crashes at 2 a.m., right? This can, of course, happen. Traffic suddenly jumps 10x, okay, what will happen in that case? You need 5 more instances of a particular service. So let's say service A is Node.js and you would need 5 more instances of this particular service, right? One container runs on another VM, okay? So how would that work, right? So if you have multiple containers and if you have multiple VMs as well, and one container is running on another VM, you are going to deploy and you deploy a new version, okay? And you don't want any sort of downtime. So how are you going to manage this? And Docker is a platform that helps you containerize the application. Now, for all these problems, Docker does not have a solution. So there is no answer for this if you're making use of just Docker and nothing else, right? And this problem that you're seeing over here, that is listed on the left-hand side, is called as container orchestration problem. Okay, container orchestration problem. And I'm sure like many people watching this won't be aware of what orchestration is. And that is why I think we should spend some time on orchestration. See, this is going to take a little bit of time. I'm going to have some examples as well. But the knowledge that you gain over here is going to be long term. You don't need to revisit these concepts ever in your life. Okay, so just be patient. What is orchestration? So orchestration essentially means automatically managing many containers across multiple machines. And when you say managing, it includes running, scaling, networking, and even healing them. Healing means if a container crashes, you have to make sure that you restart the container. So that is called healing. Okay. So Docker will run one container. Docker as a platform will run container, right? But orchestration will manage multiple containers together. Okay. And to explain this even more, I do have an example of a kitchen. Okay, of a restaurant kitchen, you can say. So restaurant kitchen is going to have chefs, right? And it's going to have orders as well over here. Now, what would happen if a chef leaves or stops working, right? There has to be someone who is assigning orders to the chef, right? There can be multiple chefs as well in the restaurant, right? Let's say there are 10 chefs and there are orders that are coming in. So who is assigning orders to which chef? And let's say if 5 chefs leave, or they are not feeling well, or they are not there, or they switch jobs, okay, how would you bring in replacement? Who brings in replacement, right? So there is a need for a manager who assigns chef automatically to the orders, and there should also be a way wherein the manager makes sure that there are more chefs added during rush hours. For example, if morning and evenings are the rush hours, you have to make sure that there are additional chefs that are being added. You also need to replace sick chefs instantly, right? And you need to make sure that dishes that are being prepared by chefs go to the right table, right? So there is a need for a kitchen manager, right? And a kitchen manager comes in and he's going to do the job of managing the chefs and making sure that the orders are delivered in the right way to the customer. So kitchen manager over here is a orchestrator. Okay, he's doing the job of managing, coordinating workers so work continues smoothly even when things go wrong. And this process is known as orchestration. Okay, I hope this is making sense. And when you map these things to technology, chefs over here are like container. The dishes that you're seeing over here, dishes meaning orders that you're getting, is nothing but request or traffic. And kitchen manager over here is a orchestrator over here, right? And it is doing the job like this. So basically it is doing the job of managing and coordinating workers so that the work continues smoothly even when things go wrong. Okay. And this is what the container orchestration problem is. So I've summarized this problem over here. The problem is, if a container crashes, who restarts it? Docker is not automatically going to restart it. It is a platform to help you make containers and run it, right? It is not going to restart it and manage them for you, right? Of course, see, you can make use of Docker Compose to start and stop multiple containers. But if a container crashes, Docker Compose is not going to restart it, right? Scaling, how do you scale? How do you run 10 copies of a same service? So let's say if there is an order service and you are running an e-commerce platform, there is an order service. And let's say there is a big billion sale, or let's say there is a Black Friday sale, some big sale is happening. Instantly on the sale day, you would need 10 copies of the order instance because there are going to be a lot of orders flowing in and you don't want the customer experience to hamper. So you would need 10 instance more power in the order service. So that is called scaling. Load balancing. If there are multiple instances, the instances. So let's say if there are 10 instances running for order service. Now, how are you going to make sure that the request is evenly distributed amongst all the instances? That is called load balancing, right? Service discovery. So let's say there are two services, A and B. And of course, for the outside world, they are like a single unit, right? So how they are going to communicate with each other, right? So that also needs to be taken care of. Zero downtime deploy. So generally, when you deploy a new version of the application, there is a downtime. Okay, because the new version will take over the old version. So you need to make sure if you're running a very, if your app requires a high level of uptime, basically, and if there is a sale going on and you're fixing some bugs in the production, you have to make sure that there is zero downtime. How are you going to manage that? Multi-machine setup, right? So Docker works in one machine, okay, or one machine at a time. So how are you going to manage multi-machine setup? Right? Health checks, how to detect broken containers. So all these things are the problems of container orchestration, and these are the problems that can occur when you're just making use of Docker, right? And in production, okay, this is not how things are going to work because you need to manage containers at scale, and that is where Kubernetes comes into play. So all of these are the problems without Kubernetes. So what is Kubernetes? Kubernetes is a container orchestration container orchestration platform, not problem. I'm sorry about that. That manages containers for you at scale. Okay. And it does the job of automating deployment, scaling, healing, networking, and managing the containerized application. So yes. So see this. applications are already containerized using Docker. Okay, you have created containers, but you need to manage multiple instances. You need to manage all these containers. So for that, you need Kubernetes, right? So let's say the example that I gave, you need to scale your order service instantly because there is a lot of traffic coming in for order service. So you're going to have a scaling strategy in place for order service within Kubernetes. And Kubernetes is going to make sure that it has right number of instances up and running at any given point in time, right? And it won't, it has to have those many instances. That problem is taken care by Kubernetes. Okay, so that is what Kubernetes is for you. Now, let us talk about Docker and Kubernetes. So there is a lot of confusion whenever beginners learn about Kubernetes or hear for the first time. They get confused as to what is the difference between Kubernetes and Docker. So here I have head-to-head definition. Sorry, not head-to-head definition, head-to-head differences between Docker and Kubernetes. So Docker runs the container, but Kubernetes is going to manage them for you, right? Docker is single host focus. Kubernetes is multi-node cluster focus. So there are multiple clusters that are running when you run Kubernetes, and it can manage all those multiple clusters. But Docker is single host focus. Docker has manual scaling, but Kubernetes has auto scaling, right? Docker, if something fails, you need a manual restart. But with Kubernetes, it's going to be self-healing. So if something has failed, it's going to automatically restart that container. That's the power of Kubernetes, right? And auto scaling, if I have to talk about auto scaling, you can have things defined that at this particular point in time, I want to auto scale these services. So it will auto scale, and you can even scale down. All these things are possible. When it comes to Docker, there is manual networking, but in Kubernetes, there is built-in service discovery, right? So that's the difference between Kubernetes and Docker. Now, Docker is the engine, and Kubernetes is basically the autopilot over here. Okay. Now let us take a look at scenario as to how things would work without Kubernetes. So without Kubernetes, if Node.js service crashes over here in this architecture, we have front end, Node.js, Spring Boot, Python. So there are multiple services running. Okay, this is the service running in Node.js, this is a service running in Spring Boot, and this is a service running in Python. So if you're running a microservices architecture, it's normal to have different services making use of different programming languages and frameworks. Okay, just in case if you have that question. Now Node.js service crashes. Okay, and the app breaks. So what is going to happen? So if there is no Kubernetes, okay, operations team will wake up. They are going to connect to the server using SSH, and they're going to restart the container. Now this is very manual, right? Someone is manually, okay, app crashed. So there will be some notification that will be sent to the operations team. They'll log in via SSH, and they'll restart the container. This is very manual, and if operation teams is not available or the notifications was not sent properly, even if they were available and if the notifications were sent properly, there is going to be some delay because it will take some time for operations team to connect and restart the container. So there will be a little bit of downtime in your application, even in the best case. This is not the right way of doing things. But if you're making use of Kubernetes, okay, let's say we migrate to Kubernetes, then Kubernetes itself will detect the crash, it will restart the container and maintain the desired count. Example I've given over here, 3 replicas. So when you define the Kubernetes configuration for your application, you have something called as replicas that you can define. And that is what it's talking over here about. Okay, so you define replicas, and the number of replicas you define, Kubernetes will make sure that it matches the defined state. So if you have defined 3 replicas, I want 3 replicas of, let's say, the service that is running using Node.js. It is going to make sure that there are 3 instances running at all given point in time. It is going to route the traffic to healthy pods only. Pods meaning the containers run in pod in Kubernetes. Okay, so it is going to route the traffic only to healthy containers, and it is going to scale up and scale down based on the load. Okay, there is no human intervention needed over here. It's that amazing. Okay, so I hope you are getting a gist of the power of Kubernetes and the actual problem it solves. Generally, people are not aware. See, they start using Kubernetes. Oh, Kubernetes is the hype these days. Let's use Kubernetes. But why are you using Kubernetes? What problem does it solve? These are all very important things that you need to understand from a long-term developer perspective and even from an interview perspective. Your interviewer, he might ask you or cross-question you on these all concepts. So it's really important that you spend some time and get crystal clear as to
why Docker won't work in production. See, Docker will work. You need Docker. You cannot say no to Docker. You need a platform to containerize your applications. That is important, right? But just Docker won't work. You need something that manages all the containers at scale. And that is where Kubernetes comes in. So Kubernetes plus Docker is the strategy over here, right? Now, let's talk about some of the key problems that Kubernetes is going to solve. The number one problem is self-healing. Okay, so container is of course going to crash in productions. Okay, this is a normal scenario. There will be bugs. Now Kubernetes will come in over here. It will restart it automatically. And if there is a node that dies, okay, the pod will move to another node. Okay, so there is a concept of node and pods in Kubernetes. It is going to make sure. So basically Kubernetes over here maintains high availability. That is the point that I'm trying to communicate over here, right? Scaling. Okay, so if there is a traffic spike, of course, which they will be, okay, if you're running it, if you're building a tech application, of course, there will be spikes, because there are going to be days wherein a lot of users start using you, right? So you might want to have, instead of 3 instances that you have defined initially, you want to have 10 instances of a particular service now, right? So you have to just define this and it will auto scale, right? And based on CPU and memory metric, it is going to auto scale. You do need to intervene over here. Service discovery and networking. So instead of making use of this kind of a URL, you get service names when you run containers in Kubernetes. So there is built-in DNS mechanism that comes into play, and the service names are that are given are stable enough to use, right? Then zero downtime deployments. Now this is very important. Okay, you want to deploy a version 2 of your application without breaking all the users. So what you can do is you can have rolling updates, or these are all deployment strategies that you can implement, right? Blue-green deployments or canary deployments. Infrastructure abstraction. So your app does not care which VM is being used, which cloud is being used, which IP is being used, right? Kubernetes handles it all. Okay. Also, one thing I would like to mention, why every company uses Kubernetes. So by the way, today a lot of production systems are migrating to Kubernetes. So the reason is because modern systems are microservice based, cloud native and distributed, and they always need to be on, because the expectations from users is of high availability. So they need to always be on, and Kubernetes gives you reliability, scalability, portability. So all the cloud platforms that you see, AWS, GCP and Azure, they have Kubernetes there. So if you're learning Kubernetes, you can use them on any cloud of your choice, like Amazon, whether it's Google, GCP or Azure, which is by Microsoft. All right. And that is why all the startups use it. Enterprises have standardized on it, and DevOps engineers today must know it. Right. And to summarize this entire video, Docker is going to package your applications, right? And it's going to package your applications into containers, and Kubernetes is going to run and manage them reliably at the very scale. I hope this has been super useful and super clear.
So now it's time that we begin talking about history of Kubernetes. Now, history of Kubernetes is a bit fascinating. Okay, so it originated from Google. Yes, Google, the search engine, the largest search engine that you know today. And they also have a lot of other products. Okay, so inside Google, there was a real problem. And this was way back in early 2000s, where Google was running millions of applications, right? Like search, Gmail, YouTube. And they were manually managing servers that was impossible, okay, because they had a lot of machines, and huge traffic spikes used to happen globally, and there were thousands of services talking to each other, right? They had this microservices architecture, and there were machines failing daily. And managing these servers was almost impossible, like you can imagine. And then what Google did is they built a internal system called Borg. They named it Borg, and this was an internal system which worked inside Google. And what Borg did was it automatically ran apps on multiple machines, restarted apps if they crashed, and it scaled up, scaled down, and even distributed traffic for them,
right? And Bog worked so well that Google ran everything on it. It was amazing for Google, right? Because it solved a real problem that they themselves were facing. Then came the era of containers, right? And containers became popular, wherein Docker gained a lot of popularity. And this was in the year 2013 to 2014, wherein containers made life easy for everyone. And Docker could be used by developers to package their application in a clean way, right? Now, the problem over here was Docker could run containers, but it could not manage them at scale. And the same old problem returned: how do we run thousands of containers reliably? Okay, so this is where Kubernetes was born, and this was way back in 2014, where Google decided to take ideas from Bog. Yes, so it was Google who took ideas from the internal system that they had originally developed, which was called Bog, and they rewrote the entire system, and they open sourced it for everyone. Okay, and they called this project as Kubernetes in 2014. So Kubernetes is basically Bog ideas plus containers meaning the platform or the applications have to be containerized, and it's open source. Okay, so just to sum it up, Google took ideas from the internal system that they built, which was called Bog. They rewrote the entire system, and they open sourced the system for everyone else. And that system today is called as Kubernetes, right? And then Kubernetes exploded in popularity. And why did it explode in popularity? Because it solved a real production problem, and it worked on any cloud like AWS for Amazon. Okay, for Google we have GCP, and for Microsoft we have Azure. So all three major cloud companies had Kubernetes with them, and it was open source, so there was no vendor lock-in, right? And then in 2015, Kubernetes was donated to CNCF, which is Cloud Native Computing Foundation, and this was done to ensure it was vendor neutral and not controlled by a single entity, right? So this is the history of Kubernetes, and Kubernetes today is the industry standard. Okay, almost every company uses it directly or indirectly today. So that's the history and where we are today with Kubernetes. Now, what does K8S means, right? So you will often hear these terms if you're working in the field of DevOps or technology. You're going to hear this field. You're going to hear this term as K8S. So Kubernetes, okay, Kubernetes is long to say. So engineers shortened it to K plus 8 letters plus S, right? So it's called K8S. And that is how, this term called K8S was invented. So K8S is nothing but Kubernetes itself. It's just another way to call Kubernetes. So to summarize, Kubernetes started at Google to solve a real large-scale container management problem and became the global standard for running applications reliably in production. Okay, so I hope this has been super useful. And just to summarize, Google built initial system, which was called Bog. Then Docker popularized container. And then Kubernetes came into picture, which brought in the Bog style orchestration to the entire world. And the main company behind this was Google. I hope this has been useful. So now it's time that we begin talking about the architecture of Kubernetes and understand what happens behind the scenes. So Kubernetes works in a cluster model, wherein a cluster is a combination of control plane and worker nodes. Okay, so you can actually think of control plane as the brain who decides what should happen, and worker nodes are the ones who actually do the job. Okay, now we'll go into the details as to what happens and what happens with control plane and what's there with worker nodes. Okay, but for now, just remember this, that there is a cluster model that Kubernetes operates in, and it combines of these two things, which is control plane and worker nodes. Okay, and control plane, like I said, it is a decision maker. It decides what should happen and manages things, and worker nodes is actually going to run your application, right? You never deploy your applications on control plane. The apps are deployed on worker nodes. All right, now let's talk about control plane first. Now this is control plane. Control plane, like I said, it's the brain inside Kubernetes, and there are some main components that exist. So these are all the components. Now you don't need to memorize these components. Okay, you just need to understand who does what and how things function. That is what you need to understand. Don't memorize anything. So first is API server that I'll talk about. So API server is basically the entry gate. It's the central point of the Kubernetes, and all commands go through the API server. So whatever commands you're executing, whether it's through the command line, whether through the user interface, or if it's through the CI/CD pipeline, all the commands go through the API server, like I said. For example, you might run command that says that run 3 containers of this particular application of mine. So all those commands are going to be coordinated via API server. Then you have scheduler. Now what is a scheduler? Scheduler decides which node should run a particular pod. Okay, now what is a pod? If you're not aware of the pod is basically the smallest deployable unit, and it's going to wrap the containers. Okay, that is what the pod is. So whenever I refer to pod, just think of it that way. Okay, so like I said, scheduler decides which node should run a pod. It looks at the CPU memory availability to decide this. Okay, and whenever you want to run a container, the scheduler is the one who is going to decide, okay, it should run on node 2 or node 3, like that. Then you have controller manager. Now what is controller manager? Controller managers is a component who is going to keep a continuous check. So it will make sure that, hey, if the developer had said that 3 replicas of this particular service should run, or 3 containers of this particular service should run, or 3 instances. So replica, containers, or instances, whatever you call it. If you have said that 3 instances of this particular service should run, then there has to be someone who has to keep on continuously checking, right, that 3 are running or not. So that job is being done by controller manager. Okay. If anything crashes, for example, if one container crashes because of some bug, it is going to fix it automatically. Okay. That is the job of controller manager. And then you have etcd. Now etcd is nothing but it's like a memory or the database inside the Kubernetes. So it's going to store the cluster's state. Okay, what is the meaning of a cluster? Like I use this term cluster. Cluster is nothing but a group of VMs. Okay, so the state of all the VMs is going to be stored in etcd, this component. Okay, and it also stores the desired versus the actual state. Okay, and if this particular component is lost, then the memory is lost essentially. Okay, now once we are aware of these components, okay, they're pretty simple and they do their own job. Then you need to understand what worker nodes are. So this is about control plane, the components within the control plane. Then there is something called as worker nodes. Now worker nodes can be multiple. Okay, like there can be multiple worker nodes depending on the size of application you are running, and each worker node is usually a virtual machine. So this is worker node 1 over here, and this is worker node 2. Now components reside inside. There are some components that reside inside worker node. So first is kubelet over here. Okay, now what is kubelet? Kubelet is a component that is going to do the job of talking to the control plane. It is going to stop and start the containers, and also it is going to report the container's health. Then we have something called as kubeproxy that runs on every node in the Kubernetes cluster, and it is responsible for maintaining the network rules and enabling the communication between the pods and the services. Okay, so like I said, every container that you runs inside a pod in Kubernetes. Okay, so pod is basically the smallest deployable unit. It is going to wrap the container. Containers are not going to run directly. They are going to run within pods. Okay, and service is basically a stable network endpoint that exists in Kubernetes. Okay, so like I said, kubeproxy is going to make sure that it enables the communication between the pods and the services. Okay, all of this you would see in action. Okay, but now it's important that you understand all of this, right? So this is about kubeproxy. Then you have container runtime. Now this is actually going to do the job of running the container, and it is going to provide, it is going to make sure that containers run within the worker node. Okay, and then you have pods within worker nodes. So here you can see you have multiple pods, and here you can, inside the pods you're going to have all the containers. Now a pod can have one container, which is very common, or it can also have multiple containers running inside, right? So Kubernetes does not deploy containers directly, it deploys pods, and within pods your containers are going to run. So this is the entire architecture of Kubernetes and what happens inside. I hope this has been very clear. See, you don't need to memorize all of this. You need to understand just how things function, because if you get any sort of error or anything, you should know you should understand the terminologies basically, right? So you need to understand here how things happen. What is the meaning of worker node? What is the meaning of pod? What is kubelet and scheduler, API server, controller manager? What is controller pane? All of that you need to just understand. Don't memorize this. All right. Now, here you can see this is a sort of a summary that, or highlight pointers. Control pane is going to decide and manage everything. Worker nodes inside the application is going to run your application. Okay. Now let us take a look at a simple request flow and what happens when you run this command kubectl apply-f app.yaml. Okay. Now this is a kubectl command. Okay. So if you want to make any sort of changes or give sort of command into Kubernetes, you use kubectl. Apply, you are applying a configuration, and app.yaml has that configuration defined. So for example, if you want to add 3 replicas or 3 replicas of a particular container or something like that, you define all of that in the YAML file and you're applying this. So let's say this is an example command that a user has executed. Now what is going to happen? First thing, API server is going to receive this particular request, right? And then the desired state will be saved in etcd. And this is, like I said, the memory, right? Then the scheduler is going to pick the worker node that has been selected. And then kubelet is going to create a pod for making sure that whatever request has come in to serve that, right? And then container runtime is going to run the particular container as requested in the configuration that you have executed. And then controller keeps watching and fixing it. Controller keeps a watch. Now, if there are no crashes or anything like that, everything is working fine, then there is no sort of fixing that is needed from the controller. I hope this is making sense. So, yes, control pane is the brain behind the entire working. Worker nodes are the actual muscles who are actually doing the job. And then you have pods, which I can call them as cells. Okay, that are actually doing the actual work, and within pods you have all the containers running. Okay, now this architecture matters. It's important that you understand this architecture and how request flows within Kubernetes, because it gives you an understanding of how self-healing works, how scaling works, how rolling deployments is going to work, how service discovery, and a lot of other things that we learn later on when we are mastering Kubernetes. Okay, it's really important that you understand this entire flow. I hope this has been useful. So now is the time that we begin talking about Kubernetes and how you can set it up locally onto your system. Now, by setting up Kubernetes locally, you would actually be setting up a Kubernetes cluster on your local machine, and you will be interacting with them. Now, this term cluster, I will be using this quite a few times now, and you will also hear this if you are working with Kubernetes a lot. You are going to hear this a lot. So what exactly a cluster is? So cluster is nothing but a group of machines running Kubernetes. Okay, that's what it means. And group of machines meaning nodes that are running Kubernetes. All right. Now, when you want to set up Kubernetes locally onto your system, there are quite a few ways. Okay, it's just not one way. There are quite a few ways. Now, first way is by making use of Docker Desktop. Now, Docker Desktop, if you have worked on Docker, you will already be aware
that Docker Desktop is a program or a software that enables you to work with Docker on your local machine. You have to install it onto your system and then you can run Docker commands. So Docker Desktop itself has the ability to run Kubernetes or set up Kubernetes onto your local machine. So if you have Docker Desktop already installed onto your system, what you can do is you can enable Kubernetes as well. It's just a checkbox over there, right? And there is no extra setup, okay? And it has a stable and a clean UI, okay? So this is one way. Another way is by using a tool called Minikube. Now, what is Minikube? Minikube is a tool or software, I should say. It's a tool, I should say, that runs Kubernetes in its own VM. And if you're using Minikube, you don't need Docker Desktop. So you can directly use Minikube. But if you're using Kubernetes using Docker Desktop, you have to keep Docker Desktop open all the time, because that is what is powering the Kubernetes cluster on your local machine. Now, Minikube is also very popular. See, Docker Desktop is quite popular, and you will also find a lot of tutorials making use of Minikube because it's also popular. But I'll tell you, there are the commands that you use in Minikube are slightly different. Okay, slightly different. It's not that you cannot learn it, you can, but slightly different. Then the third way is by making use of Kind, which is Kubernetes in Docker. So what you can do is you can run Kubernetes clusters inside Docker containers, and this is also a way. Okay, so there are three ways, and what I'll be doing is I will be going ahead with Docker Desktop approach. And there is a reason for this, okay, because if you enable Docker Desktop, the commands that you run are very close to the commands that you will run in production. Okay, of course you can learn Minikube and other tools as well later on. Okay, but you know, to start with, I feel Docker Desktop, like Kubernetes in Docker Desktop, is the right way. And what I will do now is I'll come over here to the browser, and this is the official website of Kubernetes, which is kubernetes.io. So just head over to this website and you can read more about Kubernetes over here. So you can see over here, it is also known as K8s. It's an open source system for automating deployment, scaling, and management of containerized applications, right? So you can check out this website. You can see all the features over here. Like these are the key features of Kubernetes. And I'll tell you, if you're visiting this website, they keep on updating the UI every now and then. So depending on when you're watching or when you're watching this video, okay, you might see a little bit changes here and there. So don't stress. The information and the problem it solves remains the same, right? It's just the UI. So you can come over here to documentation now and click on tasks and then click on install tools. Now here you will see some set of tools that you have over here. Okay, let's talk about each one of them. So this is kubectl. Okay, some people call it kubectl, some people call it kubectl. I've heard people saying kubectl. So whatever you pronounce it, but I'll say kubectl. This is a Kubernetes command line tool. Okay, now this is a tool that allows you to interact with Kubernetes clusters. So if you have Kubernetes already set up, you can make use of this tool to interact with Kubernetes clusters, right? You can use it to deploy. So you can see over here, you can use it to deploy application, inspect, manage cluster resources, view logs, and everything, right? So that is what kubectl is. Do we have to install it? So if you're making use of Docker Desktop for Kubernetes, you don't have to install it because it comes pre-packaged with it, right? So you directly get access to it out of the box. Okay, so that's kubectl. Does kubectl run Kubernetes clusters? No. Kubectl is a tool that allows you to interact with Kubernetes clusters. Remember that. It allows you to interact with Kubernetes cluster. You don't set up or kubectl does not have Kubernetes clusters, right? You need to have Kubernetes clusters running. So if you're using Docker Desktop and if you enable Kubernetes on your local machine, then you get access to kubectl as well because it comes inbuilt, and then you can interact with Kubernetes clusters. I hope this makes sense. Kind. Now what is Kind? Kind lets you run Kubernetes on your local machine. Okay, and this tool requires either Docker or Podman installed. Okay, so this is another way. Minikube, like I discussed, so we already spoke about Kind. Now Minikube is also listed over here. So like Kind, Minikube is also a tool that allows you to run Kubernetes locally. Okay, you can see over here Minikube runs in all in one or a multi-node local cluster on your personal computer. Okay, and this is Minikube, and you can check out Minikube's guide over here. They've linked it to it. So if you want to just read and if you're curious, you can check out Minikube tutorial as well over here. Okay, you can see over here. Okay, you'll also see some requirements that are needed. Okay, like 2 CPUs, 2 GB of free memory, 20 GB. Okay, and all the commands have been given over here. All right, that's okay. There is one more tool called kubeadm. Now this is also used to create and manage clusters. Okay, but yeah, so like I said, Minikube is very popular. Okay, you will see a lot of tutorials around Minikube, and kubectl is a tool. It does not set up it does not have Kubernetes in it. Okay, it is just a tool to interact with Kubernetes. Okay, so what I will do is I'll first now come over here, and here I have opened Docker Desktop. Okay, this is Docker Desktop. Head over to settings over here on the top right. Okay, and we are going to enable Kubernetes. So just head over to settings and then click on the left hand side, just click on Kubernetes like I'm doing, and you will see enable Kubernetes, start a Kubernetes engine or a multi-node cluster when starting Docker Desktop. So I'll say apply, enable, and you will see it's making use of, it's asking you whether you want to make use of kubeadm or kind. So I'm just going to make sure the default one over here is selected. I won't enable show system containers. Okay, and I'm going to say apply. So system containers, like you can see over here, show Kubernetes internal containers when you're running Docker command. So this can actually confuse us. There might be some Docker containers that Kubernetes might have internally running. Okay, these might be internal containers, right? And I don't want to have them in the output, right? So I'll just keep that unchecked and I'll say apply. Now the moment you say apply, it'll say the installation. It's going to install the Kubernetes cluster. And installation is going to take few minutes and it is going to require an internet connection. So make sure you have an active internet connection, and I'll just say install. Now you can see over here, it is starting and it is pulling all the images that is needed. So kubeadm image it's pulling. There's one node and this is a version. Now version number might be different depending on when you're watching the video, but don't worry, they keep on releasing every new version every now and then. Okay, so nothing much changes. And things and the process will remain as it is. Now I'll wait for a while. It will take some time wherein it's going to pull all the images and set up a local Kubernetes cluster. Okay, so just hang in there. Now it took some time and now I can see running over here. Okay, I also got a success message. So I'll just say close over here, and yeah, you will see some additional containers up, like that might appear over here. You can see like these are some additional images that have been pulled. Okay, and here on the bottom, okay, here on the bottom bar within Docker Desktop, you're going to see this message which is Kubernetes running. Okay, this is the RAM it's consuming, the CPU it's consuming, and everything. So Docker is also running over here. Kubernetes is also running. Okay, if you click on Kubernetes over here, you will have this Kubernetes option on the left hand side. You can see in the left hand side, this menu, you will have Kubernetes option. And you can see over here, it's running this way, right? So yes, we have successfully set up Kubernetes onto our local machine. Now what we can do is let us run a few commands. So I'll come over here. Okay. Now to run the commands and interact with Kubernetes cluster, I'm going to make use of kubectl. And like I said, kubectl comes already bundled with Kubernetes on Docker Desktop. So I'm going to say kubectl over here, version, and I'm going to say client. Okay, so I am getting the client version, and you can see over here client version is 1.34.1, and this is the customized version. You might see different version, okay, because they keep on releasing version numbers every now and then. So this last digit might become 3 or 5. They might release a new version, so don't worry about that. Okay, everything else remains the same. And another command you can run is kubectl get nodes. Okay, so you're going to see Docker Desktop, and it would be termed as, okay, sorry, so I did a spelling mistake, kubectl. Okay, kubectl get nodes. Okay, so you can see over here, these are the different nodes. Okay, it's not well formatted. Okay, so this should have ideally given the right output, but this is not giving the right output. So one way is it has not fully started yet, okay, because Kubernetes takes time to start. But I don't think that is the case in on my machine, because I've waited for a while. I paused the video and waited for a while, but it has still not done this. So if you face this kind of an issue, I'm not going to edit this from the video. I'm going to fix this live. So if you face this kind of issue, just come to settings over here, go to Kubernetes, and okay, so there is no restart option here. What I would do is I would reset the cluster. So I'll say reset anyways, okay, and this is going to stop the cluster. And then here, so it's starting the cluster here. And once the complete reset is done for the cluster, I'm going to say apply. So it is going to reset and restart the Kubernetes cluster. So this will take some time. I'll wait for a minute. So here you can see it's running now, and I'll say close over here, and I'll come over here. Let me run this command again. Okay, so it's not running yet. So what I will do is I'll clear everything. I'll zoom in a bit so that you can see the commands clearly that I'm running. So I'm going to say kubectl over here. I'll say config.get context. So I'm trying to get the context that Kubernetes is using. Okay. So you can see over here, I have used Kubernetes in past, and I already have Minikube installed onto my system. Okay, I keep doing experiments. I have Minikube already, and the problem over here that happened with my machine is it's making use of Minikube. Okay, I want to make use of Docker Desktop, and that is why, since Minikube is not started, it was not showing us the nodes. This was the main reason. Okay, so what I will do is I'm going to say kubectl over here, config, and I'll say use context, and I'll say Docker Desktop, something like this, and I'll say enter. Switch to context Docker Desktop, and now if I try to get the context again, I'm going to see this option that it's making use of Docker Desktop. Okay, so I hope the issue on my machine is clear to you. Kubectl was pointing to Minikube. Why? Because I'm already a Kubernetes user and I've used Minikube in past. So Minikube was already configured onto my system, and I wanted to make use of Docker Desktop, like Kubernetes within Docker Desktop. And I was trying to get the nodes, but kubectl was pointing to Minikube. So there were no nodes. So if you see the previous command that we ran, okay, the previous command like get nodes, now it will show Docker Desktop. Okay, but if the context is set to Minikube, earlier it was set to Minikube. Why it was set to Minikube? Because I've used Minikube in past. So you can see your Minikube is not up and running. So kubectl is pointing to Minikube. So, okay, it's not getting any nodes there. Okay, and I thought there's a problem with Docker Desktop, and we did reset and all. But that was not the case. So I'll switch the context to Docker Desktop, and then I'll get the nodes, and you can see over here, Docker Desktop is ready. Okay, you should not face this challenge if you have never used Kubernetes or any tool around Kubernetes on your system. But if you've used tools like Minikube or something like that by following other tutorials in past, okay, you should face this issue, and you now know how you can fix it. I hope this has been useful, and I hope you all had some fun. So now it's time that we begin talking about pods and deployments and understand what these are. And trust me, if you're working with Kubernetes or if you plan to be a long-term developer with Kubernetes, you're going to hear about pods, deployments a lot. Okay, and if you will be writing a lot of deployments, and those deployments will create pods. Okay, so let's talk about what these are. Okay, so first we talk about the pod. So pod is basically the actual running app. Okay, the actual app that is running in Kubernetes. Okay, and this app will be wrapped in a Kubernetes layer, and it runs. Pod is where your app lives and run. That is what I mean to say. It's like a house, okay, where your app is going to reside and it is going to run. So that is what I mean by saying it's a container wrapped in Kubernetes layer. Okay, I hope this makes sense. And it's the smallest deployable unit in Kubernetes. That is something that you need to remember. Now let's talk about deployment. So deployment is a component in Kubernetes that runs your app continuously. So if your pod crashes, Kubernetes is going to restart it automatically, and it does it with the help of deployment. And if you want more copies, when after deploying the app, if you want more copies of your app, which we call it as scaling, Okay, deployment is going to handle it. So let's say like if you run an e-commerce website, and if there is going to be a spike in orders and you want to scale up order service, so you would be needing more instances or more copies of order service, right? So you are going to update the deployment for the same, and Kubernetes is going to handle it. Okay. If you want zero downtime updates, deployment does the rolling updates. So there is a concept of rolling updates that you can have. And if you have a new version that is supposed to be released, so without having any sort of downtime, you can basically roll out a new update. Okay. So with deployment, you can always have, so with deployment, you can always have your app running, and Kubernetes is going to restart if it dies, and it is also going to allow it to update easily. Okay. Now, one question that you might have is, if you heard or if you have learned about the Kubernetes architecture, there is a component called controller manager that you see over here. This where my mouse pointer is. Within control pane, there is a component called controller manager. Okay. And what I had told you is controller manager, or even if you read up online, you will know that controller manager is the one that makes sure that if there is, it keeps a track of whether the pods are running or not. And if anything crashes, it is going to automatically restart, right? It is going to automatically restart. And right now, when explaining deployment, okay, I said that, hey, deployment is actually going to make sure that nothing crashes. And if anything crashes, you can define the replicas and all. If anything crashes, okay, it is going to restart and all. So what I've observed is whenever beginners learn this, okay, they go a little bit confused between this component, which is controller manager, which is actually monitoring all the pods. And if anything crashes, it restarts. And then you have this deployment component, which is also doing the same thing. Okay, so I would want to clear the air over here, and I would want to explain what is the difference between deployment and a controller manager. Okay, so see, deployment is an instruction that is coming from you. You as a developer will define deployment files. You will create deployment. So it's a component or instructions that is coming in from you. You are defining your desired state of your application. So let's say you want 3 replicas. Replicas meaning 3 copies of your application running, right? So you would define that in the deployment.yaml file. There is a configuration file for deployment. You will define it over there. And you will, this is like you're declaring the state that you wish your app to be always in. Okay. And controller manager is going to receive, or it is going to check that deployment component, and it's a worker. Okay, so what it's going to do is it is going to follow the instructions that you have defined in deployment. I hope this is making sense. It is actually going to follow the instructions that you've defined in the deployment. So how things work is you create a deployment YAML file, then API server is going to store it. Okay, it is going to store it in the storage of the Kubernetes. Controller manager is going to see it, and then controller manager is going to manage it. Okay, I hope this is clear. Okay, I hope this is clear, and I hope you all are clear between the difference of the two. Okay, generally beginners got confused, so I thought I'll emphasize a bit on this. So now it's time that we are going to create our first deployment. Okay, and with the help of deployment, a pod is going to be created. Okay. So first we'll check if there are any pods running on our local machine, and the command for this is kubectl. Okay, get pods, like so. So you will see there are no resources in default namespace, which means, or which indicates that there are no pods running. Now what I'm going to do is I'm going to say kubectl. I'll say create deployment. Okay, and I'm going to, so this is the command basically using which you can create a new deployment always in Kubernetes. Okay, kubectl create deployment. Now how are you creating the deployment? So I'm going to specify the name of the deployment, which is web. Okay, I'm going to mention the image over here. So I'm going to say image is equal to, and you can specify the image name over here. So the image name I'm specifying is nginx. Okay, so this is what I'm doing. Okay, so I'll just reiterate. I'm saying kubectl create deployment. Okay, so kubectl is basically the tool. Create deployment is the command that is instructing to create a new deployment object. Web is the name of the deployment that I'm creating, and image is the image that I'm specifying. So this image is will be used from Docker Hub by default. Okay, and a pod will be created using this. Okay, so I'll say enter, and you can see over here deployment.apps/web is created. Okay, so you can see over here this is created. Now if I run this command kubectl get pods, you're going to see that there is one pod that is running. Okay, so one question I would have is, did we create pods? No, we create deployments, right? And as a result of creating the deployment, pods got created. Who creates pod? So as a developer, we do not directly create pods. Pods are created by the control plane. Within control plane, if I have to be specific, is the controller manager who creates the pod for us. So as a developer, we always create deployments, and it's the control plane within Kubernetes that does the job of creating and managing pods. So I hope this has been useful. So now it's time that we begin talking about services in Kubernetes. Now, what are services? So you have a pod running in Kubernetes, right? Whenever you run any sort of application, it runs within a pod. Now, pod by itself is not accessible, okay? And pod is invisible to the outside world beyond cluster. And pods are such that they keep on crashing, restarting. Okay, so it's not sure that the IP address that is even assigned to the pod that is going to be stable, right? So this is a problem, and this is where services or service component in Kubernetes comes into picture. So service says, I am going to give your application a permanent IP, and I'm going to let you and all the other apps talk to your application. Okay, so basically it is allowing you to expose your application to the outside world and also within the cluster itself. So within the cluster, so there are multiple services that might be running within Kubernetes. So you might have 10 services, one for order, payments, notifications. They might want to talk within themselves as well, right? And the outside world might also want to access these services. So both these use cases are satisfied or fulfilled with the help of this component called service. So service gives your application a permanent IP. Okay, it lets other application inside the cluster talk to it, and it lets you expose it to the browser via node port. Now, what is node port? Node port is a kind of service type which we'll be talking about shortly. Okay, so service basically gives your application a stable address so that browsers and other apps can reach it. I hope this makes sense. Now, there are few service types that you should be aware of. First is cluster IP. This is one of the service types. Then you have node port. Then you have load balancer. And then you have external name. Now, these are some of the service types that exist. Now, let us talk about cluster IP. Now, what is cluster IP? So cluster IP is going to expose your application within the cluster itself, and your application won't be accessible from the browser. Okay, it is useful when backend is talking to backend and within the microservices communication. So if there is service to service communication within your application, then you can make use of cluster IP. Okay, because it is not going to allow other services access it from the browser. Other services within the Kubernetes cluster can talk to each other, can talk to them if they're making use of cluster IP. Okay, I hope this is making sense. So you should use cluster IP when you don't want your service to be accessible from outside the Kubernetes cluster, and you just want it to remain accessible inside the Kubernetes cluster, which is other services will continue accessing it. That's cluster IP. Then you have node port. Now, what is node port? Node port is going to expose your app on a node's port IP. Okay, nodes port and IP. Okay, now what does this mean? So it allows you to access your application from the browser. You can access it using a IP and a port number. So IP plus port. Okay, on your node. That is how node port the name arises. Okay, and there is a range of the port that you're seeing. Okay, it's 30,000 to some 32,767, and it is generally used for local testing, demos, or for learning Kubernetes. All right. Then you have load balancer. Now, what load balancer does is it is going to create a cloud load balancer, and it is going to give you a public IP or ATNS. Okay, and this works best on cloud services like AWS, which is by Amazon, By Google, you have GCP, and by Microsoft, you have Azure. And this is majorly used in production applications with real users. So when you take your application to production, you switch to load balancer. And you also have external name. This is also one kind of service. Okay, one kind of service type. What this does is it is going to map the service to an external DNS. Okay, and it is used for external DB or third-party API. And this is a bit advanced, and it is rarely or less used is what I would say. Okay, so these are the kind of services that exist. And just to summarize over here, you are going to, this is a summary table over here. So cluster IP is accessible from inside the cluster, and it is used when you want to do microservice to microservice communication. Like within the microservices you want to do communication, you should use cluster IP, because cluster IP does not expose your app to the outside world. Node port, it is going to expose it from IP and port, like from within your browser, and it is good for local testing or learning. Load balancer is going to access it from the public internet. It's going to allow it from accessibility from the public internet, and it is good for production. External name is going to map your services to external DNS, and it is good if you want your application to be accessed by outside services. Okay, so this is how things work. Okay, you have deployment. Deployment is going to create and manage pods. Okay, you define a deployment, and then Kubernetes is going to create a pod for you. Okay, and it is going to run your app. An example app that you can run is Nginx. Then you have service. So you have created a pod using deployment, right? You've created a pod using deployment. How do you access it? So you can make use of service that can give you a stable connection to the pod. And node pod is a service type that lets you access a service from your laptop. If you're trying to access a service within your laptop, for the pod that you are running locally, you can make use of node pod service type. Okay. Now you have browser, right? So the request will go to the node port, which is so node port is going to give you the host and the port. Okay, and from there it is going to go to the service, and service is going to take it to the pod, and then pod is going to take it to the container, because within pod you will have your container running. I hope this entire explanation makes sense, and I hope this has been super useful. So right now what we've done is we have a pod running, which is this pod where Nginx is running. Okay, so I'm just going to clear this, and I'm going to say get pods, and you can see over here this pod is actually up and running. Now what I'm going to do is I'm going to try and access this particular service, try and access the Nginx welcome page. Okay, it's running within Kubernetes, and I want a way for me to access it. Okay, so what I'm going to do is I'm going to first expose my application, which is Nginx, using a service. So I'm going to say kubectl over here, kubectl, expose deployment, and the deployment name is web, and I'm going to say type over here. Okay, so we need to now specify the type of the service that we want to make use of. So type is equal to node port. Be sure of the capitalization over here, and then mention over here port is equal to 80. Okay, so what this command is doing is we are saying expose, we are making use of this tool kubectl, then we are saying expose this deployment which with the name web. Okay, because we have created the application deployment with the name web, right? And I'm saying make use of the service type as port over here. And the port within the container is 80, because Nginx by default is running on port 80. The moment I say enter, it will say service/web exposed, right? This is a confirmation. So what I can do now is I can say kubectl get svc. So this is the command that will help us check the service. And you can see over here, web basically is giving the output as node port, and you can see this is the cluster IP. And you can see the port 80 within the container is exposed on port 30241 on my local machine, as you can see over here. Okay, 80 is the app's internal port, and 30241 is the port open on my machine. And this is the cluster's internal IP. Okay, this is something that we can ignore for now. Okay, so this port is what is important. kubectl get svc web. Okay, I'll say enter. Okay, and you can see okay, get svc web. So you will see this get svc web. So now I'm just getting the svc, the service web over here. Okay, and I'll say take 30241 and I'll head over to the browser. I'll say localhost : 30241. And you can see over here, this is Nginx. Okay, so what happened now? When we hit this URL, okay, this request went to node port service, and then from node port service, it basically went to the pod, and then from pod we are actually seeing the Nginx containers welcome page. You can see over here. So this is running now on Kubernetes, exposed via service, and the service type that we've used is node port, and we created a deployment. With the deployment created pod for us, and within the pod we have Nginx container running. I hope this is making sense. So at the bottom, at the crux, we have Nginx container running within Docker. Nginx container, it's just a container that is running. Where is it running? It is running inside a pod, right? And who created the pod? We have not. Kubernetes created it with the help of deployment that we specified. And this pod is exposed via service, and the service type that we are using is node port. I hope this entire thing is making sense now. Okay, and congratulations, you now have your first container that you can access, and it's up and running within Kubernetes. Okay, so this is a command to get all the services, and this is a command to get the details of a particular service. I hope this has been useful. So now it's time that we begin talking about replica sets. Now, what are replica sets? So if a pod crashes in Kubernetes and it's supposed to be available, then Kubernetes restarts that particular pod using something called as replica set. Okay, so let me give you a demonstration. So here, if you run this, you have this pod that is already running. Okay, what I'm going to do is I am going to delete this pod. So I'm going to say kubectl, kubectl. I'm going to take the name of the pod. This is the entire name of the pod. Okay, and I'm going to say delete pod and then pod name. Now you will see this pod has been deleted. But now if I say get pod, you will see that this pod is already being created now. So this was deleted actually, right? So earlier this pod existed. Okay, then we deleted this pod, right? Can you see this? We deleted this pod, and then now you can see Kubernetes is recreating the pod, and you can see, you can verify that with the help of the status container creating, right? So it's actually creating. It's not in the running status yet when we ran this command. Now if I run this command, you will see that it's now in the running status. So initially it was creating that particular container, creating that particular pod. Okay, so what happens is Kubernetes, to Kubernetes, we have, when creating the deployment, we had told that we want a deployment of this particular with this particular app, and I need one instance. So we did not specify the instance, but by default, one instance is what is needed, right? And what Kubernetes is doing is it is always trying to match the desired state that we mentioned as a developer. So when creating the deployment, we said we want one copy of this particular app always running, right? When creating this deployment, we said that Nginx, we want this deployment to be running, right? It created one pod as a result, right? Now, when we try to delete that pod, Kubernetes is trying to match the desired state mentioned by the developer, and as a result, if you try to delete the pod, it is going to recreate it, because at least one instance is what is needed by the developer, right? And I can also demonstrate this to you in a separate window. Okay, so generally doing this sort of demonstrations, a separate window is recommended. So what I would do is I have this window, okay, and here I have this another window. Okay, so what I will do is, here you can see I'll run get pods in the watch mode -w. Okay, now what it will do is it is continuously running and keeping a tab of what sort of pods are running. Okay, I'll say clear. Oh, wait a minute. I'll just stop this. I'll say Control C. I'll say clear, and then I'll run this. Okay, so you will have this running always at the top. The screen is clear. Now here I'm going to say kubectl delete. Okay, and delete pod, and I'll mention the pod name. Now what is the pod name? So this is the pod name. I'll just copy this. Oops. So I'll go over here and I'll paste this and I'll say enter. So you can see over here the entire process. Okay, here you can see the entire process. Can you see the entire process? It was initially running. Okay, then I ran the delete command. So this got terminated, and then here you can see this new pod was immediately created. You can see, and it was in the pending state. This is a new pod, right? And while this was being terminated, okay, this was in pending state, and then this started container creating, okay, and this deletion of this was completed, and then this started running. Can you see the entire trace using this option of -w? Now -w is a useful option, very useful option. It means watch mode. So you are running this command in the watch mode, okay, and what this command tells is, what this option in fact tells is, -w means keep watching the changes that are happening with this command, and whatever changes are happening, it is going to show you all the live changes, and you can see all the live changes, like how one pod was terminated because of a command we ran, and how Kubernetes tried to match the state match the desired state that was mentioned by the developer. Okay, and this entire process, that you're seeing over here, is called as Kubernetes self-healing. This is a self-healing property or a feature of Kubernetes. I hope this is making sense, and I hope this demonstration is turning out to be useful. So I'll just close this another terminal that I had open, and I'll just exit this watch mode by clicking on Control C on Windows and Command C on Mac. Okay, so I've not exited. Now, how is this happening? So this is happening with a component called replica set, and so you will say, I have not created any replica set. So yes, replica set was created automatically. Okay, so you can say kubectl get rs, which is, so you'll get this replica set over here, and you can see over here, desired count is 1 over here. Okay, current count is 1 and ready state is 1. Okay, and age is 82 minute of this replica set. You can also say kubectl describe rs, and you can get this replica set described. So it is going to give you the complete description of this particular replica set as to what is the label and everything, like who owns, like who is controlling this, right? So you can see over here, this replica set is being controlled by the web deployment, and web deployment is the deployment that we have defined over here. Which image is it using? It is using this Nginx image over here. Okay, so this is how you can see, and yeah, so this is about replica set. Replica set is something that we have not created. Now this replica set we had not created, it was created by Kubernetes itself. When we define deployments, these things like replica set and all are created behind the scenes, right? And this is what makes sure that the state is met, like the desired and current state is kept track of, okay? And things work the way developer always wants it. I hope this has been useful. So now I'm going to show you how you can scale your application to handle more traffic, okay? So here, if you say kubectl get pods, okay, we have one pod running, okay? What I'm going to do is I'm going to run this in watch mode. Okay, 1 second. So I'll just clear everything. I like running watch mode in a clear screen. So we have one pod running. Okay, now I'm going to have another instance of the terminal, and here I'm going to run another command. So I'm going to say kubectl, and I'm going to say scale deployment, and I'm going to say web -, 2 times, and I'm going to say replicas is equal to 5. Now, how many number of instances you want, you have to mention that with this replicas option over here. Okay, so what you're saying is, using kubectl, you're communicating to the Kubernetes cluster. You're saying scale my deployment. The name of the deployment is web, and scale it to have the replicas 5. And the moment you say enter, you can see 5 new instances, like 4 new instances will be created. One instance is already there that is running. Okay, and you can see 4 instances were created. Right, you can see over here, all the 4 new instances are created. Can you see? Right. So this is how you scale things. Okay, and now if you exit watch mode, and if you just run get pods without watch mode, you're going to see your application is up and running. And there are 5 pods. One pod was already there, and there are 5 pods now that are running. Okay, and you can actually see this is the replica set over here. Okay, you can actually describe this replica set. Okay, and if I describe this replica set, okay, and if you scroll up, you're going to see the desired count of the replicas is 5 now. the current is 5 and the ready state is 5. Okay. So why 5? Because we have updated the replicas over here, right? We have updated the replicas over here using this option. Okay. So from the developer standpoint, how things work is you update the deployment. You say that, hey, I want 5 replicas of this particular app running. Behind the scenes, replica set is updated. You don't update replica set. Kubernetes does that. Replica set is updated to the desired count of 5. Okay. And then Kubernetes checks the replica set has current state of 1. Okay. So initially there was only 1 instance there, right? So what it does is desired is 5. So it will try to match the current state to that of desired state. And it will add 4. It added 4 more containers, like you could see, right? And 4 more pods were added, and then we could verify it. Okay. On verification, we could see like there are 5 pods running. Now you can again have this running in the watch mode. Let me have this in the watch mode. Okay, like this. And I'll scale the deployment again. I'll scale it down now. Okay. So let's say my e-commerce website had a lot of traffic. Okay. Like there is a, let's say, Black Friday sale that is going on, a New Year sale that is going on. And I scaled my order service like this. I scaled it to more instances. Now the traffic is gone and the sale is ending. So I want to scale it down. So I can scale it down like this. I can say 1, replica 1. So you can see it's terminating everything. Okay. It's terminating everything. And now there will only be a 1 pod that will exist. So if I say kubectl get pods like so, you can see only 1 pod running, right? So this way you can scale up and scale down really, really easily with replica set, and it's totally in your control. Okay. And as a developer, you feel that power. Okay. And these things that I'm showing you are really helpful when you start working on production grade applications, like scaling up your application, scaling down based on the traffic. These all things is what matter. Okay. You are doing it seamlessly with the help of this amazing tool called Kubernetes. Hey there. So now it's time that we talk about rollouts, okay, or application updates. See, whenever you're working in production or any sort of application you're building, there is going to be updates in your application, right? You would want to roll out updates. And generally what happens is whenever you roll out updates, if you're using traditional methods, there will be application downtime, which you cannot avoid because you would be actually replacing and deployment will happen. It will take some time depending on the complexity of your application. But with tools like Kubernetes, okay, you can actually roll out a deployment, you can roll out a update, basically a version update with 0 downtime. Okay. And enterprises, trust me, these days expect having 0 downtime because, we are living in an internet world. And everybody wants the application to be up all the time. And if application goes down, it's a revenue loss for the companies. So they want 100% uptime. So I'm going to show you how Kubernetes makes your life easy over here. Okay. So first of all, I'm going to say kubectl get pods. We have this 1 pod running. What I'm going to do is this particular pod is running Nginx, right? And it is running the latest image of Nginx because when creating the deployment, we had not specified the image, right? The image version, right? So what I'm going to do is I'm going to say kubectl and I'm going to say set image deployment /web for this particular deployment. What you can do is you say Nginx is equal to Nginx colon 1.25. Now this is one of the versions, okay, one of the image versions that I have for Nginx. You can change this to any version. Okay, so what I'm saying is for using kubectl, interact with the cluster, set the image for this particular deployment, and the images, Nginx image should be 1.25. Now the moment you say this, you will see the image is updated. And if you go over here, okay, now you can watch the rollout happen. Okay, now how can you watch the rollout? So for that, you will have to make use of kubectl and you will have to say rollout status deployment /web. Okay, now if you press enter, you will see waiting for the deployment web rollout to finish. 1 old replicas are pending termination. Okay, 1 old replicas are pending termination, and then the deployment has been successfully rolled out. So this gives you the status. This command actually gives you the status of any sort of update or rollout that you are doing. Okay, now what I can do is I can see if actually the image was updated. Okay, so you can go to kubectl and you can say describe, and I can say over here, okay, I missed E over here, kubectl, and you can describe this image. Okay, so the pod actually was deleted and restarted because you updated the image. Okay, so first I'll have to get the pods now, and then I'll have to describe this pod. Okay, so I'll have to copy this because the older pod was deleted, and I'll have to get this. Oops, so it's not describing this kubectl. Okay, so I missed a pod keyword over here. Okay, that is why it was not working. Okay, so I added this pod keyword, describe the pod. Okay, now you can see over here. Okay, you can see these are some of the events that have happened within this pod. You can see how it pulled the image 1.25 and it successfully updated this image. You can see over here, and container was started. So these are some of the events that you're seeing inside this particular this particular pod. Okay, so you can see it's actually using the image that you specified, right? And there was no downtime. Okay, you can see a lot of things inside. Okay, and here I think there has to be a label that mentions the image. You can see the image over here. So this is that label. Okay, it mentions the image name. Okay, so it's using the version that we are using. Now what I can do is I can again update the rollout over here. I can say instead of 1.25 now I want latest version of Nginx. So I'll say this, and then I'll check the rollout update. So you can see waiting for the rollout to finish. The rollout has finished, and I can now again get the pods because the pod's name will change. Okay, you can see this is the pod name. Okay, what was it earlier? So you can see earlier it was G8TKV. Okay, and now it's QH9HG, right? So now what I will do is I'll just describe this pod over here. Okay, I'll just get rid of this name. I'll copy this name properly, and I'll describe this pod. Now if you describe this pod, you will see some events here at the bottom. Okay, you will clearly see that it pulled out Nginx latest, and here if you scroll up, okay, you will see the image that is being used is Nginx latest. Okay, so this way you can actually see the rollout happen in real time, and whenever you do a rollout, okay, the pods that are using the old images, okay, pods containing containers using the old image are deleted, and new pods are parallelly started, and they are replaced with the new old pods. Okay, so that is how the thing works, and the traffic never stops. It basically performs a switch from old to new. So first the new pods are created, and then the old ones are replaced with the new ones. That is how things work. Okay, I hope this is clear as to how this rollout is happening and how there is zero downtime. And I've actually proven to you that you can actually update the image names, image versions over here. So how it will work is, see, if you're working in a microservices architecture or in a monolith application, you will basically have the image, okay, like the application containerized, and there will be the image tags that you will add, which will act as a version, right? And these image tags, like let's say if you are running your application on version 1, and let's say you made some changes in the application code, now you want to release that as version 2. So what you will do is you will create an image with the tag version 2. You'll push it to remote Docker registry. Okay, and then in Kubernetes, wherever you are running the Kubernetes in whichever cloud, okay, you will come and you will say, hey, now use this particular image version, and automatically the deployment will update itself. It will pull the latest image from the remote registry, whichever you are using and whichever you have configured, and it will update it. That is how the entire process works. I hope this has been useful.
So let's start talking about the importance of app selectors or selectors, okay? And we'll understand how a service selects a pod. So what I'm going to do is I'm going to say kubectl, and I'm going to run a command that is going to help me get the YAML configuration for the service that we are running. Yes, so we have not written YAML, but for whatever service that is running, we can actually get the YAML using a command. I'll just show you. So you'll say get, SVC stands for service, web, I'll say -o, and I'll say YAML. Okay, like so. I'll press enter.
And now over here, you are going to see, so this is the entire YAML configuration. And we have not defined this, but for the service that we created, we got the YAML. We can actually save this in .yaml file as well. Okay, but I'm not going to do that. Here you can see this selector tag, which says app:web. Okay, now what this is going to do is this is going to make sure that it selects all the applications that have this particular label. Now, what is exactly a label? Okay, what is this term label that you're hearing again and again? Label is just a key value tag that is stuck on a pod, and that is stuck on a pod to help identify it, because there might be multiple apps running in a Kubernetes cluster at any given point in time, right? So when on the pod, you're going to have app is equal to web, okay, and this tells Kubernetes that this particular application belongs to the web app, like the application named web. Okay, that is what it tells to Kubernetes. Now, what does service actually do? Okay, this was about pod. Now, what does service actually do? So you create a service using this this command. So you say kubectl expose deployment, okay, and then you say web, and then you mention the type as node port. This is what we did, and then you say port is equal to 80. This is how you expose the deployment and service was created. Okay. Now, by running this command, what Kubernetes does is it creates a service that internally says selector will be app and web. Okay, which means this means that the service is supposed to send all the traffic that it gets over here to all the pods that have app is equal to web, that are tagged with this label called web. Okay, and that is how things functions, and this is the importance of labels and selectors in Kubernetes. Okay, I hope this is making sense. So how traffic will flow is whenever you head over to the browser, and if you try to access the service or the application, okay, what will happen is this traffic will go to the service first, and then the service is forwarding this particular traffic to all the pods with the label web. Okay, so that is how it works, and this particular service is exposed on this particular port on a local machine using node port type. Okay, now what I can do is I can remove the label over here. So let me remove the label. Okay, so I'll say kubectl label pod. Okay, we'll need the pod name, so I'll say kubectl get pods. Okay, I would also want to show you the labels associated with this particular pod. So what I can do is I can say get pods, and I can add this option, which is okay, show labels. Okay, and you'll see these are the labels. You can see app is equal to web. This is a label that is assigned to this particular pod. If you scale this particular deployment, there will be multiple pods, and they all will have this label because they belong to the same deployment. Okay, now what I will do is I'll try and get rid of this label. Okay, so here what I will do is I'll say kubectl and then label pod, and I'll mention the pod name. So pod name is this one. Okay, I'll mention this pod name, and I'll say app hyphen. Okay, so this is going to remove app is equal to web label. Okay, and let me press enter. Okay, so you can see unlabeled, and now let me show you the label over here. So what exactly happened over here is, if you see, okay, so here we removed the label, right? You can see this particular pod was unlabeled. Okay, and this particular pod over here is this one, and you can see the label being removed from here, right? The label is removed, but what happened is Kubernetes is trying to match the declared state, and hence if we modify the label, okay, it started a new pod with this particular label. You can see over here. Okay, so this is Kubernetes trying to match the state that has been declared by the developer. Okay, so if I unlabeled something, it already tried to match, and it created a new container with this particular label, as you can see over here, and this new pod is actually running now. Okay, if I run this again, you will see now that we have two pods. So earlier we had only one pod with this one label, but as soon as I unlabeled this particular pod, we have now one more pod with this label. And now if I try to access, it is still going to work. Okay, so here Kubernetes is trying to make sure that this app is always running. But I've shown you how labeling and unlabeling works. And now what will happen is whenever you are trying to access this application from the browser, the service is sending the traffic to this pod and not the old pod, because the old pod has been unlabeled. I hope this has been useful. Now let me show you some commands using which you can debug the pods. And debugging pods is one of the important skills, because in production you might face some sort of issues, challenges, and you might want to see the logs as to what is happening. All right. So what I'm going to do is I'm going to say kubectl get pods, kubectl gets pods. So I have 2 pods right now that are running. What you can do is you can say kubectl logs, and you can mention the pod name over here. So I can copy this pod and I can mention the pod name, and you can see over here, this is the entire log of all of this particular pod over here. You can see over here, like Docker is being initialized and then it launched, and then whatever happened over here, you can see all the logs over here, right? You can access the logs. You can even execute commands into the logs. Okay. So if I want to log into the container, log into the pod, and this will open the shell inside the container and I can run commands. So I can say kubectl exec -it. Oops, I'll need the pod name over here. Okay. So I'll say kubectl exec-it. Okay. So I'll log in interactive mode. I'll mention the pod name over here and I'll say sh like so. Okay. Oops. So it's okay. So sh has a space over here, and now I'm inside the container. Okay. And now I can say ls, and you can see over here, docker entry point .sh, and then I have dev etc folder. You can see there are a lot of other folders like home, media, proc, and a lot of folders out there. I can say what is my present directory. So I'm in the root directory. I can say cat -etc, /etc nginx/nginx.conf. Okay. And you can see the nginx file over here. Okay. This is the nginx file. Okay. Nginx configuration, and I can say exit over here. So I've exited the shell over here. Okay. I can even describe the pod. Okay. So I can say kubectl describe pod, and I can mention the pod name, and you can see the entire pod details over here. All the details, like what image this is using. Okay. It is using nginx latest. Okay. Namespace, what is the priority of this pod, what node it is running on, when it was started, everything, the IP of this particular pod. Can you see this? Port, host port, and where is it mounted? You'll see a lot of things over here. You can see all the events as well that have happened with the pod over here. Okay. So you can see events, images it running, IP of the pod, container status, and everything. This is like one of the important. So these few commands that we have seen are important to help you debug pods and any sort of errors in Kubernetes. Hello everyone, and now it's time that we begin talking about how can you define YAML configurations when it comes to Kubernetes deployments. So what I'm going to do is I am actually going to run a command over here. Okay, so the command I'm going to run is kubectl get deployments. This is the name of the deployment. I'll use this flag -o and I'll mention YAML. Now the moment I press enter, I'm going to get this YAML configuration over here printed. Okay, and this is the configuration that Kubernetes itself, like kubectl, is giving me. And this is for my deployment that we have created with the help of command. Okay, now first question is, what is YAML? Okay, so YAML is basically a configuration language, you can say, and the structure of the file is like this. Okay, you have like key value pairs over here. So kind is deployment, metadata. So within metadata you have annotations, and the annotations are these. Okay, so creation timestamp is this. So this way the configuration is defined, and you would notice everything is key value pairs and there is indentation. So here these three things are not indented. There are no spaces on the left hand side, and then here you have space, then here you have tab, like one tab here, two tabs here, then again one tab over here. So this is how the file is organized. Okay, so just for them who don't know this YAML format, okay, I'm just giving you an overview. So this is YAML, And why Kubernetes uses YAML? Because you cannot do everything with the help of just commands. You need some sort of configuration that needs to be defined so that you can define your desired state as to how you want your app to be deployed. For example, if you want 3 replicas or 3 instances of your application, you should have a file wherein you define all of that, like the number of instances or the replicas you need, and the image that you want to make use of, and everything like the match label, selector, everything. Okay, here you can see images and all, everything we have mentioned. Okay, everything is mentioned. Available replicas, all of this. Okay, so there should be a file where you can update this, and you can even apply the configuration using that particular file. Okay, and Kubernetes, what it does is it looks at the file and it tries to match the state that you have mentioned in the file. So that is the significance of YAML file. Okay, you can generate the YAML file not only for deployment, but you can also generate it for service. So for service, you have to say svc. So kubectl get svc web-o YAML, and you will get this for service. Now what you can do is, okay, here this is auto generated for the deployments and services that we have created so far. This is auto generated, and there are a lot of unnecessary values and tags that have been mentioned since this is auto created. So what I have done is I've taken these 2 configurations and I've created 2 separate files, which one is for deployment and other one is for service, and both the files you will find as an attachment to this particular lecture in the form of resources. So feel free to download those files. And here, as you can see, I've downloaded both the files, like app.yaml and service.yaml. Okay, what I'm going to do is I'm going to copy these files. Okay, just save it somewhere on your local machine, unzip it, and then what you will do is come over to our project. Okay, this is our project here. And now here in our project, what we can do is we can define a new folder. So I'll say K8s, and within this folder, you can have like another folder called demo. Okay, and within this demo folder, we can paste both these configurations over here. Okay, so you can see these both are YAML configurations, and if you open this, okay, you are going to see both the configurations. Okay, here this is app.yaml. So I'll just collapse this sidebar so that we get a better view. This is app.yaml, okay, which is defining the deployment over here, and this is service.yaml, which is defining the service. Okay, so what we can do is we can go through both the files, and you will notice like I have done a lot of cleanup. Okay, for example, here there are a lot of there are a lot of configuration that is actually not needed, like annotations is not needed over here. So I've just cleaned that up. Okay, so this is a cleaned version or a better version of the file that you can see. Okay, so let us go through the files. Okay, first thing, I'll start with the deployment file, which is app.yaml. Now the first thing that you see over here is the API version. So this specifies which Kubernetes API to use. Okay, so we have mentioned apps/v1, and kind defines the kind of object that we are defining in this YAML file for Kubernetes. Okay, so we are not defining a pod or a service, we are defining deployment. So that is what I've mentioned over here. Then we have specified under metadata, we have specified name, and this is the name of the deployment. So you can name it whatever you want to. So if you are deploying an e-commerce application, you can name it whatever you want the deployment name to be. I've defined it as my app. Okay, because something called as web we have already created. Okay, so I'm defining my app. Then you have some specs. Now under spec tag, under spec over here, you are going to have all the desired states as to what you want Kubernetes to do. Okay, so here you are mentioning replicas first. Okay, so you are saying over here that I want 2 pods of this particular deployment or the app that is there. I'm deploying this deployment to be there. Okay, I'm mentioning the selector over here. Okay, so selector is basically the selector basically defines how deployment finds its pods. Okay, so here we are defining the pods with the labels my app. Okay, so all the labels with my app, all the pods with my app label will belong to this particular deployment. Okay, and then if you scroll down here, you have template. Okay, now this is a template as to how each pod should look. Okay, and that is what we are defining over here. And then here we have the spec again, and this is the spec for the containers over here. So this template part is actually like defining the pod structure. Okay, pod over here. So metadata labels my app, meaning this is the label that should be added to every pod that is created. And then under spec, you have containers over here. Okay, so this is a pod specification. Here you are saying the name should be my app. Okay, image that you should use for this particular container is Nginx. This is the Docker image that you should run, and port, which is the container port. So this should be on port 80. Okay, so app inside the container listens on port 80. So that is what you have defined over here. So this is deployment structure that you are defining. And then you have the service structure. So here what you're doing is, it's a similar structure, but the configuration is for service. So here you can see the API version again we have defined. This is the core Kubernetes API that we are mentioning. Kind, what is the kind of the object? So we are not creating deployment now. Here we were creating deployment, but now here we are creating a service. This is the name of the service here. Then under spec, we have all the specifications. So here you can see this is a selector. So what does service do? It exposes your pods, right? It allows external traffic to come and reach to your pod. So we are saying selector as app : my app. So what this is going to do is it is going to send all the traffic that have the label as my app. Okay, this should be the label. App is equal to my app. What is the type of the service we are using? We are using node port. And the ports that we have mentioned over here, this is the service port. Okay, this is where clients talk. Okay, and then this is the target port. So this is where the traffic is forwarded to the port within the container. And this is the node port. This is a fixed port opened on our machine, on the host machine, on your machine as a developer. So you can access this service using localhost 32,000. Okay, I hope this is making sense. Now, once this is done, let us see how we can apply this configuration and get the deployment and service created in Kubernetes. So what I'm going to do is I'm going to come over here in the terminal. I'm going to make sure that I've navigated to the K8s folder, which is the folder where these both files are defined. Okay, so it's not defined in K8s, but within K8s, there is a demo folder. Okay, so I'm going to navigate to demo here. And here I have both the files. So you can see app.yaml and service.yaml. What I'm going to do now is I'm first going to apply or create the deployment, and then I'm going to apply the service. Okay, so I'm going to say kubectl over here, apply -f, and I'm going to say app.yaml, something like this. And I'll press enter. You can see this deployment was created, and I'll also apply service like this. Okay, so you can see service was also created. Now, if you say kubectl or kubectl get pods over here, you're going to see the pod over here. So you can see two pods running now with the name or the label my app. Why my app? Because here you have defined my app. You can see my app, right? The labels is my app, right? You have defined that, and you can see that running. You can also get SVC over here, which is the service, and you can see over here, this is what we had defined for my app. You can see the port that is being exposed on a local machine is 3200. Now, if you come over here, so this is 30241, which is something that we created early on. So if I go to 3200, you will see, oh, it's 32000. So if you enter that, you're going to be able to access Nginx welcome page. And this is because this is how it's operating. Now here you might have noticed I applied deployment first and then services. Okay, so this is the order in which generally things work. So you first create the deployments. Deployments are created first and then services, because to route traffic, service job is to route traffic to deployments, right? So to route traffic, pods must exist, and pods are created with the help of deployments in Kubernetes. Okay. Now this is done. We have everything set up, and you can even access it from the from this particular page. Okay. Now one thing I would like to clear over here, like if you come to the configuration, okay, I've seen beginners get confused between these three ports. Okay, why are we defining like these three ports? So within ports, like this port tag, okay, here you have mentioned the selector, which is fine. You want this service to be associated with all the labels, all the pods that have these labels. Okay, you have defined the type of the service, which is node port. This is clear, but generally people get confused for this ports thing over here. So we have port, we have target port, and we have node port. Okay, so let me clear out over here. Port meaning Okay, port is the service port. So 80 over here, this is the service port, which means like there is a service that is created inside Kubernetes, right? So whenever traffic comes to the Kubernetes service, okay, it hits this particular port of the service. And what service is going to do is it is going to forward the traffic from this port to internal pods. Okay, target port is 80. So this is the port of the container. Okay, so traffic from service port 80 is forwarded to the container port 80 over here. This is the container port. And then node port is the port that is exposed on your local machine, 32000. Okay, 3203 times. Okay, so this you can change, okay, depending on your preference. Okay, here target port, this is the container port. So Nginx by default runs on this port. So that is why we have this mentioned over here. And service port we have mentioned as 80. So traffic first hits service, then from 80 it is forwarded to container port 80. Okay, and it comes from here. This is our local machine. So this is one sort of clarification I wish to provide. Okay, now our app is running. Now what we can do is we can even delete the service and deployment. So what I will do is we have it up and running. I'll say kubectl, okay, delete -f, and I'll say service. So I'll delete the service first because I want to cut off the traffic first, and then I'll delete the deployment, which will in turn delete the pods. So I'll say delete this. So you can see over here, this is deleted, and then over here, I'm going to say app.yaml. So this is also deleted over here. Okay. Now, if you try to get the service, you won't find that service, and you won't even find the pods over here. You can see services and pods both are gone. And now if you refresh this, this won't work. You'll get page not found, a site cannot be reached. Okay. So this is gone. So this is how you can actually, make use of configuration. So here I have two sort of configuration. One is for deployment and other one is for service. Also, rather than running two different commands, you can combine both the commands into one. So what you can do is, instead of saying apply 2 times, what I can say is apply app.yaml, and then I'll say app service.yaml over here in single configuration. And you can see both are created in a single, single command. Okay. And you can delete both as well. Okay. Delete -f, and I'll say service.yaml, something like this. You can see both are deleted. Okay, so this is how you can make use of files. And if you want all the configurations that exist in a particular folder to apply, what you can do is you can say kubectl apply -f, and you can press dot. So in the current folder, whatever YAML files are there, they all will get applied. So let's say you have a lot of YAML files and you want to apply or create the objects for all of them, you can directly say dot. Okay, and if you want to delete, you can simply say delete like this. So these are all different variants of the commands, okay, that you can make use of. Okay, now what we've done is we have created 2 separate files over here. Okay, 2 separate files. Now what I can do over here is I can create a third file. Okay, and I can have both these files combined into one file. Okay, so I'll create a folder over here. Okay, I'll say separate. Okay, something like this, and I'll move both these files over. I will just move service.yaml over here. Okay, like so. Okay, and app.yaml, I'll get it copied over here. So app.yaml and service.yaml have moved to separate. Okay, because here we have both the separate files. And now what I can do is I'll take the service.yaml. Okay, and I'll combine it with app.yaml. So I'll come over here, and in the bottom, okay, I'll mention a syntax. Now what is the syntax that I need to mention? I need to mention a document separator. So here you need to mention 3 dots. Okay, enter, and then you need to paste everything else. So you can see over here. Okay, you can see over here, this is the service definition and this is the deployment definition. So both deployment and service now belong to a single file. Okay, so if you don't want to have multiple files, of course you can have multiple files, have things segregated, but this is also an approach that you will see commonly being used. Okay, if the files are smaller, people generally prefer combining them rather than having 2 separate files. Okay, so how I've organized my folder structure, just to give you a gist, I've created under demo, I've created separate folder. I've added the I've moved the configurations that we created initially. And here in the demo folder now, I have one file which is app.yaml, which has both deployment and service over here. and they both are separated using this document separator. And document separator tells Kubernetes that this is one YAML file, one configuration file, but multiple objects are there, like multiple objects configuration. So this is like a, you can say, this is like a divider that is being created. Okay. Now what you can do is here, okay, I had deleted both of them. Okay. So I'll just clear out everything. Now I can simply apply, okay, and I'll say app.yaml like so. Both has deployment and service now, app.yaml, right? So I've applied both, and now if I come here and access, you can see 3200 is available to access, right? So this is how things work, and I can say kubectl get pods, you can get svc, which is the services, and you can see how things are working fine, right? And if you wish to delete, okay, you can just run a single command and delete things as well. Okay, so instead of deleting, like applying this way, you can say delete like so. Okay, so deployment is also deleted and pods is also deleted. You can see get svc, there is nothing. And if you refresh this, this is not going to work. Okay, so this is how things function. Okay, when you can, when you work with files. Okay, and generally having files is one of the approaches that developers often use. Why? Because this allows them to define the desired state that they wish to see in Kubernetes for their applications, and Kubernetes takes these configurations and it works on it and tries to make sure that the state in Kubernetes matches the state that you have defined as a developer. Okay, so yes, I hope this has been helpful, and I hope you all have been able to follow along. So now is the time that we begin talking about the environmental variables or environment variables that our containers would need within Kubernetes pods. All right. So here I have the deployment defined. Okay. Let's say this particular container, which is running the image of Nginx, needs a few environment variables. Like for example, I can define environment variables like app message and DB password, let's say, hypothetically. Okay. And this is a common scenario wherein, you know, you will have applications that are dependent on environment variables. So how are you going to pass those over here? Okay, so let me show that to you. So here you have defined the container configuration. So here you are going to come in and just under the image, I am going to say env over here. And here I'm going to say name. Okay, and you can see there is a brilliant auto suggest from Visual Studio Code. Okay, I've added this, and again I'll add one more environment variable. Okay, so this is the name of the variable. I'll say app message over here, and the value for this is hello from app.yaml, something like this. Okay, and here this is the another environment variable. So this will be db underscore password, something like this, and I can add the db password as this. Okay, and okay, so 1 second, I pasted this, and you can see base 64. Okay, so I got the auto suggest as well. This is the base 64 value for the word password, as you can see over here. Okay, interesting. Visual Studio Code is smart. Okay, so you can save a lot of time using these autocompletes. So what am I doing? I am within this container. So this is deployment. First of all, there's a deployment object. Here you're defining the specification for containers, and here you have mentioned env. So env, and this is a key and the value, key and the value. So this way you are passing in environment variables into the containers, right? Now here you'll see this dot, okay, this white dot, which means that the file is not saved. So I'll save this file, come over here, and I'll clear everything out. Okay, and I'll make sure that I apply this file. Okay, so I'm going to apply this file again. See, whenever you make any sort of changes in the configuration, you have to make sure you apply the file, and that is when the configuration gets updated. Okay, so I'll apply this, and you can see deployment is created and service is also created. Okay, now what we can do is we can actually, I can actually log in inside the container. Of course, this is an Nginx image that the container is using. Now that actually does not require these environment variables that we have set. What I'm going to do is I'm going to log into the container, and I'm going to show you that these variables are accessible from within the container. So if your application needs environment variables, you would know that it would be passed this way. Okay, so what I will do is I'll come over here. I'll say kubectl get pods. You have these pods over here, which is my app. I'm going to copy the pod name, and I'm going to say kubectl scuttle exec in the interactive mode. I'm going to pass in the pod name and I'm going to mention over here sh like this. Now I'm logged in to this particular pod and I'm going to say print env. This is the command, and I'm going to say grep db underscore password. Okay. So this is the command that I'm running, and db underscore password is the name of the environment variable that I want to check. And you can see this is the value that is set over here. I can even check it for print env, and I can check it for app underscore message. So you will see both the values being passed inside the container. Okay, and this can be consumed by the application that is running inside the container. And this is actually how you pass in environment variables inside a container that is running. Okay, now once this is done, okay, this is how you pass in the environment variable. But the problem with this approach is, you are hard coding the values inside deployment files, right? And this is not a smart strategy, because these files will be committed to version control system, and it's not a good strategy. What Kubernetes does is it basically provides separate components, and these components are called as ConfigMap and Secrets. So these both are components that are provided by Kubernetes. Like we have components of deployment, we have a component called service, right? We have component called ConfigMap and Secret. Now, when do you use what, and what is ConfigMap and Secret? So ConfigMap is a way in which you can store your application configuration, and these configurations are non-sensitive. So all the non-sensitive configuration goes into ConfigMap, and all the sensitive configuration like database passwords, tokens goes into Secret. Secret is also a object that is provided to us. Okay, so for example, just to give you an example, if you have configuration like which environment you are on, the logging levels, the name of the application, all of that can go and sit into ConfigMap. If you have feature flags, API based URLs, all of that can go into ConfigMap. And in Secrets, you will have sensitive data like database passwords, API token, JWT secrets. All of this will go into Secret. Okay, and Secrets must be base 64 encoded. That is one because Secret stores sensitive data. Okay, now there has to be some sort of encoding that will be added, and Secrets has this property wherein all the data or all the values that you are storing has to be base 64 encoded. Okay, now what I would recommend is we are going to create two files over here. Okay, in this folder, demo folder. One is for ConfigMap and one is for Secret. And what I would recommend is you all head over to the resources section or the attachments of this particular video and download two files that you see. Now the files that you will see, I have already downloaded. So this is config.yaml and another one is secret.yaml. These are the two files that you will get. So I'll copy this. Okay, and I'll come over here in my application folder, and under demo folder where app.yaml resides, I'll just paste both these files, which is config.yaml and secret.yaml. I'll also open both of them. Okay, so let us talk about config.yaml. Now, what is config.yaml? Config.yaml is a config map over here. It is a object of type config map. We are making use of API version over here. The kind is config map, as you can see. Okay. Now you have metadata over here. So under metadata, you have name, wherein you are defining the name of the config map, right? And this is how we are going to reference it, right? This is how we are going to reference it. Then you have data, and this data will define the key value pair that will actually become a env environment variable. Okay. So you have app message, and this is the value. And you can have more of these, right? Right now I have only one. I've defined only one. You can have more of these. And similar is the structure for that of Secret over here, as you can see. Okay. So this is again making use of API version. The kind is Secret. This is the object type. Metadata basically defines the name of the secret. And this is the type, right? So this is a generic secret type, opaque. And then I have data, and this is the data that will be going in as the environment variable. And like I said, Secret is used to store sensitive stuff, and that is why we have database password over here. Okay. And config.yaml has generic stuff that your application is going to need. Okay. Now what you can do is we can actually make use of these into our application. And how would you do that? Okay. So I will come over here. I'll keep this commented, something like this. Okay. And here I'm going to say, I'm going to define, okay, not here, but let me come here. Okay. I'll say env again. Okay. Oops. And you can see over here, I got some nice auto suggest. Okay. So I'm going to say env, and here, okay, here you can see name app message. Okay. Let me press tab and then I can modify this. Okay. So I have env, name is app message. So see here also we used env, name was app message, and then here value was hello from app.yaml. Okay, so here instead of value you have to write value from, because you want to refer to the config map, right? So see here we were not making use of config map, so we had directly used name key and value key. But here we are going to use name key, but the value key we have to use value from. Okay, and you have to mention config map key ref, and here you have to mention app config, and the key is app message. Okay, so here what is app config over here? App config is the name of the config or the config map that you are creating. Okay, these two should match, and the name of the key is app message. So name of the key is app message over here. Okay, and that is what is going to happen. Okay, so what will happen is during runtime, this value will come and it will be passed as app message over here inside the container. This is done. Then for DB password, you do the same. DB password value from secret key ref. Okay, so here you use config map key ref, but here since you are referring to the secret, okay, secret is the component where this value is coming from, you have to make use of secret key ref. Name is DB secret and key is DB password over here. I hope this is making sense, this syntax. Okay, earlier we were not making use of config maps and secret, so we had everything hard coded like this, name and value. But now since we are making use of config map and secret, okay, the syntax changed a little bit, and I've not deleted this, I've commented it for the same purpose so that you can compare this. Okay, so you're using value from in both the places. Here, if you're making use of config map, you have to make use of config map key ref, and here secret key ref, right? And then you mention the name of the config map and the key that you want to refer, and here name of the secret and the key you want to refer. That's the only change that is needed. Okay, and then what you have to do is you have to save this. So just be sure to press Ctrl S, because Visual Studio Code does not save everything automatically, right? Then come over here, okay, and just say, oops, so I'll have to exit this. Unfortunately, I'll exit this and just say over here apply. Okay, you can see deployment.apps/my app has been configured, but the service is unchanged. Okay, so basically it has only taken changes into consideration. It knows that you changed the environment variables over here that you're passing, and services were not changed. So services were not changed, and only the deployment was configured over here. Okay, now what you can do is here we'll go inside the pod again. Okay, we can get the pod, and actually, okay, we have the pod up and running. We can get inside the pod over here. Okay, this is the pod. I'll log in, and here I'm going to say print env, and I'll say grep app underscore message, like so. Okay, you can see, okay, it's still picking up the value from app.yaml over here. Okay, can anyone tell me what the issue is? Okay, I've got the issue. And I'm not going to edit this. I'm actually going to debug this live so that you learn things from this. Okay, see, I'll tell you if you're not able to get what we did over here is we are trying to access the old container. So this is the old container. Okay, NR7. You can see early on we NDR7. This is the old container where we had set the value hard coded. Okay, and you got the value like this, old container. Now what happened is you updated the deployment. Okay, and what happened, what Kubernetes did is it basically updated the deployment and it started creating new pods. Why it started creating new pods? Because the environment variables are set when the pod starts. So it started creating new pods, but the new pods that it tried to create failed. I'll also tell you why it failed. So here you can see, this is the new pod that it tried creating. You can see create container config error. Okay, why it failed? Because we have not created config map and secret, and the new container that it tried creating with the updated configuration that we are referring over here does not exist because we have not created config map and secret yet. So the solution to this is we need to first create config map and secret over here. So I'll say apply, I'll say config.yaml like so, and I'll also say secret.yaml like so. Both have to be applied. Okay. And then I need to say apply -f app.yaml. Okay. So what happened here is initially it was not able to find the config map and secret. And that is why this new container did not start. See, there is a rolling update that happens in Kubernetes, right? Unless and until the old pods are live, unless and until new pods are running, the old pods are not destroyed. So this new pod did not start. It failed because it could not find the config map and secret that you're referring to in deployment because they were not created, right? And that is why the old pods were still running and you were actually logging into old pod and trying to access the data. And of course, in old pod, you're going to get the old data only, the old environment variable that you had set. So that was a problem. Okay. So two problems. One, we were trying to access the old pod, and the second problem was this container did not start. Why? Because config map and secret were not created. Okay. Some bit of learning over here, right? So here you can apply like this. Okay. And I'm going to say enter over here. Okay. So, okay, let me check the pods now. Let me get the pods. Okay, I think after updating the configuration and after creating the config map and secret, the rollout has been successful. So you can see over here, these are the pods. Now what I will do is I'll copy the pod name. Any of the pod name you can copy, starting with my app. Why my app? Because web is our old deployment. Okay, my app is the deployment and the pods that we have created using this configuration, right? We have mentioned over here, my app, right? My app. So you have to make use of my app, and I'll copy this over here and I'm going to say execute it, and I'll update the pod names. You can see the old pods have been removed now. Okay. And here I'm going to say print env. Okay. Like this. And I'll say grep. I'll say app underscore message. This should ideally show the new message. You can see hello from Kubernetes config map. And you can even, you can even see the app secret grep app underscore db underscore password. That is the name, db underscore password, like so. And you should see the db password. Okay, you can see this was base 64 encoded, but you can actually read it. Okay, so there is a joke in Kubernetes that secrets are actually not secret because you can read it this way. Okay, but that is how things work. Of course, there are different strategies as to how you can make secret secure in Kubernetes. Okay, you have to externalize it even further. But for now, this is we are learning about secret, and I also want to highlight that secrets in Kubernetes are actually not secrets, and everybody can see it. Okay, that is one meme that everybody shares because here you can actually read your password. This is base 64 encoded, right? So this is how things work. Okay, and if you want, what you can do is you can also check the config map that has been created and the secrets that have been created. So you can say over here exit first of all because you are inside the container. Now you can say kubectl and get config map, and you can say app -config, something like this. So you will get this app config. You can see over here. Okay, this is your app config. And a similar command for secret as well. So here you can say instead of get config map, you can say get secret, and here you will mention the name of secret. See, the name you're mentioning over here, like app config and db secret, these are all you have defined, you yourself have defined, right? So here you can see metadata name is app config and secret is db secret, right? You can change the name depending on the scenario for you. So you can see these both are created. So earlier these were not created, and that is why it was not working. But yes, this is how you pass in environment variables using config map and secrets in Kubernetes. And I hope this has been useful. All right. So now it's challenge time, and it's time where you step out of this watching mode and get into doing mode. Okay. The goal of this challenge is basically to make sure you go hands-on with Kubernetes, and it's going to be a simple challenge. Okay. Based on everything that we have covered so far. So here, what I'm going to do is come over to EmbarkX official
repository. Okay, so either you can come to EmbarkX official repository or your own repository as well. Okay, so hub.docker.com/u/EmbarkX. This is the official one, and here you will find 3 images. Okay, 3 images that are basically, so what happened? That are basically for for displaying hello world. Okay, they are simple containers that display hello world, and they expect one environment variable that you can pass in. All right, so these are the three containers, I would say, 3 images that exist, not containers, sorry, 3 images that exist on Docker Hub, and you can pick any one. Okay, these 3 are written in different programming languages. Okay, but they operate the same way. Okay, environment variables needed are also same. So you can pick up Node or Python. It does not matter, right? Because you're going to pull the image and use it within the Kubernetes configuration, right? So either you can make use of this official one, or you can come over here. You might have, if you're following this entire tutorial, you might have also set up your own repository, right? Like I have mine, and you might have, these what we call it, these images pushed to Docker Hub, right? So you can either use your own, or if you don't have your own and you prefer using mine, you can. Okay, these are the official ones, and you can get the details of the official one. If you click on this, you can see this is Node.js demo. Okay, this image runs a Node.js hello application. Okay, these are the ports, and you can see over here the environment variable that it needs. Okay, and this is what you pass in. You can even configure the port. So these 2 things you can pass in from when running the containers. Okay, so this is what you can do. Okay, you can even make use of Spring if you are into Spring Boot. Okay, so you can make use of this as well. Now all the details have been shared already. Okay, you will find all of this over here. Okay, and you also have the templates defined for deployment, service, config map, and secret as well. So these are just the files. Okay, what you can do is you can replicate these files, update the configuration. So here, for example, in deployment, we are making use of Nginx image. Here we won't be making use of Nginx. If you are willing to make use of Hello Spring, so if you are willing to run this within Kubernetes, okay, you are not going to use Nginx image, but you're going to replace that image over here, the image URL over here, right? So the template is with you. Okay, you know how to refer to the environment variables. Okay, so I will leave it over to you. Okay, what you do is pause the video right now, attempt this challenge sincerely by yourself, see how it goes. See, the goal of this challenge is not to get the right answers here, right? Even if you are not able to, that's completely fine. If you get errors, that's absolutely okay. The goal is basically to get you go hands-on, because when you start going hands-on, only then you start learning things and you start stepping out of your comfort zone, and that is when you become a good developer, right? So I want you all to do that, and pause the video right now, and I'll be solving this. I'll be deploying this myself, and I'll be showing you how you can. And if you pause the video right now, attempt it yourself, and then you can play the video and watch my solution and compare it with yours. Remember, getting the right answer is not the goal here, but trying out is the goal. So pause the video. Welcome back. I hope you all had a chance to attempt this. Okay, what I'm going to do now is I'll come over here, and I have this folder called KTS/demo. Here I'm going to add a new folder. I'm going to say hello app, something like this. Okay, this is the hello app. Okay, or I can say app1-hello. Okay, let me rename it that way. app1-hello. Okay, and what I'm going to do is I'm going to copy app.yaml config and secret that I had created previously into this particular folder here. Okay, and I'll close all from the editor. Okay, so I have all the files now open over here, right? I can make use of these, right? So what I will do is, first of all, okay, I won't go directly with config map and all. Okay, I'll just comment the config map. We'll go step by step. Config map is commented. I'll try to make use of env directly over here. So I'll uncomment this over here, right? And here, instead of app message, okay, instead of app message, what we need is we need env value, env_value. Why env value? Because the container over here, okay, the container expects env_value. So that is what we need to mention, env_value. And here I'm saying hello from app.yaml. Okay, you can have db password as well. That's absolutely okay. Okay, but this is not going to be used by the app because app does not need it. Okay, this everything is fine. Replicas we have mentioned too. You can like have just one replica over here. Okay, and here instead of my app, I'm going to say app1 hyphen hello. Okay, this is okay, and I'll update this as well to app1 hello. I'll update this as well to app1 hello. Everything is updated to app1 hello. If you scroll down, this should also be updated to app1 hello and app1 hello. Okay, so I'm basically updating everything. Okay, and I don't think anything else is needed. Okay, so deployment is there, app1 hello. Okay, we have app1 hello. All right, image needs to be updated. So image over here will be the image that is here, right? So I'll come over here, tags, and I can get the latest image. This is the latest image. Okay, what I can do is EmbarkX / hello spring : latest. I'll get this one, right? You can get any version. So I'll just add this. Okay, image is added, and here the container port is 80. Okay, so container port won't be 80. I'll tell you why. Because this is a Spring Boot application, and as per the docs over here, if you go to overview, this application is running on 8080, port 8080. You can see, right? This application is running on port 8080. So this Nginx was running on port 80, and that is why you had this port 80 added over here. But here, what we need to do is I'll say container port should be 8080. I'll scroll down to this service over here. Okay, so somewhere over here. Okay. Here instead of port 80, I'll have 8080 like so, and this thing will also become 8080. Oops, and we can let this be 32000. Okay, make sure there is nothing mapped to this particular port. All right, I think this is it. I don't think we need anything else. We have not created config map yet. What I'm doing is I'm hard coding the env value like this in the deployment and the service file. Right now, what I will do is I'll come over here. Okay. I'll make sure I'm in the right directory. So first I'll go one level up. I'll say pwd. I'm in K8s. So I'll switch over to the directory where I've created the configuration. So this is my configuration, app.yaml. Okay. I'll say kubectl apply -f app.yaml like so. I'll get this applied. So you can see the service is also created and the deployment is also created. Now what I can do is I can try and get the pods over here. So you can see this pod is running. Okay, and I can come over here, and here earlier on this particular port there was Nginx running. I can refresh this, and now you can see here we have this hello Spring Boot app running. Right, we did not change the port actually. We just switched the image and the environment variables. The configuration mostly remained the same. We just changed the selectors and the name of the application that we wanted to have. Okay, name of the, so here if you come, okay, we have updated all these names over here to app1.hello, name of the deployment, the selectors, okay, the containers over here, the container labels, everything we have updated, service and the selector in service, everything we have updated to app1.hello because we wanted it to reflect. Okay, so this is, you can see the container is this one, right? And you can see over here, simple app Spring Boot is running. env hello from app.yaml. Where is this coming in from? This is of course coming in from app.yaml here. You will also be able to access DB password if you log into the container. You know how to do that, right? So this is actually done. Okay, and we did this without creating config map. So what I can now do is I can also add config map over here. Okay, now config map, instead of having app, I can have like name as app config. Okay, and here I can say hello from Kubernetes config map. You can modify this, okay, if you wish to, but I'll keep the same. Come over here and I will comment this entire thing. Okay, oops, sorry. I'll comment this entire thing and I'll uncomment this entire thing here, uncomment. Okay, and what I'm going to do is I'm going to say app message. Okay, so this won't be app message. Container needs env value. env underscore value is the name of the variable. So I'll add that. Okay, so this is the value that gets passed. Okay, then over here you have config map key ref. So here inside config map, this config map, the config name is app underscore message, right? App underscore message. So that is what we are referring to. Okay, This is coming in from secret. So secret also we need to define, but secret we won't change. I'll just keep the same file. You can modify if you wish to. You can change the name of the secret if you wish to. Okay. If you add hello db secret, you can add that. That's completely fine. And here you can say hello db password, something like that. Okay. And here also you can say hello app message, hello underscore app message. And here also you can say hello underscore. So if you update this, okay, if you update this, you come over here and here instead of, you have to say hello underscore app message, like so. Okay. And this also will be hello, and this also will be hello everywhere, right? All these things will be there. Make sure you save everything, right? What we have done is we have now commented out the env, like the env values that we had hard coded in our deployment and service file. And we are referring now to an external config map and secret, right? So ideally, if you run the app, okay, instead of seeing the current message that you're seeing over here, which is hello from app.yaml, you should be able to see hello from Kubernetes config map in the API. Okay. Now this is done. What I will do is I'll quickly apply the changes, and to apply, I need to also create the config map. I also need to create the secret. I also need to create the deployment, right? Because deployment has changed. So what I will do is I have all the files in the same folder. So I'll say dot over here. It will apply all the files. You can see. So this configured service is unchanged. Config is created and the secret is also created. Okay. All of this is created. And if you try to get the pods, you will have the pods running. You can come over here, and if you refresh now, you can see, okay, can you see this env hello from Kubernetes config map, and hello, this is the application, right? So yes, this is the challenge. This was a challenge. I hope you were able to do it successfully. It's pretty simple based on the knowledge that we have gained so far. We've just tried to replicate the steps to the application, other application that exists, wherein we have to actually pass the env variables so that you understand how env variables are passed actually. So here, remember, this container needs env variable as, what is the name of the env variable? Here, if you scroll down, this env underscore value is the name of the variable. So you have to make sure you mention env underscore value here in the name, because this is how it's being passed to the container. And how this variable gets the value, it's getting in from the config map, like so. So you're referring to this config map and you're getting this key. Okay, so from this config map, you're getting this key. That is how it works, right? I hope this is making sense. I don't think anything else is needed. Secret over here. Yeah, so everything else is working. Now, if you want, okay, you can also try this out with other images. So you can come over here, go to EmbarkX. Okay, we tried Spring 1. You can go to Node.js if you wish to. You can just experiment with things, you know. So in Node, you can even pass in env value and port. So you can do that. Okay, you can pass in env value and port. If you don't pass port, there is a default port that exists, right? You can see default is 3000. So all the documentation is given over here. You can even refer to, Python 1. You can run the Python 1 in the same way. You can see over here. Okay. It also needs env value and port. Port, if you don't pass, the default is 3000. Okay. And env value, you have to pass the same way you passed for this container. Pretty simple. This is not language dependent. Whichever container you want to run in whichever programming language you have written, that's completely fine. You can run that. Okay. Just that you're running inside Kubernetes. These are images that you're pulling locally. Like Kubernetes pulls this image locally and it runs it on your machine because you have Kubernetes configured onto your machine. If you configure or if you're interacting with Kubernetes in cloud, this is going to run in cloud. Right now, with the help of kubectl, where are we interacting? Kubectl is the tool that is helping us interact with Kubernetes clusters, right? So where are we interacting? We are interacting with our local cluster on our machine, right? Down the line, when we go to cloud, okay, we can make sure that kubectl points to the cloud, right? And at that point in time, you will have all this running in the cloud. Isn't this amazing, right? So to update the images, you will have to update the image like this over here. You can even update the tag. You can update the name if you wish to, but name, I think it's fine. You just update the image and you just make sure you're passing in the right env variable. That's it. And the containers should run fine. I hope this has been useful. Hello and welcome. And now it's time for another challenge. And this challenge is going to be a little bit challenging one, but we are going to have full on fun doing this.
So what we are going to do is, so far we have deployed monolith application into Kubernetes cluster. What we are going to do is, we are now going to take a look at how you can deploy microservices onto Kubernetes cluster. So here, if you come to our official Docker Hub page of EmbarkX, you're going to find these two services, which is Task Service A and Task Service B. These are the two services that run in Microservices architecture. And one service is responsible for providing the tax values, and other service is responsible for calculating the final amount based on the country and amount that is being passed. So here you can see the complete diagram of how this entire thing works. Okay. Of course, there is a front end as well. Okay. But let's not look at front end right now. We're going to deploy these two backend services, and we are going to do a API call to get the tax calculation. So here, price service, which is service A, it accepts amount and country code. How does it accept? It accepts through the URL like this over here, and it returns the final price based on the tax in the country. Now, where does it gets the tax amount from? It gets tax amount from the service B. So it calls service B. It passes the country code and it gets the tax amount from tax service. And tax service over here, service B, returns the tax based on the country and accepts the country code over here. Okay, this is the format in which the API call is supposed to be done, right? It accepts it over here, and price service, which is service A, is going to display the total amount based on the country and the amount that you have passed. So we are going to work on this, and here in the official image, you're going to find a lot of information over here. Okay, so you can see over here, it accepts the price and country code like this. Okay. And here, if you scroll down, you will see it accepts tax service URL as well. So you need to pass in tax service URL and the port. Okay, so this is how it's going to function. And then you have tax service B as well. Oops, I pressed back accidentally. So tax service B, if you go over here and if you open, if you open this in new tab, okay. So here you are going to see this is also the service that returns the tax amount. Okay, so this is the sample JSON, and these are the country codes available. And here you can see where is the env. Okay, this is the env variable that you can pass in if you wish to. All right, so that is this is what we need to deploy to Kubernetes cluster, and of course they are going to communicate amongst themselves. So what I would recommend is, okay, you all have the format. If you come over here, you all have the format for service and deployment. Okay, don't bother about creating config map or secret right now. Okay, I'll just close this. Just create deployment and service for this. Okay, there will be two deployments and two services. So two app.yaml files is what you're going to need. One for service A and other one for service B. You need to pass in the right environment variables. Okay, and you need to make sure you use the right image name. So you can either use my image from the official repository of EmbarkX, or what you can do is you might also have this same, if you have the same app push to your repository as well, you can get the image from there as well. Okay, so it's totally your choice. Okay, from where you get the official repositories are also there, and you can even use yours. So what I would recommend is pause the video. Of course, this is going to be a little bit challenging, but you know, we need to get out of our comfort zones and we need to start writing code. Okay, you fail, you get errors, only then you learn. Okay, of course you can play the video and watch me solve this particular challenge as well. Okay, but I want you all to at least give an attempt. Getting the right answers, like I've always said, getting the right answers is not the goal over here. This is not an exam, right? I want you all to at least attempt, because that is when you start going from watching mode to doing mode, and you start doing things actually. All right. So pause the video right now and attempt this. Welcome back. I hope you all got a chance to attempt this challenge. What I'm going to do is I'm going to do a little bit of organization over here first before I create any sort of files. So here I'm going to create under K8s, I'm going to create a folder. I'm going to say app2 and I'm going to say tax over here. Okay, or let me see how I've named this in Docker. So it's tax calculator, tax-calculator. So I'm going to rename this tax-calculator. You can rename it, you can name it whatever you want to, but I'm just following the conventions. Okay, and then I'm going to have another folder. So I'm going to say service-a over here,
and then one more folder which is service-b. Okay, so all the YAML files for service A and service B will be in their respective folders, right? Now what I'm going to do is I'm going to have app.yaml copied. Okay, so I'll copy the app.yaml from here. Okay, and I'll paste it in service A first and then in service B. Okay, I'll close this one. Okay, we need to close this one, so I'll just close this. I have now service A and service B open over here. Okay, so what we are going to do is we are going to first take a look at service A. All right, so service A is the tag service. So if you come over here, okay, let's come over here. Service B, okay, this is service B. So what I would do is I would start with service B first, because this is the service that provides the values to the service A for calculating the tags. Okay, so this is the first service. And what I'm going to do is here, instead of app1 hello, I'm going to say service-b, something like this. Okay, copy this, come over here, and also rename this to service B, rename this to service B. Okay, container name service B over here. Okay, nothing else is needed over here. Okay, this will also be so within service also I'll call this service B, service B. Okay, everything is service B now, right? And now scroll up, let's take a look at other things. The name of this service is service B. Replica is 1. Okay, I have this, I'm matching the labels service B for all the containers. Okay, here I'm mentioning the labels. Okay, and then here the container name is service B, and I need to mention the image here. So image that we are going to pick is tags service B. So I'm going to copy this tags service B, come over here and tags service B latest. If you don't mention latest, it is anyways going to get the latest image for you, right? Now here in env, I am not bothering about creating a config map or anything else. I'll just comment this out. I'll keep this very simple, very, very simple. Okay, so from here, I'm going to comment this out like so. And what does this expect? So this does not expect, I think it expects port. Okay, but I'm not going to pass in port over here. If you see, the default port is 4000. So I'm not going to pass in port. Okay, that's completely fine. So what we can do is we can just turn off all the envs. If you want to have this running on a separate port, that's absolutely okay. All right, and here you have to scroll down and say container port will be 4000 because the default port is 4000 and the service is going to run on 4000, right? Now if you go to the service, okay, you have to make sure that here also you update the ports. Okay, here also you update the port. Now, one thing over here. Okay, one thing over here. When you are creating the service for service B, okay, should you use node port over here? Should you use node port? Think a bit. No, you should not. When do you use node port? Node port you use when you want to expose a particular application or expose a particular container or pod basically onto your local machine for testing, right? But here service B, we are not going to access from our local machine, but instead service A is going to communicate with service B. So there is a type of service that allows you to do inter-service communication in Kubernetes, and that is cluster IP. So that is what we are going to use over here, cluster IP. Okay, now over here you can see all the suggestions I'm getting. Okay, so you can see, okay, I'm not going to accept all the suggestions. I can, but see, since we updated the node port type to that of cluster IP, we don't need this property, node port. This we are going to remove because this is for mentioning the port of our local machine where this service is going to be mapped. So I'm going to get rid of this. Okay, now port of the service will be 4000 and the target port within the container will be 4000. Okay, that is what I've mentioned. Okay, pretty much simple and pretty much to the point. Why are we using cluster IP? Why did we have node port first of all? Node port is a kind of service that allows us to expose a particular pod basically, or a particular application onto a local machine on a particular port so that we can access it and test it. Okay, you have load balancer as well as a type of service which is used in production, but since we are locally testing, we are not using load balancer. Now, why am I using cluster IP? Because cluster IP enables inter-service communication. So within the Kubernetes cluster, service A should be able to communicate with service B, and that is why I have assigned this as cluster IP. Okay. Now service B is internal only because it's cluster IP. It is not node port, so it cannot be exposed on my local machine. It cannot be called from outside Kubernetes, right? So since we have given this as cluster IP, it will be exposed using the service name. So what is the service name? Service name is service B. Okay. So service A can access service B using service B :4000. Let me show that to you. Okay. So this is done. Okay. This is for service B. This is a very simple deployment and service file that we have defined. Now I'll come over here. Okay. And here I have mentioned this as service B. So here I'll say this is service -A like so. Okay. Service A. I'll copy this. Okay. Visual Studio Code is very smart. It's suggesting me everything. Pretty good. Right. Come over here. Scroll down. App1. Hello. This will be service A. This will be service A. Okay. Now this is done. Okay. I'll save this. Now here, when it comes to env, I'm not going to bother to create the config map. We can create that later. But first, let's get this service up and running. We'll go step by step. Right. And here I'll enable this. Okay. So I'll just hard code the values. So first thing is I'm going to get rid of this, like I don't want two envs. Okay. Here. So here I'm going to say env value. Okay. Instead of env value, what is the name of, so one second. So what is the name of the env? Name of the env is tag service URL, and port also we can pass in if you want to customize the port, but I'm not customizing it. Let it run on 3000, which is default. So I'll take tag service URL over here, and I'll mention the name as tag service URL. And what will be the tag service URL over here? Okay. It will be HTTP. You can see over here, service -B :4000. This is going to be the tag service URL. Correct? Why service B? Because this is what the service name is, right? Here, this is what the service name is, and it's having cluster IP, right? So it's not exposed outside Kubernetes cluster. You can access it inside Kubernetes cluster. So I hope this is making sense as to what we are doing and why we are doing, how we are setting up inter-service communication. And then you'll have to get the image. So I'll come over here, and here this is the image name, tag service A. So I'll come over here, and here I'll update this image to that of tag service A. That is it. I think we are all set now. So deployment service 1, service A, and if you scroll down, okay, 8080, okay, service A, node port. Why are we giving node port over here to this particular service, which is service A? Yes. Think, why did we give cluster IP over here? Because this is not being accessed from a local machine. But service A, we need to access it from a local machine. And hence it's node port. And I'm exposing it over here on 3200. Okay, one thing we forgot. We need to update the port over here. So the port by default is 4000. Let me see. What is the port by default? It's better to cross check. Okay, 3000. It's not 4000. So here I'll have 3000. Okay. And here also I'll update this to 3000. Okay. And this target also I'll update this to 3000. So this is the service port, and this is the target port within the container for the service. I'll save this. Okay. I hope this is making sense over here as to what we are doing and why we are doing, right? This is done. Now what I can do is here, service A, service B are done. Okay. So I'll come over here. First of all, if you see, there are few pods that are running, right? Few pods, one pod, one service will be running. So what I will do is I'll do a cleanup. Okay. And for doing a cleanup, there is a command kubectl delete all, flag 2 times, like -- 2 times, and all. Okay. So if I run this, you'll see all the service, pod, and deployment is deleted. So there's nothing now running. No pods will be running, right? I'll clear this out. Okay. This is done. And I'm in some other directory. So I'll just change this to one level up, and I'll do pwd. I'm in KTS now. Now I'll do app2. Oops. App2 tax calculator. Okay. Now I'm in this directory where I have service A folder and service B folder. Service A has app.yaml and service B also has app.yaml. Okay. So what I'm going to do is I'm going to say kubectl, okay, kubectl apply, and I'm going to say -f. Okay. And first thing, we are going to call, we are going to apply service B. Okay, so I'm going to say service -b like so. Okay, let me press enter. The moment you press enter, all the files within this service B folder will be applied. So there is one file which is app.yaml, which has service definition and the deployment definition, right? So you can see services and deployments are created. Okay, then you will also apply service A. Okay, this is done. And then you can finally get the pods here. You can get the pods. So you can see over here, service A pod is running and service B pod is running. Okay, you can have this in watch mode. Okay, they both are running now. Okay, now what we need to do is let us try accessing service A. And how would you access service A? So here you need to come in, and here service A is being exposed on port 3200. Okay, and what is the URL? The URL that you need to pass in is, so there should be a sample URL, sample API call over here. Okay, so here, okay, this is for tags. No, service A sample call will be, okay, this is a sample call, right? So you can copy this entire thing, copy this, and then come over here and then paste over here, and then instead of 3000, this will be 3200, because node port is exposing at 32,000 port on a local machine. And just press enter. You're going to see over here, you can see service B is running in this container. Okay, this is a service B pod. So you can see service B WH2NB. You can see WH2NB, right? Tax amount is 8, amount is 200. Service A is running on this container. You can see over here. You can see FDZCH. So this is FDZCH. Perfect. And the total is 208. Okay, if you pass in some other country, it is going to work absolutely fine. Something like this. Now, can you access service B from your local machine? Can you access the service for tax from your local machine? Can you access? No, you cannot. You cannot access because it's in cluster IP. You have assigned the service type as cluster IP, right? So it cannot be accessed. So service B is not accessible. It is there only for inter-service communication. Only the internal services that exist in Kubernetes can refer to it using service names, right? Service names. So here we are making use of service names, which is cluster IP, right? I hope this is making sense, and I hope you all are able to follow, and I hope you all have idea as to how you can deploy microservices into Kubernetes cluster. It's pretty easy. Okay, this can be in any programming language, it does not matter. Okay, but you can do so, right? And now you can even update this to make use of config map or something like that. You can update this, right? You don't need to hard code the variables, right? Also, I'll tell you something. Here, I'm having one YAML file. Within service A, I have app.yaml. You can create deployment.yaml and service.yaml within service A. You can separate both these. Okay, and you can have under service B also, you can have deployment.yaml and service.yaml. Okay, you can do that. And now if you want to delete everything, delete the deployment, what are you going to do is, you're going to say kubectl. Okay, there has to be a delete command that we had run. Okay, so here apply delete -f. Okay, and you're going to say everything in the current folder. Oops, sorry, not everything in the current folder, because in current folder there are two folders. So you're going to say delete service A first, and then you can delete service B. So you can see both are deleted now. Okay, and now if you try to get pods, you're not going to get any pods. No pods exist. If you try to refresh this, this is not going to exist. Okay, this is going to fail because the pods are removed. And if you want to turn them up, you can absolutely, turn them up. You can see service A and then service B as well, like so. So both the services are up, right? And now if you refresh, now if you refresh, okay, you can see it started. It's up and running, right? And you can even scale this. So now I can come over here. Let's say I want to scale service A to that of 2 replicas over here. Okay. And let me scale this over here. I can say service A, apply. You can see configured and unchanged. Now, if you see here, you're going to have multiple pods running. Okay. So multiple pods for service A because you scaled service A. You can scale it back to 1 if you wish to. I'll scale it down. replicas 1, and I can just say apply service A, and you can just get the pods. You can see the other pod is being shut, and that is why you have this error status, right? One pod is being shut. Now if you go, there are only 2 pods, right? I hope this is making sense, and I hope you all have understood the entire crux of how you can run and manage microservices into Kubernetes clusters.
So now it's time where we begin talking about things or life before CI/CD. And why are we talking about how things used to operate before CI/CD was used? So the reason for this is it will help us set a strong base in understanding the importance of why this kind of thing was even brought in. So let's get started. So before CI/CD, just to give you a sense, everything used to be pretty much manual. Okay, CI/CD brought in automation into the software development workflow or software development pipeline. But before that came into picture, everything was pretty much manual. So how things used to happen is this is a developer that you're seeing over here, and this developer would writing some sort of code, and the moment he pushes the code to the repository, he writes in code, and his job will be to run the test. Okay, then he would build the app locally onto his machine, and then he would build the Docker image. Okay, assuming that the application makes use of Docker. So he built the Docker image, and then he'll push the Docker image to a remote Docker registry. So just reiterating on the steps, he'll first make changes into the code onto his laptop or onto his machine, and he will push a new feature or a bug fix. And once he does that, okay, there will be some sort of manual testing that will happen with the new feature that has been pushed. The app will be built, okay, built as in, if it's a Java-based application, jar file will be created. If it's a Python application, some sort of build process will be there. If it's a web application or Node.js application, there is a process of building the application before deploying it to production. All that things will happen. Build process of any sort of programming language exists. So that will happen. Then a Docker image will be created, assuming that a project is making use of containerization, and then the Docker image will be pushed to the remote repository or remote Docker hub. Now here the build process of the app, the build process of the Docker image, and pushing the image to a remote repo, all of this is pretty much manual. Okay, pretty much manual. And then once this is done, the image happens to be pushed to Docker registry, and then from there, it's going to be deployed to production, and then someone is going to verify whether the application is working properly in the production, like whether the application is live and whether the right version number has been deployed. Now, this entire workflow was completely manual. Okay. Manual dependency, like human dependency, will be there at every point or every stage that you see over here. Okay, and just to put this in the form of a software development pipeline, first the code is written. Okay, once the code is written, it's being tested, then it's being built as in there is a build process. If you're using a Java application, or if you're building a Java application, jar file will be created. Okay, then the application is packaged. And package meaning the image creation and the image tagging and version will happen. See, code meaning you will push the code to GitHub. It is merged with the right branch. Testing as in unit tests, integration tests, quality checks, all that will happen. Build as in jar or binary creation will happen. Then package as in Docker image creation and image tagging will happen. Then the image is pushed to the Docker hub or Docker registry. Okay, this is the artifact that is being created. Artifact as in the version of the software that can be distributed, like in the form of Docker image. Okay, so that is being pushed, and then it is being deployed to a server, virtual machine, or Kubernetes, whatever the team is using. And there the configuration and the secrets are applied, and then the application is checked after the application is deployed. So there are health checks that will run, and if things are not working as expected, rollback will be done. Okay, so the build will be rolled back. Now this was the entire software development pipeline, and this was completely human driven. There is no sort of automation that is triggered when there are code changes that are happening. No sort of automated processes there. Like at every step there is a human intervention or a human coming in and making the changes. Now the question is this is manual, right? This is a completely manual process. There is a human dependency risk involved because if human makes any sort of error, okay, it's going to cost for the mistake, right? And the process is slow and painful. There is a painful feedback loop because it's very slow, because humans are involved. Okay, so the question is, should growing team trust humans every time? Should growing team trust humans every time? So just think about this. The answer to this is no. Okay, because as you scale, as the application scales, you cannot trust humans. Of course, there has to be some sort of automation in place. Things have to be automated because there will be large teams, a lot of developers that will be working on a common code base. So growing team cannot trust humans every time, right? And what do you think of this question over here? Let me know in the community, the Q&A forum, and let me know what you think about this. I hope this is clear as to how life used to be before the advent of CI/CD. So now it's time we begin talking about continuous integration and continuous deployment and understand what it is. So we know the software development pipeline. It starts with coding, then testing, building. So building as in once you write the code, you test the application, you build the application. Building as in you create, let's say if it's a Java application, you create a Java file. And then you package it into something called as a Docker image or an executable that can be distributed. And then you push it to wherever you want it. So if it's a Docker image, you push it to Docker Hub, then you deploy it, and then you verify whether the application on production is working fine. Okay. Now, what is CI? So CI stands for continuous integration, and continuous integration is this part of software development pipeline over here that you see I have highlighted. Right. So every code change, when it comes to continuous integration process, every code change is automatically built, tested as soon as it is pushed to the repository. Let me come again. Okay. CI stands for, so when you say CI/CD, I'm just talking about CI and not the CD part. Okay. When you say CI/CD, there are two terms involved, CI and CD. CI stands for continuous integration and CD stands for continuous deployment. We'll come to that CD part, but let's talk about CI first. So CI stands for continuous integration, like I said, and it is this part of software development wherein you start with code, test, build, and package. So once you package the application, the CI part in the software development pipeline ends. Okay. So here you can see every code change that the developer does. Now, what will developer do? He'll make changes of the code on his local working copy, and he'll push the code onto the Git repository. Now, as soon as the code is pushed, there is a automated process that will be triggered if you're making use of CI. Okay. Automated process will be triggered as soon as the code is pushed to the repository, and these steps will be executed. Okay. So code is pushed, that triggers the process, and then you have automated testing. Automated testing would involve execution of unit test, integration test, quality checks, whatever is configured in the CI process. Then you have build, wherein the jar or binary creation will be created or will be done, and then the application will be packaged. Now, packaging involves image creation, Docker image creation. You might want to tag image, versioning, all of that you would do, right? And this is all automated, and it is triggered when git push is called, or when a developer pushes the code to a remote Git repository. Everything is called automatically. Now, what is the goal of CI? Why does this sort of process exist? Okay, so the goal of CI is one of the goal is to detect bugs early. Okay, so as soon as you push the code, any sort of changes is made in the code, test cases run, the application is built and packaged and pushed to the Docker Hub. So here, whenever the code was pushed, if there are any sort of issues or bugs, they all are identified in the subsequent steps. Okay, so it's one thing of one goal of CI is to help detect bugs early. Okay, second goal over here, I would say, is to avoid integration conflicts. Now, integration conflicts meaning, see, whenever you merge code, you are working on a feature and other developer is also working on a feature. Whenever you combine both the codes, there could be some integration issues because of the code you both have written. right? So merging and testing early helps you identify or detect those sort of bugs in very initial stages of the software development pipeline, right? And that is beneficial for everyone in the team. So that is the goal number 2. And the third goal is to ensure that the main branch is always stable, okay? And every commit is buildable. So that these are a few goal or benefits, I would say, of continuous integration, okay? And keep in mind, continuous integration ends once you have a packaged output or once the software artifact is ready. Okay, now if you're not aware of this term software artifact is a ready to deploy packaged output of the build process. Okay, ready to deploy packaged output of the build process is known as software artifact, right? So once you get the software artifact, where will you get software artifact in this entire process? You will get it in the package step, right? Because once you hit the package step, and once the application is packaged into Docker image or whatever you have configured over here, I'm taking the example of Docker over here. If you package the application in Docker, it's ready to deploy, it's ready to distribute, okay? And that is where you have a software artifact in place, and that is where the CI process ends. Okay, CI meaning continuous integration ends over here. Okay, so where does it end? It ends once you have the distributable version of the software, which is software artifact, okay, which you have naturally after the package step. Now once this is done, okay, you have continuous deployment. So this first part was continuous integration. Then you have continuous deployment, wherein these steps comes in, like you push the image to that of Docker Hub, and Docker Hub or whichever registry you have configured, you deploy it, and then you also verify it onto the production. Okay. Now CD, this is CD, which is continuous deployment. So this says that every successful build is automatically deployed to an environment without manual intervention. So once you have a software version packaged, okay, the goal of CD will come into place, and CD will do the job of pushing, deploying, and verifying the application onto the production. And the goal of CD is to deliver fast. So whenever there is a new code change that is being done, testing is automatically done, build is automatically done, package is automatically done by CI. And then CD comes into play. It will push the deployable version, and it will deploy, and then it will verify. So whenever code changes is done, you will have a version being deployed. Okay, so goal over here is to deliver really, really fast as soon as developers are building and committing something, right? So there will be a fast delivery and consistent delivery. So it will be consistent, and it will reduce the release risk because you are releasing continuously. Okay, I hope this entire thing is making sense, this entire pipeline, and you are understanding how we are breaking this down into CI and CD. Okay, now if you compare this with manual and CI/CD, in pre-CI/CD era, all of these steps were manually triggered, like some human was doing all of this manually. So either one single person was responsible for this entire pipeline, or there were multiple people at different stages in the pipeline who were responsible. And here, since it was manually triggered, multiple people involved, it always leads to blame game, and inefficiencies, inconsistencies, and the entire process in general is prone to errors. Okay, but when you have CI/CD, things become much more easier, because with the manual way, you always had broken releases, late feedback, and always there was a fear of deployments among the teams, right? But CI/CD came into this thing, and it automated this entire flow, wherein developers can now commit without any fear of problems. So yes, here comes the punchline. Before CI/CD, software quality depended on human discipline and not automation. Now you cannot always be dependent on human discipline, and this is a problem. This is a major problem that CI/CD solved. So CI basically does the job of building and verifying the software, and CD does the job of delivering and deploying the software. Okay, CI stops at the artifact stage, like once you have a software artifact ready, which is the distributable version of the software, and CD takes over from there, and it does the job of deploying the software, right? And before CI/CD, like I said, entire process was manual. A developer would manually test, build, create Docker image, push to Docker registry. There were lots of steps involved, and generally you would have a text file with all the commands, and you would just do copy pasting, right? And with CI/CD, this became very easy and low stress, with low stress, because some developers might even skip the tests. They might not run tests because they have to deploy quickly. Right? So imagine like pushing the code and then you want to deploy quickly. So you're going to skip the test and then you will deploy it, and then something breaks in the production, and then everybody's like, okay, how did this happen? So with the automated process, these things cannot happen. Builds are consistent. Things are very easy and transparent. I hope this has been useful and clear. So now it's time we start talking about CI/CD pipelines and pipeline engines that exist. So what is a pipeline first of all? Okay, so pipeline is nothing but a predefined sequence of steps that run automatically to take your code from developer to that of production. So see, we have a software development workflow wherein once the code is written, it has to be, tested, then built, then the image is built, then it's pushed to a remote repository like Docker Hub, and then it's deployed, and then it's verified. So these are the steps involved in a software development pipeline or a software development workflow. So what is a pipeline? A pipeline is a predefined sequence of steps that would run automatically to take your code from the developer's machine to that of production. And you can think of it like a assembly line in a factory wherein you have different stations, and each station would do its job, and the output of one station would become an input to the next station in the queue. Okay. So pipeline is nothing but, just to put it in the form of equation, pipeline consists of steps, order, and the automation over here. Okay, so typically pipeline would have like getting the latest code, then testing it, building the application, grading the image, pushing it to the remote repository, deploying, and then verifying. So here you have different steps, okay, and there is an order in which these steps should be executed. It cannot be just in random order, right? So there has to be an order in which these steps are executed, and also they have to be executed in a automated way. So pipeline is nothing but steps plus order plus automation over here. Right now, without pipeline, so there are two tools first of all. Okay, so two tools that help us run pipelines are Jenkins and GitHub Actions. Okay, these two are very popular, and if you have read about CI/CD before, it's likely you must have heard about these two tools often. Okay, and I was talking about pipeline. So pipeline is really important, wherein without a pipeline, dev is going to do everything manually, but with pipeline things are really automated. And pipeline is actually not a tool. Jenkins and GitHubs are tools. Okay, pipeline, when you write a pipeline, you are not creating, or you are not having a tool. Pipeline is not a tool. Okay, Jenkins and GitHub Actions are tools that help you run pipeline. And pipeline in itself is a combination of logic, steps, and flow. Like I said over here in the previous slide, it consists of steps, order, and automation. Okay. Now, Jenkins and GitHub Actions are two popular tools that help you run pipelines, and depending on the organization or the project that you're working on, it's likely that either of these two tools will be used to create CI/CD pipelines. Okay. And this is what a pipeline looks like over here. So here you have a pipeline, and the trigger is the push of code, and then there are multiple stages right within this. So these stages are nothing but steps over here. Okay, so you have test, build, then you create Docker image and push to Docker, and then deploy, and then verify. So these are multiple stages, or you can say steps, that are involved in a pipeline, and within these stages there will be multiple commands that will be written basically to do a particular operation. Okay, so that is what a pipeline is. And this is how it looks like. Now let me head over to the browser over here. Now here on the browser, I have this website jenkins.io. So this is the official website of Jenkins. And here you can read more about Jenkins if you're curious. So you can see over here, it is the leading open source automation server. So first of all, Jenkins is open source CI/CD automation server. And it is very widely used pipeline engine.
and it basically runs the series of steps on code changes, supports complex workflows, and it has many good features that you can read more about over here. So you can see over here, easy installation, easy configuration, plugins, extensible, distributed, and you can read more. Okay, you can come and read more. You can go through the documentation as well. But this is the official website of Jenkins. Then you have one more tool that I just spoke about, which is GitHub Actions, and this is a tool that is provided to us by GitHub. Okay, so GitHub is the one behind this, and you can see over here, it makes it easy for us to automate all software workflows, and it helps you build, test, deploy your code right from GitHub. So the moment you push your code to GitHub, it is basically configured with GitHub, and once you push the code to GitHub, it basically runs and makes code reviews, branch management, everything. Okay, whatever you define over there. So this is how it works. You can see over here. So on push, okay, here you have this YAML file that you have created. So yes, the configuration for this is written in YAML file. And once you push, so here a build process will happen, then testing will happen, and then publish will happen. So this is how it works. Okay, and you can read more about this entire this tool over here. You can see a sample file over here as well, right? And this is the UI. Okay, you can just go through this website just to get familiar with what it is. But yeah, GitHub Actions is also quite popular and a lot of companies are using it. Okay, and the best part is it is a CI/CD engine built directly into GitHub, since GitHub is the organization behind this. I hope this has been useful and clear. Hey there, so now I want to talk a little bit more about GitHub Actions. So here on the official website of GitHub Actions, you're going to see this link for Get Started with Actions, and this is going to take you to the documentation. Now, why people are preferring GitHub Actions? Because there is zero setup. Like, you don't need to install anything onto your system. Because there is no server needed, there is nothing needed. It just works out of the box with GitHub, you know. And these days everybody uses GitHub as the version control system, Git and GitHub, and hence it's becoming really easy for developers to make use of GitHub Actions. So with GitHub Actions, you just start writing YAML configurations wherein you define your steps and the trigger as to when the CI/CD pipeline should be triggered, and whatever you have defined in the series, it gets executed whenever the trigger is met. So for example, if you have mentioned the event or the trigger as push, like code push, so whenever there is a code push in a particular repository or branch, this is going to get triggered, the entire workflow of CI/CD that you have defined. So that is how it works, and there is a minimal setup. Like, there is no setup. In fact, I should not say minimal setup. There is no setup. In fact, like you are making use of GitHub, you can directly start working on a CI/CD as well with GitHub Actions. It just works out of the box. Okay, so that is why it's gaining a lot of popularity. And what I would recommend is you all should keep this documentation handy over here. Okay. So this is really helpful, and here you can read more. So if you get stuck or if you want to enhance your knowledge later on down the line, it's best what are the official sources of learning this. Okay, so yeah, this is what I wanted to mention about GitHub Actions, and I hope this is useful. So now it's time we begin talking about some of the fundamentals and terminologies that you will often come across when you're working with CI/CD. Alright, so let us begin talking about what all we are going to discuss. So there are 4 important terms that you need to understand. First is the workflows. Then we have something called as jobs. We have steps. And then we have something called as runners. And we'll be understanding this in clarity and in detail. Okay, so let's get started. So first of all, what is a workflow? So workflow is nothing but the full automation process that you do with the help of CI/CD. That entire thing is known as a workflow. So if I have to put it simply, workflow is nothing but your entire pipeline. Okay, the entire pipeline is called as workflow. It starts with an event. Now event can be a code push. Okay, a code push can be an event. It starts with an event and ends with the end. And end is usually deployment or verification after deployment. That is what usually it is. Okay. Then the next terminology that you have is job. Okay. Now what is job? So job is nothing but a big unit of work or a major task that happens inside a particular workflow.
Okay, now a workflow can have one job, or it can even have multiple jobs. Now, one job can be, so I have to give you an example. If I have to give you an example, one job can be responsible for building the entire application, right? So it's a major unit of work that is taking care of building the entire application. Then another job could be like doing testing or testing the application. Now this involves multiple tasks in it, like running integration test, unit test, or checking for any sort of vulnerability. So all sort of tests are run over there. So testing basically is one job with multiple steps in it. Okay. Then you have like deployment job. Okay, and there could be multiple steps for deployment in it. Okay, so job is basically a major unit of work or a major task inside a particular workflow, and there can be multiple jobs that are running in parallel, or they can even run one after another. Okay, so it depends. So this is about job. I hope this is making sense. And then you have something called as steps. Now steps are nothing but individual steps or individual commands that get executed inside a job. So see, a job can be building an image, right? But building an image is a series of steps. It's not just one command. There could be series of steps in a particular job. So those series of commands are nothing but individual steps that are within the job. Okay, so steps are inside the job, and a job is a part of a workflow. I hope this is making sense. Okay, now if you're planning to test the application, like one step, like it would have multiple tests that you might want to run. One is integration testing. You might want to run unit testing. You might want to verify the app for vulnerabilities. All of these sort of tests you might want to run. So running unit tests, there might be series of commands that you might want to run. Running integration tests, there might be series of commands that you might want to run. So every command that you run is one step. That is what it means. I hope this is making sense. And then you have the concept of runner. Now, what is a runner? So runner is a computer, a sort of machine, I should say, okay, that gets provisions to run your job. Okay, so see, this job, workflow, steps, everything has to run somewhere, right? So the runner, it runs on runner. Everything executes on a runner, and runner is a temporary computer or machine that gets provisioned for the entire thing to run. Okay, and it can be GitHub hosted, okay, or usually Ubuntu based, and or it can be self-hosted as well. Okay, so I hope this is making sense. Now let us see how they all fit in together. So first you have a workflow, okay, which is the entire pipeline, like I said. Then within workflow, you have one or multiple jobs. So here I have shown 2 jobs, but you can have multiple jobs. And then within jobs, you have multiple steps. And all of this runs on a runner. I hope this is making sense. So if I have to also show this or demonstrate this with the help of an with the help of a diagram, not example. This is actually an example only. So see, you might have this workflow. So this entire green part that you see, this is the entire workflow. Within workflow, you have this one job, which is responsible for building and testing the application. And within this job, you have multiple steps. So step 1 will check out the code, step 2 will run the test, and step 3 will build the app. Okay, so you can have multiple jobs. So this is the first job, build and test. Then you have another job, which is build, image, and deploy. And that again has series of steps, right? So this is steps, okay? And then you have, these are jobs, right? And this entire part, this entire pipeline is a workflow. And this entire workflow runs on a machine that is called as a runner. I hope this diagram is helping you understand how the entire process works. So you have jobs, that is major unit of work. Within jobs, you have steps. Okay, steps are nothing but individual unit of work or commands that get executed. And the entire pipeline is known as workflow. And one pipeline can have multiple jobs. Okay, one job can have multiple steps, and the entire thing runs on a runner. I hope this makes sense. Okay, now what exactly happens in the real world? Okay, so generally the CI/CD pipelines are tied to a event, and the event is generally a trigger that gets pulled in. So some common events are like developer pushes a code, or a pull request is created, or there can also be a manual trigger, like you can trigger a CI/CD pipeline manually as well. Okay, so depending on what your requirement is, there is a trigger, and that once that event happens, trigger is basically the event. So once that event happens, okay, what happens is workflow is selected. Okay, so GitHub Actions will check for a workflow,
that listens to this particular event, and it will select that particular workflow. Now, once the workflow is selected, a job is scheduled. So inside the workflow, GitHub is going to see, okay, there are these jobs that are defined, and to run these jobs, I'm going to need a machine now, right? Where do I run these? So a runner is provisioned, right? And this runner is sort of a virtual machine, you can say, or a container. It's a clean environment where everything that you've defined is going to be executed, and then steps execute on the runner, like I said, and then the job finishes. Okay, and everything happens in series, and the job can be successful or it can be a failure. If it's successful, it's successful. If it's failure, you will see why it failed. Okay, then the runner is destroyed. After job completion, the runner is deleted, machine is cleaned up, and nothing is reused. So every time a runner is provisioned, it is a clean machine or a fresh machine that is being provisioned for that particular workflow or jobs to run, and then it's marked as complete. Okay, so yeah, this is the entire workflow in using the diagram, and I hope this is helping you visualize and understand the concepts very easily. Okay, I hope this has been useful. All right, so it's time we go a little bit hands-on and start creating our first CI/CD pipeline. Okay, this is going to be we are just going to make use of the UI and have things up and running. So what I'm going to do is, and what I also recommend you doing is, come over to your GitHub repository, whichever repository you are working on, okay, and click on this Actions tab over here. So on every repository that you're working on, you're going to see this Actions tab. So this is the official repository that I'm on for the DevOps course, and I'm going to click on Actions over here. And here, when you click on Actions, you're going to see it's asking me to select a workflow. Okay, so you can see over here, it is suggesting some pre-built workflow that already exists over here. So there are a set of pre-built workflows. So these are workflows that are suggested for this repository. So it's suggesting a workflow that can build a Docker image to deploy, run, or push to the Docker registry. So this is a ready-made workflow that exists. This is a workflow to publish a Node.js package to GitHub packages, publish a Java package with Maven. So all these ready-made workflows exist. These are pre-built. Okay, and based on a repository, it is suggesting us these workflows, and then you have some workflows around deployment, security, CI, automation, and all of that. Okay, you can even browse category wise. So this is really helpful, wherein GitHub provides you a list of workflows that are already there. Now, if you click on configure, you can directly start using it. Okay, but we are not going to pick any workflow. We are going to come over here. Now, here you can see at the top, you can even set up a workflow for yourself, wherein it will take you to an editor. So if you click this, if you open this in a new tab, it is going to take you in an editor, and you can see over here, it has created this file automatically, main.yaml, right? Main.yaml file, because GitHub Actions, you can define pipelines using YAML files, like YAML syntax. So it has automatically created this main.yaml under this .github folder. So just see the location. Okay, there is a lot to learn over here. The location where this YAML file is being created. So first of all is the repository. Then within repository, it has created a .github folder. Did .github folder already exist? No, it has created for us over here. Okay, and why is it creating .github folder over here? Because see, whatever you are writing in terms of CI/CD with GitHub Actions, everything is to be written under this .github folder, and this is a folder. So GitHub actually can recognize this folder. That is why it separates the CI/CD pipelines that you write. And what happens is, if you're making use of GitHub, there is a GitHub's internal automation engine that looks for the pipelines, and generally it looks for this particular folder. And this is GitHub's way of segregating things and making sure that it detects everything automatically. Okay, so if you have a pipeline to be defined, and if you want it to be picked up by GitHub Actions automatically or GitHub automatically, you have to make use of this .github folder. That is a convention, and within that, it has created this workflows folder. Okay, so .github/workflows is the path, and you have main.yaml. Okay, and you can see over here, it is creating this in the working branch. Now, working is a branch name over here, which is the default branch for this repository of mine. Okay, so whichever is the default repository set for your GitHub account or for your GitHub repository, not for your GitHub account, for your GitHub repository, it is going to pick that one. And whatever your file contents you add over here, so you can enter
you can start writing in your pipeline code. It is going to create this pipeline and it is going to configure it for you. And you can see over here, it has marketplace actions and documentation as well over here. Okay. So documentation is also pretty handy and you can commit directly. Okay. But we are not going to, like I said, we are not going to create a pipeline by ourselves. I'm going to use something ready-made. Okay. So here I'm going to come and I'm going to search for simple workflow like so, and just press enter. You're going to see over here simple workflow and just click on configure. Okay, so you can see over here, this is the simple workflow that can help us understand and learn things. Okay, so we'll take a look at this. So what this says is these are comments. Okay, this is a YAML structure and these are comments. This is a basic workflow to help you get started with actions. Okay, and name of this workflow is CI, right? And here, this part of the code, okay, I'll just zoom in. So this part of the code just tells you the trigger for this particular workflow. Okay, so this part controls when the workflow will run. Okay, so this is going to, so you can see over here, it is going to trigger the workflow on push. So here we have written push keyword. So it is going to trigger the workflow on push or pull request. Whenever there is a push or pull request on this particular branch working, it is going to trigger this workflow, as you can see, right? And it is going to also allow you to run this workflow manually from the actions tab. Okay, so this is the workflow dispatch event that we have mentioned over here. So this is a name of the event, this is also name of the event, and this is also name of the event. Okay, so I hope this is making sense. So this part that I've selected over here controls the trigger. Trigger meaning controls the event when this workflow should be executed. That is what you're defining over here. So you're defining 3 triggers. One is on push event. Okay. Another one is on pull request. And third is you are also enabling the manual run for this workflow by adding workflow dispatch. Okay. This is done. So this is the trigger part. And how is trigger part defined? Using on over here. If you scroll down, here you have jobs section. Okay. So if you hover on this, the best part about this editor is you will also get some documentation. So you can see if you hover on keyword over here, you're going to see it's the GitHub event that triggers the workflow. Okay, and event can be a single string, array of event, and all of this it's mentioned. Okay, jobs basically a workflow is made up of one or more jobs that can run sequentially or in parallel, like we know. Okay, and this workflow is having a single job. So here we have defined only one job, build. Okay, and this is the name of the job. Okay, you can define whatever name you want to. So build is what I've defined. You can say build image or clean image, verify image, whatever you want to have the name you can mention. Okay, and here you have mentioned the name of the runner where this job will run on. So runs on controls this. Okay, so you can see over here, use runs on to define the type of machine. Okay, and this is the machine, and we have mentioned Ubuntu latest over here. Okay, Ubuntu latest. So it will run on Ubuntu. And then within this job, we have defined the steps. Now steps are nothing but the sequence of tasks that will be executed as a part of this job. Okay. So here what we are doing is we are making use of a GitHub action. Okay. So that is what we are mentioning over here. Okay. And what this action is going to do is here you can see. Now see, if you are writing CI/CD, okay, if you are defining steps over here, you will need to check out the code. Check out the code, but where? Okay, so like this entire operation is running on a separate machine. So here you have mentioned this runner, okay, and this entire operation is going to run on this particular machine. This machine is temporary. It does not have anything initially, right? So you want, let's say, to build the application. So you will have to download your source code onto this machine, right? So what you are doing over here is you are making use of this action, checkout @v4. Okay, now what is this action? Okay, we have not created this. So yes, here I won't go super depth into this. Okay, we'll be understanding this down the line, but I'm just giving you a gist over here. This is a pre-built action that exists on Marketplace. Okay, it's a pre-built action, and this action we have not written. So there are such pre-built actions that have been already written, and you can use it in your code. So what this does is it tells to download the GitHub source code, okay, onto your machine that has been provisioned so that the job can access it. That is what it says. And then we are running this one line script, which is a simple script, simple shell command, okay, that says hello world. Okay, so we are saying name, Okay, over here, name is just the name, and we are executing this command, echo hello world. And since it's a Ubuntu machine, we are making use of echo. Okay, and then we are running one more command. Okay, this is a set of command that we are running over here, multiple commands into a single step. You can see run a multi-line script. So here one echo and another echo. Okay, so it's a very simple pipeline that has been created with nothing. There is no sort of complexity. Okay, we are defining the name just to give you a flow or the structure of the actions file or the pipeline file over here. We defining the name, we are defining the trigger, then we are defining the jobs, and within jobs we have steps, and within steps we have like individual tasks that are defined. Okay, now what we can do is we can come over here. Okay, we can just say commit. Okay, before doing commit, I'll also tell you here I mentioned like this is a actions that we are using. Okay, this is the action that we are using from the marketplace, and on the right hand side you can see over here marketplace, and you can search for actions. Okay, you can see checkout over here. Okay, you can search for checkout, so it will check out a GitHub repository at a particular version. You can mention that. Okay, so all of this is there. Okay, these are all ready-made actions that you can use of. But anyways, I'm going to do commit over here and see where this is being committed. Okay, .github workflows and blank.yaml, right? Blank.yaml. So what I'm going to do is I'm going to say commit here. Okay, and here this will create a blank.yaml. I'm going to commit. So this is created now. Okay, so you can see this has been created. Where it has been created? It has been created in .github folder /workflows, and within that you have blank.yaml. Now what you can do is you can come over here to actions file, actions tab over here, and you're going to see all the workflows and everything, like all the runs from all the workflows. Okay, so we have created this blank.yaml, and it's on this particular branch, and you can see it's been 6 seconds ago. All right, and this particular action, this particular pipeline was created to trigger on push, right? On push. Whenever something is pushed to the repository. So there has been a push when we created this particular file, right? We had to push. So this got executed. So you can see there already has been one run. Okay, there has been one run already because we created something, we changed something onto this particular working branch. And you can see it executed 1 minute ago and it ran for 6 seconds. Okay, this has been a workflow run, and you can click on this and see the details. So if you go inside, okay, you can go inside and you can see all the details over here. So there was a push that triggered this 1 minute ago, and I actually created this particular file. So it triggered a push, and this CI pipeline got executed over here. You can see over here, and this is the commit that triggered this, and the status is success. Total duration it ran for was 6 seconds, and here you can see this visual representation wherein if you click on build, okay, you're going to see what happened inside this build. So this build is actually a job. Okay, let me open the YAML file side by side so that you have some decent understanding of what's happening. So here you go to github.github workflows, and if you go to blank.yaml, okay, here you're going to see the job name is build. Can you see the job name as build? What is job name? Job name is build over here, and here you can see build, right? On the left hand side you are seeing CI over here, this side. On the left hand side you are seeing CI. Why are you seeing CI? Because the name of this workflow is CI. I hope this is making sense as to how these things that you have defined in YAML file are mapping to that UI. Everything is being mapped from this YAML file to the UI. Okay, so on the left hand side, let me go back. On the left hand side, under all workflows, you are seeing CI. Why are you seeing CI? Because that's the name of your pipeline, right? If you click on this, you will see here the workflow has been executed once. If you click on this, right, you will see this is the job that was executed. If you have multiple jobs, you are going to see them over here, but right now we have only one job. So if I click on this job, you're going to see all the steps as to how this executed. So you can see set up the job. Okay, so this got set up over here. You can see runner image was provisioned over here. The operating system was provisioned. The runner image was added over here. You can see this is the Ubuntu image. Why Ubuntu? Because we mentioned Ubuntu, and you can see the version and everything of Ubuntu over here, right? GitHub token, meaning permissions were given because the code needs to be checked out. And then you can see over here, the code was checked out. You can see the code was checked out from the GitHub, and this completed the job name called build. Okay, and here you can see the actions were run. Okay, so this checkout actions was run. Okay, then you had run one line script, so echo hello world was run a multi-line script, so you can see multi-line script was also executed, and then you had post actions run, so post job cleanup was being done, everything was cleaned up, and then you have the complete job. Okay, cleaning up orphan processes. So once this entire file was executed in an automated way, what happened is the cleanup was automatically done. We have not defined the cleanup steps, by the way, let me tell you, and the job was also marked as complete, and you can see how it was executed. You can see everything, all the logs over here. These are actually logs. You can search for logs as well. Okay, so it's totally up to you, and you can you will see all the jobs over here on the left hand side, and you can switch between jobs. So this is for the job build. You can see usage over here, so what sort of usage happened, like what all was used. You can see over here, if you click on build, you're going to see, so if you go to usage, you're going to see like 4 seconds of runtime. If you go to the workflow file, you're going to see the workflow file as well that triggered this. Okay, so all the things you can see over here, and then you can go back and see like under all workflows, you can see this workflow triggered the run. Okay, now one thing I would like to mention is, if you go inside this run over here, the workflow run, the logs that you see against all the jobs over here, these logs are very useful for debugging. These are heart over here, I should say. Okay, so you should have the habit of seeing these logs. Okay, and you should know how you should check them, how you should read them. They're very simple to read, nothing complex. But if you have a complex pipeline, you might see a lot more information over here. This is a simple pipeline, and see the amount of information it's generating. Okay, you can come to CI again, and here under CI, so not under all workflows. If you're on all workflows, just go to your workflow, and here you are going to see run workflow button. Okay, so you can also trigger this workflow manually. Why? Because if you go to the code that you have written, this workflow triggers on 3 events. One is whenever there is a push on working branch, whenever there is a pull on working branch, and workflow dispatch has been added over here. And if you have added workflow dispatch, it shows you this button over here, using which you can trigger this workflow manually. Okay, so if you don't want any sort of manual triggers for a particular workflow that you have defined, or for a particular pipeline that you have defined, you have to get rid of this. If you remove this, this is not going to come in, because it's showing you, see, this workflow has workflow dispatch event trigger, which means you can dispatch it manually. So I'm going to come over here, you can dispatch it manually. So I'll select the branch where I want to run this. I'll say run the workflow, and you can see workflow run has been successfully requested. And if you go to all workflows, there will be a run, and you can see this is running now. Okay, it's in process. You can go inside, and by the time we clicked on it, it actually got executed. 7 seconds it took. And if you click on this, you're going to see all the updates over here, right? Like we saw for the previous run. So you're going to see all the workflow runs. You can have multiple pipelines defined. Like for example, you can have 10 pipelines defined for different sort of trigger scenarios. So right now the CI is being triggered by blank.yaml, which we have just defined. You can have different pipelines with different names and that do different jobs. Okay, so this is how GitHub Actions work, and this is one of the demonstrations over here. You can click on runners and see all the runners over here. 0 available runners right now. Self-hosted runners. You can have self-hosted runner over here. Okay, but the major part I would like to show you is we created a workflow, and this folder automatically got added. Right, and within this there is a file that got added. Now these files do not exist on our local machines. So if you come over here, okay, I'm on the right branch. Let me open the terminal. So let me open the terminal over here. Okay, and if I say git status over here, I am on this working branch, the branch where we have created this workflow, right? But I don't see any sort of .github folder and of the workflows that we created. So what I can do is I can say git pull, okay, because this version of local, the version that I have locally is not in sync with the one now I have on remote, because I made use of UI to create certain files and folders as well. So I'll just say git pull, and this is going to pull everything, and you can see now I have this .github folder and blank as well over here. I can make any sort of changes over here, and I can push the things, and whenever I push, okay, it's going to trigger the workflow again as we defined, right? I hope this has been useful, and I hope you all have been able to follow along with me so far. Okay, If you're working with Visual Studio Code, you must be aware of the concept of extensions. So extensions are they are like plugins that you can install onto your Visual Studio Code, and they enhance your experience. So I do use a lot of extensions, and when I was using CI/CD, I got this suggestion. So it's likely if you are making use of CI/CD for the first time, GitHub Actions, you're going to get this kind of a suggestion over here wherein it's asking you to install the extension. So you can click over here and you can click on install, and you can see this is the extension that I'm adding, and it's usually helpful to add the extensions. So you can see over here, this is basically an extension. Okay, let me hide this. So this is an extension for GitHub Actions for this. And if you come over here, you're going to see all the workflows over here, the current branch and everything. So it gives you a nice UI sort of thing over here within Visual Studio Code itself. So if you plan to make use of GitHub Actions a lot, okay, I would highly recommend this extension. And here you can see this little icon has come up on the left hand side, GitHub Actions, and you can see over here all the workflows. And you need to sign into GitHub, of course, once you sign into GitHub, you're going to see all the actions. So just click on sign into GitHub, and it's going to ask you like, do you want to allow this particular extension to do this? So I'll just say allow. So it took me to browser and it finished the entire authentication setup, okay, authorization setup with GitHub, and then it brought me back to Visual Studio Code, and now I can see all my branches, workflows, and everything. You can see over here, okay. On the current branch, I have these two workflows that I have executed. This is one workflow that exists. So everything you'll see over here. Okay, so you can make use of this. This is helpful if you plan to make use of GitHub Actions a lot. I would highly recommend. Now, what I would want to do here is I would want to create a GitHub Actions or second pipeline basically from the Visual Studio Code. And here I'm going to come over here and like you know, all our pipelines reside in .github workflows. So I'm going to come over here and create a new file, and I can call this file as second .yaml. Okay, something like this. Okay, so this is created now, and what we can do over here is I'm going to mention name. Now name of this is I'll call this as second, like so. Okay, and second CI, maybe you can call this as second CI, like so. Okay. This is the name. I can say on. Okay, so it's suggesting me over here, okay, what all I can add, but I will just have a push over here. So I'm just going to get rid of this over here, like so. And then over here, I'm going to say jobs. And then here, I'm going to say, oops. So here, I'm not going to add all of this. So I'm going to say jobs build. And I'm going to say runs on Ubuntu latest. Oops. So builds run on Ubuntu latest. Okay. And it has generated some code for me. Okay, so here you can see steps. So I'm not going to make use of this actions over here, the pre-built actions that we used in the previous code. I'm just going to make use of name of the step, and then I'm going to have this command executed over here, like so. Okay, this is done, and okay, it's suggesting me something. So this is done, and yeah, we have our second CI also written over here. It is going to trigger on push. What I'm going to do is I'm going to come over here to the terminal, okay, new terminal, and I'm going to say, and here what I'm going to do is I'm going to say git add. So I'm going to add everything to git. I'm going to say git status. So you can see this new file is added, okay, and I'm going to say git commit -em. I'm going to add the message as second pipeline, okay, and I'm going to say push. Now the moment I say push, you will see this trigger the workflow here. Right now here you just had one workflow. Okay, now you see second workflow, and both the workflows are being triggered over here. You can see this was pushed, okay, first of all, and now it's running over here. So let me like refresh over here, and you can see over here for second CI, if you go inside second CI over here, this is our second CI, and it just got executed. So this is the file that we just created, okay. And as you can see over here, you can see, right? So this is what we defined, right? So we first set up the job, okay. This is actually, we have not said it to, we have not asked it to set up a job, but it did it by itself because we have defined a job. And here you can see
this is coming in from the second workflow, and like the cleanup was done, right? So the say hello is one of the steps over here. If you see, say hello is one of the steps, and that is what you're seeing over here, right? So just try to map whatever you're seeing on the UI with the file that you see, okay? And just go back and see. Now you should see 2 runs over here. Why 2 runs? This should also run because you did a push to the repository. So the earlier pipeline should also run, the one that you had initially, and the second pipeline should also run. So CI pipeline and second pipeline both got executed, right? I hope this is making sense, and I hope you all are able to follow along. Now what I would say is, I would want to show you a little bit complex file, okay, with the actual stages of developers that they see in the real pipeline. So I have, along with this lecture, you would find an attachment of a text file, and this is the text file that you see, okay. So here you can see, let me zoom out a bit, okay, this is the actual pipeline that has been created. You can see real dev CI demo, okay. This is triggered on push in pull. And this is the name of the job, CI pipeline, and it runs on Ubuntu. This is the runner. And here you have multiple steps. So step 1 is check out the code. Okay. So it's going to like check out the code over here. Then step 2 you have over here, which is going to install the dependencies. So it is installing the dependencies. It is installing Java, Node, and Python dependencies. Okay. And we are not actually installing the dependencies, but we are just making use of echo over here. Okay. In real, you will have the actual commands to install the dependencies. Okay. Then you have step 3, which is running a linter over here. Okay, so it will check for any sort of issues in your code. And then you have a step for building the application. So here, after running the linter, it is going to build the application. So for example, if it's Java application, it is going to run this. If it's Node, it is going to run this. Now I'm not actually running the commands. Ideally, you should be running the commands like npm run build over here. But I'm just running echo. I'm just printing the commands. I'm not actually running because we don't have a project yet. We are not working on the project yet in terms of pipelines. And then you have step 5, which is running the test. Okay, so you can run the test, then packaging the artifacts basically into .jar or .zip or build folders, whatever you want to. Okay, and then you upload the artifact somewhere. Okay, so artifact is uploaded somewhere, and this is how you upload. Okay, and then you build the image. So image will be built, and this is how you build the image. Okay, step 1, step 2, and step 3. Remember, these commands are not being executed in real. I'm just printing these commands using echo. Okay, so ideally you should be running these commands. Okay, but we are not working with the app, so that is why I have not mentioned the actual commands. And then you will be pushing the code to remote Docker Hub or Docker Registry, and then here you have a failure demo. So how a failure looks like, that is what we are simulating. So what I will do is I would recommend copying this, coming over here, and adding a new file, third.yaml, something like this, and just paste this. Okay, once you are done with this, just save it and just come over here and just commit third pipeline. So I'm going to say third over here, like so. Oops, I forgot to add. Okay, git add, and then you add third pipeline, and then you say push. And the moment you say push, you're going to see the third pipeline appear over here. You can see real dev CI demo only, and you can see this is being triggered right now. Okay, it's running right now. And you can go and actually see how it's running. You can see uploading, it's uploading build artifacts. It did all of this, and then here you have intentional failure. So you can check all the logs over here. You can see this gives you a good gist. So setting up the job, you check out your code over here. Okay, on the runner, and then installing dependencies happened. So you can see all the echo statements that you had added. In real, you would be actually running these commands. So you won't see these one-line statements. You would see logs, really long logs over here, right? And then you have lint code. And then if you scroll down here, we have failure simulation. So this is how a failure simulation looks like. I wanted to show this to you on the UI. And here you can have a failure handler as well. Okay. And here you have a post checkout code. Okay. And here it completed the job. So this entire thing, this is how it works. And here you have this failure message coming in. So if you go to, if you go back over here, and if you click on all workflows, you can see all the other workflows executed successfully. But this thing, like the third pipeline, this got failed. Okay. So you can see over here, with one push, we did one push right now, right? We added a new file over here. We did a push right now. How many pipelines should be executed when you are doing a push in our repository? 3 pipelines should be executed. So this also runs on push, this also runs on push, and this also runs on push now, right? So if you come over here, you will see these 3 pipelines have been executed. You can see these 3 pipelines have been executed. Okay. This third pipeline that you're seeing over here, third pipeline as the title, that is the name of the commit that is causing the trigger. Okay. So this thing is the name of the commit that is causing the trigger. This is the actual name of the pipeline that got executed. You can see this is the name of the pipeline that got executed. This is the name of the pipeline that got executed. So for one single commit over here, you can see 3 pipeline got executed. One is real CI demo, other is the CI, and the last one is the second CI. All 3 got executed, but one failed. Why it failed? Because we purposely created a failure state over there just to see how a failed pipeline looks like. Okay, so you can see in the UI how it looks like. It clearly gives you a glimpse of how it failed. Okay, it shows you the timestamp. So all these 3 ran exactly 2 minutes ago when we just pushed the code. Okay, I hope this is making sense and I hope you all had fun. So just check out this file in the attachment of this particular lecture and you should be able to download and use it.
So now's the time where we begin talking about anatomy of a CI pipeline, and we are going to go through a CI pipeline, a sample one, and we'll understand different components. This is going to give you a good understanding of the file again. So here, this is the file that we are going to take a look at. Okay, it is a simple CI pipeline which includes the name, trigger, and jobs along with steps. Okay, so first we'll talk about name. So this part of the CI pipeline is the name part, like it says. And the purpose of the name is it just gives this pipeline a human readable label. And whenever you are working on the Actions UI on the GitHub, so you're going to see this name reflect over there in the UI. And whatever name you give, it does not have any effect on the execution. Okay, so whatever name you can give. And the structure that we are seeing over here of the CI pipeline, this entire structure, this is what is followed generally. Okay, so majority, like whatever code you will see down the line, whether it's on production or any sort of project, and if it's making use of GitHub Actions, you're going to see this kind of code in this particular format. Okay, so that is why I've taken this example. Yes, the files might look complex in some projects if they might have a lot of steps involved in the pipeline. So it might look a little bit complex with a lot of steps, but the structure remains this. Okay. So like I said, name is nothing but a human readable label, okay, which gives you an understanding of what the pipeline name is. Okay, it's basically like a identity over here, right? Then you have the next part, which is the on part, and this is the trigger that can grow. Okay, now over here we have written the trigger as push, which means if there is anything pushed to the repository where this action is being created, it's going to trigger this particular pipeline. Okay, now you can have multiple triggers over here, like you can have push, pull request, you can have workflow dispatch, you can have multiple triggers in a single pipeline, and you can design a workflow or a pipeline to get triggered, and it can listen to multiple events, is what I mean to say over here. Okay, so that's about on part. Then you have this jobs part, which actually does the work. Okay, so it's like a backbone of the pipeline over here that you are writing. And so the understanding of jobs over here is jobs define the unit of work, and here whatever name you are giving. So here I've mentioned build. So whatever name you mention, this is the name of the job. So this is like an identifier. So on the UI, you are going to see build as one of the jobs and what happened in that particular job. And you can have multiple jobs in a particular pipeline or in a particular file. That's completely okay. Okay. Now I've mentioned over here runs on. Okay. This runs on will make sure that a machine is provisioned. It's called a runner. It will be provisioned for running this particular pipeline. Okay. And GitHub does the job of providing a machine. Now the machine can be a Linux machine. Here we are making use of Ubuntu latest, and whatever logic you have defined over here in the steps is going to run on this particular machine, because this is going to need a little bit of computational power, and that is why a machine is needed. All right, I hope this makes sense. Then you have steps part, this part that you're seeing over here. This is where you define the work that is supposed to happen. So this is where the actual action happens, right? Now over here, you can see there is one step only, but in reality, you can have a pipeline with multiple steps, of course. But here you are having only one step which says hello, and it is running this command over here, right? It's running the command. It says echo hello from the second workflow, whatever you want to add. You can say hello from the pipeline or whatever you want to run. You can add Linux command over here and they will run. So this name is the name of that particular step, and run defines the actual command that will get triggered. Okay. So you can see over here run, and here in case of run, you can even have uses over here. Okay. Which is a little bit uses is basically you will make use of a predefined action. You will make use of uses over here, but it can be run or uses. So here I've shown the example of run when you are executing a command over here. Okay. And each step over here, so this is one step. Each step is one unit of work or something happens in that particular step. Okay. And if there is any sort of failure in any of the steps, the execution is stopped. Okay. Now here, whenever you go through the CI pipelines, okay, multiple versions of code, you're going to see different syntaxes, okay, like you're seeing on the screen. But trust me, different syntaxes have same meaning, okay. It's just different ways of writing things. So here you are seeing, this is how you are defining trigger. So here you are seeing this trigger is being defined as on, push. Now you can have multiple triggers this way, on, push, on, pull, and you have a colon over here. So that's completely okay. Here you can have on, push, and you can define branches as well here in the brackets. Okay. So if you want to make sure that you are listening to a particular branch and not to the entire repository. So if a particular push happens on this particular branch, only then this trigger will be invoked. Okay. So the YAML file over here. So you are defining this. This is a YAML syntax. So YAML file allows multiple styles, and GitHub supports all the valid forms. Okay, forms of the code that you are writing over here. Okay, so yeah, that is about that. This is about the anatomy of a CI pipeline. Now remember, whenever you are seeing any sort of CI pipeline, this is what it's going to look like. The structure that we discussed. This is what it's going to look like. Any sort of CI pipeline. Okay, this is standard structure. Yes, the code might be more or less. Triggers might be more or less depending on the requirement, but the structure remains the same. I hope this helped. Now is the time we take a look at the difference between running command versus using actions. So first thing I would like to mention very clearly over here, whenever you're writing steps in the pipeline file, every single step will do some sort of work, right? Or it helps you define unit of work, right? So every single step will do something, and within a step, you can only have two things. One is you can run a command using run, or you can use a pre-built action. All right. So these are the only two things that you can do in a single step. Now let's talk about running a command first, and then we will go to like using an action. Okay. So what does run actually mean? So let us take a look at this example. So within a step, you're going to define something like this. This is a step called say hello. And you within run label, you are having echo and you're printing a message. Okay. Now what this is allowing you to do is it is basically allowing you to run a Linux, to run a command on the terminal on a Linux machine. So it is telling that create a Linux machine and run this command in its terminal. And Linux machine is created using the runner, okay, that you're provisioning. And now within that machine, you are running this command. That is what this means actually, right? So run executes shell commands. Okay, you can use same commands that you are running on shell in a Linux machine, and you can run it locally like this. Okay, and the syntax is also same as Linux terminal, because the runner that you're provisioning is a Linux machine. Okay, and these are some examples of valid run steps that exist over here. Okay, so you can see you can execute mvn test. Here I'm making use of Maven to test my application. I can say npm install if I'm making use of Node.js. I can say docker build with a dot if I'm in the directory where I want to build my application. You create an image, and you can also run Python using this command. Okay, you can see. So these are all valid commands and some examples that I have pasted over here. So key idea over here behind the run command is it helps you run your command on the runner that you have provisioned. All right, that's the significance of run command. Now, this is one way of defining a step. Another way is by making use of a pre-built action. And here you can make use of uses keyword over here, right? So here you can see this step. Here I've mentioned the step name as checkout code, and I've written uses actions / checkout, right? So what this says is run a pre-built automation that has been written by someone else. And where is the automation? The automation is action / checkout. So this is the actual automation that you are invoking. Have you written this? No, someone else has written. So this is like an importing a library. So if you're writing code, let's say you are writing Java code, you will import a library into your Java application to reuse a code or a snippet of code that someone else has written for you, right? And this is true for all the programming languages like Python, Node.js. You can use a pre-built written piece of code that has been written by someone else, right? And you can do that using import statements and all of that. You can reuse the library. So that is what this means over here. So here, action / checkout, we have not defined. We are reusing someone else's logic. It has been defined, it has been published somewhere, and we are using, right? So we are not writing commands here, we are just reusing logic. And what are these defined actions? So what are these predefined actions? So you will have this query as to what does this predefined actions actually mean? Who is defining this, right? So predefined actions are reusable automation packages that have been created, okay? Who creates this? They have been written by GitHub themselves or by the community, and they've been published, right? And they are versioned. For example, here in the example you saw, we have a version checkout @4. So here these packages or these actions that have been defined are versioned, and you can refer to them using the version name, right? Or the version number. And then they are stored in the repositories somewhere, and they're executed for you, right? So this is these are what predefined actions are, and some of the popular ones are these. So you'll see these being used a lot. For example, you can check out your code using actions checkout @v4. You can set up Java over here. So this is going to install Java over here. You can log into Docker Registry using this. You can upload the artifact over here. Okay, so you can do all of this using these predefined actions, and they don't care how you work initially, okay? So you don't care how they work over here because it's defined by someone else. You are just making use of them. You know the end result that you will get. For example, action / checkout will help you check out the code on your runner that you have provisioned, okay? Now, one question that generally beginners have is, why are we using pre-built actions? Why can't we write our own code or own commands, right? Why can't we use just run? Why does this uses even exist? So one major reason is you will have to do a lot of work there if you try to write your own code. And let me give you an example over here. So let's take checkout as an example. Checkout as in you are checking out the code you have written onto a machine, right? So what would you do is you will have to run a series of commands, right? You'll have to run git clone, okay, and you will have to write a lot of commands. You'll have to authenticate with GitHub, store the code somewhere. So GitHub says don't write so much of code or so many commands over here. Simplify. This is a common use case. A lot of developers, everybody out there would want to check out some code using the CI pipeline, right? To build an image or to whatever you want to do, right? So here what GitHub says is don't write so much of code. I'll just give you one action that will cover all the series of steps. Okay. So that is what it does. And checkout process is not generally easy. Checkout involves like authentication, tokens, pull request handling, shallow clones. You will have submodules, some sort of security rules that you will have to deal with. So all of this comes into play, and that's too complex and risky to write every time. Right? So what GitHub says is it says just use this action and it will do the job for you because it has everything written in it depending on the scenarios, right? And the key idea over here is you are actually, using uses over here and a pre-built action along with uses to handle complex, common and error-prone tasks that you as a developer don't want to focus on. You just want to focus on your business logic, right? Not on how you can clone your code from GitHub. Right, so that is what it is. And runner has no code by default. This is one important thing that you should understand. Runner, whenever you provision a machine or a runner, GitHub is going to create a brand new machine, and that machine has no project code. And whenever you try to run something like this, okay, it is not going to list anything for you or run anything for you over here because there is no code on the machine. So if you are running ls, it's not going to show you any sort of output, right? So that's something that you should be aware of. Okay. Now, one thing I would like to mention is, can run and uses be used together? So absolutely no, because you can see over here this piece of code wherein we have defined a step. This is a bad step, and I'm making use of run and uses both in the single step. So this is invalid. This is not allowed. And a step can do only one thing. Either it can run commands or it can execute an action. So either of the both you can do. And the right way of doing things is like this. So you have this one step over here wherein you are checking out the code, and the other step is wherein you are building the project. Okay. So this is absolutely valid over here. Okay. Now let's talk about run and uses over here. So you should use run when the command is specific to your project. You are controlling the logic and it's simple and transparent, right? So if you're doing something that's simple and transparent, only then you should make use of run. But you should use uses when the task is common, like for example, checking out the code, right? That's common. Installing Java, that is also common. Installing Python, that's common task. So you should use an action there. Security matters. If you have something wherein your security matters to you and someone has written much more secure code, the setup is complex. For example, installing Java can get complex. So it's best you use the action rather than doing it manually by running the commands. And some best practices already exist. Even then you will make use of use over here. Right? So this is something you should understand. Okay, so you should use run when you want to build your application, and there are some custom build commands that you want to run. You want to test your applications, and there will be some custom test command that you might want to run. If you want to run some custom script, debug script, so you can use run. But you should use uses when you want to check out code, because it's a common sort of a scenario that is pre-handled. If you want to set up a language runtime, then too you should use uses. If you want to log into like cloud or registry, like log into Docker Hub or something like that, then you should use uses over here. If you want to upload artifacts, you should use uses. Okay, so I hope this is making sense. The clear difference between using run and uses. Okay, I hope this has been useful. All right, so now is the time where we start talking about env, which is environment variables, and the secrets. So I already have few pipelines written over here, and what I'm going to do is I'm going to just comment out the events over here, and I'll make sure all have this workflow dispatch. Now, why am I doing workflow dispatch? So you can see over here the documentation. Workflow dispatch event allows you to manually trigger a workflow run. I don't want all these pipelines. So see, I'm writing quite a few CI pipelines, right? Or quite a few pipelines over here. And I don't want to trigger all of them when I commit something or push something, right? So I'm commenting out over here this thing, and workflow dispatch is what I'm adding over here. So I'll just copy workflow dispatch. I'll go to like second over here, right? And here also instead of on push, I'm going to say workflow dispatch like so. And instead of third, I'm going to comment all out. And I'm going to say workflow dispatch. Okay. So this is how it will be. And on blank here we have workflow dispatch. I'll save this. Okay. So all the files have been saved. Right. And we have this set. Right. Now what I will do is here I have this second CI. All right. And what I will do is I'll copy this second CI and let us use this as an example where, we talk about the environment variables and secrets. So here I'll say rename, and here I'm going to say env, and I'm going to say or underscore secrets, something like this. Okay, env secrets and inputs also we are going to talk about. So I'll just add this over here as a line. You can just say you can just mention whatever file name you want to have. Okay, demo ci env. And I'm going to say env secrets, something like this. Okay, so I've added this, and now I'll save this. Okay, now what are environment variables? Okay, or we call it as env. What are they? So these are normal environment variables that you might want to use in your pipelines for any sort of code. Okay, so that is what it is. Now, there is also something called as secrets, which is secure environment variables. We will come to that in a bit. Okay. Now, first, let's talk about the env variable. So here you can see I have this step over here. So what I'm going to do is I am going to like duplicate this step. Okay. And I'll come over here and oops. So here I'm going to add this step. Instead of say hello, I am going to say install something or try env, whatever you want to say over here, and you can say echo run. And let's say in this particular step, I want to make use of env variables, okay, or environment variables. So I can say env over here, okay, like so, env, and I can say colon, and here I will say app underscore env colon demo, like so, okay. This is what I've added, and here I can say environment, and I can say colon dollar app underscore env, like so. Oops, app underscore env, like so. So this is done. Okay, I'm getting a mark over here. Okay, so this is because, okay, here I need to add echo hello. So I think we can get rid of these codes over here. Okay, now it should, okay, I'm still nested mapping not allowed. I'm still getting the problem, and I think I've identified and understood the issue. Here the problem is you have added colon over here. So I'm getting rid of colon, okay, because colon is having a meaning here. Okay, you're making use of colon here too. So it's throwing an error. Okay, so I've just added that. I'll save this. And now what I can do is I can go to the terminal over here, new terminal. Okay, and I can simply push the code and let us see how this works. So what we have done is we have defined a environment variables over here, right, which is called app env, and I'm using that here in this particular step. Now what I can do is I'll say git add, and I'll say git commit -am, okay, new env ci over here, and I can say push. Okay, I'll just push this and let us see what happens here. So I'll just come to the actions tab here, and here you can see env secrets here. Okay, all right, so this is basically on workflow dispatch. So I'll just run this workflow. Let us see how this works. Okay, so this is running now. Okay, and you can see this is running, and I'll just click on this. Let us go here, and within build, let me click here, and it says install. Okay, so here this is the thing that we defined, install. Okay, so you can see over here it's saying echo app env. And here, in fact, you can see here you are having the output environment demo. So this is the actual output. Demo is coming in from here. You can see the demo defined over here. Now, whatever value you change over here will be reflected here, right? I hope this is making sense. We can keep this. So we are working on this. So we can keep this one trigger on push, right? Our rest all are on workflow dispatch, but this one is on push. And now I can change the value to demo new. Okay, demo underscore new. And I can simply have a commit now. Okay, I can say push, and here you're going to see the commit. Okay, so let me go back, and here you should see one more run happening. Okay, so let me go to all workflows. Okay, so you can see new env ci, and here if you go over here, if you tap here install, okay, you're going to see demo new. So this demo new is the value that we have changed. Now what is the use of having this sort of environment variables? See, environment variables are plain configuration values. You might want to switch the environment in your code or any sort of things, okay, and you might want to use it like for the configuration that you might want to provide for your application that you are running. And generally, if you are making use of such environment, okay, you hardcode the value over here in the code, and this is getting pushed to the GitHub repository. So here you should only make use of things that are not sensitive, right? You will make use of things that are not sensitive. Now the question comes is, hey, so if I want to deal with sensitive data, like DB passwords, I cannot hardcode my environment variable like this, right? So for example, let's say you are building an application. Here you have the command to build the application, right? So you might want to, so you will say, okay, the app in env, instead of app env, you will say env, or you can say app env, and this is, let's say, dev environment. Okay, you are compiling the app for dev environment, and now over here you will say db underscore password. Okay, now this is database password over here that you want to add as an environment variable. Okay, let's say you will say demo@123. Now this password is actually not sensitive. It's sensitive data. But right now it's not being handled in a sensitive way. You have hard coded it in your source code. Now whoever commits the code, everyone is going to see this. So how do you deal with this? Okay, so the answer is secrets. So here you're making use of environment variables. These are environment variables, app env and db password. There is another concept called secrets, wherein what you can do is you define the values in the UI. UI meaning over here. So you come over here. Okay, you go to, let's say, settings. So I'll just open settings in a new tab, and you come over here, and here under actions. Okay, sorry, not under actions, but you come over here, and here under secrets and variables, you go to actions, and here is where you can define like environment secrets. Okay, environment secrets, repository secrets, organization secrets. You can define this, and these can be consumed in the code. Now over here, you can have sensitive information added. Okay, so this is what secret is. So what I can do is, instead of hard coding the database password like this, okay, I don't want to hard code my password this way. What I will do is I will say $:2 times. I'll say secrets dot db underscore password, like so. Okay, this is what I have added. Now what I'm going to do is I'm going to make use of, I'm going to go to the UI. Okay, I'll save this, and I'll say environment app env using, okay, using $db underscore, oops, sorry. So I'll say $db underscore password. So $db underscore password, like so. Okay, this is what I've done. Now I'll take this db password. I'll come over here. Okay, I'll go to repository secrets, and here I'll say new repository secret. I'll define the secret name, and I'll say my database password, like so, @123, and I'll say add the secret. Okay, I've added the secret, and this is done. And now what I can do is I'll come over here, and I'll just push this code. Okay, so I'll say git commit, and I'll say push. Okay, the moment we push, let me come to actions over here. Okay, you should see a new workflow running. Did we push it? It got pushed. Okay, so you should see a new workflow running. Okay, so here, this is it already ran. Okay, so if you click on this, if you go over here, and if you go to install is our step name. So here you are going to see environment dev. Okay, environment is dev, right? Because app env is dev using the database password. So we are using, and you can see the database password is not printed. Can you see it? You have got 3 stars over here. Why you have got 3 stars? Can you tell me why you have got 3 stars? Because it has been defined as a secret. Okay, so you have defined a secret over here. Okay, and you're consuming it over here this way. So it's a secret. You can see over here, right? So it's a secret that you have defined, and even if you try to print it, anyone tries to print it, it's not going to work. So this way, what you've done is you have got rid of the sensitive information or sensitive data that you are willing to use in your application, like database passwords, any sort of token, anything that is sensitive, you can use it this way. So GitHub will encrypt it. You cannot see it again. Nobody can see it again. If you try to access it, you cannot see it again. It's encrypted now. If you try to edit it, you won't be able to see it. Can you see? You cannot see it. You just have to add a new value, right? So GitHub encrypts it. You cannot see it again. And if you log it using the CI pipeline, I'm trying to log it over here. If you try to log it, you have seen what we see. You do not see any output. You just see a masked value. Now here in the UI also, you will see multiple places where you can define secrets. One is environment secret. So this is a secret that is tied to the GitHub environment. Then you have repository secret. So if you want to make use of secret at a repository level, like you want that secret to be accessible only to that particular repository. For example, I want a secret to be accessible only over here. So I have to define a secret over here. Okay, because this won't be used across other repository. It's only specific to this repository. Okay. Then you can have organization secret. Okay, organization secret as in the secret will be there at organizational level. Okay, so this is how you can define the secret, and you can consume it in your application. Now env values can be also at different levels. Okay, so here what we have done is we have defined these env values at a step level. Okay, we have defined it at a step level, meaning these env values are only available to this step only. Now what you can do is you can copy this and you can define a env at a global level as well. Okay, so here if you come, you can say a global level env. Okay, let me go over here. This is an example of global level env here. Okay, so if you press enter, you can say global app env. Okay, and it's global -dev. Okay, this is a global env, means it is available to all the jobs and all the steps. Okay, what you can even do is you can define a job level env. So here you have job build, and you have said it runs on. So basically under the job name here, under the job name at runs on level, you can paste this and you can say this is also a env. Okay, so you can say job app env, and here instead of global you can say job dev, like so. Okay, this is done. This is a job level env. Okay, so we have seen workflow level env. This is global, meaning workflow level. Global meaning workflow level, not outside the workflow. This is job level env, right? And then you have a step level env, which we have already seen over here. Okay, this is step level env. This is available only to this particular step. Okay, so you can say environment app env using db password. I've added db password. I'll add comma. I'll say what is the name of the global env? I'll say global app env. Okay, global app env. I'll add a comma again, and I'll say I also want to make use of job level app env. Something. Okay, so this is done. I'll commit this, I'll push this. So now you should see the output over here. Let me go back here. So I'll just go back. You can see this is running. I'll go to build, and by the time I click, it's going to run. Okay, so it's running, install, and you can see over here environment dev using global dev and job level dev. Okay, so both the global meaning workflow level. Okay, I think global, you might get confused that it's available across every workflow, right? That's not the case. It's globally available, means it will be available within that particular workflow. So that is what it is. So I hope you all have been able to follow along, and I hope this has been useful. All right, so now it's time we talk about the concept of inputs. Okay, now see, whenever you run a pipeline, it runs on a machine that is provisioned over here, and it's called a runner, right? It runs on this particular machine, and once this pipeline execution is completed, this machine is destroyed. Destroyed as in you don't have access to anything that happened on this machine, right? Now there will be scenarios wherein you run some sort of test cases, you generate certain files, you might have test reports that might get generated. You might want to save them for accessing later on, right? But if you have it on the machine, see, those files will be generated on the machine, and if the workflow ends and the machine is destroyed, then you won't have access to those particular files. So it's best that you save it. Okay, so there is a action for this same. Okay, so this action name is upload artifact. So using this is a pre-existing action. So just come to github.com/actions. Okay, this is github.com/actions over here, right? You will see all the automated GitHub workflows, and you scroll down over here and you can search for, you can see there are so many workflows over here, right? Toolkit, all of this, so many workflows. Setup Python, setup Java. These are all workflows, like automated workflows or actions that you can use if you want to set up Java onto your machine. The runner that gets provisioned, if you want to set up Java there, you can do that. Set up Python, you can do that. Okay, so here I'll say upload artifact. Okay, upload artifact. So this is quite popular and very widely used. If you click on this, what this is going to do is, if you scroll down, okay, it basically will upload things that you provide to them. Okay, so okay, I don't see a documentation over here of what it does, but that's fine. You can see over here usage. Okay, so this is how you use it. You can see this is how you use it. It's a predefined workflow or action that exists. So this is how you define it. And yes, it expects a list of parameters. Okay, now these list of parameters that you're giving is known as input. I'm sorry. These list of parameters is known as an input. So what are the parameters here? It accepts name, and this defines the name of the artifact to upload. The default name given over here is artifact itself. If you want a custom name, you can define. Okay. And then the path. So path is nothing but the file path directory or a wildcard pattern that you can mention of what you want to upload. Okay. So for example, if you're generating test cases, right? If you're generating test reports, you run a command. Okay. How would you run a command? You would come over here, you would define something like this, and you would run a command to run the test cases. Now, in next step, what you can do is you can make use of this action and you can upload the test cases that are generated. So you will have a specific path where the test cases or the test reports have been generated. So what you can do is you can mention the path over here. So basically in this particular path, you go and get it uploaded. That is how it defines. And these are all the parameters that have been defined. Okay, so you can see over here, this is given very clearly. So if you want to make use of this artifact, you can use this. What I will do is I'll copy this. Okay. And we can actually define a new step over here. Like so, I'll copy this. Okay. And here I'll say instead of install, I'll say upload artifact demo. Okay. Upload demo, something like this. Okay. And okay, this is giving a red mark. Why is it giving a red? Okay. So indentation issue. So I'll just bring this over here like so. Oops. Okay, this is done. Okay, upload demo is the name, and then I'll say uses like so, and I'll say colon, and I'll say here we have mentioned what is that we have mentioned uses, and this is the thing. Okay, so I've mentioned upload and this it makes use of this actions artifact. I'll say with over here. And I'll say name, okay, and then I'll say path like so. Okay, so name and path both we have to define. Now what is the name? I'll say build artifacts demo like so. Okay, and here I'll say, so you can mention any path that you want to define, but I'll say dot over here. So whatever is there in the current path, just upload that. Okay, are we checking out any sort of code over here? No, so we are not checking out any sort of code. Okay. Okay, so what I will do is I will have one more step defined over here. So I'll just copy this over here. Okay, so before defining this, I'll just have one more step, and instead of install, I'll say create demo file. So I'll just create a demo file using some Linux commands, and I'll say run over here. Now I want to run multiple commands in a single step, multiple commands. So what I will do is I can add a pipe over here. Just go to next step, and I'll say echo, and I'll say hello from CI pipeline. Okay, and I'll take this as an input for demo.txt like so. Okay, and I'll say echo file created successfully. So I've used pipe symbol. Pipe is basically used if you want to run multiple Linux command in a single step, right? So that is what I've done. And basically whatever is there in the current folder will get uploaded. Okay, so what I will do is I'll say git commit, and I'll say push like so. Okay, let us see what happens. So I'll come over here. Let us go behind like one step, and let us see new env ci. I'll click on this, and here if you see, you can see the artifacts over here, right? You can see the artifact. So you're seeing the artifact, and if you click on this artifact, if I click, okay, let me click. Okay, so it's downloading it. You can see it's downloading. So I'll just download this. So I do have downloaded and I've extracted the zip file, and you can see over here I have demo.txt, which has this text in it. Okay, can you see it has this text in it, and this is the exact text, okay, that we had given over here in the file. So this file is actually created, and we have now access to this thing. Okay, so yes, this is what I want to demonstrate, and now this is available only in this run. Earlier this was not available. So if you go to the previous runs, like for example the very previous run, you won't see any sort of artifacts over here. Can you see any sort of artifacts? No. But if you come back and if you go to the latest run, you will see this artifact over here. You can see artifacts produced during runtime, and this is the basically name of the artifact. Okay, so this way you can download, you can even delete it from here, and you can do various things. If you click on this, okay, you would see upload was done. You can see here upload was done. You can see here the demo file was created. You can see, right? Install step is also run over here. Okay, the demo file is created and you get the link also to download the artifact. Okay, can you see the entire process over here? So this entire process is happening because of this action. So it provided the path, artifact name and the directory input path that you've given was validated. Then the file was being uploaded, then uploaded bytes were being printed, then finished uploading. Then you could see a lot of steps, and then zip was created, and then the URL was given to you. Okay, and the job was marked as complete. So if you want to save anything from the execution steps, you can make use of this particular action over here. So there are quite a few things we picked up from this video, we learned new in this video. One is how you can provide input in GitHub Actions. See, whenever you are writing any sort of code, input can be important, right? You are using an action and this action required input. So we have given inputs in the form of width. We have made use of width over here, and we have said name and path are two inputs that we want to give over here. So these two inputs we have given, name says the name of the artifact and path is basically telling from which path you need to pick up the files. Okay, this is one. We also understood about this upload artifact in the process. So upload artifact is a pre-built GitHub Actions workflow that you can make use of. It is used for saving the files that would rather get deleted from the runner, basically, or the runner machine. Okay, so that is what we have defined. And yeah, these were the concepts that we learned, and we also saw the file that got uploaded, and we also downloaded it and checked it out. So this is very useful. In fact, I'll tell you, if you run test reports, any sort of test cases, any sort of logs you generate, you can get it exported this way, or you can get it saved onto GitHub this way. And instead of losing it on the runner machine, it's best you save it. I hope this has been useful. Whenever you create pipelines, these pipelines can have multiple jobs, and jobs run in an isolated manner generally, but you will have requirement, or you may have requirement wherein one job is dependent on another. Okay, now you can define dependencies in the pipeline file. So what I'm going to do is I am going to create one more job over here. Okay, and this is build job. Okay, which has this step. So I'll just copy this over here. I'll just scroll down. And I'll just come here and I'll add this job over here. Okay, now instead of build, I'll name this job as test. It runs on Ubuntu latest. Okay, and I'll just get rid of this env over here. Okay, and here it says test job is what I'll tell over here. I'll mention over here this step name is test job, and echo is over here. I'll say test job. Okay, something like this. So let's say this is a test phase. Okay, this is built over here. So once the application is built, I want to run certain test cases on this, right? Now, what I would want to do is these are two separate jobs, right? They are not dependent on each other. They will run in an independent fashion. But let's say I want to run test job only after the build job is complete, right? Test should only happen once the building is complete. So what I would do is I would come over here and I would have the needs keyword. I'll mention needs over here and I'll say build. Okay, something like this. Now what this will do is this tells that, hey, for test to run, it is dependent on build. So wait until the build job is complete. And I'll show this to you. So I'll just open the terminal and I'll say, let's commit, and I'll say push over here. And I'll come over here. Let us go back and let us see the job being executed. So it's being queued. And if you come over here, you can see build is running. This is not started yet. Build is running still. And this has not started test. Now the test is running. So you could clearly see build was run first and then the test was run. So it waited for 4 seconds because this build took 4 seconds. And after that only test started, right? And you're seeing over here test job and this was printed. Okay, test job, right? So this is the importance of needs keyword. With needs, you can define the dependencies in the pipeline, right? And yeah, this is how you can control the order of execution within a particular pipeline when you have situations wherein one step or one job is dependent on other and you want to wait. you want to make sure that this particular job waits for the other one to complete. I hope this has been useful. Let's start talking about context objects and understand what they are. So here I'm on the GitHub documentation, and here I'll select this GitHub Actions over here. And here under reference, I'm going to head over to workflows and actions, and here I have something called as context. You can also search for context over here directly in the search part, but I'll prefer navigating the manual way. Now, what are context objects? So see, GitHub automatically provides built-in context objects, and they give you some sort of information about the environment around. Now, these are not environment variables, but these are special objects that you have access to. For example, let's say you want some information within your pipeline. So within your pipeline, you want information like who pushed the code, okay, what branch we are on, okay, what is the commit SHA, right? So whenever you commit, you get a SHA. So what is that? And what is the repo name? So all these sort of information you will have access to using these context objects. So you can see over here in this context reference, okay, you can see this gives you the information about context available in GitHub Action workflow. Okay, so these are all the objects that are available. So GitHub is one object, env is one object, vars is one object, job is another object. Now if you want to see the details and the usage, you can click over here. You can see over here GitHub, and if you open this in a new tab, you will see all this information. So this thing opens up. Oops, so let me open it again. So I'll just open this up, and you can see this is GitHub context, and this context object contains the information about the workflow run and the event triggered the run. Okay, so here is how you can use it. So if you say GitHub.action, it is going to give you the name of the action that is currently running. If you say action.path, GitHub.action path, this is a path where the action is located. So all this sort of information you get over here. GitHub.actor, this is going to give you the username of the user who triggered the initial workflow run. Okay, so you can get access to all of this in the pipeline itself. Actor ID, API URL, all of this, and this is just one object with so many properties. You can see over here the repository, GitHub.repository. This is going to give you the owner and the repository name for example, something like this, the URL like this. Okay, this is giving you the repository ID. This is giving you the repository owner. A lot of stuff you get over here. It's a huge information over here. And if you scroll at the top, you might also see some information as to how you can use it. So you can see this is how you use it. Okay, we'll see all of this. But yeah, different objects you can access, like env is one, env is another. Okay, you can see over here env and env. You can access the environment variable name. Okay, and if you want to see the usage, you can actually see it down over here. I scrolled up, but here you can see example of usage of GitHub context. You can see this is how you are going to get the output. Okay, this is giving us the output. Okay, these are all the properties that it's showing us. Okay, and this is how you can use it. Okay, here is the usage. So if the event name is pull request, you can see over here, if GitHub.event name is pull request, then you execute this. Right, so if you want to have a conditional execution on a particular step, this is how you can do it. Right, can you see this? Right, so this is how it does. We have env over here. There are tons of context objects you can see over here. Okay, if you scroll down, where's context? So tons of context objects. Okay, there is a long list. You can go through it. Okay, but I'll show you directly by example as to how you can make use of it. So along with this video, I have this file that is being attached. And this file actually makes use of, some of the context objects over here. So I'm going to copy this. I'm going to come over here to the code, and here I'm going to create a, I'm just going to, can we duplicate this? I don't see any sort of duplication over here, but I'll just create a new YAML file. I'll say context demo.yaml. Okay. And I'll just paste this here like so. Okay. And what I will do is the previous file that we were working on, env secret inputs, it is actually now running on push. So I'll just comment this, and I'll just make sure it runs on workflow dispatch, because I don't want it to run automatically. Okay, I want to focus on one file at a time. So you can see over here, this is one example over here, context demo object, and here you can see you're using this context demo GitHub actor. So whoever is the actor, the username. So my username will come in is testing out GitHub Actions. This will be the run name. over here, right? And run name is the name of the workflow that is generated, right? Workflow runs, the name for the workflow runs that are generated from the workflow, okay? And GitHub is going to display this workflow run name in the list of workflows, okay? So this is what we are going to see. I've given it a custom run name. Here you're seeing like when it's triggered, push, jobs, okay? This is explore GitHub Actions, and here you can see it runs on Ubuntu latest, and you can see all the jobs over here, okay? So this job was automatically triggered by, and here we are making use of event name. Okay, this job is running on runner.os. So runner is a object. You can see over here, right? You're seeing it. Name of the branch is github.ref, right? So it's giving you the name of the reference branch name, right? And your repository it is making use of this, okay? Then we are checking out the repository code, and then it's telling us, okay, the owner has the name of the repository over here. You can see it has been cloned to the runner. And then here we are printing the workspace, and then here we are printing the job status, right? So all these, this is just an example. What I would do is I would quickly commit and I'll say context demo here, like so. And I'll say git push. Oops, so this file was not added probably, so I'll just get it added, and here now I'll say push, right? So this is pushed, and if you come over here, if you go back, okay, and if you see, you will have a workflow run over here, context objects demo, you can see, and it's running actually. So you can see over here, the run name is Faisal. So this is my username. This is testing, he's testing out GitHub Actions, right? So this is a run name that I'm seeing. Now, if I go inside here, I'm going to see over here, you can see, okay, this was automatically triggered by the push event. So you can see this push is coming in from here. So you can see over here, push event. We're getting this from the context object. This is now running on a Linux server. This is also coming in from the context object, right? Now this is also coming, your branch is refs, heads, and working. This is also coming in from the context object. And you're seeing the complete output over here. The repository is, this is the repository, official repository, right? EmbarkX official / full stack AI DevOps Masterclass. Then checking out the code over here. So this is where the actions came into play. And then over here, you are seeing this repository again. It has been cloned to the runner. And then you're seeing the workflow is now ready to test onto the runner. We are listing the files over here, you can see. And the job status is success. You can see over here, right? Post checkout of the repository flow. So all this cleanup is being done. So you can see over here how you were able to get some data, real-time data into the context of how the run happened, right? Who is running it, everything. So you can see over here, if you want to have a predefined run like this with the actor name, okay, you can make use of context objects. Right. So I hope this concept is clear of concept objects, and I hope the syntax is also clear, right? And I did not type in the entire file just to save the time, okay, because we already know these concepts, and I wanted to focus a bit more on the syntax and the concept of context object over here. I hope this has been useful, and I hope you found this valuable. All right, so now it's time where we are going to take a look at this app 1 Hello application, and we are going to take a look at the Spring Boot version. And what we are going to do is we are going to build and test the application using a pipeline, and we are also going to push after successful building and testing to a Docker hub or Docker repository or Docker registry, whatever you call it. Okay, so we are going to do that. So it's going to be completely in an automated way, wherein any sort of push, if it happens to the repository, what you can do is you can get the build tested, compiled, tested, then you can create a jar, and then you can get it pushed to the Docker hub. That is what we are going to do over here. Okay, and for this, what we will do is we'll also need a Docker hub account. We already have a Docker hub account. This is where we are going to push. This is the exact repository where we are going to push, and I'll come over here. We'll start defining the things. So here what I will do is I'll create a new file. I'll say hello ci, or I'll say hello spring _ci .yaml. Okay, something like this. And here for all the other YAML files, just make sure they are set to workflow dispatch. All right. So that I don't want all the workflows to trigger whenever you push any sort of code there. Right. What I will do is I'll come over here in second.yaml. I'll just copy this template sorts and I'll just paste it so that I can save a bit on typing. And here I'm going to say hello Spring Boot app. Okay. Hello Spring Boot app to Docker. Something like this we can say. Okay. Now instead of workflow dispatch, I'll just comment this workflow dispatch and I'll have a push over here. Something like this. Now I have the job defined build over here. So I'll just rename this job to build test because we'll be building the application and we'll also be testing the application over here within this particular job. And we are making use of Ubuntu latest over here. Okay. Then we have steps over here. So different steps. So what all steps we need over here? Okay. So I'll just define all the steps. So first step is I'll say checkout code. Okay. Of course, before executing anything, we will need access to the source code. I'll just copy this here and then, okay. So then after checking out the code, I'll need Java on my machine. Okay. So see this runner that is being configured over here, that is a fresh machine. That is like a fresh machine. Right? It does not have anything. So we need to set up things on it. Now, if we want to build jars, if we want to test the application, we need Java, right? So here I'll say set up JDK. Okay. And I'll just trim down this echo statements over here. I don't want echo, but I'm just keeping echo for now. We'll update these things. Okay. Right now I'm just defining the steps, all the steps. Okay. Oops. So here now I'll say something like this. Okay. So this is done. Now after setting up the JDK, what I'm going to do is I'm going to build and test the application. So first I'm going to build and test. Okay. So we are going to run a command that is going to test the application and we are going to run it using Maven. Okay. Once this is done, I am going to come here and I am going to say I'll upload the test reports. Okay. Upload test reports. Something like this. Okay. So what am I doing? I'm first checking out the code. Okay. So code checkout is done. Why are we doing this? Because we need code first. Then I'll set up the JDK. Then I'll build and test the application using Maven. And then I'll upload the test reports if they are generated or whatever is generated. I'll do that. Okay. And then we will have another job. Okay. Which is going to do the job of pushing and like creating the Docker image and then pushing it to the server. Okay. But first let's have things with one job only. Or what I can do is I can at least define like both the jobs. Okay. So I'll copy this much. I'll come over here. Okay. Press enter from here. I'll paste this. Okay. So this is done. And here instead of build test, this will be, I'll just get rid of this. This will be Docker build push, something like this. Okay, this is also going to run on Ubuntu latest and this will be dependent on the previous step. So I'm going to say needs build test, something like this. Okay, because this is dependent on the previous step, build test, right? So this is done. And then I've defined the steps over here. Now we need to modify all the steps. Okay, so first step is again checkout code because this is a fresh machine that is getting provisioned for a new job, right? So I'm first going to do a code checkout over here. Then I'm going to set up JDK again. Okay. And then over here, instead of build and test, I'm going to build a jar for Docker, a fresh jar for Docker. That is what I'm going to build. Then we need to publish this particular image, right? So what we need to do is we need to log into Docker Hub. So I'm going to say login to Docker Hub like so. And then let me copy these steps. I'll copy. Okay. And here I'm going to paste this, login to Docker Hub. And then I'm going to say over here, build and push Docker image, build and push Docker image like so. Okay. This is done. And this will be the last step. Okay. So what are we doing? We have created two jobs. First one is going to do the job of building and testing the application. Okay. First of all, this entire workflow runs on push. Whenever there is any code pushed, this entire workflow runs. Okay. And we first like we have two jobs. One is build and test, and other is Docker build and push. So it builds the Docker image and pushes it. In build test, we have we first get the code, we set up the JDK. This is all housekeeping stuff. Then we actually start building the application, and then we upload the test reports. Okay. And then over here in Docker build push, we again, because it's a new machine, first of all, it's dependent on the previous job, which is build test. That job has to finish first. Then we are doing a checkout for the code, and then we are setting up the JDK. Then we are building the jar, and then we are logging in to get Docker Hub. I'll show you how you can do that. And then we are building the image and pushing it. Okay, so let's go step by step now from the beginning. First thing is check out the code. Okay, so here we are not going to make use of run. We are going to make use of a GitHub action. I'm going to say uses, and I'm going to say actions / checkout @v4. Now this is a ready-made GitHub action that you can make use of, actions / checkout. Then I'm going to set up the JDK. So if you come over here, I can go to GitHub Actions like so. Okay, here, and here, and you can. Okay, we don't have. 1 second. So if you scroll down on this page, you can explore the actions marketplace over here. Okay, so I'm going to make use of, you can see, so it's Java, right? I want to set up Java. So you can see over here, set up JDK. Okay, so if you click on this, you can see here, how do you use this? If you scroll down, okay, here is how you can use it. You can see it uses setup Java. Okay, and you can mention the distribution and the Java version, and it is going to set up for you. Okay, so I just want to copy the setup part, which is this part, okay, from the uses. Okay, I don't want the checkout part over here, so I'm just going to come over here and I'm going to replace this. Okay, oops, so this needs to be indented well, like so. Okay, all right, so it will be like so. Oops, it will be like so. Okay, this is done with distribution. What is the problem now over here? Okay, I understood. So this cannot be like this. I did some indentation mistakes. All right, so this is done. This is sorted now. Okay, some syntax issues, but it's all sorted. So what we are doing is we are saying actions / setup Java v5. Then I'm mentioning the distribution over here, which is Temurin. You can see the supported distributions for available options. Okay, so if you search for Java Temurin, you will get the available options. So I can search over here Temurin Java or Temurin Java, something like this, and you can see all the latest releases of Temurin. So all of that you can check. If you want some other release, you can see in which distribution it is provided. But I'm making use of Temurin. I'm fine with 21. Okay, I hope the application will run with 21. So let me check that as well. Okay, so here if you go to pom.xml, okay, it will work on 21. Okay, this is important. You should know how your application works, right? So 21. If you're making use of any sort of latest Java version, you can mention that and get that distribution. So this should be done. Okay, Java. Now what we need to do is we need to build and test. Okay, so for that, I'm going to come here and I'm going to specify the working directory. Right? Why am I specifying the working directory? I'll get to that shortly, but I'll also mention the command over here. So command I want to run is mvn-b, and I'll say clean verify. Okay. Now where should this command be run? Where should you run this command? This command should run in hello spring folder. It should not run anywhere on this runner, right? The runner that is getting provisioned Ubuntu latest, it should not get run anywhere. So what I need to do is I need to specify the working directory as to where this command will be executed. So I'm going to say Docker. Okay, so where is our actual code base? It's in Docker app1 hello. Then I have Spring Boot and then hello spring. Okay, if you want, you can get it using the command line as well. So you can say clear over here and you can get the present working directory. And you have to, so not here, but you can navigate to Docker and then you can say app1 hello, and then you can say Spring Boot, and then you can say hello spring, like so. Okay, now you have the complete directory over here. Okay, I'll just copy this and so I'll copy this and I'll paste it over here like so.
Now we cannot use backward slash. I'll have to make use of forward slash. Okay. So like so, and done. Okay. So this is done. So in the current directory, what it's saying is in the current directory, just navigate to Docker, app1 hello, Spring Boot and hello Spring. And in the current directory, you will have Docker because you have checked out the code. You've checked out the code, right? In the previous step. So you will have this directory. Now what you are doing is you are running this command in this directory over here, which is good. Now we need to upload the test reports. So what I will do is I will come over here. Okay. I've navigated to github.com/actions. And here I'm going to search for upload. Okay. Upload -artifact like so. Okay. Now here, so you can find actions from here as well, or you can find actions from here as well from the marketplace link. That is completely okay. All right. Now here, you can make use of this action. So if you scroll down over here, usage. So here under usage is what you will find the information for. So name and path is what you need. You will copy. Okay. And you will paste it like so. Okay. Indentation issues again. So I'll get this indented well. Like so. This is done. Okay. And yeah, I'll get rid of these comments. Okay. I don't need these. You can either type in or you can do using copy paste. It's completely your choice. But yeah, this is done. Okay. Action/upload artifact version 4. And you need to mention the name of the artifact. So it will be test reports. And from here, I'm also going to mention the path that needs to get uploaded. So the path, see, there is a default path where these test reports will be generated by default. So you can mention under hello Spring within application, there will be target folder /sure fire reports. Okay. So this is what you need to mention. Now why sure fire reports is the folder that we are picking in? Because this is where Maven JUnit store the test results by default. Okay. So this is what we are referring to. So this one job is complete. Okay, one job is complete. What I will do is I'll save this. Okay, I'll save this. I'll come over here. I'll say clear and I'll say commit. Let's commit and let us see. Hello Spring CI, right? Hello Spring CI is the message. Oops, so this does not get added. That's a problem. So I'll just get this added. Okay, what's the problem? Okay, this is not again added. So 1 second. Okay, so git add, git status. Okay, this is not added yet. Let me try again. So I've exited the terminal. I'm saying git add. Okay, and then let's say git status. Okay, so it's been added now, and now I'll do a commit, and now we can do a push like so. Now the moment we do a push, you would see a workflow run over here, right? So let us see the workflow run. Okay, so let me refresh. Okay, you can see hello Spring CI. This is the workflow run, and it's running right now. It's building the application. Okay, it's downloading the JDK. You can see over here the entire stack trace. It's downloading the JDK onto the runner, right? And okay, so it's building the application. Let's wait for a bit. Okay, the JDK download is happening. Okay, once the JDK is configured, it is going to upload the test results. So you can see uploading, and then post setup JDK, post checkout code, and then the job was completed, which is fair enough. Okay, Docker build push does not have anything. So what I'm going to do is I'm going to collapse everything, right? And let us see what happened. So were the test reports uploaded? Yes, the test reports were uploaded as well. Okay, let us see what were uploaded exactly. So if I come over here, okay, and if I go over here, let me see. If you scroll down, here you're going to see the artifact, and this is the test report. So you can just click on it and get it downloaded. So I've downloaded the zip file. I got the zip file, and you can see these are the test reports that I got. Okay, this is how you get the test reports. Okay, I'm not going to open these, but that is okay. This is how you will get the test reports generally. If you want, you can open like this. Okay,
You will see all the reports here. Okay, but I'm not opening this. I'll just close this. But this is how you can upload the test reports. I hope you get the context over here. Now, what are we going to do over here is this is done this much. We come over here. This part is done, like building and verifying the application and generating tests is done. Now, what we need to do is we need to build the Docker image and push it to the remote Docker hub. And as you can see, a few steps, there is an overlap for few steps. So I'll just copy this much until build and test, or I don't need to copy until build and test Maven. I'll just copy that first 2 steps and I'll just paste it like this over here. Okay. So here also we are checking out the code because it's a fresh new machine, and we are setting up the Java over here. So Java setup is done. Now we need to build the jar for Docker. Okay. And for that, we need to run the command. So command running already we have done like so. So this is what I'm going to copy, command running. And here I'm going to paste this like so. So working directory is this, right? And I'm going to say mvn-b clean. And instead of verify, I'm going to say package d skip test. So I don't want to run any sort of tests when packaging the application. Now the output of this is it is going to give me a jar file, .jar file. And before making use of .jar file, I'm going to log into Docker Hub. Okay. So to log into Docker Hub, I'm going to come back. Okay. And here I can search for Docker Hub like so. Okay. And here Docker login. Okay. Docker login is here. And how is it used? If you can see, okay. Build tag push. Okay, this is not the one I'm referring to. So 1 second. So here by all creators I need by verified. Okay. So Docker. If I just search for Docker. Okay, so this is verified now by verified creators. Okay, 1 second. So let me select by verified creators. Okay, this is there. And there is a GitHub action for Docker Hub. Now if I click on this, okay, you can see this is what it is, and this is verified. GitHub has manually verified the creator. Okay, if you scroll down over here, you're going to see this, right? This is how you use it. See, there are going to be many actions that you will see over here in the marketplace from different creators. You have to make sure you're picking the right ones, right? So these are all verified, and you can see this blue tick. Verified as in some organization might have published this, and here in case of this, I'm not able to see the organization name over here, but yeah, it's by Docker officially. You can see over here, it's by Docker officially on the right hand side. So it's official, right? It's an official action that you're using. So it's good. So I'll come over here. I'll copy this step over here. Okay, this much. Let's copy this much and let us come over here. And we are going to log into Docker Hub. So I'll just paste this like this. And I'll press tab. Okay, tab and tab like so. Okay, this is done. So I'm saying login actions, and here Docker Hub username. Okay, I won't say vars, I'll say secrets, Docker Hub username and Docker Hub token, or you can make use of Docker password. Okay, so you can say Docker password or Docker token, whatever it is. So I'll just say Docker password. Okay. This is, see, these are secret names. So whatever you're defining over here, you have to make sure you define that in the UI, right? So you have to mention that, and username password you have added. And now what you need to do is you have to build and push the image. Now for this particular step wherein we need to build and push Docker image, I'm going to come over here and I'm going to say build Docker, and we'll see this build and push Docker images action. This is official one. And if you scroll down, you would see the usage as well. Okay, build and push. So we already have a Docker file in our application. So what I'm going to do is I'm going to make use of this last one. Okay, I'll copy this. We'll come over here and I'll simply paste this over here like so. Okay, I don't need name, so I'll just get rid of name and I'll just indent everything. Okay, this is like how it is. Okay, yeah. So you can see over here, okay, this is how build and push Docker image is working. It is making use of this action, which we just saw. And I have a width over here. Okay. Now there are a lot of parameters that you can set over here. We need to set this context, right? Why are we setting the context? To build a Docker image, right? So we need to set that.
And there are a few parameters that you should have access over here as well. So you can see over here, context is 1. Okay, build context. You can see context. This is context, right? So all of these parameters we'll use. It's there already on the page as well. So here, what I will do is I'll come over here. I'll say context like so. So we'll specify the context. What is the context? So this same thing, same path is the context, because this is where our Docker file resides. Okay, I'm going to say push is true. Tags, okay, we can mention tags over here. So I am going to say something like this here. And on the next line, I'm going to add multiple tags over here. Okay, so first thing is we can mention secrets dot Docker username. So I'll copy this much. Okay, so let's say I want to tag this. So I'm going to make use of the username that we have access to. And I'm going to say /hello. And what is the name of the repo? So I have the name of the repo over here. The name of the repo is hello spring. So I'm going to copy hello spring, come over here and just mention hello spring like so. And you can say latest. Okay. Now you can add multiple tags to this. So this is one. I can stick to one, or I can add multiple tags if you wish to. So I can say spring, and here I can also add the SHA. So I can say GitHub dot SHA. Okay, something like this. And then I'll duplicate this again, and I can say one more tag over here can be ref name, ref underscore name. So you can add as many tags as you want, and you will see all this reflecting on Docker Hub. Okay, this is done, and I'll just save this file, and let us now try pushing the code, and let us see this in action. So I'll just come over here, I'll clear, I'll say git add, and I'll say git commit. So let us do a commit quickly, and then do a push like so. So the moment you push this, let us come here, and I'll see CI over here. Let us go back. Okay, you can see the workflow run is there. It's in process. Build push, build test is happening. Okay, 3 seconds down. Now Docker build push has not started. Why it has not started? Because we are making use of needs keyword. Okay, so here if you see, we are making use of this needs keyword, right? So that is why it's dependent on build test. It's not started until build test completes, right? And you can actually get the use case of this particular keyword. So you can see build test finished, and now it has started Docker build push, right? And if you click on this, you're going to see everything. So jar building is happening. You can see, okay, jar building. Oops. So jar building. If you go down, there's a lot of processing. Okay. By the time I scroll, okay, there's a lot of processing here. Okay, so here you can see now post checkout code, and everything was done. Okay, so it was done. Oops, so login to Docker Hub failed. Why did it fail? Okay, I know the reason. Simple reason, we did not set up these env variables, right? So that was incorrect. I've almost forgot about it. So I'll come over here. I'll go back. Okay, I'll go to home, and then I'll go to settings over here. We will scroll down. I'll go to secrets and variables, actions, and I'll add 2 repository secrets over here. One secret is the Docker username. Now whatever is my username, I'll add that. So decode 007. This is what I've added. I'll add the secret. Okay, just make sure the name of the variable that you are adding and whatever you are adding in the UI, they both have to match. Otherwise it's not going to find it. I'll enter my password over here, and now you can see the secret has been added, username and password, right? So this should now function. So what I will do is I will come over here again in actions. Can we do a manual trigger? I think we cannot, right? We cannot. View the workflow file, delete. Okay, I cannot trigger it manually. So what I will have to do is I'll press enter one time over here, and I'll do a commit. Okay, so I'll commit and I'll push. Okay, let us see this in action. So this should now work in my opinion, because we have added the 2 env variables. I think this was what we needed, right? No other variables, Docker username and Docker password. That's fine. So I think this should now be working. Let me refresh. You can see this is working. And now so you can see build test is running 12 seconds down. I'll just be on Docker build push. Okay, so this should start. So we'll wait for a while, a few seconds, but you can see it is already in progress. And right now building and testing is happening.
25 seconds, 26 seconds, 27. It seems like it's done. Now let's go to Docker build push. This is the next job. The machine is getting provisioned in my opinion. So I'm not able to click. Okay. Yeah, now it started. So you can see building jar for Docker. Okay. It's building the jar file. Let us wait for a while. It should log in successfully now to Docker Hub, if provided your username and passwords are correct, by the way. Okay. It should be correct. And it's trying to log in. Okay, login was succeeded and it is building the Docker image now. Okay, build failed. And now it's doing the post checkout. So why did the build fail? Let us see. BuildX failed with error invalid tag. All right, invalid tag. Okay. So we are trying to make use of what over here? It's not able to access it. Okay, I get this. Username, and invalid tag. Okay, I understood the problem over here. Very silly mistake we have done. Okay, this is not a valid tag. Why it's not a valid tag? Because we missed the $sign. Oh, how can I miss something so simple? Okay, I've added the $sign over here. You can see now. And now let us do a commit. It should work for sure now. So I hope you got the issue over here. We were trying to tag. Okay, we were trying to tag the image over here. But this expression that we had mentioned was not getting evaluated to something meaningful, and that is why it failed. All right. So what I will do is, if you see the Docker Hub as well, let me refresh. There was a push around 30 days ago. So you can see last push was quite some time back. Let me refresh. Okay, it's still 30 days ago. So there is no push yet. Let me go to summary. Okay. And let me go back. And let me see how the run is happening now. Okay, build test is, we are 30 seconds down the line. And right now, build test is done and Docker build push has started. So let us see how this is working now. It's building the jar for Docker. It should now successfully log into Docker Hub, right? In my opinion. I should not face any issues because login succeeded last time as well. Okay, let's see. So login succeeded and image is building. You can see over here. Okay, it's happening and it's pushing. Okay, it's pushing the image. You can see over here, right? You can see the logs. It's pushing the image and you can see everything is done, right? And post build cleanup is also done. There are no failures now, right? Can you see this? It's completely successful. And this is absolutely brilliant. So we are now able to build our application and push it to Docker automatically, okay, using a CI pipeline. So if you come over here, you can see last push was 30 days ago. There is only one tag and this is the latest, like 1.0 and latest. Okay, latest was pushed around 1 month back. So I'll just refresh this and we should see a latest push. You can see last push was 1 minute ago. This is the working tag. These are all tags that we have added. This is the image, commit hash, So if you come over here, so if you go to the repository, if you see the commits, okay, you are going to see this hash BF1AF66. So that is what it's tagged with. BF1AF66 and the complete hash. That is what it's tagged with. If you don't want to have this, that's completely okay. I've just shown you ways of doing things. Latest is pushed, latest is tagged. Working was also tagged. Why working was tagged? So see over here, there are 3 images that were pushed. One is the latest. Another one is the the commit ID. Okay, this is commit SHA. Okay, and then you had the branch name over here. Branch name. This is the branch name. So 3 things were triggered. Okay, if you want, you can comment this and just have the push done to what we call the main branch, right? Or using latest, right? So I can just comment this. Why is it not commenting? This is commented. Okay. Now if you scroll up, okay. Now there is one problem. I'll tell you the problem also. It says if there is any sort of push event occurring on this entire repository, trigger this, right? Now tell me, if someone makes changes, let's say to README file, should the entire pipeline run? Should it run? No, it should not, right? Why would you waste resources? You would run everything. You would upload a new test artifact. This way, you know, on every small change, even if someone makes any change to this Kubernetes configuration, this pipeline is going to run, right? When do you want this pipeline to run? This is for hello world like hello application for Spring. So if there are any changes happening in this folder, only then you should run this pipeline, right? If there are any changes happening in this folder. So what I'm going to do is I'm going to say on push, and I'm going to have a colon over here, and I'm going to mention some configuration. I'm going to say paths, and I'm going to mention the path over here. So this path is the change path. So if any sort of changes happen in this particular path, only then you run this. Okay. Now this is for run, and this is for workflow dispatch. Okay, over here. Workflow dispatch. So I can also trigger this, manually. Okay. So workflow dispatch, push, and only on this path. So if there is any sort of changes that is happening on this path, only then you trigger this pipeline, right? So let me run this now. Oh, sorry. Let me commit this, and get this pushed. And now let us come over here. I'll go back. Okay. Okay. You can see. All right. So you can see this workflow has this. So you can now run this manually, right? So that is absolutely okay. And you can see this workflow was not triggered now. Can you see this? Was it triggered? No. Why it was not triggered? Because you added this configuration, right? If push happens, or if there are any changes in this path, only then you trigger this workflow, right? Did you make any changes in this path? No, you actually made changes in this pipeline, right? Which is outside this path. So there was nothing that was triggered over here. Now, if you want to trigger, you can, we have added workflow dispatch. This is the only reason why I've added workflow dispatch, because we are not going to make any changes to the code, right? And I wanted to demonstrate this, right? Now, if you don't make any changes to the code and you want to trigger pipeline, you should have workflow dispatch. So that's why I've added this, and I can now run this. Okay. Now the moment I run this, okay, where is the run happening? Let me see all workflows. It's running now. And now you're going to see like working, and this hash won't be like added, but there will only be push that will happen to latest over here. Okay. So we'll wait for a while. It's 12 seconds, 13 seconds, 14 seconds, but I hope you get the gist of why we added this, why we added this path, and how we also saw it in action. You made changes to the CI file. Okay. And because CI is outside this path, after committing, this was not triggered, right? So we won't want all the workflows to run when there is a small change in the application, right? We won't want that to happen. You can even configure this to make sure that this runs on a certain branches only. Branches, you can say -main. So you can mention the branch name. So on main branch, if any changes happen on this path, only then this workflow will trigger. Okay. I'm just commenting out. I don't want to add branches, but you can see the level of customizations that you are getting over here. Okay. You can see Docker build test, and build test is happening, and Docker push is also happening. But you can see the level of customizations that you're getting in the CI or in this pipeline over here. Okay. So you can see, okay, Docker build push is failed, and I probably know the reason over here. Okay. So this thing is not commented yet. The thing is, this is not commented yet. The last part. Okay. This is not commented yet. So what I will do is I'll just leave it this way for a while, or what I can do is I can just convert this into something like this. Okay. So the thing over here is this is not being considered as a comment because I've used pipe. So instead of that, I'll make use of normal list over here. So I think that should work well. Okay. So now this is a normal list. Okay. Normal one. Oops. Okay, it's not allowing list as well. So I'll just do a Control-Z and we'll stick to where we were originally. Oops. So this I'll make sure it's commented. And if you scroll down, this I'll make sure it's commented. If you scroll down, I'll just get rid of these and I'll just make sure this exists. Okay. And let me save this and let me commit and push. So you cannot add comment over here because this is after pipe. Okay. And it's considering it as a part of string. So you had either delete it, right? I don't want to delete because I want to have this as an example on the repo for you all. So I'm not deleting this, but now what I can do is I can just run this for the final time, and I'll show you it's working. Okay, so if I run the workflow, you're going to see it running, and we're going to see this for the last time now. And this is like a test run that I'm doing. Okay, we already saw it running, but after making all the changes, I want to make sure it's running fine. Okay, so you can see now build test is happening. All right, so I waited for a while, almost a minute, or more than a minute, I would say. And I could see like this first job took 39 seconds and this one took 40 seconds. Okay, but both are successful, and now you can see the latest images also. So last push was 2 minutes ago. If I refresh this, it would be like less than a minute ago, right? So this is working fine, and I hope you all have been able to follow along this, and I hope this has been super useful for you all. Hey there, so now it's time we take a look at our Node.js application. And if you come over here in the Docker folder, app1, hello, and just head over to Node over here. So here you are going to see this is our Node.js application. We already have a Docker file that we have already written. We have the app here in app.js, and everything is here in this particular folder. Okay, so what we need to do is we need to containerize this application. So first of all, we are going to build this particular application, build and test the application. That is going to be step 1. And then we are going to build the Docker image and push it to Docker Hub or whatever registry you are using, right? So here we are going to do this with the help of a pipeline that we established. We wish to achieve this in an automated way. And here on Docker Hub, we already have this hello node. So here is where I want to do some push. So if there is any sort of code changes that happens in the repository or in the application for a node, okay, I would want to build it automatically, get it tested, and also create an image and push it to the remote Docker registry. That is what I want to do. So what I'm going to do is I'm going to come over here, and here under GitHub workflows, I am going to add a new file, and this is going to be hello. I'm going to have node, and then I'm going to have ci.yaml. Okay, something like this. So this is my YAML file that I have created, and here I have this template for the pipeline. So I'm going to copy that and I'm going to paste it over here. Right now we'll start making modifications over here so that we adapt to our requirements, right? So the first thing that I'm going to do is I'm going to make sure it works. It runs on push. Okay, this thing runs on push, and also I'll just have a workflow dispatch as well. That's completely okay. I should be able to run it manually as well. So this is there. I would like to add some sort of configuration over here. Now see, one thing is this, with this configuration, this pipeline will run whenever there is any changes to the repository. But what you can do is you can add one more path parameter over here, and you can add the path over here. Whatever path you are adding over here, that path will be tracked. And whenever there is any changes in that particular path, this pipeline will run. So this pipeline only runs if there is a push at the path that you mentioned. Okay, so we can mention that settings, we can add that setting, but I'm not adding that right now. I'll just comment this out. Okay, we'll add that in the end, but right now this is done, and we need to define the jobs over here. So there are going to be 2 jobs. One is building and testing the application. Okay, so this first job is build test. I'm calling it build test. You can call it whatever you want to, and it runs on Ubuntu latest. Okay, I have steps defined. Now let us take a look at the steps as well. Okay, so this is number 1. Okay, this is number 1 over here, and this build test, I would have the other job, which is Docker build push, like so. Okay, and this is also going to have some sort of steps over here. We'll come to that, but there are 2 jobs that we are defining over here. One is building and testing of application, and the other job is to create a Docker image, build it, and push it. Okay, these are 2 jobs that we have defined. Both the jobs will run independently. So first, let's complete the first job over here. So first step we will do is we will check out the code. So I'll say check out code over here. something like this. Okay, I'm not modifying the run statement over here. I'm just leaving it as is. I can just get rid of this. Okay, the statement over here. I'm just leaving the run over here. Okay, we can come back and modify it later on. Okay, but I'll go back to the new line. I'll paste this. So this is step 1. We check out the code. After checking out the code, the runner machine is empty, right? The runner machine that gets provisioned is of Ubuntu, right? It is going to be empty machine, a fresh machine that has nothing on it. And we want to build our application. So what is the first thing that you would need on that particular machine? First thing you would need is the ability to, run Node.js commands. And for that, you're going to need Node.js. So set up Node.js is our second step. Then we go down over here. The next step is, of course, to install all the dependencies. So here I'm going to add this step, and here I'm going to say install dependencies over here. Okay, this is going to be the next step, and then after this I'm going to have the next step as run tests. Okay, so I'm going to say run tests, and I'm going to run this conditionally. So if there are any tests defined in the application, only then it will run. If there are no tests, then it won't run. So I'll have the commands defined conditionally. Okay, so the first job does the work of building and testing the application. First, we check out the code, we set up Node.js, then we install the dependencies, and then we run any tests that exist. Okay, then the next job is of building and pushing the Docker image. Now over here also we are going to need the steps and all. Okay, but first we need to mention the runner machine over here like so. Okay, and here we have mentioned the runner machine. I'll also say needs over here, and this is going to need this previous step, build test over here, and then I'll copy all of these steps. Okay, let's copy all of these steps. We'll modify them as we go. Okay, just copying things, it saves a bit of time, from typing in the syntax, right? So first step would be to check out the code, right? Second step would be to log into Docker Hub, right? So we'll log into Docker Hub. Third step will be to build and push the image. Okay, build and push the image. Okay, build and push Docker image, I'll say like so. Okay, we don't need the last step over here, so I'll just get rid of this. Okay, now here we do not need to install a Node.js on this particular runner machine that gets provisioned. Okay, so I've not set up Node.js here. So just to reiterate, this is a new job, Docker build push. So a new machine gets provisioned, new runner machine gets provisioned over here to complete this particular job. And this job is dependent on the previous job. That is what I've mentioned, because only after running the test, installing all the dependencies, like running the test, building the application, only after that you would go for building the Docker image and pushing it, right? But you still need code for the same. So I'm checking out the code, logging into Docker Hub, and I'm building and pushing the Docker image. Okay, so this is how the entire flow is going to look like. Of course, we have not defined the actual commands that we are going to run. Okay, we will do that shortly, but it's important to understand the flow first. So this is how pipelines are also planned. See, whenever you're working on a production grade application, generally you would have an outline of the steps that you need to do. First, you would check out the code, then you would log into Docker Hub, then you would, if it's a Spring Boot application, you will have to create a jar file, right? But here, it's not a Java project, it's Node.js. So you will basically directly build and push the Docker image. So all of these things, you need to plan out first, like I've planned. You can plan it out on a piece of paper, you just write down, or in your notes, write down the steps and then convert it into code. That way, you will make very less mistakes, okay? Now let us start defining things. Okay, so for checkout code, what I will do is I'll head over to the actions page. So come over here to github.com/actions and search for, I would search for checkout like so. Okay, so you would see checkout over here. This is an action for checking out a repo. And if you scroll down over here, okay, you can see how this is used. Right, so I'm going to copy this and then come over here and then you can add it over here like so. Okay, so first thing we are going to check out the code, right? So checkout code is done. Then we need to set up Node.js. So of course you would need an action for the same. So here you can come and you can say node. Okay, so if you come over here, this is probably the one, setup node. So this, you can see over here, set up your GitHub Actions workflow with a specific version of Node.js, and this constantly updated. So you can just open this. Okay, set up node, and just come over here, and here you can see the actions file, or you can see you can see the usage over here. So just copy this. Now how you can use, what all parameters this action need, all of this is demonstrated, like depicted over here along with the comments, right? So which version you want, you can mention your version and all. So we will just mention the version. I'll just copy this, and then I'll paste it over here. Okay, and then I'll have to indent this. So I'll do it like this. I'll get rid of the comments. I don't need comments. Now we need to mention Node.js version over here. So whenever you are watching the video, whichever Node.js version is available, you can mention that. So I'll just mention 25. Okay, you can mention whichever Node.js version is available. Now what this is going to do is this is going to set up Node.js onto this particular runner machine, and this is a parameter that you're passing to this particular action, right? Other parameters are optional, so I'll just skip them. Then we have installing the dependency. Now installing the dependency, what I'm going to do is I'm going to run a command over here. So I'm going to get rid of this. I'm going to say npm ci over here. Right, so this is the command to run the dependencies, and here this command needs to be executed in a working directory, right, or in a specific directory. So I'm going to say working directory, and I'm going to say the working directory is going to be docker /app1 hello /node. So in this particular directory, I wish to run this particular command. Now here you must be wondering, why are we using npm ci and not npm install? So we use npm ci in CI pipelines because CI pipelines must always produce the same result every time, and npm ci will install dependencies exactly as locked in package lock.json. So in this package lock.json that you have over here, node, and you will have package lock.json. So the locked dependencies will be installed as it is, making builds faster, predictable, and repeatable. Okay, and this is also this is better basically for pipelines. So that is what we are doing over here. And then we need to run test if any. Okay, so this command actually will run in this working directory, and then we also need to set the working directory over here for running the tests. Okay, like so, and then we are going to run it over here. So I'm going to say npm test, and I'm going to say if present flag. Okay, so npm test if present. So if there are any test cases present, I think our project does not have any sort of test cases. But if you write any, if they are present only, then it will be executed. Otherwise it will be skipped. Okay, so this is the first job that we have finished writing. Okay, now let's head over to the next job. Okay, so here we have mentioned the runner, we have mentioned the dependencies. In step, we need to check out the code. So of course, checking out the code is going to be same as this one. Here I've copied this, and I've mentioned checkout code over here. Okay, so this is done. Now I'll have to log into Docker Hub. Okay, so I need to log into Docker Hub. So I'll come over here. I need an action for that. So I will come over here, and I'll say login Docker. Okay, and okay, it's not coming in. So login action, let me check. So there is an action for this. Okay, so it's not coming in. Let me search for Docker. Maybe it will come in now. Okay, it's not showing up over here. I don't know the reason for this. Docker, let me go to the marketplace actually. So here on github.com/marketplace, I've come to marketplace, and here also I can search for actions. So here let me search for, or let me select actions first, all actions. Okay, and I've selected all actions, and now I'll mention Docker over here. So let us see what are the results we get for Docker. Okay, so here we are seeing some Docker related actions. I don't know why they are not coming over here, but if all the actions are not coming over here, maybe you should use the marketplace search. Okay, so come over here, Docker login, just tap on Docker login, and here you're going to see this action, and here if you scroll down, you will see the usage code as well, right? So you can see name is login to Docker Hub, and it is also giving using and with thing over here. So just copy this entire thing, come over here, and here just paste this. Okay, uses and with, so something like this. Okay, and you have to, okay, like this. So now it's sorted. Name is login to Docker Hub. It uses this action, login action, and we are passing in the Docker Hub username and Docker Hub token. Okay. Now what I will do is I'm passing both from one from wheres and one from secret. I'll make sure both are coming in from secrets. Okay, that is what I'll do. And both of this you need to add in on your Docker UI. Okay, on the UI. Now I'm renaming both. I'll rename this to Docker underscore username and Docker underscore password. Okay, password, like so. Okay, so I want to have this as a variable name. You can modify this. Okay, you just got the syntax from here, right? This thing just gave you the syntax. If you want to have a different variable name, you can of course do that, right? So I've done that. Docker username, Docker password. So this is done. Okay, login for login into Docker will be done, and now we need to push the Docker image as well. So I'll come over here, and here when you search, you also have build and push the image. So just open this. Let us see what this action looks like. Okay, so here if you see, okay, so here it is setting up. It is setting up BuildX. We don't need this. We need to make use of this last thing over here, build and push. You can see build and push action at the version 6. I'm going to take this and I'm going to paste it over here like so. Okay, and this has name as well, so I don't need name. I'll just get rid of name over here. Okay, and then I will use it like this. Okay, now we need to modify this a bit. Okay, so here what it's doing is it is making use of this action. There are a few parameters that you can mention over here. So first parameter is, so if you scroll down, okay, you can mention context over here. You can see. So I want to mention context because we already have a Docker file defined. So you can see we have a Docker file in this particular folder. So what you can see, what you can do is you can come over here, you can say context, and you can mention this location over here. All right. So I've mentioned this like so. Okay, push. I'm setting the push to that of true. Tags, you can add your own tags, whatever tags you want to add. Okay, so here now I'll add a pipe over here, and here I'm going to say something like this. Okay, and here I'm going to say secrets. Oops, so 1 second. So I'll just take Docker username over here like so, right? So Docker username, and I'll say slash hello node. So what is the repo name I have? Whatever my repo name is. So my username slash hello hyphen node. So I'm going to add that hello hyphen node. I'm going to say colon, and I'm going to say latest like so. Okay, this is what I'm going to do, and this is what I'll push it as. So I think this is it. We don't need anything else. Context is set, everything is set, and let's see how this functions. Okay, I'll go to terminal, and I'll make sure I'm in the right directory. Okay, I'm in the node directory itself. So I'll say git status here. Okay, if you want, I'll move this to the top right. Let me move this to top right so that it's better on view, right? So I'll say, okay, I've moved the terminal to top right by, I did a right click over here on the terminal itself, and I'll say, I said panel position, and I moved it to right instead of bottom. So this view is much better, I feel, right? So here now I'm going to say, so if you say git status, you are going to see this is not committed. So I'm going to say git add, and then I'm going to say git commit in am, and I'm going to say hello node ci dot YAML like so. Okay, this is my commit message. That is what I'm mentioning. Simple commit message. Okay, so this is not added. It says this is not tracked. I'll make use of UI to make sure it's tracked. I don't know, using command why is it not coming in, but if you say get status now, okay, it's added now. I'll commit this, and I'll say git push. So let us see what happens when we push. So I've pushed it. Let us see over here under workflow runs. Oops. So one thing I forgot over here, and you have to like come to settings over here. Okay, come to settings, scroll down and just make sure you go to secrets and variables and actions over here, because we are making use of variables over here, right? And add these two variables that you are using in the actions file. I've just added this Docker password and Docker username. So these two things you are using over here, right? So if you come to the code and if you scroll down, these two things, like you're using Docker username and Docker password here, right? So just be sure to add both of these, and only then it will make sure that it runs. So you can see it's running now. And just come over here. Okay, so the build has failed. Why has it failed? Okay, there is some problem. So this probably has happened because on my machine, I feel can only install. Okay, so the problem is my package.json and package.lock.json are out of sync. That is what the problem is. So what I need to do is I need to say rm hyphen rf, and I'll remove node modules. Okay, node modules. So right now I am in the node folder. Okay, where am I? I'm in the node folder and I'm removing node modules and package, not package JSON, but package lock JSON. I'm removing both of this. Okay, so this is not going to work on PowerShell. All right, which is fine. So what I'm going to do is, instead of like dealing with the commands, I'm going to just delete it from here. So I'll delete node modules first of all. This is deleted. Package lock JSON also I will delete. It's deleted. Okay, and I'll run npm install over here so that both the files are recreated again. Okay, and you can see now both the files are recreated. What I will do is I'll say git add, and I'll add a commit over here, right, like so. And I'll say git push. Let us see now what happens. Okay, so this issue can happen because package lock and package JSON both were in sync probably on my machine, so that is why it might have happened, right? But that is absolutely okay. We deal with errors, we evolve, we learn. That's completely fine. And I won't be painting a fake picture that no one gets errors when it comes to programming. Right, so I'm not going to edit this. I'm going to show you all the debugging, everything live, and you can see this workflow run is happening now. It might fail. Okay, it did not fail. It might fail. That's completely fine. We will debug it, and I would be happy if it fails, because you all get a chance to see debugging as well. Okay, so it's building the Docker image. You can see. Okay, it built the Docker image and it pushed. So both the steps have succeeded. You can see clearly over here, both the steps have succeeded. Okay, this first one took 10 seconds. Then Docker build push waited for the first step to complete because we had marked it as dependent on the first step, right? So it waited for the previous step to complete. Once the previous step was done, Docker build push was executed and the code and this thing was pushed, image was pushed. You can go and check the logs if you wish to by clicking over here and see what all happened in every step. Okay, so you can see over here, login was succeeded with the right credentials. You saw everything happening over here. You can see all the execution happened over here. Okay, and you can confirm if the build was pushed over here. So here on the repo, you can see last push was 1 month ago. And for latest over here, last push was 1 month ago, right? So what I'm going to do is I'm just going to simply refresh. Let us refresh. And now you can see last push was less than 1 day ago and it was pushed 1 minute ago. Can you see? Just a minute ago, all push was done. You can see it's all updated over here. So this is how pipelines are working over here. You can see, right? And it's indeed fun to watch this. So every time you make any sort of code changes, this pipeline is going to run. It is going to automatically test your application. If there is any sort of test failure, it is going to notify you via email. If there is no failure, it is going to build the Docker image and fresh and it is going to push it. Now you can configure these pipelines to a particular branch as well. So I can tie these pipelines to the main branch. And if there is any sort of update or anything that is happening onto the main branch, it gets triggered and things start happening. So here, if you come, okay, I'll just disable the terminal here. Okay, terminal is gone. If you come over here, you can configure this to a particular path or a particular branch depending on your preferences. So for example, here you can say branches, okay, branches, and here you can mention main branch. So if there is a push over to main branch, only then this gets executed. You can also mention path over here. So I've mentioned path. Okay, and this will go in the next line, and here you will have the entire path mentioned. Okay. All right, what happened? Unexpected value path. Is it paths? Yes, it may be paths. Okay. And now here you need to add the value. Okay. So the value is this, right? So if there is any sort of code changes in this particular path on main branch, only then this pipeline gets triggered. And I have also added workflow dispatch over here purposely, because since we are learning, I would want to run this pipeline manually as well. So you can disable this if that's the case, right? But you can imagine, okay, the level of control that you have access to. You can mention any branches you want. You can mention multiple branches. You can mention paths you want. You can mention multiple paths. That's completely fine. So I can mention multiple branches over here working as well. Okay. You can mention multiple paths. That's completely okay. So the level of configuration and the level of control that you get is insane over here. Now you can see I've mentioned this. So if there is any sort of change on the main branch for this path, only then this gets triggered. What I will do is I will do a commit over here and I'll push this. Now the changes have not been done. So you can see the changes have not been done on main branch, and neither the changes have been done on this path, right? So since the condition is not matching, this won't run automatically. I can guarantee you that. If I refresh, you will see it's not running automatically, right? So you'll have to manually run this now. So you can go over here. Okay, sorry, not here. But you will have to go over here. And second CI. Oops, I think I forgot renaming the pipeline name. I'm sorry about that. So I can mention over here, hello node CI. Okay. I also have one more pipeline for Spring that is written. It has hello Spring Boot app to Docker. Okay. So I'm going to add the same thing. Hello node app to Docker. Okay. Something like this. And now I'll make the changes. So I'll say here commit and then push. Okay. This is done. The code is gone. And now if you come here, okay, this should be renamed. Oops. So I'll go to actions. And here you can see, yeah, hello node app to Docker. So if you click on this, you're going to see the workflow has not started automatically, because we have configured now for it to work on a particular branch if there are any changes on a particular branch and at a particular path. So that has not happened. If you make any changes there, it will work. It will get triggered. But now I can run this manually. I'll run this manually. You can select the branch and it runs manually. Why manually? Because we have added this workflow dispatch event trigger in the pipeline. Okay. And it's running manually, and you'll see a run appear over here. Okay. Or over here. You can see it's initializing. Okay. So if you come over here, you can see it's initializing. It's initialized actually. Build happened for 8 seconds. And now it's a Docker. Now it's building the image and pushing it. Okay. And you are going to see the image being pushed as well. Okay. So yeah, this is how you can have insane level of control in an automated way. Imagine this working in a production grade scenario. You have multiple branches, feature branches, different developers, different teams working on branches. And whenever a feature is complete, you merge all that code into main branch, and main branch is actually configured with pipelines that will automatically, build, test, and then build Docker image, and it will deploy your app to production, So you don't have to do anything. You just have to make sure whatever you're merging into the main branch is the code that you want on production. You just merge it and you are done. The pipeline automatically triggers. It does all the job. It is pushing Docker image. It's doing everything, right? You're seeing it hands on. So that's how production grade teams work in real world scenarios. And this is something you're getting a vibe of this, right? And this is something very important for you to understand and experience. And I hope you all have found this super valuable. All right. So now it's time where we write pipeline to build and push our Docker app, our application in Python for hello. Okay, so this particular application under Docker folder, which is app1.hello, and there is this Python folder that you will find. Now, this is the main application. Okay, this is the file, and here we have a Docker file as well. Okay, so what I'm going to do is I am going to create a pipeline over here. I'm going to just duplicate this second pipeline here. Okay. I'm going to rename this file over here. So let us rename. I'm going to say hello, and I'm going to say Python _CI, something like this. Okay. And I'll also have a nice name for this particular pipeline. So here I'm going to say hello Python app to Docker. Okay. So make sure you have a good name. This name can be anything. It will be visible to you on the UI of GitHub Actions. Okay. Now, when do I want to trigger this particular pipeline? So I want to trigger this on push. And since I have multiple events over here, I will end this with a colon. Okay. Now, let's start planning the pipeline. Okay. So here, what we have done is we have defined the name. We have said on push or workflow dispatch. Workflow dispatch means you can run this pipeline manually. Okay. And push meaning if any sort of push event occurs across the repository, it is going to run this pipeline. Right? Fair enough. Now, if you come over here, we have job over here, which is build. I would want to create a job over here, which is called as build test. So I'll say build test. Okay. And I'll say runs on Ubuntu. So this is going to run on Ubuntu machine. And there are certain steps that I wish to define over here. Right. So the number one step is checkout code. Okay. I will make sure I get rid of this echo statement that I have over here. That is something I'll get rid of. Okay. So this is what I've defined here. And then here I'm going to paste this. So first step is checkout code, because we need to see whatever is getting provisioned over here, this runner over here is like a fresh machine. It does not have anything. And to work with our code, we are going to need the code as well, right? So we are going to check out the code, and this job is about building and testing the application. So for building and testing the application, you are anyways going to need the code. So that is something you need. Then I'm going to have one more thing over here. I'm going to say set up Python. So in this step, we are going to set up Python. And then let us have a few extra lines here, and I'll paste this thing again. Okay. Like so. Set up Python, check out the code, and then I'm going to install dependencies. Okay. This is how you would be building the application. And then over here, we're going to run the test. Okay. So we can run test like so. Okay. So what are we doing? We are actually doing a checkout for code. We are setting up Python. We are installing the dependencies, and we are running the test, right? This is done. Now I would want to copy this entire job over here, because we would need one more job to build and push the Docker image. Okay. So here I'm going to name this job as Docker build push. Okay. Build and then push like so. Okay. And it is going to have its own series of steps. So first step is going to be checkout code, because see, every job you have in your pipeline. So your pipeline can have multiple jobs. This is the first job that I have. Within job, you have steps. There's a second job I have, and it is going to have its own steps, right? So this job is going to run on its independent machine, right? And once this job is complete, this is going to run on a separate machine. So this is a fresh machine. So we will have to check out the code first, right? So that job is for building and testing the application. This job is for containerizing the application and pushing it to Docker Hub or whichever registry you are using. We'll be using Docker Hub here. You can use any, right? So to push the image, to build and push the image, you need the code first. So that is what we have got. You need to log into Docker Hub. So I'll say log into Docker Hub like so. And then I'm going to build and push the image. So here I'm going to say build and push image like so. Okay. This is done, and then I'm going to get rid of this, right? So yeah, 2 jobs, build and test. These are the steps, and then Docker build and push. These are the steps, right? I'll save this. Now, what we need to do is we need to have the code for every step, right? So first step is checkout code. So what I'm going to do is I'm going to come to GitHub Actions Marketplace, and of course we are going to make use of like reusable GitHub Actions. So here on the marketplace, just make sure you select all actions over here under actions, right? You select all actions, and then over here, you can search for checkout. So we'll get all the actions for checkout. So you can see checkout over here. Okay. Now here, if you scroll down, you will get the usage as well. So you can just copy this usage like so. And you can come over here
And for checkout code, you can just paste it over here like so. Okay. Like so. I'll do a tab. Okay. And yeah, this is it. So we've done this. Okay. And I need to mention the repository. I don't need to mention. Okay. Because the default repository is the repository that we are on. So I won't add any sort of parameters. Okay. I'll just get rid of all of this. Okay. So I'm just checking out the code. We have done a code checkout. Now we need to set up Python. Now to set up Python, what we need is we need a action again. So I'm going to come over here and here I'm going to search for Python, right? If you search for Python, you will get this official action over here for setup Python. Just come over here. Okay. And you can see how this is being used, right? So I'll just copy this over here, this much, or you can copy this entire steps over here. Okay. So I'll just take this entire thing, come over here, and for setting up the Python here, like so, you do this, right? And here, what I'm going to do is I'll select all. And here, I'm going to say, okay, I'm going to get rid of this steps over here. Okay. So I have name setup Python. I don't need this hyphen now. Okay. I'm going to say uses checkout v6. Okay. So this is not needed. And actions setup Python. Okay. With Python version, you can mention. And here you have the command as well. Okay. So I don't want this as well. I'll just get rid of this. Okay. So right now we are just setting up Python. So I'll just focus on that. I'm saying this is the action that we want to use with Python version 3.13. Okay. You can change this version to whichever version you wish to make use of. All right. But if you're watching this video at any particular point in time wherein there are new Python releases that have happened, that's absolutely okay. You can just change the version, and this version might also change for the action. That is completely fine. It's important you understand the concept. See, this version changes is fine, right? So this is done. Then you install the dependencies over here. You say working directory like so, and you mention the directory, and here you mention the run command. Now, why are we mentioning working directory over here? See, to install dependencies, you would be running the command, and in fact, I'll be running multiple command, not one. So I'm going to add a pipe over here, go to the next line, and I'm going to say Python -m. This is a command for Python. I'm going to say pip install upgrade, and I'm going to say pip. Okay. So this is going to install all the dependencies along with the upgrade, and I'm going to say pip install -r requirements.txt, because we have some requirements over here in our application. You can see requirements.txt. So this app that we are running needs Flask, right? So all these requirements, whenever you update the requirements file also, all those will get installed, right? So this is being done. Okay. And once this is done, so what have we done? We have done package upgrades, and we have installed all the requirements. So this is done. Now what we need to do is we need to set up the working directory, because this has to be executed in the working directory where our app exists. So what is our working directory? Working directory is Docker app1-hello/Python, like so. Okay. So Docker is over here. Okay. So when you check out the code on the machine, okay, the runner that gets provisioned, you will have Docker folder. So I'm saying Docker app1-hello, which is app1-hello, and under that you have Python, right? So there, this command will be executed. This is important. Otherwise, if you don't set a working directory, okay, it assumes the current directory, and you don't have requirements.txt in the current directory. So it's important that you mention the working directory, or else you mention the complete path of where requirement.txt is there. I hope this makes sense, right? So that is what we are doing. And now what we need to do is we need to run the test over here. So what I'm going to do is I'm going to say Python -m py_compile, and I'm going to say main.py. So I'm in a way running the smoke test. Okay. You can say whatever kind of test you are running, you can mention that. So this is going to compile the entire file over here. And of course, we again need to set the working directory as well, because this command needs to be triggered in this particular directory, right? So this is done. And then if you scroll down, so this is actually done. This entire job is done.
over here of building and testing the application, right? So you can see how this is working. Here you can check out the code. Here you are setting up the Python. Then you are installing the dependencies, and then you are running this test over here. That is done. Right now you need to build and push the Docker image. Okay, so for that we again need to check out the code, and we already have written the step for that. So I'll just copy this. I'll come over here and I'll check out the code here like so. And then I'll log into Docker Hub. So for logging to Docker Hub, it's a process. So we won't be writing commands for that. But in fact, there are ready-made actions for this. So I'll come over here to the marketplace, and here just search for Docker like so. If you search for Docker, you're going to see Docker login as one of the action which you can make use of. If you scroll down, you're going to see over here uses login action, and you can make use of username and password. So it accepts username and password of Docker Hub. So I'll copy this, okay, and I'll paste it over here like so. Okay, and once you do this, oops, so actually I should not have selected everything, but only this much. Okay, once you do this, it's all sorted, and I think this is it. Okay, so now this is done. We log into Docker Hub, and you can see over here we have vars and secrets. So I'll have both of them referred as secrets over here, and instead of Docker Hub username, I'm going to say Docker underscore username, and instead of Docker Hub token, I'm going to say Docker password. Now both these variables you need to create over here. So you need to come over here before having the workflow run. You need to go to settings over here. Under settings, if you scroll down, you have secrets and variables, and select actions. So these are secrets and variables for actions. And here you have to make sure you create Docker password and Docker username. I've already created this. You need to say new repository secret. Just add Docker underscore username and enter your username, and Docker underscore password and enter your password. Okay. My username is decode007 right now, with which I'm working, right? So you have this Python image over here that I've pushed. Okay. So this is where I'm going to push it, but I'm making use of this username. Okay. So you use that, you add that, and you are referring to that over here. So make sure the names are same. If there is a name mismatch in what you've added on github.com under secrets, and if you've mentioned some other name over here, it's going to create trouble, or it's going to trouble you, right? So this is done. Now what we would do is we would build and push the image. Now for building and pushing also, you have a ready-made action. So you can see over here, build and push the Docker image. So if you see this action, if you scroll down, okay, here you will see a little bit more steps. I'm not going to take all the steps, but we are going to take only last thing for building and pushing. So I'll just copy this, come over here, and here I'm going to paste this, right? And just use tab over here. So this is done. Okay, so build and push image, and this is the action that is getting used with push is true. So I want to push this. Okay, I also have an option to set the context over here. So if you scroll down, you can set the context, right? So since our application has Dockerfile defined, you can see Dockerfile is defined. I would want to set the context, right? Where the image building process should happen, or generally when you build images with Docker, you have to give context. I'm going to say context here, and I'll enter the path of the folder. So this is the path of the folder, right? So, okay, so this is done. I've mentioned the context, and now push is true. I need to mention the tags. So I can mention the tag over here. I'll add a pipe, and I'm adding pipe because I can add multiple tags later on, right? But if you don't want to add multiple tags later on, you can just mention without pipe as well. That's completely fine. So I'm going to tag it with my username. Okay, I'm not hard coding my username. You can see over here, I'm not hard coding my username. So I'm getting my username and slash, what is the name of the repo? Username slash hello Python. So I'll copy this, and then I'll say hello Python, and then colon latest like so. Okay, so this is done, right? So this is how the entire pipeline, or this is what the entire pipeline will look like. So you can see over here, the name of the pipeline. I'll just take you through all the steps so that if there is something that you are not clear on, it goes clear, right? So here the name is what we have defined. This is the name with which you can refer to this pipeline, or this is the name with which you are going to see the pipeline in the UI on github.com, right? What is the trigger? When should this pipeline be triggered? On push, like any sort of push in this repo, it should be triggered. Of course, you can customize this and go a bit granular, and you can say, okay, I want this to be triggered only on only if there is a push on this branch, or only if there are any sort of changes at this path in the code on the repo. Only then I want to trigger this, which of course you can, but right now I'm not adding that. And I've added workflow dispatch, because if you want to run this manually, you should be able to run that. You can get rid of this in production grade scenarios if you don't want to have manual runs in your pipelines, right? So you can get rid of that. Jobs over here. Okay, you have two jobs. One is build test and other is Docker build push. Okay, so here in build test, it runs on Ubuntu latest. These are the steps. Okay, so you have checkout code over here. Okay, so you first check out the code, then set up the Python, and then install the dependencies for Python, and then run smoke test for the Python app, right? So you are using actions a lot. These are reusable actions that you're using for checking out the code. For setting up Python, you have mentioned Python versions. These are the parameters or the inputs that you're giving to the action. Then you are setting up the working directory, and you're mentioning these two commands. Now, why have I mentioned pipe over here? Because I want to run two commands, right? If I don't mention pipe, I can run only one command, right? So for me, running it as two commands, I've added the pipe over here. So what I'm doing is I'm upgrading pip, and I'm upgrading packages, and then I'm doing requirements.txt install, right? So then we are running the test. Okay, this is good. Then if you scroll down for Docker building and pushing, I'm checking out the code because it's a fresh new machine that gets provisioned. I'm logging into Docker Hub, and here I'm making use of actions again, and I'm also making use of secrets that will be configured on the UI. Okay, make sure you configure these in the way I've shown you, and then I build and push the image. Okay, so I've added pipe over here as well, because if I want to add more tags, I should be able to. So if I want to add one more tag over here, I should be able to, right? So all those things I can control. This is done. Now what I would do is I would get this added into into GitHub, and I can commit it from here only. So I can say hello _ Python _ CI.YAML over here. Okay, this is my commit message. I'll just say commit, and I'll get this pushed. Okay. Now this is syncing the changes. The push is happening. Okay. And what I will do is I'll come over here, and we can see all the workflow runs over here as well. Okay. So you would see the run happening over here for Python. And what is going to happen is it is going to take the repo. It is going to provision, provision a machine. And I think we've missed one thing. So we have not created dependency between both. So that's one problem that we did. Okay, but let me do that over here. So if you come over here, you can see this, this particular job is not dependent or not waiting for this particular job to finish. So we need that to happen. So what I will say is I'll say needs over here, and I'll say build -test like so. Okay. Once we do that, I'll again do a commit over here. So I'll say hello _ Python _ CI.YAML like so. And I'll commit this. This is done, and I'll say push. Okay. This is done. And once this is pushed now, okay, so you can see it was not dependent. So Docker build push was executed along with build test. It did not wait for 9 seconds for build test to complete. But now in the next run, you're going to see it's waiting for build test to complete, and both are separate jobs, and Docker build push is dependent on build test. Okay. Can you see this? And if you go inside, you're going to see all the logs as to what things happened, whatever happened. You can click on this and you can see all the output over here, right? You can see everything over here, all the logs. If there are any sort of errors also, you can debug from here. Okay. If you come over here, the building and pushing of Docker image, you can click on this and you're going to see all the logs. Okay. Here, like so. Okay. And building the image also you can see over here. So all of these logs you can check and you can see both are successful, right? So like so, right? And if you come over here, you can see last push over here was 1 month ago. Okay, and for latest, you can see this was 2 months ago. So if you refresh this, you will see a build push happen just about 1 minute ago. You can see 1 minute ago, latest was pushed and last push was 1 minute ago. So this is coming in with the help of CI pipelines that we have configured over here. You can see we are pushing it in the latest tag. You can add more tags if you wish to, but that's completely okay. And now you can even get granular control. Like for example, see, this is for the Python application, right? And the repository is huge. There are tons of applications here. For example, here only you can see app 1, app 2. There is code for Kubernetes, right? Now, any sort of change in Kubernetes file, I don't want this pipeline to run, right? When should this pipeline run? This pipeline should only run when there is change in the Python code. Okay, that too for the Hello app. So what you can do is you can customize or you can add some configurations over here. You can say push and then you can say paths, and here you can mention the path. So I'll mention this as the path over here, this entire thing over here, like so. Okay, and you can even control the branch over here. Okay, you can say branch and okay, branches, and you can say hyphen and main, like so. Okay, so what this will do is any sort of push on main branch with changes in this path only will trigger the CI/CD pipeline. And we also have workflow dispatch, because if we want to run this manually, since we are learning this, we should be able to do that. So now if I commit anything over here, you're going to see like nothing, like it won't automatically run. So let me show this to you. Okay, so here if I say hello Python ci.yaml, okay, I commit this, and if I push this, this is pushed. But did the changes happen in this particular folder? No. Did the changes happen on main branch? No. Where did it happen? It happened in workflows folder for .github. So the automated workflow or the automated trigger is not going to happen for this particular pipeline. You can see over here, it did not run automatically. You can go to all workflows and also see, right? It did not run automatically. Okay, so the configuration has been applied. Now what you can do is, if you want to run it manually, you can go to this pipeline and you can click over here, hello Python app to Docker, and you can say run the workflow. So this is going to run the workflow manually. It is also going to allow you to select the branch on which it should run, like you saw in the UI. Okay, whenever you say run, you can select the branch, right? And once you do that, okay, it's going to run. So you can see now the run has appeared. And if you go inside, you can see this is waiting for build test to complete. And now it's building the Docker image and pushing it. Okay, this ended in 10 seconds, and the second stage or the second job waited for 10 seconds for the first job to finish, because we have added that needs tag right in the configuration. So it waited, and now it is building this image, and it is going to push it over here. So you should see a push happening over here. Okay, so you can see the push happened, and if you refresh, you can see the last pushed less than a minute ago. You can see less than a minute ago. Okay, so pushes are happening. Okay, you can click on this and see the history if you wish to. Okay, it won't show the history. Okay, but that's okay. You get the gist, right? So yeah, this is how things are functioning. Okay, you can see the tags over here. You can see 1 minute ago over here, this was pushed, right? So I hope this has been useful, and I hope you understand how production grade applications work. And with any sort of change, you can configure this. So for example, I can configure this on main branch at a particular path. And now whenever, like, you will have multiple people in teams working on the same repo across different branches. Whenever a feature is done, what you can do is you can merge that feature branch into main branch, and it will just do the job. You know, this pipeline will be triggered. So it will not only be triggered if you have deployment steps written, it will also deploy it to the production, right? So you're just merging the code, and you would merge only when you want those changes to go live. So you're only merging the code, and the code is taken from your machine to Docker Hub or whatever you have configured, and then to production, right? So it's so automated. Imagine doing all of this manually, right? It's so automated. And in real world, like real pipelines look even more complex than this. Right now, we are just building Docker images. But if you have more steps, if you want to conduct integration testing, different sort of testing, you will write different steps for that. Okay. But it's just written once and it's automated for life. You have to just make changes if you wish to, but it's all automated. So that's the power of pipelines. I hope this has been valuable and it has helped you understand how production workflows function in real. So now it's time where we start talking about continuous deployment, which is CD. So the CI part, which is continuous integration, and CD is continuous deployment. So what it is, so this is the software development pipeline wherein you code, test, build, package, push, deploy, and then verify. This is how an ideal software development pipeline functions, and the steps ahead of push. So steps from code, test, build, and package. This is part of CI. Okay, CI as in continuous integration. Now after package, whatever steps you have is continuous deployment, and continuous deployment means every successful build is automatically deployed to an environment without manual intervention. And this actually means every build which you want to deploy or which is successful gets deployed automatically. There is no approve button. There is no manual intervention. If tests pass, then test as in the test cases that you might have written in your application. If they pass and if they are part of CI/CD pipeline, then the code directly goes to the user. Okay. And see, CI part over here, which is continuous integration, ends with a validated artifact. So over here, if you see the steps until package over here, so code, test, build, package. Okay. This is part of validated artifact. So the output that you get is a validated artifact. Now, what is a artifact? Artifact is an output that you get, right? A deployable unit, right? So it can be in any form. It can be a Docker image, a jar file, or a build package. If it's a Python application, it can be in any form. So the output of CI is artifact, and then CD takes that artifact and starts from there. Okay, CD as in continuous deployment. So it takes that artifact, starts from there and not from the source code again. Okay, so this is what continuous deployment means. And once you are done with continuous integration, it's time we start moving our code or our product or application to the production automatically. And whenever you push the code, the power of this pipeline is whenever you push the code, whenever you make any sort of changes, right, there are test cases that automatically run. The application build automatically happens. Application is packaged automatically, whether that's a Docker image or a jar file, whatever form you have written the code for, it gets packaged and then it gets pushed, deployed, and verified onto the production. Okay. Now the power over here is this pipeline is completely configurable. Like you can define which changes or what sort of changes should trigger this entire pipeline. For example, you can say, okay, I want this pipeline to get triggered on main branch and only for changes at this particular path in the source code. And once that condition is met, only then this entire pipeline is triggered. Right? And it is triggered automatically without any manual intervention. That's the power of CI/CD, which is continuous integration and continuous deployment. I hope that makes sense to you all. So now it's time we'll understand how CI/CD talks to Kubernetes. Now, when I say Kubernetes, I mean Kubernetes clusters. See, you can have Kubernetes clusters anywhere, right? On any sort of cloud, or you can have it on AWS, you can have it on Azure, you can have it on GCP, Google, right? So how would your CI/CD pipeline deploy your application that you are building using CI/CD and you wish to deploy using CI/CD? How will it deploy to your cluster? How will it point over there? So that is something we are going to understand conceptually. And this video is really important because this will help you understand how deployment to Kubernetes clusters in production, development, and any kind of environment works with the help of CI/CD. Okay. Now, first of all, I would want to talk a little bit about something called as kube config. Okay. Now, what is kubeconfig? And I'll also talk about kubectl. So see, kubectl, if you have used Kubernetes, if you are learning Kubernetes or deploying projects, whatever you are doing with Kubernetes, you must have used this command kubectl, right? And when you are using kubectl command, you are actually using a command line tool. You are actually invoking a command line tool. And this command line tool helps you interact with Kubernetes cluster. So wherever your Kubernetes cluster is located, it is going to help you interact. So you can create clusters, delete clusters. You can do n number of things, right? Now, one question I want to ask you is, how does kubectl know where your cluster is located? How does kubectl know how it should authenticate to your cluster? See, clusters, it's not like anyone in the world can access your cluster. Okay, there is some sort of authentication mechanism, authorization mechanism that are in place and that work behind the scenes when you run this kubectl command. So how does kubectl authenticate, and how does it know, okay, this is where your clusters are? Okay, so the answer to this question is via kubeconfig. Now, kubeconfig is a configuration file. It's a config file or a configuration file that tells kubectl how to connect to Kubernetes cluster. Okay, it has all the information. It has all the information that kubectl needs to connect to the clusters. Okay, that is what kubeconfig is. So what's inside kubeconfig? Okay, so the information is organized inside kubeconfig, and it is organized into cluster information. So cluster information gives the where part to kubectl. So it contains the endpoint as to where your cluster is located, your certificate authority data that is needed to connect to the cluster. Okay, then it also has users information and credentials. So for example, if you are trying to connect to your Kubernetes cluster, it should know who is trying to connect, right? So it contains your credentials, it contains a client certificate, bearer token, username, password, all this sort of information which is related to authentication, authorization, that is also there in this kubeconfig. Then you will also have context information. Now, what does context information mean? It means, see, at any point in time, if you're working on Kubernetes, it's not like you will be connecting to a single cluster. Right, you can connect to one cluster. Now tomorrow you might want to connect to another cluster, and then day after tomorrow you might want to connect to your local cluster, right? So these multiple configuration for different clusters are stored in the form of context, and it's like a shortcut that links a specific user to a specific cluster. Okay, and see, if this context information is not stored, okay, then what would happen is you as a user will only be able to connect to one cluster at any given point of time. There will be no switching abilities. So you as a user, you want switching abilities, right? Today you should be able to connect to cluster that is located on AWS. Then tomorrow you should be able to connect to some other cluster on AWS itself. Then day after tomorrow I want to connect to some cluster located on Azure. Then after that I want to connect to some cluster located locally. So this is managed via storing information in the form of context, right? And with this context information, you can switch clusters. Okay, so these are some information or some data points that exist in kubeconfig. Okay, and we use it, like I said, for switching environments. For switching environments, meaning if you want to jump between environments like development, staging, productions by switching context, you can do that. Automation, if you want to automate things using CI/CD pipeline, you can make use of kubeconfig files to authenticate and deploy your code to clusters. Also for security, okay, so it keeps your credentials organized, separate from kubectl. So kubectl is a tool and kubeconfig is a configuration file which exists separately, independently of kubectl. Kubectl is making use of kubeconfig, okay? It does not have the authentication information by itself, all right? And also it has the ability to connect to, or it gives the ability to connect to cluster using the information. Okay. So this is some exists. These are some points that exist. Now let's talk about some commands that you should be aware of. Okay. So this first command, kubectl config view, if you run this command, you will get all the configuration that exists. Okay. Or all the configuration that kubectl can access using kubeconfig. Okay, this is one command. Second command is kubectl config current context. So this will give you the current context as to, if you see, kubectl can point to multiple clusters, it can have multiple clusters information, but where is it pointing at any given point in time? That you can get using current context. Okay, then you can have you can switch context. So today, if I'm connecting to AWS servers, tomorrow I want to connect to my local Docker desktop or Kubernetes running on my local Docker desktop, right? So I can change the context using this particular command, kubectl config use context, and I can switch it to something else wherever I want to. Okay, and this is how it works. And where does this kubeconfig file exist? That is also one of the question. Where on your machine? So on Linux or Mac OS, it is going to exist on this particular path. And on Windows, it is going to exist under user profile. So if your user profile is C drive users home or C drive users your name, and then within that, it's going to have .kube folder, and under that config folder, right? And that is where the configuration is going to exist. Okay. So by default, these are the locations where kubectl is going to look for the kubeconfig file, right? Now the question is, do you create kubeconfig file? No. So when is this particular file created, and how is this created? Okay, so I'll give you some example. Let's say if you're setting up a Docker desktop, if you're setting up Kubernetes using Docker desktop, then when you enable Kubernetes in Docker desktop, see, it's not by default enabled Kubernetes in Docker desktop. If you enable it, okay, it is going to create and set up kubeconfig for you. Okay, and if you're using AWS, then when you create the cluster, automatically behind the scenes kubeconfig file is updated, and the cluster's information as to what all which clusters you are pointing to and which clusters exist now will be updated in the kubeconfig configuration. So you are not doing it manually. You are not updating kubeconfig or creating configurations manually. It's automatically updated behind the scenes, right? You never see it happening. You never see the command, but it actually happens. Okay. Now let us talk about what happens with GitHub Actions or inside GitHub Actions. Okay. So what happens is, see, a action runner, whenever you run a CI/CD pipeline, there is a runner machine that gets provisioned, or that gets provisioned. Now, what is a runner? It is a brand new virtual machine. Does it have anything? No, it does not have anything pre-installed. It's a brand new virtual machine. There is no memory that exists, right? There is no file that exists, and there is no kubeconfig that exists on this particular runner machine. Okay. So now on AWS, what we need to do is we will have to run this command to create, update kubeconfig for CI/CD. So if you take a look at this command, AWS EKS, now this is specific to AWS only, all right? And we are talking about AWS, deploying things on AWS. So that is why I'm sticking to this concept of AWS. So AWS EKS update kubeconfig. -2 times name, and we'll mention the cluster name, whatever your cluster name is. You can replace that placeholder over here, and then the region where your cluster is located. So after running this command, what will happen is we will have the kubeconfig settings updated, okay, on the runner machine. Now this, make a note over here, this is running using AWS CLI, for which you need to be authenticated with AWS. Okay, how are we going to do that? You will know when we actually write CI/CD. Okay, but for now, just remember that this particular command is used to fetch the cluster connection details from AWS, and it will write them to your local kubeconfig. You don't run this. I'm repeating again, you don't run this locally on your machine, because when you create cluster, all of these commands are executed in the background, and for you, it's you don't need to run it. Okay, so it's all done in the background. But if you want to update kubeconfig separately, manually, you need this command. Okay, I hope this is clear and useful. All right, so now is the time wherein we would want to create our AWS cluster. Now, if you already have a AWS cluster created, or EKS cluster is what I should say. If you already have an EKS cluster created onto Amazon or AWS, then you don't need to follow this particular step. So we are creating the EKS cluster. I hope you know the reason, to deploy our application, okay, onto EKS using CI/CD. So what I'm going to do is I'm going to run a command. I'm going to make use of EKS control, EKS CTL. I'm going to just zoom in so that you all can see it clearly. Create cluster. I'll mention the name over here. Name, you can mention any name. So I'm going to mention a simple name, hello cluster. Okay, you can mention any name of your choice. And I'm going to also mention region over here, AP-South-1. You can choose the region of your choice. And then I'm going to have nodes is equal to nodes 2. Okay, or you can have one node. So I'm creating a cluster with 2 nodes. And I'm going to say enter over here. So this is going to start the entire process, and it is going to begin the setup. And let me tell you, this is going to be a very patient process. Okay, it's not like you hit this command and it started and it finished in seconds. Okay, you can see I'm not seeing any sort of logs yet, right? So it's going to take a bit of time. And if you come over here to EKS on Amazon, so if you go over here, you are going to see I don't have any cluster. So if you have any cluster created, you don't need to follow this step. You can make use of that cluster itself, like I said, right? Don't create too many clusters because you're going to be billed in the end for that, right? Even if you have credits, your credits will be utilized for that, right? So that's the thing. And you can see over here on the command line where we executed the command, you can see it has begun the process. Now we'll wait for a while until this entire process is complete. Of course, this is going to take like, I should say 5 minutes in my experience, 5 to 10 minutes. So I'll be patient over here, and you'll have to be patient too. All right, so it took some time, okay, and now you can see this EKS cluster is created. It took some time. I waited for at least like 5-10 minutes, okay, I don't know, but I waited for a while. And now if you come over here, and I'll just hit this reload button, refresh cluster. So I'll just reload this, and you will see a new cluster is provisioned now, right? Just so the practice that I follow is whenever I need to deploy something and test something, I create a cluster, and then once I'm done working on the project, I delete the cluster, because this is not something that I need to keep live forever. You know, if you're building something, a service that you're serving, that is serving some consumers, you need to keep that service live, but this is just for learning and demonstration purpose. So I delete it as well, so that, you know, I'm not, I don't get any surprise bills from AWS. That is really important when it comes to utilizing cloud resources. So yeah, cluster creation is done. I hope you all have been able to follow along. So now is the time where we deploy our Hello Spring application to the Kubernetes cluster on AWS using CI/CD. So what I'm going to do is, here I'm on my project, and here if you go to K8s folder under AWS, you already have app1 hello folder, wherein we have already written the configuration files. Okay, and this is written already. You can see this is a deployment file, and this is the service. All right. One thing that we will have to change over here is, see, you're creating the image, you're pushing the image to your own Docker Hub repository. So what you will have to do is, you should not use the official image over here. See, if you're making any sort of changes, you should use your own repo, because that is where you are constantly deploying your new images, right? Now, if you are working for an organization, if you're working in a production grade projects, this image tag over here will be of your organization, and it's most likely you will have access to push over there, right? But for now we are learning, so I'm demonstrating. So I have a separate Docker Hub account, which is with a particular username. Whatever username you have, you replace that over here, okay? And here in the pipeline, here you can see I have the source code as well for app1 hello. That is fine. Now here under workflows, I already have the Hello Spring CI. This is written, right? And it is pushing the app over here. So after authenticating to Docker Hub, it is pushing it to Docker username / Hello Spring latest. And also it is adding two more tags apart from latest, but that's fine. So what I will do is, instead of, we'll develop this CI pipeline ahead to add the steps for deployment. So I'll just duplicate this. I won't make any changes within that. Okay. And I'll rename it over here. I'll say CI _ CD, like so. Okay. And I'll just get rid of this. And here I'm going to add Hello Spring Boot app to AWS EKS, something like this. So I'm naming it uniquely so that it is easily identifiable on GitHub Actions UI. Of course, I have the push enabled, workflow dispatch enabled, and any sort of changes over here will trigger this particular workflow. That is fine. Now here, if you review this YAML file, we have two jobs. One is build test, which is responsible for building and testing the application. It will build the application, test the application, and upload the test artifact, and you can access it right from the interface. Now, if this is successful, it will head over to Docker build push, wherein after building and testing, the next step is we build the image and push it to remote registry, Docker Hub. So that is what it does. You can see over here, it checks out the code, it gets the JDK, it builds the jar, it logs into Docker Hub, and then it is going to build and push the image to Docker Hub. So that is what we are doing. Now what I need to do is I need one more job to be created for the CD part, which is the deployment, continuous deployment part. So what I'm going to do is I'm going to just copy this much over here. I'm going to come down like so, and here I'm going to paste this. Okay. Now instead of Docker build push, I'm going to say deploy AWS EKS over here. Okay, something like this, and this depends on build test. So I'm going to rename this. This depends on Docker build push, something like this. Okay. So here we are deploying the code. Okay, so this is the job that I've created, and it's dependent on the previous step wherein we are building and pushing the Docker image. And now let us define the steps. Okay, so first of all, I'll just have a few. Okay, what I will do is I'll create a few steps over here. Okay, like so, and I'll paste this over here. I'll paste this, and then paste this. Okay, this is fine. Now let us define this. Okay, so why am I getting this error? This is already defined. Okay, steps, you cannot replicate steps. I'm sorry. This need not be replicated. You only need, you don't need the steps keyword, in short. Okay, I'm sorry for replicating that. Okay, so I have few steps over here. Now first step over here, this is a fresh runner machine, right? This is a fresh runner. Okay, it is making use of Ubuntu latest. So I first need my source code so that I can access all the files, right? Second step would be to configure AWS credentials like so. Okay, then the third step would be to set up kubectl. Okay, or kube control, whatever you call it. And then the next step would be to update kubeconfig for EKS. Okay, and then the second last step will be to verify the connection. This is for verifying if you are able to connect to EKS over here. And then I'll say, after verifying, deploy to AWS. Okay, and this will be Kubernetes. Okay, this is done. So what I'm going to do is, let's review the steps. First, I'm going to get the source code onto this new runner. Then I'm going to configure the AWS credentials. Now, why are we configuring AWS credentials? We are configuring AWS credentials so that we can authenticate with AWS. Now, the question is, why do we want to authenticate with AWS? Why can't we just connect using, kubectl? We cannot, because we need, so to set up kubectl, we are going to run the command which is going to make use of AWS CLI. And for that, we need to configure AWS credentials. Okay. And then we need to set up kubectl, wherein we'll be installing kubectl, and then we'll update the kubeconfig for EKS. This is a simple command that we run. We'll verify the connection, whether this connection is working fine, and then we will deploy to AWS. Okay, so let us go step by step over here. So first thing is over here for checking out the code, for code checkout, this is fine. Then let's talk about configuring AWS credentials. Now, how do you configure AWS credentials? So for this, like you must have already imagined, you already have a GitHub Action. So come over here to Action Marketplace, go to all actions here and search for AWS like so. Okay. Now over here you can see this is the verified one, configure AWS credentials, and we just go over here. Okay. So if you scroll down, you're going to see how you can use it. Here, you can see how you can use it. Get up AWS Actions, configure AWS credentials, and you have a version over here, right? So if you scroll down, I wish to make use of the secret key and access key over here. Okay, secret key and access key. So we are going to make use of it this way. Okay, secret key and access key. So you can see assume role with static IAM credentials in repository secrets. So you just copy this,
just come over here. Okay, so this is configure AWS credentials. I'll just replace that with this. Okay, something like this. Indentation is an issue, so I'll just do tab over here and it's all sorted. Okay, so you can see over here, configure AWS credentials. We are making use of this action over here, right? And then you can see the parameters. One is access key ID and then secret access key over here. That is what we are passing. And then the region also, right? And now region, I don't want it to be US East 2. This has to be exact same region where your cluster is located. So I'll say AP South 1. This is where my cluster is located. Okay. Now, of course, these access key and secret access key, we will have to configure on the UI against the repository. So we'll do that shortly. Okay. Set up kubectl. So I'll just copy kubectl, come over here and I'll just close this. Here, I'm going to search for kubectl like so. Okay. So here you will see a few responses. Now here you can see kubectl tool installer. So just open this here like so. And we'll copy this uses setup kubectl @version 4. You can pass in some parameters like version and all. I don't want to pass that. So I'm just going to come here. It is not needed. So I'll just paste this. So it will set up kubectl for us on this particular machine. Okay. Now what I'm going to do is I need to update kubeconfig over here for EKS. Now for this, we are not using action, but we are going to run a command manually. Okay. So I'm going to say a pipe symbol. On next line, I'm going to say AWS EKS update kubeconfig like so. I'm going to say name over here and I'm going to add my cluster name here and I'm going to say region and AP South -1. Okay. Now you can mention your cluster name over here. Hello cluster, something like this. Whatever your name is, you can add over here. If you don't want to hard code your cluster name, what you can do is you can also add this via GitHub Secrets. That also you can do if you want this to be fully configurable, right? But I'm just adding hello cluster over here. I'm hard coding it in the pipeline over here. And then you need to verify the connection. So what I will do is I'll run a simple command over here. I'll add this and here I'll say, pipe is actually not needed. So I'll say kubectl and I'll say get nodes like so. Okay, this is done. And then I'll deploy this to AWS. Now, how would you deploy this to AWS? So I'm going to say run over here. And here I'm going to say kubectl apply -f. I'm going to apply the files. Now, where are the files? So we have checked out the code, right? So the files exist in K8s AWS app1 hello, right? So I'm going to say K8s AWS app1 hello like so. Okay, so this is exactly like you're running kubectl command on your machine. This is how you would also deploy it locally, right? So right now this command is being executed on the runner. So it's as good as being executed locally, right? So I hope this is making sense what we did. Okay, now let us configure these secrets. Now, how do you get these secrets? So come over here. Okay, and go to just verify you have cluster up and running. Okay. And what you can do is, in fact, what you can do is, I would prefer not hard coding and getting the cluster out. Okay, I don't know why I get that feeling that we should get the cluster out. So you can get the cluster out, but I think I'll leave it here. Right? If you want, you know how to. Okay, so here now we need what we need. We need the secret and the access key. So I'm going to go to IAM. Go to IAM. Just see the user that you have. Okay, so what user you have? I have few users. So I'm going to go to admin courses. This is my user for recording courses. It has admin access. So I'm going to go to security credentials. Okay. And I'm going to create an access key. So just create an access key here and just select command line interface and just say, I understand the above recommendation and just get this created. Okay. That's asking you for a tag value. So I'm going to say GitHub Actions, CI/CD. So you can add a tag value and this explains the purpose of access key as to why this is being created. So later on, if you review all the access keys, you know, okay, this access key is for this purpose. So I'm saying GitHub Actions CI/CD, create the access key. Now this access key, don't try to use this access key. This is specific to my account. I'll be deleting this access key, by the way. So just copy this access key. Okay. Come over here to your repository. Okay. And here just go to settings and just go to secrets and variables, actions, and here create a new repository secret. So just paste this secret over here. And what is the name of the secret that you are trying to access? So one is access key ID. Okay, so just add the access key ID. Okay, then the next secret that you need to create is AWS secret access key. Okay, so here if you come, you'll create a new secret access key. Okay, and you got access to the secret access key over here. So just copy this. Okay, just copy this and simply paste and add the secret over here. Now remember, these secrets are really secret. Okay, so don't expose this to anyone, don't tell this to anyone, because it's as good as sharing your password. Anyone can access your AWS account and turn on the resources. All right, your secret is your responsibility. So this is done, this is configured, right? What else do we need? Do we need anything else? I don't think we need anything else. I think we are all good over here. Okay, so what I'm going to do is I'm going to go to terminal. I'm going to say git add. Okay, and then let us run a commit over here. So I'm going to say git commit am, and I'm going to say I'm going to put in the name of the file, hello spring cicd.yaml. Okay, and I'm going to push it. Okay, only one file changed. Why is that so? Okay, let me see where I am, which folder I'm in. Okay, I need to come a bit ahead. Okay, let me see. Okay, now I think I'm in the right folder, the DevOps. Okay, DevOps Masterclass, clear. Okay, and I'll say git status. Okay. Okay, git state. Okay, this is not saved. The problem is this file is not saved. You can see that is why it's not coming in the commit. This file needs to be saved. You can see this dot over here around the closure. It's not saved. So I'll save this and now it should come as the edited file. Yeah, makes sense. So what I will do is I will now add one more commit and now I'll do a push over here. Okay, push. And once we do the push, what is going to happen? The pipeline is going to trigger itself. So I'll come over here. And let us go to actions. Right, the pipeline will trigger. Okay, this is absolutely okay. Access secret key. Okay, this is fine. I'll come over here. Let us see if the workflow is triggered. Is this triggered? Okay, it's not triggered. Okay, you can see hello Spring Boot app to EKS. Okay, it's not triggered manually because I believe, let me check, it's not triggered manually. There is a reason for that. So it should trigger if there is change in this particular path, hello spring. Okay, so there is no change in this path and that is why it's not triggered. So what we will have to do is we will have to run this workflow manually. Okay, so I'm running this workflow manually and let us see what the output looks like. Okay, so now the run will be triggered. Okay, I'll go over here, all the workflows, and now I'll go inside this. I hope you get the understanding as to why this was not triggered manually, because we have configured this particular workflow to work on only if there is change in a particular branch on a particular path, which did not happen in our push. So that is why it was not triggered. And it's good you have workflow dispatched also added, so you can trigger this manually. So I'm getting this triggered manually, and you can see the application was built successfully, right? And it's actually pushing to Docker Hub now. Okay, let us see how this is going. Okay, it's building the jar for Docker right now, and then it's going to log into Docker Hub. So jar building process is taking a bit of time, but it should ideally deploy successfully without any issues. You can see it's pushing the image to Docker Hub. Okay, it's pushed, you can see, right? And you should be able to verify this by visiting Docker Hub as well. Okay, it's done. You can see the push is done. So if you come over here and if you do a refresh, okay, you will see the last push was less than a minute ago. Can you see this, right? Less than a minute ago, which is good. So we have latest version being pushed and this job is done. Now let's go to deploy AWS EKS. So you can see over here, it's okay. The deployment is also done almost. You can see it verified the connection. You can see over here, right? It updated kubeconfig. Okay, so let us go through all the steps. So first is it configured. Okay, so first it checked out the code, which is okay. It got the code. And before that, there were some housekeeping steps like setting up the job and setting up the runner. You can see the runner image and everything was set up. Then configure AWS credentials. So we proceeded with the authentication. Then kubectl was set up. So that setup was done over here. You can see. And then we updated kubeconfig for AWS. So you can see added a new context. This is the context that was added over here in this particular location, which is good. Then we verified the connection. So when we ran this command, you can see we got this output. There are 2 pods running, which is good. 2 nodes running, I'm sorry. Okay. And then we deployed this to AWS Kubernetes. You can see it was deployed. This is the output. And then we, this is post job cleanup. Okay, which is good. So it's deployed to AWS right now. And if you go to terminal over here, okay, so this is the cluster creation command. I'm just going to clear this. Now you can say kubectl get pods. You can see there will be 2 pods that are running. Why there are 2 pods running? Because we have 2 replicas configured. We have count of 2 configured in our YAML file, right? So that is why they are running. And then you can say, if you want to access this service, you can say svc. So we'll get the service URL using this. So you can see this is the service URL. Okay, this entire piece of, okay. I'll copy this. We'll come over here and we'll come over here. Okay. So here I'll paste this and I'll also make sure this is not HTTPS. This is HTTP only. Okay. This is not a secured connection. And now you can see this is the output, right? So isn't this amazing? We made one simple change. If you make one simple change, this is going to go automatically via CI/CD pipeline from your local machine to GitHub repository, from there to Docker image. It is going to build and test it first, of course, before creating Docker image. It is going to be verified first. Then it is going to go into an image form and it will be pushed to Docker Hub because we have configured Docker Hub. And then from there, it's going to be deployed to AWS. Okay. So how does it feel? You have your first app deployed to EKS on AWS using a CI/CD pipeline in an automated way. Now, of course, this pipeline that we have written will be much more complex when you work on a production grade scenario, but it's important you understand the steps, you understand how it works, you understand what we are doing. That is really important. And once you get that gist, okay, everything becomes a cakewalk. Okay, so it's understanding concept is important. See, whenever you are learning a new tech, whenever you are doing something, building something, it's important you understand the concept first. Because once you understand the concept, you have a lot more ability to do complex things. Because now you understand behind the scenes, you now understand how things are working. You're actually doing it with me. So you're going to win. I hope this has been useful. Alright, so now it's time we deploy our Node.js application to Kubernetes using CI/CD. Okay, and first of all, what I'm going to do is I'm going to check if there are any sort of pods running on AWS Kubernetes cluster. So actually there are a couple of pods. So what I'm going to do is I need to delete. So I have just deployed the Spring Boot application. So what I'm going to do is kubectl. Okay, and kubectl over here, and I'm going to say delete -f, and I'm going to say k8s and AWS /app1 hello. Okay, app1 hello, and I'll say enter. Okay, now this will delete the deployment and everything from the namespaces. Right, you can see this is being deleted. Now, before running this command, also make sure that you are in the root of the current project directory. Okay, because from the current directory, you are referring to k8s AWS app1 hello. Okay, so you should be in your project directory, which means you should be over here in DevOps Masterclass. All right, only then you can refer to the files this way. Okay, and if you see, I'm here. Okay, I'm in the root of the directory. So this is deleted. Okay, I've deleted the application that I had deployed, and this was for the Spring Boot application. Okay, this is deleted. Now what I will do is I will implement CI/CD for the Node.js application. And what I want you all to do is I want you all to take this up as a challenge. Yes, as a challenge. See, I'll be showing you how you can deploy, but it's best you take this as a challenge on your own because you've already seen one pipeline being deployed automatically.
right? So pause the video right now, attempt this as a challenge. Remember, the goal of all the challenges I give is not to get the right answer. It's to get out of your comfort zone. It's to get from watching mode to that of doing mode. Only then you become a great software engineer. Pause the video right now. Welcome back. I hope you all had a chance to attempt this challenge. Now I'm going to give you the solution for this challenge. So Node.js CI I already have in place over here. And this CI is basically responsible for it basically triggers on push on main and at this particular path. It also has workflow dispatch, and it has two jobs. One is to build and test the application. We build the application this way, we run the test, okay, and it is also building the application and pushing the Docker image to the Docker Hub repository. Okay, so these two I have. Now I can modify this particular pipeline itself, but I'm not going to modify. I'm going to instead create a new pipeline, new workflow, because I don't want to touch that thing over there. Okay, so I'm going to say CI_CT over here. Okay, and here deploy hello node app to AWS EKS. This is done. Okay, so this is done, and then over here what we need is we need these steps for deployment. So what I'm going to do is I'm going to come over here, okay, and here I'm going to copy this entire thing, like deploy AWS EKS. Okay, this entire thing. So it will be the same thing. Okay, I'll just paste it over here. Okay, it's not going to be different. Okay, you can see it's being deployed here. Like all the steps will be same. For example, checking out the code, then configuring AWS credentials. Okay, we already have these access key and secret access key set up. Setting up kubectl, updating kubeconfig. This is also going to be same. Verifying the connection, and then finally deploying it to AWS. Now what we need to do is we need to check this particular file. So here app.yaml, and here we will have the image for Spring. So I'm going to update this image to that of Node. Okay, and instead of EmbarkX, I think we need over here what we need. We need over here T-code 007, something like this. Okay, this is what I'm going to need. So make sure that this particular thing points to the pipeline over here. Okay, so this particular configuration points to the image that we are building. Okay, make sure you do that. So just do this, and then you come over here. This all is done. Okay, this is fine. Now I'll save this. Okay, and let us commit this code. So I am going to open up the terminal over here. Okay, and here I'm going to say git add, like so, and then I'm going to add the commit. So instead of hello Spring, this is going to be hello node. Okay, that is the commit message I want to add, and I'm going to say git push. Now the moment you push, okay, here if you come to the repo here, okay, let me go back and let me see if this is triggered automatically. Ideally it should trigger automatically. Let me see all the workflows. Okay, all right, it's not yet triggered automatically. Let me do a refresh. Okay, what's the problem? Let me see here. Okay, this is pushed. So if you see over here, so let me go to hello node app. Okay, so it's not triggered because there were no changes in the paths that were mentioned. So but we luckily have run like workflow dispatch added. So I'll just run this workflow and let us wait to see this happen. Okay, now what this should ideally do is this should push the image to Docker Hub over here. Okay, here hello node should have the latest update. So you can see last push over here for my repo was 2 days ago. Okay, let us see if we get the latest update over here. So I'll just go to this particular workflow. It's getting triggered. You can see the building and testing of application is completed in 10 seconds. Now it's doing Docker build and push. We'll wait until this finishes. Okay, so ideally this should also finish successfully and without any issues because this CI pipeline was working fine. What we have added new is the CD pipeline. Okay, so here you can see this push process is done, and now let us see if this is done as well. Okay, so we'll wait for a while. Deployment is in process. So build step took 28 seconds, and until then deploy AWS EKS was not triggered because this is dependent on the previous step. So you can see over here this is done successfully. You can check if there was a new build that was pushed. If you refresh, you will see last push was 1 minute ago. Can you see last push 1 minute ago? Yes. And now if you see, this is also successful. All right. And there should be some pods running. So what you can do is, I'll say clear, I'll say kubectl get pods over here like so. You can see 2 pods running. I can get the service URL for me to access, right? I'll just copy this. I'll copy and I'll come over here and let us try to access this. Okay. I'm going to try and access. This was for the Spring Boot application. Now this is for the Node.js application. Okay. This is not yet up. See, if you try to access it immediately, it might not be up because there is provisioning that happens on AWS, like creating load balancers, setting up the URL, all of that happens. So if you are not seeing the output, it's likely that the provisioning step is in process. So just wait for a couple of minutes and then you should see the output. Okay, it's not yet working and I found the reason for this. The reason is here we added Node.js image, right, in the YAML file, the Kubernetes configuration YAML file. We added Node.js image, but Node.js is not running on 8080. Okay, it was Spring Boot application that was running on 8080. This one is running on 3000. So I'll update this to 3000 and also the target port over here for source of service will be 3000. Now once we make these changes, ideally it should work. Let me see if there is anything else missing. It should work. Okay, and let me come over here and let me trigger the workflow again. So I'll come over here and I'll say run the workflow again. Let us re-trigger the workflow and this time it should properly run. So let us wait. The workflow has triggered all the workflow. And if you go over here, you should be able to. So I'll wait for a while until this entire process completes. So you can see over here, the entire build process is complete. If you go over here, you would see the last push was also there 1 minute ago. And let us come over here and let us refresh. Okay, so now you can see the node application is also deployed to AWS. So imagine now you doing some changes in the code and you're pushing the code and it's auto deployed to AWS with the help of this CI/CD pipeline. Isn't this an amazing feeling? We did one mistake. Yes, the port wiring was not correct. So here we changed the image from Spring Boot to Node.js. For Spring Boot, it's 8080, the container port, and hence the target port was 8080. But for Node.js, since within the container, Node.js app is running on 3000, so you need to make sure the container port is also 3000 and target port is also 3000. Only then it will work properly. I hope this is making sense and I hope you are able to have some fun. Also, if you want to delete this now, so what you can do is like you deleted the previous app. Okay, you can delete something like this, delete -f. And if you delete it like this, you can see both are deleted now. It will take a bit to complete this command, but this is going to be deleted from the namespace. Okay, and you can then deploy something else if you don't want this app there. Okay, so this is deleted. Okay, it's not yet giving me the prompt to write, but that's okay. I'll wait for a while until the deletion is complete. Okay, see, the deletion is complete, and now if you try to get pods, there won't be. This is in the terminating status. Okay, so they are actually being deleted. It's not yet fully deleted, but they're in the terminating status now. Earlier they were in the running status, as you can see, right? And if you try to get service also, it will be okay. It's gone, right? So yeah, the deletion process has been successful, and we have been able to. We have seen how you can deploy and work with Node.js app. I hope this has been useful. All right, so now it's time where we start deploying our Python application to Kubernetes using CI/CD. All right, and what I'm going to do is here, if you come, I'm going to check if any sort of pods or anything are running. There are no pods running. If there is anything running, you need to delete that. So what I'm going to do here, if you go to Docker, you have this Python code over here. Okay, and the Python app is running on port 3000. So that is good. Okay. And we already have the Kubernetes configuration also defined here, right? This is a Kubernetes configuration for Node.js app. And of course, Node.js app also runs on 3000. So this is configured to work on 3000. Now what I will do is I'll first update the image over here. This image will be for Python, hello node. Sorry, not hello node. It will be hello Python. So here if you come, if you go to hello Python, you can see this is what it should replicate, because your image will be pushed over here by the CI/CD pipeline, right? So we have added that over here. I'll save this, and then I'll come to like GitHub folder here, and then let's take a look at the Python CI over here. So I already have a CI written for Python. I'm going to duplicate that because that is the same file that I'll use for writing the CD code as well, which is continuous deployment, like so. Okay, I'll update the name, deploying like hello Python to AWS EKS, like so. And here, if you see, we have like the trigger configured. Okay, so any sort of changes here in this particular path, this is going to trigger. And we have workflow dispatch also, so we can run this manually. Now there are two jobs. One is build and test. So this will build and test the Python application. And then we have Docker build and push, which is going to build the image for this particular application after building and testing. And it's going to make a Docker image, and then it's going to push it to your Docker Hub account. Okay. Now we need to add the AWS part over here. So what I'm going to do is here, I already have the CI/CD written for Node. Okay. So I can copy this. I can copy the deploy AWS EKS part completely, and I'll paste it over here. Okay. Somewhere over here. Okay. And yeah, this is done. So rest, everything remains the same. Okay. So we will be deploying on EKS. We'll check out the code first. Okay. This job depends on the previous step or the previous job. We'll check out the code first. Then we'll configure the AWS credentials. Then we'll set up kubectl. Then we'll update the kubeconfig for EKS. Then we'll verify the connection, and then we'll deploy to AWS. That's fine. And now I will I'll open the new terminal. Okay. And I'm going to say over here, I'm going to commit. Okay. So I'll have to commit. So let me first add everything. So I'll say git add, and then I'll have to commit here. So I'll say, oops, so git add didn't work properly. So I'll have to say git add and then dot, and now I'll have to commit. Okay. So to commit, I'm going to say hello Python CI/CD, like so, right? And you can see the commit was done, and I'll do a git push. Okay, so everything is being pushed now. Okay, and this is, remember, this is for the Python app. So I'll come over here, and here I will just trigger the workflow. So if I refresh here, you can see hello Python app to EKS. This is not triggered because it's configured to trigger only if there are changes in a particular path on the repo. So it won't trigger. So I'm just going to run this manually. Let us see how this runs, and we'll soon have a workflow appear over here. Okay. So the goal of this is basically to build the application in an automated way, to build the image, and then to get it deployed onto the production. So you can see the building and testing of the Python app is done. Docker build push is happening. So if you come over here, last push was 2 days ago. Okay. So let us wait until this push is done. This should be done now. Okay. It won't take much time to push this app. I think, let me refresh. You can see the last push was done less than a minute ago. You can see over here, right? So push is done. You can see it's successful. And then now it is deploying to AWS EKS, right? So we'll wait for a while until the deployment completes. It's not going to take much time. But yeah, you can see the services and everything have been created. And you can see all done, right? So here, now if you check for pods, it's going to work, right? What I will do is I'll get the service. Okay. Now you get this service URL. So you are supposed to copy that, and then you are supposed to, so here this won't work, but here I will paste this URL, the URL that I've got in a fresh way. Okay. This will take a bit of time because load balancer and everything will get provisioned. We'll wait for a bit until we see this. So I'll wait for a couple of minutes. So after waiting for a couple of minutes, you can see now we have the Python app also running. You can see, right? This is fun, right? So remember, if you wish to delete, you can simply delete it something like this, right? Just run this command and it's going to be deleted, right? And if you come over here, now it's being deleted. If you refresh, okay, it's still accessible. Okay, it's not accessible now. It's gone, right? So I should see cannot access page. Okay, but yeah, it's deleted, and here also you can see the confirmation, right? So it's deleted. Okay, it's not accessible. You can see it's in continuous loading state. So yeah, I hope this is clear, and I hope you all have been able to follow along. Now, after you are done deploying and working with all the services on AWS, it's important that you clean up everything. And the reason it's important for the cleanup is so that you can avoid surprise bills, invoices from AWS. So here, what you need to do is, I'm going to say EKS CTL. So we are going to make use of EKS control, delete, okay, cluster, and I'm going to say region. So my region for my cluster was AP-South-1, and I'm going to mention the name as Hello Cluster, like so. Okay, so this is really important. Now what this is going to do is going to delete everything like EKS control plane, node groups, load balancers, security groups, everything that has been created, IAM roles for this to work well. All of this is going to be deleted with this particular single command. Of course, this does a lot of cleanup that so see, there was a lot of setup that was done when you created the cluster. Cluster creation itself takes like 5-10 minutes minimum, right? So of course, there were so many things created on AWS. Now those need to be cleaned up. So this is also going to take good amount of time. It will take 5-10 minutes at least. So just hang in there, okay, and wait for it to finish. So I'll wait over here and I'll get this finished. So you will get the confirmation in the end, okay, that it has been deleted. I hope this has been useful. So I also wanted to mention that this particular course is a part of full-fledged course that is available here on Udemy, and you can get the discounts coupon for this particular course here on our website, the link for which you will find in the description below. Don't go directly and buy the course, but you should claim the discount coupon for being a viewer of our channel. So you will find a discount coupon below. You'll find the link and just head over to this website, and if you click on enroll now, you will get the latest coupon applied, the link with the latest coupon applied. So just click over here and this link will take you to Udemy with the best coupon available at that particular point in time. Now talking about the course, this course is right now the bestseller in its category, and as I'm recording the video, it has just launched, okay, and it is part of Udemy for Business subscription as well. So Udemy courses, you know, like you can get it for very low price. We believe in affordable education, and yes, this course is around roughly 40 hours. Okay, I'm adding more and more content every now and then. So people who are enrolled into this particular course, thank you very much for the trust. And you all know like how I'm updating the content, like, right? So there is new releases happening every now and then. So this length increases with latest industry trends and technologies, whatever is happening in the world. I keep on updating the courses, and right now you can see this course stands strong with roughly 40 hours. It's total 40 hours right now in length. It's massive. It deserves a lot of, or it demands a lot of commitment from you, but it delivers the skill. And this is something that you can get from the ratings and the bestseller tag that it has. Now, remember, being a bestseller in this niche on a platform like Udemy is not a joke. Okay, there are so many courses that are competing for this spot, but good content always finds the way. Okay, so just head over to this website, and this website is EmbarkX.com. Also, I'll talk a little bit more about this course. So here you can see this is the course. So by the way, from the title, you will see Full Stack AI DevOps Masterclass. So why are we calling this course as Full Stack course? Because in this particular course, we learn how to deploy full stack applications, right? We learn how to do DevOps on full stack application. Full stack meaning front end as well as back end. We don't build the application, but we learn how to perform DevOps, right? Then AI. I've not added AI as a marketing tactic over here, okay? Because every other course you see, they add AI in the headline, but that's not the case here. You learn AI-driven DevOps as well, AI-assisted DevOps as well. You learn how to make use of DevOps to you learn how to make use of AI to improve on your DevOps workflow. So that is also covered. So that is why AI comes over here. DevOps, of course, because it's a DevOps course. Real projects, because we give you access to some real projects. So we give access to monolith application. And also microservices. I'll talk about that. Microservice access is also given. You get a ready-made application, a full stack application built in microservices architecture, and you can do like everything, like deployment, containerization, Kubernetes deployment, deploying it to cloud. So all of that you learn, how you can manage configurations, all of that is covered. And yes, this is the first course, I would say, that covers all the three major technologies, major cloud platforms, I would say. AWS, Azure, and GCP. These three in combination in a single course are rare. Okay, at least I have not seen. And at an unbelievable price. So we had to keep this on Udemy, okay, because we believe in affordable education, and trust me, the price at which you get this course for, this course delivers far more than that. Okay, I can promise this to you. Okay, so you can go and check the reviews as well, and you can check the curriculum. But what all we cover over here? So we understood the title, why we have this kind of title over here. Okay, we have microservices as well over here. Okay, so first this course starts with DevOps mindset. Then we head over to Docker. So we containerize the application. And when we talk about containerization, we just don't containerize monolith application. We containerize microservices, and then we learn how to go full stack. Okay, then we learn about Kubernetes. Okay, and we learn how to make use of Kubernetes and deploy our application to Kubernetes. So monolith, microservice, and full stack again. Okay. And also I'll tell you, okay, looking at these keywords, I know a lot of beginners will get overwhelmed, but don't worry. If you've never heard of Docker, for example, if you've never heard of DevOps, you don't know what DevOps is, then this course is still for you. So I forgot to mention one thing. This course is for absolute beginners. Okay. In fact, it is targeted towards developers and also DevOps engineers who are breaking into this field. So I literally start. So look at the first lecture that you see over here. Okay. You learn first what is DevOps. What is DevOps? That is where we start. Okay. And then we start with Docker. Okay. So if you have never heard of these terms, don't worry about them. Okay. You just enroll and just start taking lectures in a daily manner, and you will learn all these terminologies. So I was talking about Kubernetes. If you have never heard of Kubernetes, we have that covered inside the course. After the course completes, you will not only learn what is Kubernetes, but you will also know how you can deploy, manage applications on Kubernetes. What are pods? You will understand. If you're a developer, what major challenge is today? Developers can't interact with DevOps engineers. They can interact, but they don't understand the terminologies that they are using. So this course equips you with that. Okay, you learn the terminologies, you understand the terminologies, and you can communicate with DevOps engineers with ease. Okay. So that's something there. So first we set up Kubernetes locally, and then we take Kubernetes to the cloud. Okay, so you learn how to deploy applications in cloud on Kubernetes infrastructure. And we cover all three cloud providers over here, like GCP, AWS, and Azure. Okay, and yes, we also cover infrastructure as code. So IAC means infrastructure as code. So this is covered using Terraform. So see, infrastructure provisioning is a part. Okay. And, these days infrastructure can be provisioned with the help of code. And how it is provisioned, that is something really, really important that you need to understand. So all of that is covered in a hands-on manner. See, I deliver courses that are hands-on. Okay. I believe in learning hands-on. I don't believe in theoretical and, mucked up learning. I don't believe in that. And that is what my courses also reflect. Okay. So if you take a look at all the learners, okay, or if you take some sort of feedback from all the learners who have graduated from my courses, you will know that courses delivered by us, EmbarkX, okay, these courses are hands-on. We talk about real things. We build real things. So that's what we deliver on. And yes, Udemy as a platform is awesome. Okay, we have the courses hosted there, and you can come over here on EmbarkX.com. You'll find all these links in the description below, by the way. Okay, so we have this Spring Boot roadmap. Spring Boot course over here, which is the flagship course available on Udemy. Okay, and then we have a microservices course. Okay, this is also a flagship course hosted on Udemy. These are all bestsellers, and they're bestseller for a reason. Okay, and so that's there. And if you wish to know the roadmap, okay, or if you're not sure as a beginner or in which order you should take our courses in, so you can go to EmbarkX.com. Okay, and you can say /roadmap over here. So you will get access to this roadmap and it will give you a complete understanding. Okay, you should enroll if. So it will give you complete understanding of which course you should take when. Okay, so it starts with this full stack professional e-commerce masterclass. It's a full stack course that teaches you how to build professional e-commerce grade applications using Spring Boot. We cover React, JavaScript, everything inside the course. Everything is covered. You just need to know Java, object-oriented programming, basic knowledge of Java. You just come inside the course and we take you through, right? Spring Boot Microservices is the next, okay, which I just spoke about, and then full stack DevOps for software engineers. So this is the course. So yeah, I hope you all will leverage the coupon code, the lowest price coupon code that I'm sharing on the website. The link for the same is in the description below. Feel free to take a look at the discount and then decide. A lot of people have already enrolled and the feedback has been tremendous. Okay, this can help you take your career to the next level. Okay, all the best.